Hi everyone, welcome to PrepFusion. So in this video we are going to study about discrete time Fourier transform, discrete time Fourier series, discrete Fourier transform and fast Fourier transform. So in this particular video, this is the part 1. So in the part 1, discrete time Fourier transform and discrete time Fourier series will come, and in the next part DFT and FFT would come. Along with that we will see some miscellaneous concepts as well. Okay, right? But there are some prerequisites. You cannot start directly from this particular video. First you need to watch this particular video. You will enjoy it a lot. Believe me guys, this will be one of the best video on signal system that you would ever watch. So here the fundamental concept of CTFS, DTFS, CTFT, DTFT and DFT I have given. Fundamental means from where these concepts came, what was the idea behind these concepts, and what is the meaning of all the formula that we write down. So that fundamental concept have been given in this particular video. So when I discuss DFT or FFT or DTFT or DTFS, I don't give the fundamental concept. So in this video you will not get the fundamental concept. Fundamental concept is here. So first you need to watch this 3 hours of video. You will certainly enjoy it. You will enjoy it a lot. Okay. So first you watch this 3 hour of video. Even if you feel like that, sir, I know the fundamental concept, still I would request you to watch this video and then only you come here. Along with that, you need to know the basics of continuous time Fourier series and continuous time Fourier transform and jet transform as well. Only the basics, only fundamentals if you know, on very surface level, even if you know the CTFS, CTFT and jet transform, then also the things would work. So did you understand? First you need to watch this video and you need to have a basic idea of Fourier in case of continuous time. Along with that, you need to have a very basic idea of jet transform as well. Even if you know the formula only, then also the things would work. So these are the prerequisites, then only you can get started with this particular video. So in this video, we are going to cover DTFT. Along with that, we will see circular convolution, and then we will see DTFS. In the next video, we will see DFT and FFT. Now, what is my request? My request would be that you guys would comment. Once you are done watching this video, once you are done watching this video and this particular video, after that, I would be expecting that you will comment down. You guys will comment down that how did you find this video? And the next video will be based on DFT and FFT. So let's not keep a target, or can we keep the target? So let's keep the target of 100 likes within 2 days. Okay, within 2 days, 100 likes, and let's keep a target of 5k views. 5k views within 7 days. Within 7 days. Okay, so let's keep this target, which is, I would say, unrealistic, but let's target it. Who knows, we may achieve it. So 5k views in 7 days and 100 likes within 2 days. This is what I expect from you guys. Okay, this is the expectation from you guys now. And prerequisite is clear to you that you will study this particular video. You need to have a basic idea and then you will get started with discrete time Fourier transform. Well and good. Yeah. So let's meet in the discussion now. Hi everyone. So now we are going to start studying about discrete time Fourier transform. So basics of discrete time Fourier transform is already clear, that how the concept of discrete time Fourier transform came into action. First you find DTFS, and then in DTFS you put n naught tending to 0. So that will become a continuous and periodic signal. Continuous and periodic x e to the power j omega. Right? So formula and everything we have already seen. We have studied about jet transform as well. Now carrying the information from jet transform, we are going to study about discrete time Fourier transform. So very easy topic, very straightforward topic. Most of the things you already know. Right? So jet transform of x of n is given by x of z, where n will tend to minus infinity to infinity, x of n, z to the power minus n. Now if your x of n is absolutely summable, what does that mean? That means ROC of x of z should include unity circle. ROC of x of z includes unity circle. And if it is including unity circle, what does that mean? That in place of z, I can put e to the power j omega. So in place of z, what I can put is that I can put e to the power j omega. And if I put in place of z, if I put e to the power j omega, that will become the discrete time Fourier transform of x of n. So that I can represent as x e to the power j omega. Because it is including the unity circle, that means x of n is absolutely summable. If x of n is absolutely summable, that means I can define its a discrete time Fourier transform. So all these basic concepts we have already seen. That's why I am writing down in a very quick manner. So what would be the formula of x e to the power j omega? That would be summation n goes from minus infinity to infinity, x of n e to the power minus j omega. So this is the formula of x e to the power j omega, and from here only we can find the formula of x of n as well, right? So what is this x e to the power j omega? This is continuous plus periodic, continuous plus periodic, right? So what will be the formula here? 1 by 2 pi, it is periodic with 2 pi, so that's why I will take the limit from minus pi to pi, x e to the power j omega e to the power j omega n dot d omega. Why I am putting d omega? Because final answer you need in terms of n, so you will put the limit of omega, so final answer will be there in terms of n. So these are the two formula which we need to remember, and we already remember it as well with a very good trick, along with that with the full concept as well. Well and good, let's move to the discrete time Fourier transform of some basic standard signals, right, or standard sequences. So x of n is a to the power n un. Now you know that discrete time Fourier transform DTFT is defined only when x of n is absolutely summable. So when x of n will be absolutely summable? When mod of a is less than 1, right? Because it is looking towards plus infinity, so mod of a should be less than 1, and if mod of a is less than 1, then ROC of x of z will include j omega axis. So this concept we have already seen with respect to a lot of examples as well. So x e to the power j omega, sorry, x of z, what is x of z? So x of z is z upon z minus a, right? Just one second guys. Z upon z minus a. So here what you will be getting, 1 upon 1 minus a z inverse. So what will be the formula of x e to the power j omega? That would be 1 upon 1 minus a e to the power minus j omega. Okay, so this is the formula of x of e to the power j omega. Do you need to remember it? No, you can very easily write down in the examination hall if it is required. Okay, very straightforward, very easy, right? And one more thing you can see here, what will be the value of x e to the power j omega plus 2 pi? What I am asking, in place of omega if I put omega plus 2 pi, in place of omega if I put omega plus 2 pi, so what will be the value? 1 upon 1 minus a e to the power minus j omega plus 2 pi, right? So what I will be getting, 1 upon 1 minus a e to the power minus j omega e to the power minus j 2 pi. So what will be the value of e to the power minus j 2 pi? That is 1. So what you are getting? X e to the power j omega only. What does that mean? It is periodic with 2 pi, which we have already seen in the basics. There was one video where I explained about CTFS, DTFS, CTFT and DTFT. So there I told you that x e to the power j omega will be continuous plus periodic with the time period of 2 pi. So yes, you can directly see here, you can directly see that it is periodic with the time period of 2 pi, which is a very straightforward thing. So periodic with the time period of, I should not say time period because axis is here, the axis is omega, no, right? You are going to draw x e to the power j omega. We are going to see the frequency spectrum. As of now we are not drawing the diagram, so you are going to draw x e to the power j omega versus omega. So I will not say it is time period, so I will just say that it is periodic with 2 pi, periodic with 2 pi, right? Because axis is of omega, not of time, so I will say periodic with 2 pi. But this formula 1 upon 1 minus a to the power minus j omega is applicable only when mod of a is less than 1, because only then only x of n will be absolutely integrable. So here you can see that x of n is absolutely integrable. So what will be x e to the power j omega? 1 upon 1 minus 1 by 2 e to the power minus j omega. This is your x e to the power minus j omega. Here 2 to the power n un, 2 to the power n un, that means it is not absolutely integrable. That means x e to the power j omega is not defined. X e to the power j omega, a to the power n un. So what will be the answer? 1 upon 1 minus a z inverse, 1 upon 1 minus a z inverse. So this will be the answer, because what is the value of a here? Minus 1 by 4, and what is z inverse? E to the power minus j omega. So these are the answers. These are the very basic things which we already know, that we are going to see now, right? The second one, minus a to the power n u of minus n minus 1. So when it will be absolutely summable? Since it is looking towards minus infinity, that means it will be absolutely summable when mod of a is greater than 1. And what was the formula of x of z for this one? It was z upon z minus a. The same formula was there, right? So basically, if any of the expression is there, they can ask you any of the expression. So your first target would be that I write down x of z. then you would see that if my ROC is including j omega axis or not. So not j omega axis, if my ROC is including unity circle or not. If your ROC includes the unity circle, then just replace z with e to the power j omega and your answer is done. Right? So I have find out x of z, which I already know. A to the power n will throw z upon z minus a, then I will see u of minus n minus 1. Another negative sign is already there, so I don't need to add any negative sign from my side. So this is how we can write down x of z. Now what will be my x e to the power j omega? That will be simply 1 upon 1 minus e to the power minus j omega. There you go. This is the answer. Very straightforward, and you can directly see that it is periodic with 2 pi as well. Right? Now, what will be your x e to the power j omega for 2 to the power n u of minus n minus 1, right? 2 to the power n u of minus n minus 1. So x of z would be z upon, here is it absolutely integrable? Yes, it is absolutely integrable. So z upon z minus 2, and ROC would be mod of z less than 2, that means ROC is including unity circle, so all good, all fine. Or you can put as 1 upon 1 minus 2 z inverse. But here u of minus n minus 1 will be expecting that another negative sign should be there, but this negative sign is not there, so I have to add the negative sign from my side. So what would be your x e to the power j omega? That would be minus 1 upon 1 minus 2 e to the power minus j omega. There you go. Well and good. And here, is it absolutely summable? No, right? 1 by 2 to the power n. So what will be the value of 1 by 2 to the power minus 1? That would be 2, and you can see that it will keep on increasing. So not absolutely summable. What does that mean? X e to the power j omega is not defined, right? It is not defined. Now the next expression is important. Okay, this expression is important. A to the power mod of n. So whatever the answer you are going to get, that answer you need to remember. Okay, whatever the answer you get, that answer you need to remember. So we are going to derive it, but let me know when it will be absolutely summable. Let me know at what condition it will be absolutely summable. Mod of a less than 1, right? Do you remember this condition? What would be its ROC? Its ROC will be between 1 by a to a. ROC would be mod of z less than a and mod of z greater than 1 by a. And unity circle should lie in between. So we were getting the condition that mod of a should be less than 1. You can check as well. 1 by 2 to the power mod of n. So what kind of graph you will get? At 0 you will get 1, then 1 by 2, 1 by 4 and so on. In that manner, this kind of graph you will keep on getting. So yes, it is absolutely summable. But if I check 2 to the power mod of n, so here you will get 1, 2, 4, 8 and similar thing will be happening here. So it will just keep on increasing like this, right? So it is not absolutely summable. So what is the condition? Mod of a should be less than 1. So what would be your x of n? A to the power n un plus a to the power minus n u of minus n minus 1, right? So a to the power n un, can I write it down in this manner? 1 by a to the power n u of minus n minus 1 z upon z minus a, here z upon z minus 1 by a, and why there is a negative sign? Because u of minus n minus 1 will be expecting a negative sign, and since it is not there, I will add the negative sign from my side, right? So what we can do is that I can write it down as 1 upon 1 minus az inverse. I can take this a upward, az upon az minus 1, right? Az upon az minus 1. Can I write it down as plus 1 minus az, plus 1 minus az? Is that clear to you? Az upon az minus 1, and then I took the minus sign outward, so az upon 1 minus az. Is that clear to you? Why I am doing so? You will be able to realize it, because some kind of symmetry you can see here, no? So just to get the good expression, I am doing this particular thing. So this is your x of z. Now what I can see is that from here I can get x e to the power j omega, which will be 1 upon 1 minus a e to the power minus j omega plus a e to the power j omega divided by 1 minus a e to the power j omega. So what would be x e to the power j omega? That would be equals to 1 minus a e to the power minus j omega into 1 minus a e to the power j omega 1 minus a e to the power j omega plus a e to the power j omega into 1 minus a e to the power minus j omega. So what you are getting? Simply I am taking the LCM, simply just the mathematics it is, right? That's why I am not explaining anything. This is simply a mathematics, nothing else. So I don't think I need to explain anything, right? Minus a square divided by, if you solve downward, what you are getting? 1 minus a e to the power j omega. Then I will multiply a to the power minus j omega with minus 1. So minus a to the power minus j omega plus a square, right? This is what I am getting. Now what you can see here, what you can do with this particular thing, you can take minus a common. If you take minus a common, then you can multiply it with 2, right? And then divide with 2 as well. You took minus a common, e to the power j omega plus e to the power minus j omega divided by 2 multiply with 2. So what this will become? Cos omega, right? This will become cos omega. So what is the answer you are getting? And this is getting cancelled. So 1 minus a square upon 1 plus a square minus 2a cos omega. So x e to the power j omega is coming out to be, this is the final answer that you need to remember. There you go. Nothing like you are not going to derive it in the examination. Okay. 1 minus a square upon 1 plus a square minus 2a cos omega. So this is the answer you are getting for a to the power mod of n. And condition you already know that mod of a should be less than 1. So there you go. Now let's just say there is some expression of x e to the power j omega is given. What I am saying, there is some expression of x e to the power j omega is given. From here, if you need to find the value of a, how will you find? Again, let me repeat the question. Some expression is given. You will get to know that, okay, cos omega is there, that means it is coming from here. If cos omega is there, that means it is surely coming from here only. So how will you find the value of a? Will you compare that 1 minus a square is equals to 3 and 1 plus a square is equals to 5? No, that would be wrong. You cannot compare like that, right? If someone would say that, sir, here I can see that this particular expression I can see. Let's call this as x e to the power j omega. So this expression is 3 upon 5 minus 4 cos omega. And sir, if I compare it with 1 minus a square upon 1 plus a square minus 2a cos omega. So sir, what I can do? 1 minus a square is equals to 3. And sir, 1 plus a square is equals to 5. Just try adding up these two equations. What you are going to get? If I add both of the equation, what I am getting? 2 is equals to 8. 1 minus a square is equals to 3, 1 plus a square is equals to 5. If I add both of them, 2 is equals to 8. Does it make any sense? No. That means you cannot put 1 minus a square is equals to 3. You cannot do that, right? So this is how we are not going to find it. So what is the way? The way is you put, in place of omega you put 0. What you need to do, in place of omega, in x e to the power j omega, in place of omega you need to put 0. So what you will be getting? 1 minus a square upon 1 plus a square minus 2a. And after this you can compare. Now you can compare. Because if I put omega equals to 0 here, what I will be getting? 3 divided by 5 minus 4, because cos omega will be 1. So 1 minus a square upon 1 plus a square minus 2a will be equals to 3. Then I can compare. Or what I can do? Anything I can put. Let's try putting omega equals to pi. So what is the value of cos pi? Cos pi is minus 1. So in place of omega you can put pi. So 1 minus a square upon 1 plus a square plus 2a. So anything you can do. Basically anything you can do. Either you put omega equals to 0 or you put omega equals to pi, or even you try putting omega equals to pi by 2 as well. Anything you can do, but in this manner you need to compare. It's not that you will compare, okay, 1 minus a square is equals to 3. This thing will not work. So what I'm going to do is that x e to the power j omega at omega equals to 0. So that would be equals to 1 minus a square upon 1 plus a square minus 2a. So what is cos 0? Cos 0 is 1. 3 upon 5 minus 4, that would be equals to 3. So 1 minus a square would be equals to 3 plus 3a square minus 6a. So what you are getting? 4a square plus 6a minus 2 is equals to 0. So 2a square plus 3a minus 1 is equals to 0. So 2a square plus 2a plus a minus 1 is equals to 0. Something is wrong, calculation mistake आ गया वही 4a square, okay, minus 6a, this is what I was thinking, 4a square minus 6a plus 2, 4a square minus 6a plus 2. Okay, so here only we did wrong, 4a square minus 6a plus 2, this is what we are getting. So 2a square minus 3a plus 1, 2a square minus 2a minus a plus 1 is equals to 0. So 2a is coming common, a minus 1 minus 1 a minus 1 is equals to 0. So 2a minus 1 into a minus 1 is equals to 0. So from here value, two values we are getting, a is equals to 1 and a is equals to 1 by 2. So which one will be expected? Which one will be accepted? A is equals to 1 will not be accepted. Why is that so? Because all these formula, everything, whatever the calculation we are doing, this will be true only when mod of a is less than 1. So here this will be accepted. So a value is 1 by 2, right? So this particular expression is coming from 1 by 2 to the power mod of n. So I need to add a page. So basically what I needed to do, I needed to find this integration. If I need to find this integration, I can see that, okay, something I already know. So from something that I already know, something is coming from there. So what I could do is that I got to know that it is coming from this particular thing, because this will have the discrete time Fourier transform of 1 minus a square upon 1 plus a square minus 2a cos omega. So that would be 3 by 4 divided by 5 by 4 minus cos omega. So 3 upon 5 minus 4 cos omega. So this is the thing. So this is your x of n. Now what is actually given? Your integration I is equals to minus pi to pi x e to the power j omega e to the power j omega t. The value is 2 d omega. What do I know? I know that my x of n formula is given as 1 by 2 pi minus pi to pi x e to the power j omega e to the power j omega n d omega, right? This is the formula. So if I do 2 pi I multiply here, and in place of x of n, if I put n equals to 2, so what I am getting? Minus pi to pi x e to the power j omega e to the power j omega 2 d omega. So in place of n, what I am putting, n, in place of n I am putting n equals to 2. So I already have the formula of x of n, I need to put n equals to 2. So what is the answer of I am getting, or I or a, whatever it was, I. So I is equals to 2 pi into x of n at n equals to 2. So answer is pi by 2. So this is the answer. There you go. So this is how we need to solve these kind of integrations. Is that clear to you or not? Okay, well and good, very simple, very straightforward, right? So this is a very standard question actually. 3 upon 5 minus 4 cos omega. 3 upon 5 minus 4 cos omega. If it is possible, you can remember that it will be coming from 1 by 2 to the power mod of n. It is very standard actually. 3 upon 5 minus 4 cos omega. In mathematics as well, you will learn it. In maths as well, this expression will come. So in the examination, they can ask you 3 upon 5 minus 4 cos x dx. In place of omega, they can put x. So these kind of question can also be coming, which you will be able to understand that I need to pick omega there, and by the mathematics, if I am not able to solve, I will go with signals and systems. In the mathematics as well, you will learn how to solve these kind of questions. But just as you see e to the power j omega something, that means it is coming from signal system only, right? So this is how you can solve it. This is the answer. Okay, now let's see the magnitude and phase spectrum. Actually, this we have already seen. X e to the power j omega will be 1 upon 1 minus 1 by 2 e to the power minus j omega. So what will be its magnitude spectrum and what will be its phase spectrum, that we need to see. So let's just expand it. In place of e to the power minus j omega, I am going to put cos omega minus j sin omega. So I am just expanding it, and then I will find the magnitude. So let's just expand it. So 1 by 2 cos omega minus j sin omega 1 upon one minus 1 by 2 cos omega plus j 1 by 2 sin omega, right? Well and good. Now I can take the magnitude. So mod of x e to the power j omega, although it is not that important. Basically the magnitude spectrum and phase spectrum is not that important, but something good we will conclude. So that's why we are going to see the magnitude and phase spectrum. So can I see the magnitude? 1 upon a plus jb, right? It is a plus jb. So a plus jb, so, that means 1 upon under root a square plus b square. 1 upon under root a square plus b square. So whatever the answer you get, we don't care. It is just we are saying that it is the magnitude, and what will be the phase? Phase will be, so that would be minus tan inverse, because it is 1 by something, so answer would be minus tan inverse b by a. What is the value of b? That is 1 by 2 sin omega divided by 1 minus 1 by 2 cos omega. So whatever that you are getting, we don't care. Basically this is the final expression you are getting. I hope there is no calculation error. So 1 minus 1 by 2, 1 minus 1 by 2, 1 by 2 cos omega, okay, j 1 by 2 sin omega, then simply the magnitude, and this is the answer. Yeah, no issue. So this is the magnitude and the phase. So let's find out what all are the values. So at omega equals to 0, what you will be getting? If you put omega equals to 0 here, e to the power j 0, that would be 1. So what is the magnitude? 0. What is the angle? If you put omega equals to 0 here, sin 0 will be 0 only, tan inverse 0 will be 0 only. So magnitude is 2, angle is 0, right? I just put, although you can put omega equals to 0 here as well. But why would I put omega equals to 0 here? Because I know that if I put omega equals to 0 here, e to the power 0 will be 1 only. So it would be easier calculation for me. So 2 and 0. If I put pi here, what do I see? It will be minus 1. So again easy calculation for me. So 1 upon 1 plus 1 by 2. So answer would be 2 by 3. Right? Here again what will be the phase? Sin pi. What is the value of sin pi? 0. What is the value of sin minus pi? Again 0. So here phase are coming 0, 0, 0 only. So I need to check at some other point as well. Right? Now at minus pi, if I put minus pi here, so e to the power minus j pi, that would be somewhat again e to the power minus j pi, that would be minus 1 only. So again you are getting 2 by 3 here. Here whatever the magnitude you get, I don't care. Although you can calculate the magnitude. What will be cos pi by 3? Cos 60. 1 by 2. So 1 minus 1 by 2. And then here as well you can calculate that. I guess it will be a good value only. So we can calculate. So 1 upon 1 minus cos pi by 3. What is the value of cos pi by 3? Cos 60, right? 1 by 2. So it would be 1 by 4, right? Plus, what is the value of sin pi by 3? What is sin pi by 3? Sin 60. That means under root 3 by 2. So this will be under root 3 by 4 whole square, right? So 1 upon 3 by 4, so 9 by 16 plus 3 by 16. So 1 upon, this is basically under root 16 by 12. So under root 4 by 3. So answer is under root 4 by 3 we are getting. Okay, here as well under root 4 by 3. Let me again check the calculation. So pi by 3 we need to put, here minus pi by 3 we need to put, so this will eat up, everything will be eaten up. So cos pi by 3, 1 by 2, 1 by 4, under root 1 by 4, 3 by 4, so 9 by 16, and then here pi by 3, that means sin 60. So that would be under root 3 by 2, under root 3 by 4, 3 by 4, 3 by 4 plus 9 by 4, 3 by 16 plus 9 by 16. So that will be 12 by 16. So 16 by 12, 4 by under root 4 by 3. Okay, fine. Angle also we can check. Angle also we can check. So if I check the angle, minus tan inverse. Here actually these points I wrote down for angle only, because here angle is coming 0, 0, 0. So you cannot predict the waveform, right? So that's why I put these values. So pi by 3. So sin pi by 3. What is the value of sin pi by 3? Under root 3 by 2. So this will be under root 3 by 4 divided by 1 minus 1 by 4. So that would be 3 by 4. Right. So what you are getting? What you are getting is that 1 by under root 3. So minus 30 degree. So you are getting minus pi by 6. And here I can see that if I put in place of omega, if I put minus omega, then angle will be just negative. So here you will be getting plus pi by 6. Right. So these are the angles, these are the magnitude. Based on that, you can draw the waveform. So this is how your mode of x e to the power j omega will come out. So here in place of 1 upon 1 minus a, I know that what is my answer. Actually, the answer would be 1 upon 1 minus a. Value of a is 1 by 2. So what is the answer? 2. 1 upon 1 minus a, answer is 2 here. So here this answer is 2. And the minimum value will be 1 upon 1 plus a. That means 1 upon 1 plus 1 by 2. So what that value is? That is 2 by 3. Right? So this value is 2 by 3. Now what is the angle here? Here at omega equals to 0, the angle was 0. At omega equals to pi, the angle was 0. At omega equals to minus pi, angle was 0. You can see that at omega equals to 0, pi minus pi, angle was 0. But somewhere in between, the angle was maximum. So at pi by 3, it was, this was actually pi by 3. And this was actually minus pi by 3. So at pi by 3, it was, this angle was minus pi by 6. And you can check here, it was a upon under root 1 minus a square. What is the value of a? 1 by 2. And it would be under root 3 by 2. So 1 by under root 3 it would be. So it would be 30 degree. So this angle will be, minus 30 degree. This angle is pi by 6 and this angle is minus pi by 6. Okay. So this is the scenario. Magnitude and the phase. So this is the scenario. Okay. Now what is the important thing? One thing you can see that it will be periodic. After 2 pi it is periodic only. You can see the waveform from 0 to 2 pi and you can see the waveform from minus 2 pi to 0. It is same, right? So it will be periodic only. So usually what do we do? I told you, whenever you talk about frequency spectrum, there is always some importance of negative frequency as well. Because if x of n is real or if x of n is imaginary, then there will be importance of negative frequency as well. So our area of study will always be between minus pi to pi. Always we will be studying between minus pi to pi. Because we know that after every x e to the power j omega will be repeated. Every frequency spectrum will be repeated. You can see that whatever that is there between minus pi to pi, after that everything is repeated. Here also the same thing. Between minus pi to pi, after that the waveform is repeated. So our area of study will be always between minus pi to pi. Always it will be between minus pi to pi. Say yes or no. So this is the first thing. Now when we were talking about x of omega in continuous time, so this kind of frequency spectrum we got, no, for e to the power minus 80 ut. What kind of frequency spectrum we were getting? It was 1 upon j omega plus a. So frequency spectrum was under root omega square plus a square. So it was somewhat like this. So from 0 to it was till infinity and here minus infinity. It was not periodic. This frequency spectrum was not periodic. It was non-periodic. So our area of study was between 0 to infinity. So in this particular point, if someone asks you what is the minimum frequency, so what you will say? Omega equals to 0. And if someone asks you what is the maximum frequency, what you will say? Omega equals to infinity. In case of continuous time, your x of omega was not periodic. It was going between 0 to infinity. So our area of study was between 0 to infinity. What was the low pass filter? This was the low pass filter. That it will pass till omega c, after that it will not pass. And what was your high pass filter? That it will pass from omega c to infinity. This was your high pass filter. So our matter of concern was from 0 to infinity. So minimum frequency was 0 and maximum frequency was infinity. But in the case of discrete, if I design a digital filter, this was analog filter because of the continuous time. Because of the discrete time, if I design a digital filter, so what will be my minimum frequency? What will be my minimum frequency? That would be omega equals to 0. This is the minimum frequency. Here as well, omega equals to 0 was the minimum frequency. But what would be your maximum frequency? What would be the maximum? This is the minimum frequency. What would be the maximum frequency? That would be omega equals to pi. The maximum frequency will be pi. Why is that so? Because your matter of concern is between 0 to pi only. No, after that the things are being repeated again. Why not 2 pi, sir? Because always we need to take the negative frequency also into action. So matter of concern is between minus pi to pi. So minimum frequency is omega. Minimum frequency is omega equals to 0, and maximum frequency is infinity. Sorry, maximum frequency is pi. Here also, what was the thing? We are also taking consideration negative frequency as well. So we say that this is the minimum and this is the maximum. Right? I have already explained the meaning of negative frequency, so no need to worry about that. So the thing is, our matter of concern is between minus pi to pi. So in case of discrete time, your minimum frequency will be omega equals to 0 and maximum frequency will be omega equals to pi. Is that clear to you? All good? All fine? Okay. So this was the point that I wanted to deliver in this particular discussion. Although we are going to write it down in the form of a conclusion. So we will write it down, but before that you can see this will be the frequency spectrum for minus 1 by 2 to the power n un. Okay, because here a is negative. Previously a was positive. If a was positive, you were getting the different answer. Now if a is negative, you will get the different answer. So what will be its x a to the power j omega? That would be 1 upon 1 plus 1 by 2 e to the power j omega. So you can see that at omega equals to 0, you will be getting 2 by 3. At omega equals to 0, you will be getting 2 by 3. At omega equals to pi, you will be getting 2. At omega equals to minus pi, you will be getting 2. And somewhere in between also you can check. Okay, so this kind of frequency spectrum you will get. All good? All fine? Now we can write down the conclusion. So in case of continuous time, what was your minimum frequency? 0. And what was your maximum frequency? Infinity. In case of discrete time, what is the minimum frequency? 0. And what will be the maximum frequency? Pi. What is s equals to? J omega. So if omega is equals to 0, that means s will also be equals to 0. So your minimum frequency will be 0. And if s is equals to infinity, if omega is equals to infinity, that means s will also be equals to infinity. So in case of continuous time, minimum frequency means s equals to 0 and maximum frequency means s equals to infinity. Is that clear to you? Now come here. If omega is equals to 0, that means z equals to 1. Z is equals to e to the power j omega. If omega equals to 0, then z equals to 1. And if omega equals to pi, that means z equals to minus 1. So when I say I am talking about digital filter, so my minimum frequency, at minimum frequency I will put the value of z as 1, and at maximum frequency I will put the value of z as minus 1. A very important point, a very important table. When I teach digital filter, I will be using this particular table. Okay, we will see digital filter on surface level only, but I will be using this particular table when we study digital filters. So do you need to mug it up? That minimum frequency means z equals to 1, maximum frequency means z equals to minus 1. Do you need to mug it up? No. What you need to do? Okay, minimum frequency, discrete time, omega equals to 0. Z is equals to e to the power j omega. Omega equals to 0 means z is equals to e to the power j0. That means z equals to 1. Maximum frequency, discrete time. That means omega equals to pi. Omega equals to pi. Z equals to e to the power j omega. Z equals to e to the power j pi. E to the power j pi. What is the value of e to the power j pi? Minus 1. So 1 and minus 1. Is that clear to you? Is this table clear to you? So again, I am not going to write it down. You should be able to understand it on your own. Well and good? Okay. So some properties we can see. Although every property, every answer you can write down on your own. So x n plus n naught. This we have seen in the Z transform as well. So e to the power j omega n naught, x e to the power j omega. N by n naught. So x e to the power j n omega naught. Right? What was in case of Z transform? It was z naught to the power, z to the power n naught. So what is z? E to the power j omega n naught. So same thing. Although in case of discrete time, continuous time, what was happening? This was the property. 1 by mod of a x of minus omega by a. So something was coming out. Here something was coming out, but here nothing is coming out. So this is the difference. Okay. And you know that what kind of x n by n naught would be there. you need to interpolate zeros. Here zeros would come, again 0 would come, again 0 would come, in that manner, and always it should be expanded. That means n naught has to be greater than 1, n naught has to be greater than 1, right? So this we have seen in the Z transform. So everywhere when we are going to write down the property, that means we are going to write down that our x of n is being expanded. If x of n is being compressed, that means samples will be cut down, and if samples are cut down, that means it will be a complete different signal. So you cannot build any property for that. So it should be expanded. If it is being expanded, and it should be expanded with zeros only. You cannot put any and random alpha beta. The random alpha beta will have the values of 0 only. So for that particular case only you are having this property. So this property is there, but for a specific case. And what is that case? Which we have already discussed. Now x of minus n. So x e to the power minus j omega. X conjugate n. So x conjugate and then j omega conjugate as well. Basically, what was the property of x conjugate t? That was x conjugate, in place of omega you put minus omega. So don't get confused. When you write down x e to the power j omega, it is nothing but x of omega only. Basically, it is the function of omega only. Are you able to understand this point? Here what I will do, I will put the value of omega only. I am never gonna put the value of e to the power j omega. No, I will always put the value of omega. So x e to the power j omega is nothing but x of omega only. It is just a way to represent it. Why it is the way? Because here z is replaced with e to the power j omega. In the Laplace transform, in the continuous time Fourier transform, s would be replaced with j omega. So that's why you represent it with x of omega, or sometimes you can represent it with x of j omega as well. So even if you represent with x of j omega, that means omega equals to 0 or omega equals to 1 or omega equals to 2 you will put. You will never put j omega equals to something. Always you will put omega equals to something. Is that clear to you or not? Okay. So let's just say like x of e to the power j omega is given as x of e to the power j omega is given as 1 minus 1 by 2 e to the power j omega or minus j omega. So now if I need to find the value of x e to the power j2, what does that mean? In place of omega you need to put 2. So 1 minus 1 by 2 e to the power minus j2. So in place of omega you are putting 2. So you are never going to put the value of e to the power j omega. You will put the value of omega only. This is just a way to represent, nothing else. What about this property? It would be x of n minus, x of e to the power j omega minus omega naught, right? So what do you understand by this? That means you will be giving the left shift of or right shift to the function. What do I mean by that? Let's just say here I ask you, this is a scenario, right? So if I ask you, if I want to apply this property, that means I will multiply with e to the power j omega naught n. So let's just say I multiply this x of n with e to the power j 2n x of n. So what will happen to this graph? The graph will be shifted by 2. What will happen? The graph will be shifted by 2. This graph will be shifted by 2. So better I should have written, let's just say I should have written pi by 2 here. So now the graph will be shifted by pi by 2. So this graph will be shifted here. The center will be coming to pi by 2. Are you able to understand this point? So omega only is getting changed. E to the power j omega is not getting changed. Here you have written x e to the power j omega minus omega naught. That means omega axis will be getting changed. Is that clear to you? So this is nothing but x of omega only. Nothing but x of omega. So you are doing x of omega minus omega naught only. Nothing else. So e to the power j will remain there as it is. Here also e to the power j remains as it is. Omega is replaced with minus omega. Right? Here e to the power j remains as it is. Omega replaced with minus omega. E to the power j remains as it is. Omega is replaced with n omega naught. Here e to the power j omega as it is. E to the power j omega n naught, from your side you are multiplying. Is that clear to you? Okay. So next, n into xn. So what was the property n into xn? That was, let's write down. In case of z transform, what was the property n into xn? I told you to remember that. That was minus z dz upon xz. So what I can do? Minus e to the power j omega dy dz e to the power j omega x e to the power j omega. Can you differentiate this? What you will get? D e to the power j omega. What you will get? E to the power j omega j d omega. Right? So downward what you are getting? J e to the power j omega d by d omega x e to the power j omega, and minus sign is already there. So e to the power j omega, e to the power j omega is getting cancelled. If 1 by j goes upward, then it will go with the negative sign, so it will become plus j. So what you are getting here? Plus j d by d omega x e to the power j omega. Is that clear to you? Do you remember what was the property of t into ft? That was also j d by d omega x of omega. And what was the property of t into ft in case of Laplace transform? That was minus d by ds into x of s. Because in place of s you can put j omega. If j goes upward, that will become plus. Similar thing we are doing here. In place of z we are putting e to the power j omega, e to the power j omega x e to the power j omega. So if I differentiate this particular thing, what I am getting? E to the power j omega outside, d of omega and j also outside. So e to the power j, e to the power j omega comes cancel out, and then j goes upward, it becomes plus j. So plus j d of d omega x e to the power j omega. So plus j d upon d omega x e to the power j omega. This is what you are getting, right? And what about this linearity property? That would be alpha x e to the power j omega plus beta x2 e to the power j omega. And just let me know what will be the DTFT of delta n. What will be the DTFT of delta n? So what was the jet transform of delta n? That was 1. Is it absolutely integrable? Sorry, is it absolutely summable? Delta n is absolutely summable or not? Yes, it is summable. That means its DTFT will also be 1 only. Its DTFT will also be 1, right? Because in place of z you need to put e to the power j omega. Here there is no term of z. So what you will do? Its DTFT will also be 1. So discrete time Fourier transform for delta n is 1 only, right? Let's see this particular topic, which is very important. Fourier transform of a rectangular pulse. So in continuous time, what we were having? This kind of pulse we were having. So we used to call it a rect t minus center upon time width. So what was the answer for this? A2 sampling of omega 2 by 2. Now similar thing we are having here. We are just having these 5 samples. How many samples are there? 1, 2, 3, 4, 5. 5 samples are there between minus 2 to 2. Between minus 2 to 2 you are having 5 samples. So let's just see what answer do you get of x e to the power j omega. So you need to find out the answer for x e to the power j omega. Can I write down my x of n as? It is not periodic, it is aperiodic. Okay, it is aperiodic. So can I write down my x of n as? Sir, it is delta n minus, delta n plus 2, delta n plus 2 plus delta n plus 1, then plus delta of n minus 1, delta of n minus 2. So what I can do is that I can just make it in a good manner only, so that you can relate. Right? So what will be x e to the power j omega? So this would be z to the power 2, right? And in place of z you need to put e to the power j omega. Or what you can think, if delta n is having discrete time Fourier transform of 1, so delta of n minus n naught will have discrete time Fourier transform of e to the power j omega minus n naught. So delta of n plus 2, so e to the power 2 j omega plus e to the power j omega plus 1 plus e to the power minus j omega plus e to the power minus 2 j omega. Is that clear to you? Okay. So can I apply the formula of GP here? So this is the first thing we are getting. This is the x of omega, x e to the power j omega you are getting. This is the first answer. First answer you are getting. But this is not the standard answer. What is the standard answer? Let's see that. Can I apply the formula of GP? Surely you can apply the formula of GP. So A into 1 minus R. What is the value of R? E to the power minus j omega. What is the formula? A into 1 minus r to the power n. What is the value of n? 5. R to the power n upon 1 minus r. Right? Well and good. Okay. Now what I can do is that I can take e to the power minus j omega by 2 common, and from the upper side I will take e to the power minus j 5 by 2 common. Okay, so what I'm gonna do is that this is the x e to the power j omega you are having. Initially here you are having e to the power j 2 omega, and now I am taking e to the power j minus 5 omega by 2 common, minus 5 omega by 2 common. So this is the common part I am taking. So here what I will be left with, this thing minus this particular thing. Say yes or no. Right? E to the power minus j 5 omega by 2 I have taken common. So this is what I will be left with, divided by e to the power minus j omega by 2 I take common. So e to the power j omega by 2 minus e to the power minus j omega by 2. Is that clear to you? All fine? Why I am taking these kind of things common? Because now I can see that this and this is getting cancelled out. Basically what is this? E to the power 2 minus 5 by 2 j omega by 2. What this will be? Sorry, j omega. Basically 2 minus 5 by 2 into j omega. So what you are getting? E to the power minus j omega by 2. Downward as well it is the same. So what is happening? This part is being cancelled. And can I divide by 2j here? Can I divide by 2j here? So what it is? Sine of 5 omega by 2. So what it is? Sine of 5 omega by 2 divided by sine of omega by 2. There you go. This is the answer of x e to the power j omega. We will see the generalized form, but you got to know that I need to write down sine omega by 2, sine omega by 2. And what is this? Number of samples. But important part is it is symmetric about origin. Okay, it is symmetric about origin. So the function is even. If it is symmetric about origin, then only this thing would work. Sine 5 omega by 2 divided by sine omega by 2. So number of samples you will count down. That here it is minus n. If I call it minus n, then this is plus n. So it should be there between minus n to plus n. Just like that, this was between minus 2 by 2 to plus 2 by 2. So it should be there between minus n to plus n. Number of samples, how many number of samples would be there? 2n plus 1. How many samples would be there? The number of samples would be 2n plus 1. How can you tell that? Surely I can tell that. It is very easy to say that number of samples will be 2n plus 1. N samples here, sorry, yeah, n samples here, and 1 sample this one. So 2n plus 1. Number of samples will be 2n plus 1. And you can see that here what is the value of n? N equals to 2. So number of samples are 5. Right? So if you are able to do this particular thing, then you will write down sine of 2n plus 1 into omega by 2 divided by sine omega by 2. So we will write down the conclusion, but as of now you could see the derivation, that how we derived it. Another answer is possible. Although this is very standard, this is the best one, but another answer is possible. How another answer is possible? Let's check that out. So this was your one of the answer, right? Now what I can do? X e to the power j omega, e to the power j2 omega plus e to the power minus j2 omega plus e to the power j omega plus e to the power minus j omega plus 1. So divide by 2, multiply with 2. So x e to the power j omega, that would be 2 cos 2 omega plus 2 cos omega plus 1. This answer could also be there in the options. So all three answers are possible. This is the standard one. Right? If they are asking this question, then surely, this option will be mentioned for sure. This is also one of the possible answer, and this is also one of the possible answer. You know that how I wrote it down. I divide by 2, multiply by 2. So 2 cos 2 omega divided by 2 multiplied with 2. So 2 cos omega plus 1 plus 1. Is that clear to you? All fine, all good. So let's see the conclusion, let's see the general form. So number of samples, if I am saying that number of total samples are 2n plus 1. What I am saying? Number of total samples are 2n plus 1. N samples here, middle 1 sample. So number of samples are 2n plus 1. So what would be your x e to the power j omega? That would be sine, number of samples is 2n plus 1 omega by 2. So this is the angle, this is the complete angle, divided by sine omega by 2. And let's just make it a, the amplitude is a. So if amplitude is a, so here you multiply with a. So this is the answer. Here the amplitude was 1, right? So if amplitude is a, so multiply with a, sine 2n plus 1 omega by 2 divided by sine omega by 2. This is the best possible answer. Okay, other answers are also possible in case of cosinusoids, which we are not going to write down. This would be the answer which you need to remember. In case of continuous time, we also remember a to sine omega by 2. Here what we are going to remember, sine omega by 2, sine omega by 2, just this angle will be multiplied with number of samples. Is that clear to you? What would be the answer for this? You write down the answer on your own. So what would be your x of n? X of n would be symmetric pulse with 15 samples plus delta of n minus 8. Basically here what did I tell you? That sample should be symmetric, no? So it should be there between minus 7 to plus 7. So total number of samples should be 14. So yes, are you getting these 14 samples? Surely I am getting the 14 samples. Oh, 50. Oh, sorry. Samples are 15, no? Between minus 7 to 7, how many samples are there? Plus 7, plus 7, plus 1. So total samples are 15. So are you getting these 15 samples? Yes. So total samples are 15, which is symmetric. So this is our symmetric pulse. But along with that, one delta of n minus 8 is also there. So this delta of n minus 8 is also there. Okay. So what will be the answer? Sine of 15 omega by 2 divided by sine of omega by 2. And what would be the answer for this one? E to the power minus j 8 omega. It could be written as sine of 7.5 omega divided by sine of 0.5 omega plus e to the power minus j 8 omega. This is the answer. Okay. Another answer is possible. What is that answer? X e to the power j omega would be, this is delta of n plus 7. So e to the power j 7 omega. This is delta of n minus 7. So e to the power minus j 7 omega. In that manner it will keep on going. J 6 omega e to the power minus j 6 omega. In that manner it will keep on going. Delta of n will come. Before that, e to the power minus j, sorry, this will throw delta of n plus 1. So it will be e to the power j omega. E to the power j omega. This will throw delta of n minus 1. So e to the power minus j omega. This is delta of n, which will be 1. And this will be your e to the power minus j 8 omega. Is that clear to you? So from here what you get? 2 cos 7 omega plus 2 cos 6 omega plus 2 cos 5 omega plus 2 cos 4 omega, 3 omega, 2 omega plus 2 cos omega plus 1 plus e to the power this. So don't mug up anything. What I am saying, don't mug up anything. In the examination, you will be able to do this process. If this option is mentioned, then you will be able to do the process and write down the final answer. Say yes or no. So do you really think that I will mug up this? Like in some of the notes I have seen that they will mug up a method that from here you pick this thing, and then you write down this particular expression. No, nothing like that. You see the expression, okay, e to the power j minus 7 omega, e to the power j plus 7 omega. So cos 7 omega will be made, which I can write down. So don't remember anything, you will be able to write down everything. This particular thing you can remember. What is that? Symmetric pulse has to be there between -7 to +7. So this symmetric pulse we were getting, so this particular answer we were getting, and then delta of n plus delta of n minus 8 will be different. So e to the power minus j8 omega will be different. Okay, well and good. Let's see the next one. So it is like the triangular pulse, right? It is like a triangular pulse. 3, 2, 1. That's it. Then 0. So here there is no other option I am having. I need to write down x of n in this manner. That it is delta of n plus 2 plus delta of n plus 1 plus 2 delta of n plus 1 plus 3 delta n plus 2 delta of n minus 1 plus delta of n minus 2. So e to the power j2 omega plus 2 e to the power j omega plus 3 plus 2 e to the power minus j omega plus e to the power minus 2j omega. Can you apply any APGP here? No. There is no common factor, no? There is no common factor. You cannot apply any APGP here. So what you need to do? This and this, this and this, and then alone this one. So this will make 2 cos 2 omega. These will make 4 cos omega, right? Because e to the power j omega plus e to the power minus j omega divided by 2 multiplied by 2. So 4 cos omega plus 3. There you go. So this is the possible answer. Okay. Well and good. So no need to mug it up. You can always write down the answer on your own. What about this one? Again, nothing standard. Nothing standard. So try doing it on your, write down the expression on your own. So if there is nothing standard, so what you can see is that x of n is delta of n plus 3. Along with that, I can see that it is minus delta of n minus 3 plus delta of n plus 2. Along with that, I can see that minus delta of n minus 2 plus delta of n plus 1. Along with that, I can see that delta of n minus 1 as well, but not plus, it is negative. E to the power j3 omega minus e to the power minus j3 omega, right? So divided by 2j, multiply by 2j. What I would do? Divided by 2j and multiplied with 2j plus e to the power j2 omega minus e to the power minus j2 omega divided by 2j multiplied with 2j minus j omega divided by 2j multiplied with 2j sin 3 omega plus sin 2 omega plus sin omega. This is your x e to the power j omega. Okay, well and good. One thing you can see here, what it was? What was your x of n? It was real plus odd. So what do you expect? What should be the final answer? If it was real plus odd, do you remember this thing? Similar thing is whatever that you studied in continuous time Fourier transform, whatever that you studied in continuous time Fourier series, the same thing will be reflected in discrete time Fourier transform, the same thing will be reflected in discrete time Fourier series as well. So if it is real plus odd, so what odd will say? That odd remains as it is, but real will be changed to imaginary. And if it is real plus odd, that means it will be conjugate anti-symmetry as well. So odd will change this thing as well, that it will be conjugate symmetry. And you can see here, conjugate symmetry, anti-symmetry you cannot check, but you can surely see here is that this is imaginary 2j and then real part plus odd sin 3 omega odd, sin 2 omega odd, sin omega odd plus conjugate symmetry, which you cannot check but you can check on your own. So it is conjugate symmetry as well, right? Similar thing you can see here as well. What is this? It is real plus even. If it is real plus even, that means it will be conjugate symmetry as well. So what even will say? Even will say that everything will remain as it is. So it will be real plus even plus conjugate symmetry. You can check. Is it real? Yes. It is even? Yes. Conjugate symmetry you can check later on. What about this one? Here you cannot comment anything, right? Because it is real, but it is not even or odd. It is only real. It is only real. And if it is only real, what do you understand from there? For real, What do you understand? That its phase spectrum will be even and angle of positive frequency plus angle of negative frequency, that would be equals to even multiple of pi. Do you remember these things? We will again write it down, but we are not going to derive it now. We are directly going to write down. I hope you remember this thing, that first we see the magnitude spectrum. When we see the magnitude spectrum, we go to know that it is even or odd. Sorry, it is even or not even. If it is even, then it could be real or imaginary. If it is real or imaginary, then we need to check the angle. So if addition of angle is odd multiple of pi, that means it will be imaginary, and if it is even multiple of pi, that means it will be real. So these things we have seen in case of continuous time Fourier transform. The ditto same thing is being reflected here as well, right? So that conclusion we are going to write down, but as of now you understood these things, right? So now we will see the Fourier transform of some other sequences as well. So let's see this sequence and then we can see this sequence as well. Okay, so let me take a break only and then we will start. We will see the Fourier transform of some other sequences as well. So some sequences we need to see, very standard, very easy lecture it is going on, right? These sequences we will see and then we will see the nature, real plus even, all these things we have already seen, right? And then we will see this kind of thing, that if magnitude spectrum is even or not even, what will happen. So everything we are going to discuss, but let me take a pause, let me take a break, drink some water and then I will come back. You can also do the same. Yeah, welcome back. So continuing the last lecture only, we are going to see the Fourier transform of some standard sequences. So this is the continuous time signal, no? This is xt equals to 1. Xt equals to 1, it is a continuous time signal. So what was the x of omega for this one? Do you remember? What was the continuous time Fourier transform for this one? That was, x of omega was 2 pi del omega, right? So you are having a impulse of area 2 pi at origin. Impulse of area 2 pi at omega equals to 0, right? Now do you remember the sampling theorem? If you sample, if I am sampling it with respect to nts, if I sample any continuous time signal with respect to nts, then what will happen? We will get its clone, we will get its clone centered at every omega s, right? We will get its clone centered at every omega s. And these clones will be infinite. So what we are doing, we are just getting the same clone centered at omega s, omega s, 2 omega s, minus omega s, minus 2 omega s, in this manner. But if you need from x of t, if you need x of n, from here what you are getting, x of n ts. If you need x of n, that means you need to put ts equals to 1, right? You need to put ts equals to 1 second. And if ts is equals to 1, that means what is the value of omega s? That would be 2 pi. Omega s value will be 2 pi. If ds is equals to 1 second, that means omega s value will be 2 pi. So what you are doing, you are calculating the sample after every 1 second. What you are doing, you are calculating the sample after every 1 second. That means the clones you will be getting after every 2 pi. That means basically this 2 pi will be repeated after every 2 pi only, and which we have already seen, because we know that our x e to the power j omega will always be periodic with 2 pi, but it will be periodic with 2 pi if you are seeing x of n. That means if you are sampling it, with respect to 1 second. So after every 1 second I am calculating the sample. So this is the x of n I am getting. Can I write it down 1 to the power n, which is equals to 1 only? 1 to the power n will be equals to 1 only. Here n will be integer 1, then n equals to 1, 1, n equals to 2, 1, n equals to 3, 1, n equals to minus 1, 1, n equals to minus 2, 1, n equals to minus 3, 1, 1, 1. Always it will be 1, 1, 1. So x of n is equals to 1 to the power n, which I can write down as 1 only. And what will be its discrete time Fourier transform? So its discrete time Fourier transform is 2 pi del omega only, but it is periodic with 2 pi. So can I write it down in this manner? The discrete time Fourier transform is 2 pi del omega with periodicity of 2 pi. That means this L value will be going from, I will write it down again. So it is 2 pi del omega only, 2 pi del omega, but it is periodic with 2 pi. That means I will be having impulses of area 2 pi at 2 pi, 4 pi, 6 pi, minus 2 pi, minus 4 pi, minus 6 pi, minus 8 pi, and so on. So here I can write down L goes from minus infinity to infinity. Here your L goes from minus infinity to plus infinity. So you are having the impulses of 2 pi after every 2 pi duration. Is that clear to you or not? So what is the Fourier transform of 1 to the power n? So discrete time Fourier transform of 1 to the power n is 2 pi del omega only, 2 pi del omega only, but it is periodic with 2 pi, where L goes from minus infinity to infinity. What about e to the power j omega naught n, which is being multiplied with 1 to the power n? 1 to the power n is 1 to the power n only. 1 to the power n is 1 only. So do I need to show it? No. So basically 1 to the power n is being multiplied with e to the power j omega naught n. So what you will be getting? You will remember the property, right? X of n is having x e to the power j omega. So e to the power j omega naught n, x of n will have x e to the power, in place of omega you put omega minus omega naught. So in place of omega you need to put omega minus omega naught. So basically from where it would have come? It would have come from e to the power j omega naught t. So e to the power j omega naught t will be having a Fourier transform of 2 pi, having an impulse of 2 pi at a frequency omega naught. So what will happen? Now this impulse will be periodic with 2 pi. So second impulse will be there at 2 pi plus omega naught, then 4 pi plus omega naught, then 6 pi plus omega naught, then minus 2 pi plus omega naught, minus 4 pi plus omega naught, in that manner. So impulses will be there with the periodicity of 2 pi. Is that clear to you? So if you know that continuous time Fourier transform of a continuous signal, then can you write down the discrete time Fourier transform? Surely, very easily I can write down the discrete time Fourier transform. What I need to do is that whatever the waveform that I was having, that would be periodic with 2 pi. That's it. Okay, well and good. So 2 pi, L goes from minus infinity to infinity, del of omega plus omega naught minus 2 pi L. So what do you think, what will be the Fourier transform of cos omega naught n? So what will be cos omega naught n? That will be e to the power j omega naught n plus e to the power minus j omega naught n divided by 2. So this will be equals to pi. 2 pi would be there, 2 pi will be common, so 2 is getting cancelled, so pi here, L goes from minus infinity to infinity, delta of omega minus omega naught minus 2 pi L plus delta of omega plus omega naught minus 2 pi L, where L goes from minus infinity to infinity. So basically what is happening here? Cos omega naught n. So what you will think? In your mind you will think it is cos omega naught t only. What you will think? Sir, in my mind I will think that it is cos omega naught t only. So what will be its x of omega? That will be that you are having a impulses of area pi. You are having a impulses of area pi at minus omega naught and plus omega naught. Now one thing I know that it will be periodic with 2 pi. So that means the center will move to 2 pi. So 2 pi minus omega naught. Basically this minus omega naught plus 2 pi. This point will be minus omega naught plus 2 pi, and next point will be omega naught plus 2 pi. This point will be minus omega naught plus 2 pi, and this center will be 2 pi, and next point will be omega naught plus 2 pi. Is that clear to you? So in my mind I am thinking of cos omega naught t. In my mind I am thinking of cos omega naught t with the impulses of area pi at minus omega naught and minus omega naught and plus omega naught. Then what I am doing? I am sampling it with respect to 1 second. If I am sampling it with respect to 1 second, that means whatever the x of omega I am getting, I will get its clone with the periodicity of 2 pi. Is that clear to you? So minus 2 pi here with the periodicity of 2 pi. So minus 2 pi minus omega naught, minus 2 pi minus omega naught, and this point will be minus 2 pi plus omega naught. Is that clear to you? So center has moved to minus 2 pi, and in that manner it will keep on repeating. In that manner it will keep on repeating. So this kind of x e to the power j omega you will get. But your area of study will always be between minus pi to pi. So where will be minus pi? Somewhere I am saying that minus pi is here, and somewhere I am saying that plus pi is here. So let's take up example. Now the example is cos 2 pi by 3 n. So first what I will be thinking? I will be thinking this thing only, that it is cos 2 pi by 3 t. So if it was cos 2 pi by 3 t, what I would know that I will be having a impulses of area pi at minus 2 pi by 3 and plus 2 pi by 3. Now what will happen? This will be periodic with 2 pi. This will be periodic with 2 pi. That means what will happen is that this center will move to 2 pi. So 2 pi minus 2 pi by 3. 2 pi minus 2 pi by 3. So this point will be 4 pi by 3. This point will be 4 pi by 3. Right? And then 2 pi plus 2 pi by 3. So next point will be 8 pi by 3. So area is pi and pi. Then it will keep on repeating like this. And here as well, minus 2 pi by 3, basically this center will move to minus 2 pi. This center will move to minus 2 pi. So minus 2 pi plus 2 pi by 3. What will happen? Minus का 4 pi by 3. Minus 4 pi by 3. So this point is minus 4 pi by 3. And minus 2 pi minus pi by 3, the point will be minus 7 pi by 3. Minus 7 pi by 3. So in that manner it will just keep on repeating. Right? Okay. So here what will be this point and what will be this point? 2 pi by 3, 4 pi by 3. So this point will be pi. And minus 2 pi by 3 minus 4 pi by 3, this point will be minus 2 pi. So always our matter of concern will be this much area. Always I will be concerning about this much particular my Fourier transform, x e to the power j omega, because I know that after that it will be just periodic with 2 pi. So negative frequency I need to take minus pi to 0 and then 0 to pi. So this much area I will be always interested in. Is that clear to you? Now what if someone will say that, sir, what if frequency is greater than 2 pi? So actually frequency will never be greater than 2 pi. If you see it closely, what it is? Cos 2 pi n plus 2 pi by 3n. 6 plus 2, 8 pi by n. So this is this thing, and which is equals to cos 2 pi by 3n. That means this will be its discrete time Fourier transform. So for this particular signal and for this particular signal, both are having the same discrete time Fourier transform. Both are having the same discrete time Fourier transform. So whenever you feel like that, sir, frequency is coming greater than 2 pi, that means you need to solve it. When I solved it, I got to know that these both are the same function. If both are the same function, then both will have the same discrete time Fourier transform. Is that clear to you? So consider this as a continuous time only. Make the impulses, and then you know that these impulses will be repeated with 2 pi. That's it. Similar thing we did with 1 to the power n as well. So make the impulse, consider it as a continuous time only, make the impulse, then these impulses will be repeated. Well and good. Okay, let's see this one. Now someone may have a doubt that, sir, why we did not do the same process here? For this rectangular, what we were getting? Sampling of omega tau by 2, right? This was a rect t by tau. So a tau sampling of omega tau by 2. So what it would be? Sine of omega tau by 2 divided by omega tau by 2. So what kind of graph you will get? This kind of graph you will get, right? And if I sample it with 1 second, if I sample it with 1 second, so what I will be getting? These kind of sequences I will be getting, these kind of samples I will be getting. Let's just say I am getting 5 samples. So what I would do, I will make this waveform, then I will make it periodic with 2 pi, then I will make it periodic with 2 pi as well. Basically the center will move to 2 pi now. The center will move to 2 pi. Center will move to 2 pi. Then center will move to minus 2 pi as well. Then center will move to 4 pi, right? Then center will move to minus 4 pi as well. And then all the waveform you need to add. What you need to do, all these waveform you need to add. This one which is having center at 0, this one which is having center at 2 pi, center at minus 2 pi, center at 4 pi, center at minus 4 pi, center at 6 pi, center at minus 6 pi, and all of them you need to add. So when you add all of them, then this is the answer you will be getting, sine 5 omega by 2 divided by sine omega by 2. So there I cannot apply this method, but here what is the issue? Here what is the advantage we are having? Here we are having the impulses. Here we are having the impulses. So actually what we did here what we did, that first I was having the impulses at minus omega naught and omega naught. I was having impulses at minus omega naught and omega naught. Then I was having impulses at minus omega naught. Then I was having the impulse at minus 2 pi plus omega naught, and then minus 2 pi minus omega naught. I was having impulse at minus omega naught plus 2 pi. I was having impulse at omega naught plus 2 pi. So when I add all of them, nothing is superimposing. Here what was happening? These waveforms were getting superimposed. So if these waveforms are getting superimposed, then you don't know what kind of waveform you will get after the addition. But here you know that first I will make centered at 0, then I will make centered at 2 pi, then I will make centered at minus 2 pi, then I will make centered at 4 pi, then I will make centered at minus 4 pi. So when I add all of them, nothing will be superimposed. But here the problem was, it was getting superimposed. If someone asks you, this is my time domain signal and you need to sample it, so what will be your Nyquist rate? What will be the answer? This is my time domain signal and you need to sample it. What will be your Nyquist rate? So what was the formula of Nyquist rate? 2 into f max, right? 2 into f max. What is the f max here? If you find the frequency spectrum of this particular graph, this was the frequency spectrum. So what was the f max? F max was infinity. That means it was going from 0 to infinity. If I make this particular signal, so what is the f max? This is the f max. If I make this particular signal, what is the f max? This is the f max. If I make this particular x of omega, this was x of omega, this was also x of omega. If I make this x of omega, this is the time domain signal. When I go to the frequency domain, what kind of maximum frequency I am getting? Infinity. So your Nyquist rate should be infinity, which is not possible. So you are sampling at 2 pi, 4 pi, minus 2 pi, minus 4 pi, and then you are adding up. That means surely there will be some aliasing. 100%. In case of rectangular function, if you sample the rectangular function, 100% there will be aliasing. 101% there will be aliasing. And if there is aliasing, what does that mean? That means you cannot add them. You will not get to know that what will be your final expression after adding them. Actually, the final expression came out to be like this. So this doubt someone can have, that sir, why we were doing something else previously and why we are doing this particular thing now. So here the point is, here things are in the form of impulses, and when you add the impulses, there is no superimposition. And if there is no superimposition, then very easily you can write down the answer in this manner. Is that clear to you or not? Okay. So never ever there would be superimposition. If there are no superimposition, then you can write down the answer very easily in this manner. Okay. So for basically for periodic signal, we are seeing this particular thing. For which signals? Periodic signals. Because you know that sine omega naught n is periodic, right? Cos omega naught n is periodic. This 1 to the power n is periodic. This is also periodic, right? Periodic plus discrete. What is this? This is also periodic plus discrete. This is also periodic plus discrete. Periodic with omega naught frequency. Periodic with omega naught frequency. This is also periodic plus discrete. So for all those periodic signal, you can apply this concept, that first I will consider it as a time domain signal. Then I will see that what kind of frequency spectrum I was getting, and then what I would do is that I will sample it at 1 nanosecond. Sorry, I will sample it at 1 second. If I am sampling it at 1 second, that means omega s value will be 2 pi. So my frequency spectrum will be periodic with 2 pi. Is that clear to you? All good, all fine. A very, very good concept we have seen. But in case of aperiodic signal, you know that you will not be getting impulses. In case of aperiodic signal, you will be getting the frequency spectrum from 0 to infinity. And if you are getting the frequency spectrum from 0 to infinity, then it will be tough for you, right? Because you cannot add them up. So for that, we have built up these formula. These formula we have built up, sine of a number of samples divided by omega by 2, sine omega by 2. And previously we have seen some other example as well, like a to the power n un, a to the power n u of minus n minus 1. So these kind of example also we have seen. And then a to the power mod of n, right? That example also we have seen. So here we were. So what will be the discrete time Fourier transform of sine omega naught n? So that doubt could be there in some of the students, so that's why I cleared it. So what we will have? We will have the minus pi by j and plus pi by j at minus omega naught and at plus omega naught, right? You remember this thing, right? Minus pi by j and plus pi by j, and then this center will move to 2 pi. Center will move to 2 pi. Center will move to 2 pi. So this is 0, 2 pi, 2 pi minus omega naught, 2 pi plus omega naught, minus pi by j, plus pi by j, here also minus pi by j, plus pi by j, here 2 pi, sorry, this is minus 2 pi, so minus 2 pi plus omega naught, minus 2 pi minus omega naught. Okay, and in that manner it will keep on repeating. What about this sine 3 pi by n? Sorry, sine pi by 3n. So sine pi by 3 minus pi by 3, centered at 2 pi. So 2 pi minus pi by 3 and 2 pi plus pi by 3, and centered at minus 2 pi. So 2 pi minus 2 pi minus pi by 3 minus 2 pi plus pi by 3. Right? So minus 2 pi plus pi by 3. So what you will get? Minus 5 pi by 3. Minus 7 pi by 3. This is 7 pi by 3. This is 5 pi by 3. Okay, this is your sine pi by 3n, right? And it will be keep on repeating. What about sine 80 by pi t? So what was its frequency spectrum? What was the frequency spectrum in case of continuous time? That was minus a to a and then rectangular function, right? Sine 80 by pi t. So it was between minus a to a with the amplitude of 1. This was your x of omega. So what will be its discrete time Fourier transform? So what I am considering that a is less than this width, this particular width. Basically what I need to do, I know that I need to repeat it, because what I am doing, I am sampling it at 1 second. I am sampling it at 1 second. That means my omega s is 2 pi. My omega s is 2 pi. So what I need to do, I need to repeat it. So I am repeating it, nothing else, I am just repeating it. Minus a to a, whatever the waveform that you are having, that will be repeated. But value of a you don't know, no? Right? You don't know the value of a. So what you are doing, you are just repeating it. So it will just keep on repeating this side as well and this side as well. So this is 0, this is plus a, this is minus a, centered at 2 pi. So 2 pi minus a and 2 pi plus a. Here as well, minus 2 pi plus a and minus 2 pi minus a. Okay. Yeah, so here what I can see is that my a should be less than 2 pi minus a, because if it is greater than, there will be superimposition, no? My a should be less than 2 pi minus a, right? That means my a should be less than pi. So here the condition is given that your a is less than pi. What if, sir, what if it is greater than pi? We will see that example, don't worry. What if the value of a is greater than pi? We will see that example, don't worry about that. What will happen then? There will be superimposition, that means you need to add them up, nothing else, right? What if this a is greater than pi? Then what will happen? Again it will be repeated only. Whatever the sample you get, whatever this thing you are getting, that will be repeated with 2 pi only. But what will happen there? There it will be superimposing. So you need to add the superimposition. That's it. So we will see those examples. Don't worry about that. Right? So as of now, you got to know that sine an upon pi n. What will happen? Whatever the same waveform that you are having between minus a to a, that will be repeated with 2 pi. That would be the answer. Is that clear to you? Now sine 80 by pi t square. What was the answer for this? It was there between minus 2a to 2a with the amplitude of a by pi. With the amplitude of a by pi. Right? This was your continuous time Fourier transform. This was your x of omega. So what will be your x e to the power j omega? Here did I write down x e to the power j omega? No. So this will be your x e to the power j omega versus omega, and amplitude is 1 only. But here the amplitude is a by pi. So what will happen? This particular thing will be repeated. This particular thing will be repeated. This side as well, and the opposite side as well. Centered at minus 2 pi, centered at plus 2 pi. So 2 pi minus a. So here we are learning nothing but just sampling, nothing else. It is just sampling, nothing else. Oh, sorry. 2 pi minus 2a. 2 pi minus 2a. And here 2 pi plus 2a. Here minus 2 pi minus 2a minus 2 pi plus 2a. So you can see that 2a should be less than 2 pi minus 2a. Right? That means a should be less than pi by 2. A should be less than pi by 2. Okay, this is the condition. Sir, what if it is greater than that? We will see example. Don't worry about that. Okay, we will see the example. Don't worry about that. Less than or equals to. Because if it is equal, then also there will not be any aliasing. No? If it is equal, then also there will not be any aliasing. Right? Let's see this thing. We will see the example. Don't worry about that. Examples will come in this lecture or in the next lecture. So, or should we see it now? Because we don't have much space left. In a particular slide, I can fit in only 50 slides. So I cannot add the page now. So we will see the example when we study about multiplication and convolution theorem. So at that time we will see the example. We will take the different values of A and we will see what kind of a frequency spectrum we get. So don't worry about that. Examples will come. But as of now, you understood what we are doing. What we need to do, whatever that is there, just copy it and then make the clones. Copy it, make the clones. Clones with the periodicity of 2 pi. Right? Let's start this one. This thing we have already seen. If your x of t or x of n is real plus even, then now what we are going to see? We are going to see for everything. What is this? Continuous time Fourier transform. What is this? Discrete time Fourier transform. What is this? CTFS. And what will be this? DTFS, which we are going to study in the next lecture. Sorry, in the next chapter. So CTFT, DTFT, CTFS, DTFS, for everything it will work. So if your x of t or x of n is real plus even, so good guy plus good guy, what it will make? Conjugate symmetry. And if it is even, then everything remains as it is. Who is the deciding guy? Deciding guys are even, odd, even, odd. So real plus odd, good guy plus bad guy, conjugate anti-symmetry. If it is odd, it will change everything. Imaginary plus odd plus conjugate symmetry. Right? Imaginary plus even, bad guy plus good guy, conjugate anti-symmetry. If it is even, it will not change anything. Bad guy plus bad guy, good guy. If it is odd, it will change everything. There you go. These are the answer which will work for everything. Whether it is x of omega, x e to the power j omega, c of n, c of k. All good? All fine? Let's go to the next one. So if frequency spectrum is given, like they can draw the graph of mode of c of k as well, or they can draw the graph of mode of c of n as well. They can draw the graph of mode of x of omega, x of j omega as well. They can draw the graph of mode of x e to the power j omega as well. Right? Or what they can do? They can draw the graph of angle of ck as well, angle of cn as well, angle of x e to the power j omega as well, and angle of x e to the power j omega as well. So now we need to comment on real or imaginary or complex. right? So what we will do, first we will see at the magnitude spectrum. So if this is the magnitude spectrum, mode of x of omega, mode of x e to the power j omega, mode of c and mode of ck. This we have seen in a very great detail. So magnitude spectrum could be of two type only. Either it will be even or it will be not even. Either it will be even or it will be not even. If it is not even, what does that mean? That means your x of t slash x of n is surely complex. So everything ends here. Nothing you need to check. If it is not even, everything ends here. X of t or x of n is complex. There you go. Now if it is even, then x of t or x of n could be real or imaginary. Real or imaginary. One of the answer is possible. It could be real or imaginary. Derivation and everything we have seen for x of omega, but it will work for x of e to the power j omega as well, cn as well, c of k as well. So it could be real or imaginary. Now whether it will be real or imaginary, for that what we will do? We will go to the angles. So another graph would be made, that would be of angle. Angle could be anything. Angle of x of omega, angle of x e to the power j omega, angle of cn, angle of c of k as well. Now what we will do? We will see the angle at positive frequency, we will see the angle at negative frequency. Then we will add both of these angles. If the angle, addition of angle is coming out to be even multiple of pi, even multiple of pi, or if it is coming out to be odd multiple of pi. So if it is coming out to be even multiple of pi, that means your x of t or x of n, your x of t or x of n is real. And if it is coming out to be odd multiple of pi, that means your x of t or x of n is imaginary. There you go. Okay, understood? So first we will see the magnitude spectrum. If it is even, then it could be real or imaginary. If it is not even, that means surely it is complex. Then we will go to the angle. Addition of angle at positive frequency and negative frequency is coming out to be even multiple of pi. That means it will be real. Otherwise, if it is coming out to be odd multiple of pi, then it will be imaginary. And if it is not coming out to be neither odd multiple of pi, neither even multiple of pi, then it will be complex. But complex will end here only. So you don't need to go downward. Because if this is the condition, that if magnitude spectrum is coming out to be even, that means surely one of the condition will be satisfied for sure. No doubt about it. Is that okay for you? Is that clear to you? Okay. Now condition on real and imaginary we have seen. This was the condition on real and imaginary. Similarly, there is a condition on even and odd as well. What if your x of t is even, or what if your x of n is even? So that condition is also there, which I forgot when we were studying about continuous time Fourier transform. At that time only this topic should have been taught, but I forgot there. So that's why I am teaching it here now. So if x of t is even, what do you know? That x of t would be equals to x of minus t. So can I write down x of omega will be equals to x of minus omega? So whatever the thing that you are going to derive for continuous time Fourier transform, the same thing will be applicable for discrete time Fourier transform as well, DTFS as well, and CTFS as well. So I will only derive for CTFT. So whatever that I derive for CTFT, that will be applicable for DTFT, DTFS and CTFS as well, right? So what I can write down? Mode of x of omega, angle of e to the power j, angle of x of omega. And here what I can write down? Mode of x of minus omega, e to the power j, angle of x of minus omega, right? What I can write it down as e to the power j 2n pi plus angle of x of minus omega. Right? So what I can see here, this and this. What you are getting? Magnitude spectrum even, right? Again you are getting magnitude spectrum even. Magnitude spectrum even. And second thing, what you can see, angle of x of omega is equals to angle of x of minus omega plus 2n pi. And can I write down angle of x of omega minus angle of x of minus omega is equals to 2n pi. That means previously what we were doing the addition here. Now what we are going to do, we are just going to do the subtraction. So angle at positive frequency minus angle at negative frequency. should be equals to the even multiple of pi, then it will be even. Otherwise, it will be odd. So for odd as well, we can derive the condition. X of t is equals to minus x of minus t. So x of omega is equals to minus x of minus omega mod of x of omega is equals to e to the power j angle of x of omega. Here what I can see is that, can I write it down in this manner? So let's keep, what we do is that, let's keep it a bit upward, and what I am doing, I am keeping x of omega only as this. Now x of minus omega can be written as e to the power j 2n plus 1 pi, because of the negative sign, right? There is a negative sign, no? So because of the negative sign, I can write down 2n plus 1 j pi, because what it will be, j 2n pi plus e to the power j pi. So this will be minus 1 and this will be plus 1. So we are getting the same thing, right? So here mod of x of omega e to the power j angle of x of omega mod of x of minus omega e to the power j angle of x of minus omega plus 2n plus 1 into pi, right? This angle was already there. So what I can see, mod of x of omega is coming out to be mod of x of minus omega. Magnitude spectrum E1, and here angle of x of omega is equals to angle of x of minus omega plus 2n plus 1 pi. Now someone will say that, sir, here you added 2n pi, so here also you should add 2n pi. If I add, then there is no meaning of that. 2n pi plus 2n pi will be 4n pi, that means again it will be odd multiple of pi. Sorry, again it will be even multiple of pi. So it will be, basically if I add 2n pi plus 2m pi, what it would be equals to 2k pi. So even multiple of pi, even multiple of pi, even multiple of pi, right? So I don't need to add 2n pi again. Here only I added, no, 2n pi plus pi. So the job is done here. So what you can see here, angle. So what you will do, you will see the angle at positive frequency, you will see the angle at negative frequency, and you will subtract them, and if it is coming out to be odd multiple of pi, then x of t is odd. Is that clear to you or not? Very simple thing. Whatever that we have seen for this particular slide, the same slide we are going to see here as well. So whatever the condition that I derived for x of omega, the same condition will work for x e to the power j omega as well, cn as well, ck as well. So first what we will see the magnitude spectrum. It could be even or not even. If it is not even, that means it will be neither even nor odd. Neither even nor odd. If I show that, basically what is neither even nor odd? Your xt or x of n. Your xt slash x of n is neither even nor odd. Now I have seen it to be even. The magnitude spectrum is even. If the magnitude spectrum is even, that means your x of t or x of n could be even or it could be odd. Even or it could be odd. Now I need to differentiate between even and odd. So what I will do, I will go to the angle. So angle at positive frequency minus angle at negative frequency. Or you can do angle at negative frequency minus angle at positive frequency. Basically the job is that it should be coming out as even multiple of pi. Even multiple of pi. And if it is coming out to be odd multiple of pi, odd multiple of pi, it should be even multiple of pi. If it is even multiple of pi, what does that mean? That means here your x of t slash x of n, if it is even multiple of pi, that means it will be even, and if it is odd multiple of pi, then it will be odd. So what is the difference? The only difference is this negative frequency, this negative sign. Here you are doing the subtraction and here you are doing the addition. Is that clear to you? Everything is still ditto same. The same slide is copied, starting with the magnitude spectrum. If it is coming out to be even, that means your x of t or x of n could be even, odd, real or imaginary. 4 things could be possible. If your magnitude spectrum is coming out to be even, then 4 things are possible: even, odd, real or imaginary. Then you will go to the angles. First you will add the angle. If addition of angle is coming out to be even multiple of pi, addition of angle, that means it is real. If it is coming out to be odd multiple of pi, that means it is imaginary. Now if subtraction of angle, if subtraction of angle is coming out to be odd multiple of pi, subtraction of angle is coming out to be odd multiple of pi, that means x of t or x of n is odd. And if subtraction of angle is coming out to be even multiple of pi, that means it will be x of t or x of n will be even. Is that clear to you? Is this concept clear to you or not? A very, very straightforward and a very simple concept, right? And a very important concept as well. So this kind of question could be coming, that the graph of x e to the power j omega is given between minus pi to pi only, because it will be periodic after 2 pi, right? It is given between minus pi to pi. After that, it will be periodic only, no? So that's why they have given it between minus pi to pi, and angle also they have given it between minus pi to pi. So what you can see, this is even. If it is even, what does that mean? That means your x of n is having 4 probability. It could be real or imaginary, or it could be even or odd. Now I went to the angle. So first I will add up the angle. So angle at positive frequency. Now the thing is, someone will say that, sir, here the angle is 0 and here also the angle is 0. So 0 plus 0. No, what I will do is that I will add the angle only the point where it is non-zero. So magnitude is non-zero between A to B. Magnitude is non-zero between minus A to minus B. So I will only add up the angle of A to B only. So when I say I am adding up the angle at a positive frequency, that means I am looking at A to B only. Because here this is 0, this is also 0, so everything will be 0. 0 with the angle 0 would be 0. 0 with any angle, let's just say my magnitude is 0, e to the power j, any angle is there, I don't care, it would be equals to 0 only. So whatever that is 0, that is not the deciding factor. Whatever that is non-zero, that is the deciding factor. So here I will look the magnitude here and the angle here. What is the angle here? At positive frequency the angle is 0, plus I will look the magnitude spectrum here and angle here. That means it is between minus A to minus B, right? So what is the angle? 0 plus minus pi, 0 plus minus pi, minus pi plus pi, both are the same thing only. So it is odd multiple of pi. So what does that mean? That x of n is imaginary. Here this was the addition. If I do the subtraction, what I will get? Positive angle minus the negative angle. So 0 minus pi, so it will be pi only. So again it is odd multiple of pi. Right? So who won here? This was imaginary. That means now who has won? If the subtraction is coming out to be odd multiple of pi, subtraction is coming out to be odd multiple of pi, that means it is odd. So x of n is imaginary plus odd. Imaginary plus odd. What else you can comment? What you can comment is that now x of n is imaginary plus odd. So bad guy plus bad guy, conjugate symmetry as well. Now x e to the power j omega. Now I am commenting on x e to the power j omega directly, not on the magnitude spectrum, not on the phase spectrum. What will be x e to the power j omega? So odd will change everything. So it will be real. You can see that it is real only. Magnitude is real, real. Here the phase is minus pi. Minus pi means, what is the meaning of minus pi phase? That means whatever the positive you can see, that will become negative. Whatever the positive you can see, that will become negative. So it is real only. Along with that, it is odd only. Odd will say that I will remain as it is, rest of thing I will change. So odd, real plus conjugate anti-symmetry. There you go. This is the conclusion. You have made the comments on x of n and x e to the power j omega as well. Is that clear to you? Did you understand how we will comment on the nature of x of t or x of n with the help of any frequency component, any frequency spectrum? It could be DTFS, it could be CTFS, it could be DTFT, it could be CTFT. Say yes or no. A very good point we have understood, a very good topic we have understood in a very, very easy manner. And you are not going to find out this particular topic in any notes. Okay. So this is there in our notes only, and I am hoping that one good question could be coming from this particular topic in near future. any soon. Now we will see the differentiation property. So should I take a break? So let's see the differentiation property in case of continuous time. What it was? J omega x omega. So here if it is x e to the power j omega, so what you will be getting? X of n will be x e to the power j omega only, minus x of n minus 1 e to the power minus j omega x e to the power j omega. So from here you can see that it is equals to 1 minus e to the power minus j omega, right? So I told you in case of Z transform, the S and 1 minus Z inverse were identical. They were identical, they are not equal, they are identical. So here j omega is identical to 1 minus e to the power minus j omega. They are just identical, nothing else. They are identical. So what is the Fourier transform of ut? That is continuous time Fourier transform. That is 1 by j omega, 1 by j omega plus pi del omega. That means 1 by j omega. This kind of thing would be there, 1 by j omega. But you are having an impulse of pi at omega equals to 0. So what will happen? Here, what will be its discrete time Fourier transform? So again you are sampling at t equals to 1 second. Again you are sampling at 1 second. But what will happen is that this j omega will be turning into, what is this? Is it absolutely summable? Is it absolutely integrable? No. Is it absolutely integrable? No. Is it absolutely summable? No. Still we are finding out its Fourier transform. So there I told you some method we are going to use, some method we have used by applying the differentiation property or some property, we got this answer. First we differentiated it, then we say that ut is having a dc value as well. So 1 by 2 plus dc value of ut, that would be pi del omega. So dc value of ut was 1 by 2. So 1 by 2 into 2 pi del omega, so pi del omega you will getting. So in the similar manner you apply some method and you get the final answer of un. But I am not going to teach that particular method. I am just going to tell the final answer, that how you can remember the final answer. So un is having a Fourier transform of what? So you remember the Fourier transform of ut. And I told you j omega is identical to 1 minus e to the power minus j omega. And one thing you know, that whatever the impulse that is this guy is having, that will be repeated. Whatever the impulse this guy is having, that will be repeated with the periodicity of 2 pi. So what you will write down? Pi del omega only, pi del omega only, but it will be repeated with the periodicity of 2 pi. So L goes from minus infinity to infinity. So even though it is not absolutely summable, still we can find out its discrete time Fourier transform. We are not learning the method. What we will do is that we can find out the discrete time Fourier transform for ut. If I can find out the discrete time Fourier transform for, continuous time Fourier transform for ut, then j omega will simply be replaced with 1 minus e to the power minus j omega, right? Plus whatever the impulse is there, whatever the dc value is there, that will be repeated with the 2 pi period. So pi del omega minus 2 pi L, L going from minus infinity to infinity. Very simple, right? Now discrete time Fourier transform of any periodic signal. What we used to do in case of continuous time? What we used to do? First we used to make the graph of Cn. Right? Then what I used to tell? That in case of n, what you need to do? Omega naught, 2 omega naught, minus omega naught, minus 2 omega naught, and so on. These sequences will become impulses and it will be multiplied with 2 pi. N goes to omega, that means this will be omega naught, minus 2 omega naught, minus 3 omega naught, right? These sequences will become impulses and all the impulses will be multiplied with the 2 pi. Similar thing we are going to do here. So what we are saying, that your x of n is a periodic signal with the period 6 and these values are given. C0 is 2, C1 is minus 3j, C2 is 0, C3 is minus 2, C3 is 2j, C4 is 0 and C5 is 2. So is this graph of CK fine? No. You know that CK is periodic. In the basics we have seen that CK will be periodic. That means what will be the value of C6? C6 will be equals to C0, that will be equals to C of minus 6, that will be equals to C of 12, C of minus 12. That means it will be there for complete till infinity and here also till minus infinity. Is that clear to you? So what will be your C6? C6, that will be, C6 will be this 2 only. So what do you mean by this 6 in case of frequency? So in case of frequency, this will be 6 omega naught, right? Here what is the value of n naught? N naught value is 6. What is the value of omega naught? That would be 2 pi by 6. So what this would be? 6 omega naught will be equals to 2 pi. So in case of frequency, this will be actually 2 pi only, and it should be 2 pi because our x of e to the power j omega will be periodic with 2 pi. What I am saying, this is the ck graph, this is the c of k graph which I have drawn. That means it will be periodic. C0 will be C6. Now in case of frequency, in case of omega, because next what we are going to draw, we are going to draw, this is the ck, what we are going to draw, we are going to draw x e to the power j omega. What we are going to draw? X e to the power j omega. So I know that ck will be repeated from 0 to 5, whatever that is there, that will be there between 6 to 11 as well. So this will be 0 only in case of frequency. This will become omega. This will be omega naught. This will be 2 omega naught. This will become 3 omega naught, 4 omega naught, 5 omega naught, 6 omega naught. But what is the value of 6 omega naught? That is equals to 2 pi. And it should be 2 pi only, no? Because I know that this particular thing will be periodic with 2 pi. I know one particular thing, that x e to the power j omega plus 2 pi is equals to x e to the power j omega. That means this should be periodic with 2 pi, and which is coming out to be periodic with 2 pi only. Is that clear to you or not? So this will be 7 omega naught. This will be 7 omega naught, which will be equals to omega naught only. This will be 8 omega naught, which will be equals to omega naught, which will be equals to 2 omega naught only. But we are not going to write down 2 omega naught because on the axis the frequency is increasing. Basically, if I go from here to here, the frequency will go from 0 to infinity. But always your matter of concern will be between minus pi to pi. So where will be minus pi? What do you think? If 6 omega naught is 2 pi, then 3 omega naught will be plus pi, and this will be minus 3 omega naught, which will be minus pi. So between minus pi to plus pi, between minus pi to plus pi, this is the matter of concern for you. But at minus pi you are having an impulse, and what will happen is that they will turn impulse, no? I forgot this thing, that they will turn into impulses. All these will turn into impulses, and what you will do is that you will multiply with them with 2 pi. So this will be the graph of x e to the power j omega. Although question never came on these particular topics, but even if it comes out to be there in the examination, you will be able to think, right? Very easily you will be able to think. So whatever that we did in a continuous time, the same thing we are doing here as well. The only thing, what was the only difference? That there C of n was not periodic, but here Ck is periodic. If Ck is periodic, that means the same waveform will keep on repeating, and if Ck is periodic, that means x e to the power j omega will also be periodic. So when you move from continuous time to discrete time, the periodicity comes into action in the frequency domain. In the frequency domain, periodicity comes into action. So this is what is happening. Is that clear to you? All good? All fine? Okay. Now you need to find the DTFT of signum n. So try doing it on your own. I will take a pause. Okay. Try finding the discrete time Fourier transform of signum n. This is how signum n is defined. How signum t was defined? This was your signum t. So now if you sample it, so here 1, 1, 1, here minus 1, minus 1, minus 1, and here 0. So 0, 1, 1, 1, minus 1, minus 1, minus 1. This is how signum n is defined. So now you need to find the discrete time Fourier transform of signum n. So try doing it on your own. You know the discrete time Fourier transform of this one. You know the discrete time Fourier transform of this one as well. You can apply the property, right? If x of n is having x e to the power j omega, then x of minus n will have x e to the power minus j omega. So apply this property and find that discrete time Fourier transform of signum n. Okay. So we will continue it and then we will proceed. So let me take a pause, drink some water, and then I will come back. Okay. So yeah, did you try this one? Signum n. Signum n is given as u of n minus u of minus n. Because what will be the graph of u of n? What will be the graph of u of n? The graph of u of n will be like this. And what will be the graph of u of minus n and then minus sign? So that will be like this, right? So this and this sample is getting cancelled. So this part and this part will be remaining. So signum n is given as u of n minus u of minus n, right? So what will be its x e to the power j omega? So what will be the Fourier transform of u of n? That is 1 upon 1 minus e to the power minus j omega plus pi del omega but periodic, pi del omega but periodic, right? And here what will happen? Minus sign as it is. What will be the Fourier transform of u of minus n? That will be 1 upon 1 minus e to the power plus j omega, because plus omega will be replaced with minus omega. So minus omega will be replaced with plus omega, right? And then another minus sign, pi del omega will be replaced with minus omega, 2 pi l, l going from minus infinity to infinity. Just let me know this thing and this thing, both are same. What is this? You are having impulses of area pi at every 2 pi, 2 pi, 4 pi and so on, right? This is this particular thing. And here what we are doing, omega we are replacing with minus omega, that means we are just taking the mirror image. So what will be the mirror image of this one? The same only, no? Basically it is even. What it is even, and this will also be even only, same, the same graph you will be getting. And here also what you can do is that this delta can eat up this negative sign. So if it is eating up the negative sign, so what you will be left with? Now L is going from minus infinity to infinity, that means L will be positive as well, negative as well. Here also L will be positive as well, negative as well. So this particular thing and this particular thing, both are same. Both are pi del omega, which is being repeated with the period of 2 pi. And then when you take the mirror image of this one, you are getting the same thing. That means both are same. So both will be cancelling out each other. Is that clear to you? So this and this will be cancelling out each other. So what you are left with? Your x e to the power j omega is coming out to be 1 upon 1 minus e to the power minus j omega minus 1 upon 1 minus e to the power j omega. Okay. Now here what I am going to do, I am going to multiply in the numerator and denominator with e to the power minus j omega. In the numerator and denominator, what I am going to multiply? E to the power minus j omega. So what you will be getting? X e to the power j omega 1 upon 1 minus e to the power minus j omega minus, in the numerator I am multiplying with e to the power minus j omega, divided by, this will be e to the power minus j omega minus 1, e to the power minus j omega minus 1. Now what I can do, I can take out the negative sign. From here I am taking out the negative sign. So 1 minus e to the power minus j omega, if I take out the negative sign, e to the power minus j omega upon 1 minus e to the power minus j omega, right? Just I took out the negative sign, so 1 minus e to the power minus j omega, this will become positive. So what you are getting? 1 plus e to the power minus j omega upon 1 minus e to the power minus j omega. So this is one of the answer, x e to the power j omega. So this is one of the answer. But you can simplify it more. How will you simplify it? What you can do is that you can take out e to the power minus j omega by 2. So e to the power plus j omega by 2 plus e to the power minus j omega by 2 divided by, you can take out from here e to the power minus j omega by 2 as well. So what you will be left with? E to the power j omega by 2 minus e to the power minus j omega by 2. So here I can divide by 2j. So here I need to multiply with 2j, and here I can divide with 2. So I need to multiply with 2, and this is getting cancelled out. So what you are getting? 2 and 2 will also get cancelled out. So upper side you are getting minus j. This 2 and 2 is also getting cancelled out. This plus j will go to towards the upper side. You are getting minus j. What is this? Sin omega by 2. Sorry, cos omega by 2. This is your cos omega by 2 divided by, what is this? This is sin omega by 2. So what you are getting? What we are getting? x e to the power j omega is coming out to be minus j cot omega by 2, minus j cot omega by 2. So in 1 mark it can be asked, somewhere in 1 mark it can be asked in the examination. So directly you need to remember. If someone asks you what is the discrete time Fourier transform of signum n, so directly you should be able to tell it is minus j cot omega by 2, minus j cot omega by 2. All good, all fine, very easy, right? So two things you need to remember: a to the power mod of n, why I am writing u of n. So a to the power mod of n, that will give you a result of 1 minus a square upon 1 plus a square minus 2a cos omega. So only till now in this chapter only two things I am asking you to remember. Rest all the things you can write down there in the examination hall itself. So a to the power mod of n, you need to remember it: 1 minus a square upon 1 plus a square minus 2a cos omega, and signum n minus j cot omega by 2. And these two things you can forget anytime. So that's why it should be there in your notes or in short notes or somewhere in front of your wall. So you can forget it: 1 minus a square upon 1 plus a square minus 2a cos omega, and signum n minus j cot omega by 2. So these things you need to remember. Okay, so in 1 mark directly it can be asked, what is the discrete time Fourier transform of signum n? That would be minus j cot omega by 2. Is that clear to you? All good, all fine. Let's see the multiplication and convolution property. So just one thing, here it should be convolution, no? First I will write down the convolution and then multiplication. Yeah. So x1 of n is having a discrete time Fourier transform of x1 e to the power j omega, and x2 of n is having a discrete time Fourier transform of x2 e to the power j omega. So x1n convolution x2n, what is this? This is convolution. x1n convolution x2n will be having a discrete time Fourier transform of what? So convolution in time domain will result in multiplication in frequency domain. Multiplication in frequency domain, and multiplication in time domain will result in convolution in frequency domain. But do you remember one thing? It should be divided by 2 pi. Whenever you do the convolution in x of omega, you always divide by 2 pi. But here there is a thing. This is periodic, right? Periodic with 2 pi, and this is also periodic with 2 pi. Both are periodic with 2 pi. So what you are going to do? You are going to do the convolution. How do we define the convolution? X of tau, h of minus tau plus t. So similar thing we are going to do here. What is the axis? Axis is t, axis is tau. So now what is our axis? Axis is omega. The next axis I am going to introduce, that will be theta. So what I am going to do? I am changing the axis, x1 of e to the power j theta. So this as it is. Other one is mirrored and then shifted by omega. You understood? I hope you understood what I am doing. Here what I used to write down, x of tau, x1 e to the power j theta. That means I am changing the axis. So this as it is, this one inverted and then shifted with respect to omega, and whose limit I will put? I will put the limit of theta, and here whose limit I used to put? I will use to put the limit of tau, right? And here I used to integrate from minus infinity to infinity. But here both are periodic with 2 pi, so you will integrate from minus pi to pi. So this is the definition. What is this? This is actually the definition of 1 by 2 pi convolution of x1 e to the power j omega convolution with x2 e to the power j omega. This is the definition of convolution. This is the definition of convolution. Okay, is that clear to you? Although we are never going to use this formula, never ever we are going to use this formula, but still I am telling that this is how it is defined. This is the definition. Is that clear to you? All good? So let's see some question. X of n is given. You need to find x e to the power j omega. That means x of n is actually multiplication of two signal, right? This is the multiplication of two signal, and you know that in frequency domain what will happen? Multiplication of two signal, then here convolution of these two signal, sorry, convolution of these two Fourier transform, but divided by 2 pi. Here also convolution only I wrote down, no? Yeah. So here I need to convolve these two. Can I make the x1 of e to the power j omega? Surely you can make it. Sin an by pi n. What is the value of a? Minus pi by 4 to pi by 4. Here what is the value of a? Minus 2 pi by 3 to plus 2 pi by 3. Now you need to convolve, but you need to convolve between minus pi to pi. You need to convolve between minus pi to pi. So let's do the convolution between minus pi to pi, between minus pi to pi. So this particular thing I need to convolve with this guy. And then what I will do? Basically this is x1 e to the power j omega, this is x2 e to the power j omega. So whatever the answer that you are going to get, that will also be a Fourier transform only. No? This is a discrete time Fourier transform. This is also a discrete time Fourier transform. Now what I will get? X e to the power j omega. That will also be a discrete time Fourier transform. So that will also be periodic with 2 pi. So what you are going to do is that you will perform the convolution between minus pi to pi only. Here also between minus pi to pi and here also between minus pi to pi. So you will perform the convolution between minus pi to pi only, and then what you are going to do, whatever the waveform you get, you will make it periodic. Whatever the waveform that you are going to get, you will just make it periodic with 2 pi. That's it, right? So can you perform the convolution between minus pi to pi? Surely you can perform the convolution, because you have already seen the convolution of rectangular pulses. How do you convolve the rectangular pulses? What we are doing, we are performing the convolution between minus pi to pi. So minus pi by 4 minus 2 pi by 3. If you add both of them, what you are going to get? 1 by 4 plus 2 by 3. So 12, this will be 3, 8, 11 by 12. Minus 11 pi by 12 and here plus 11 pi by 12. What is the minimum width? Minimum width is pi by 2. That means here plus pi by 2 and here minus pi by 2, right? So 11 pi by 12 minus 6 pi by 12. So that would be 5 pi by 12. 5 pi by 12 minus 5 pi by 12. These things we have already studied, right? Then linear increasing, then constant, and then decreasing, right? This kind of waveform you will get. It is there between minus 11 by 2 to plus 11 by 2. What will be the value of this slope? This slope will be 1 into 1. So this slope will be 1. So what will be this amplitude? What is this particular thing? This is pi by 2, right? This much was pi by 2, because here the minimum width was pi by 2. So this is pi by 2. So this width will also be pi by 2 only. But do you remember one thing? It will be multiplied with 2 pi as well. It will be multiplied with 1 by 2 pi as well. So what you will be getting? 1 by 4. So here you will be getting the amplitude is actually 1 by 4. Amplitude is actually 1 by 4. Then what will happen is that after that it will be periodic with 2 pi. So basically what will happen is that this center will move to 2 pi. So just let me know, will there be any aliasing? What do I mean by aliasing? Like, will there be any superposition? Will there be any common area? Like something like this will happen? No. Why is that so? Because this particular thing is less than pi, right? This particular thing is less than pi, and this particular thing is greater than minus pi. So this thing is not going to happen. The aliasing will not going to happen. Basically what will happen is that minus 11 by 12, it is periodic with 2 pi. Basically what will happen is that center is moving to 2 pi, so this will also move ahead by 2 pi only, no? So minus 11 pi by 12 plus 2 pi. What you will be getting? Minus 11 pi by 12 plus 12 pi divided by 12 you need to do. This is moving to 2 pi, so this will also move by 2 pi only, right? So this will be 24 by pi divided by 12. So what you are getting? 13 pi by 12, which is greater than pi. So this point will be 13 pi by 12. Is that clear to you? Similarly, this point will also move. minus pi by 12 plus 2 pi, that means 24 by 12. So what this point will be? This point will become 19 pi by 12. This point will become 19 pi by 12. Is that clear to you? Are you able to understand this point? So what you are going to get is that there will be some difference. So there is no aliasing, there is no superposition. If there was a superposition, then what you would have done? You would have just added it, nothing else. So what will happen is that the same waveform will keep on repeating. That's it, nothing else. Here also the same waveform will keep on repeating. And you can mark up these points. The amplitude will be the amplitude will be 1 by 4. Amplitude will be 1 by 4 only. Okay, and you can mark up these points as well. So here this point was 19 pi by 12, right? What this point will be? 5 pi by 12 plus 2 pi. So 24 divided by 12. So 29 pi by 12. 12 and 11 pi by 12 plus 24 divided by 12. So 35 pi by 12. Okay, so all the points I have marked up. So similarly, these points will be there in the negative side as well. So only thing I wanted to take care was that there should be no aliasing, and there is no aliasing. If there is aliasing, then I need to add them up. We will see the example where there is aliasing. So this is your x e to the power j omega. Basically, this is your x e to the power j omega. And I hope you know how we got it. What we are doing, we are convolving two rectangular pulses. So minus pi by 4 minus 2 pi by 3. Here plus pi by 4 plus 2 pi by 3. This point. Then you need to check the minimum width. Minimum width will be pi by 2. So pi by 2 ahead, pi by 2 backward, right? And then this kind of a structure we will get. After that, what we need to see? We need to see what will be the slope here. So slope here will be 1 into 1. Slope should be 1. But the thing is, we will be dividing it by 1 by 2 pi as well. So if slope is 1, this particular thing was pi by 2. So this area, this magnitude should be pi by 2 only. But it will be divided by 1 by 2 pi. So this magnitude becomes 1 by 4. Okay. And same thing is being repeated here as well. So this is minus pi. This is minus 13 pi by 12. Minus 19 pi by 12. In between it would be 2 pi. Minus 29 pi by 12. And minus 35 pi by 12. So there is no aliasing, and this kind of x e to the power j omega you are getting. Is that clear to you? Well and good. Let's move to the next one. What we are going to see now, we are going to see the Parseval theorem. So some identities. First we are starting with some identity. Do you remember this identity? Let's remove the results. Forget about the results. Forget about the results. In case of this continuous time Fourier transform, we saw this identity. What we used to do? In the time domain, two signals are being multiplied. So in the frequency domain as well, they will be multiplied and then integrated. But here I need to divide by 2 pi. So whenever you see omega here, divide by 2 pi. Right? This is what we used to do. But another thing to take care, here if x2 of t is there, I need to add a mirroring. So I need to mirror it. So either I could have done it with x2 or I could have done it with x1. So similar thing will happen in case of discrete time as well. So you need to divide by 1 by 2 pi. You will integrate over minus pi to pi, because our x1 e to the power j omega will be periodic with 2 pi, and our matter of concern will be between minus pi to pi. So this is what I am going to do. So first one as it is, but other one shifted. Or what you can do, 1 by 2 pi between minus pi to pi. First one shifted, sorry, not shifted, first one mirrored, second one as it is. There you go. Now if both are same, then what will be the answer? 1 by 2 pi minus pi to pi x1 e to the power j omega x1, oh sorry, it is not x1, it is x only. So x e to the power minus j omega d omega, and one is conjugate of other. So what will be the answer of this particular thing? xn dot with x conjugate n, what it will be equals to? N goes from minus infinity to infinity mod of x of n square, and can I write it down as energy of x of n? So what that would be equals to? 1 by 2 pi minus pi to pi x1 e to the power j omega as it is. What will be the Fourier transform of this one? Fourier transform of this thing would be x e to the power j omega conjugate here but another negative sign. This is the Fourier transform of this particular thing. But whenever you write down the Fourier transform here in the integration, what you do? You take the mirror image. So that means what you are going to write down here? X conjugate e to the power j omega dot d omega. These things we have already seen in a very good manner. We have seen it. Same thing, ditto same thing we saw in case of continuous time as well. And same thing we are going to see in DTFS and CTFS as well. So x n dot x conjugate n. So mod of x of n square, energy of x of n, which is coming out to be this particular thing. Basically, what will be the Fourier transform of this one? That would be x conjugate e to the power minus j omega. But here another negative sign I need to add. So it will become plus j omega. So what you are getting as the answer? 1 by 2 pi minus pi to pi mod of x e to the power j omega whole square d omega. There you go. This is the energy of x of n, which we have find out. Energy of x of n, and this is known as Parseval's theorem, okay, which you could have written down on your own as well. So have we written down anywhere Parseval's theorem? So we can write down, okay, let's add a page, and in a statement wise we can write down what is the Parseval's theorem, although you guys already understood. Anywhere am I writing it down, or only questions are there? Okay, only questions are there, so I can write down the Parseval's theorem. So this is known as Parseval's theorem. So all the statement I am not going to write down, only two statement I will write down. What is the first one? First one says that two random signals are there, x1n multiply with x2n. So what will be its result? Surely we are going to write down in terms of x of omega, and it is periodic. x1 e to the power j omega, x2 e to the power minus j omega d omega. And what if you need to find the energy of x of n? That could be equals to summation n goes from minus infinity to infinity mod of x of n square, and that would be equals to 1 by 2 pi minus pi to pi mod of x e to the power j omega whole square d omega. There you go. This is the Parseval's theorem. Two statement you can remember, and your job is done. Let's see the questions. X of n is given, you need to find the energy. Can you find out the energy directly? No. That means I need to proceed to the x e to the power j omega. Can you write down x e to the power j omega for this one? Yes. Sir, this is the x e to the power j omega for this one. So basically your energy of x of n is given as what? 1 by 2 pi area between minus pi to pi mod of x e to the power j omega square d omega. So kind of can you write down it is equals to energy of x e to the power j omega for one period divided by 2 pi. Isn't it like the energy of x e to the power j omega for one period? That means what I need to do? I need to find the energy of this particular thing and then divide by 2 pi. So what will be the energy of this particular thing? 1 by 2 pi already there, and what will be the energy? Square into 2 pi by 3. So 9 into 2 pi by 3. 9 into pi by 3 plus pi by 3, 2 pi by 3. So 9 into 2 pi by 3. So 3. This is the answer. This is the energy, 3 unit. Is that clear to you? How did we get the answer? Very easily. 9 into 2 pi by 3, that will be the energy of x e to the power j omega divided by 2 pi. So 3 unit is the answer. Okay. Similarly, can you find out the energy of this one as well? What you need to do? Again, you need to draw the graph. So here sin an by pi n square is given. What does that mean? X e to the power j omega will be rectangular. X e to the power j omega will be rectangular. And what will be the limit? Limit will go from minus 2 pi by 3 to plus 2 pi by 3. But what will be the area here? Sorry, what will be the amplitude here? Amplitude will be pi by 3 divided by pi. So amplitude will be 1 by 3. I hope previously as well I wrote down the same amplitude. Here when I was teaching, I am not sure which amplitude I wrote down. Yeah, a by pi only. So basically you need to see here. This is the amplitude a by pi. So similarly here as well, what will be the amplitude? Amplitude will be pi by 3 divided by pi. So it would be 1 by 3. So this is your x e to the power j omega. This is what you are getting, x e to the power j omega. So what will be your energy of x of n? One by 2 pi minus pi to pi mod of x e to the power j omega whole square d omega. So 1 by 2 pi. What will be the energy in one time period? Sorry, not time period. In one period of 2 pi, what will be the energy? Do you remember the answer? A square by 3 into width. Do you remember it? For a rectangular signal, what was the energy? A square by 3 into width. For sinusoid, what it was? A square by 2 into width. And for this was triangular, sorry. For triangular, it was a square by 3 into width. For rectangular, it was a square into width. And for sinusoid, it was a square by 2 into width. Right? I hope you remember it. In the basics of signal, we studied it. So what will be our answer? 1 by 2 pi is already there. A square by 3. That means 1 by 9 divided by 3. So 1 by 27. Into width, that is 4 pi by 3. Right? Width is 4 pi by 3. So what you are getting? 2 by 81 unit. This is the answer we are getting. Right? Okay. So 2 by 81 unit. This is the answer you are getting. Now what about this one? Find the energy. Pause the video. Do it on your own. So this will clear all the doubts that sir, what if there will be some aliasing or anything like that? For this particular condition, what was the given condition? That A should be less than pi by 2. Is it less than pi by 2? No. That means there will be some aliasing. If there is aliasing, then what kind of response you will be getting? Let's just understand that. Okay. So do it on your own. Find out the energy on your own. Okay. So I hope you would have done it. You would have paused the video and you would have done it. So let's try finding x e to the power j omega for this one. What we are trying to find? X e to the power j omega for this one. So it will be there between 4 pi by 3 to minus 4 pi by 3 to plus 4 pi by 3. Say yes or no? Minus 4 pi by 3 to plus 4 pi by 3. This is 2 pi by 3, no? So minus 4 pi by 3 to plus 4 pi by 3. Centered at 0. And I know that this same thing will be repeated. That means this center will move to 2 pi. So minus 4 pi by 3 plus 2 pi. What that would be? 2 pi by 3. So what will happen is that this same rectangular graph will be repeated. And here also it will be repeated. And then again it will be repeated. So this particular point is 2 pi by 3 and this particular point is minus 2 pi by 3 and the center is at minus 2 pi, the center is at plus 2 pi. So here 2 pi plus 4 pi by 3, 2 pi plus 4 pi by 3. So this point will be 10 pi by 3. Is that clear to you what we are doing? I know that whatever the thing that I am getting centered at 0, that will be repeated with 2 pi. So this is what I am doing, repeated with 2 pi. But here the thing is, the similar thing we were doing previously as well. But there was no aliasing, now there is aliasing. So I need to add up the sample, nothing else. I need to add them up, which I will do. And what this point will be? This point will be minus 10 pi by 3. So always my matter of concern will be between minus pi to pi only. What I am saying, what will be my matter of concern? Matter of concern will always be between minus pi to pi, because I know that whatever that I am getting between minus pi to pi, that will be repeated. So what is this point? This point is pi. And what will be this point? This point will be minus pi. So whatever that is there between minus pi to pi, that will be my matter of concern. Because after that everything will be repeated. Say yes or no. Now this graph is decaying and this graph is increasing. That means between this particular point to here, basically from here to here, this is decreasing and this is increasing. What does that mean? Decreasing graph, increasing graph. If I say this is minus 2t and this is plus 2t, so what will be the addition? 0. Minus 2t plus 2t, addition will be 0. And if I say the graph is minus 2t plus 4 and then 2t plus 4, so what will be the addition? Addition will be 8. So similar thing is happening here, decreasing and increasing. So what will be the addition? Addition will be constant. So if I find out the value here, then my job is done. What I am saying, if I find out the value here, then my job is done. Why my job is done? Because whatever the value that you are getting here at 2 pi by 3, so the yellow graph is giving some value. Let's just say that value is alpha. And the blue graph is giving value 0. So addition at this particular point, that will be alpha plus 0. So that value will be alpha. So what will be the value at this particular point? That value will also be alpha only, no? Alpha, basically this yellow graph is giving some value, that would be some beta. And this blue graph will be giving some value, that will be gamma. So gamma plus beta will be alpha only. You can check it on your own. Let me give the values, okay? So first let me know what will be this value. This value will be 2 by 3, right? This value will be 2 by 3. So at 0 it is 2 by 3, right? And what is the slope? What is the slope? Slope is, what is the slope? If I call the slope here is m. If I say the slope here is m. So what is the slope? Slope is 2 by 3 divided by minus 4 pi by 3. So slope is minus 1 by 2 pi. Minus 1 by 2 pi. So slope is minus 1 by 2 pi, right? So basically when you go from 0 to 4 by 3, when you go from 0 to 4 pi by 3, that means you decrease by 2 by 3. So when you go halfway, then how much decrease will be there? When you are going from 0 to 4 pi by 3, that means it is decreasing by 2 by 3. So when you go halfway, 0 to 2 pi by 3, so how much decrement will be there? 1 by 3 decrement will be there. So this point has to be 1 by 3. Are you able to understand the point what I am saying? You don't need to calculate any slope or anything like that. Are you able to understand what did I just say? When you are going from 0 to 4 pi by 3, the decrement is 2 pi by 3, 2 by 3. Now if I go from 0 to 2 pi by 3, that means if this distance was x, so how much is this distance? X by 2. So if I cover the half distance, that means how much decrement would be there? Half decrement, that would be 1 by 3. So from 2 by 3 to I will come to 1 by 3. Or you can solve by the slope as well. How will you solve by the slope? How will you solve by the slope? So let's just say at 2 pi by 3 the value is alpha. So what is the slope? Slope is minus 1 by 2 pi. So 2 by 3 minus alpha divided by 0 minus 2 pi by 3. So what you will be getting? 1 by 3 is equals to 2 by 3 minus alpha. So value of alpha is 1 by 3 only. So this particular point is 1 by 3. Now you find out at pi. At pi what value you will be getting? Just let me know at pi what value you will be getting. So what is the slope? Minus 1 by 2 pi. Right? Value at 0, that is 2 by 3. Value at pi, let us say it is beta, divided by 0 minus pi. So what that would be equals to? 2 by 3 minus beta would be equals to 1 by 2. So beta would be equals to 2 by 3 minus 1 by 2. Right? So what is the answer you will be getting? 1 by 6, right? So it is 1 by 6. So here the value of beta is coming out to be 1 by 6. So the yellow graph is saying that I will give you 1 by 6. And what this blue graph will say? Blue graph will also give you 1 by 6 only. The blue graph will also give you 1 by 6. Yellow is giving you 1 by 6, blue will also give you 1 by 6. And what you need to do? You need to add them up. So what will be the value? 1 by 6 plus 1 by 6. What that would be? 2 by 6. That means it will be 1 by 3. So what did I tell you? Here 1 by 3 you are getting, here also you will get 1 by 3, which is pretty obvious, no? Whatever the slope it is decreasing, with the same slope it is increasing. So whatever the addition that you are getting here, the same addition you will get here as well, and the same addition you will get here as well. And the addition will be 1 by 3 only. Is that clear to you or not? So what did you understand? What did you understand now? All these calculations we have done. What did you understand from all these calculations? That now I can draw my, this is simple mathematics I was teaching you, nothing else. Now what I can do is that I can draw my x e to the power j omega. So what will be my x e to the power j omega? Look guys, there is no chance that these questions will be there in any notes, okay? So forget about solving it, people are not even discussing it. At least it is there in our notes. So what you can do, what you understood here, that between 0 to 2 pi by 3, it is continuously decreasing. This was amplitude, peak amplitude was 2 by 3. Then till 2 pi by 3, it was continuously decreasing. Here it was continuously decreasing. Then at 2 pi by 3, you go to know that the amplitude has become 1 by 3. The amplitude has become 1 by 3. And from 2 pi by 3 till pi, it will remain 1 by 3 only. From 2 pi by 3 till pi, it will remain 1 by 3 only. It will remain 1 by 3 only. And after that, what will happen? The ditto same waveform will be repeated. The ditto same waveform will be repeated. After that, what will happen is that the ditto same waveform will be repeated. Ditto same waveform will be repeated. Is that clear to you or not? Whatever that is happening between minus pi to pi, the same waveform is being repeated. Our matter of concern is between minus pi to pi only. So here you don't need to calculate anything at pi. What you will say is that, sir, there is superimposition. Previously there was no superimposition, I was happy. Just one sample I would have made. This sample I would have made and my job was done. But now here I made one sample, then I made it periodic with 2 pi. I got to know that there is some superimposition. And if there is superimposition, so I need to add the graph. So how would I add the graph? At 2 pi by 3, here I was having amplitude of 1 by 3, which I could very easily go to know. How I would have got to know that if I go from 0 to 4 pi by 3, I am decreasing by 2 by 3. That means if I go halfway, I will decrease by 1 by 3. So 2 by 3 minus 1 by 3 will be 1 by 3 only. So here my value will be 1 by 3, which will be remaining till 4 pi by 3 only. So between 2 pi by 3 to 4 pi by 3, always I will have amplitude as 1 by 3 only. So similar things are being repeated. So whatever the waveform is there between minus pi to pi, whatever the waveform is there between minus pi to pi, the same waveform will keep on repeating. Is that clear to you or not? All fine? All good. Now what is our matter of concern? What we need to find? We need to find the energy of x of n. What we need to find? Energy of x of n. This is what we need to find. That is equals to 1 by 2 pi minus pi to pi. Our matter of concern is between minus pi to pi only. Okay. So now what will happen is that between minus pi to pi, I will again draw the diagram. So what I need to do? I need to find the energy between minus pi to pi. Two by 3 and this point is 1 by 3. Now again the job becomes difficult for you. Okay, how will you find the energy? Two signals are being added. Both are orthogonal to each other? No, they are not orthogonal to each other, right? Two signals are being added, they are not orthogonal to each other. So what I am doing, I am just what is my matter of concern? X e to the power j omega is my matter of concern. This is my x e to the power j omega. This is my matter of concern, but between minus pi to pi only. So I just need to find the energy of this particular graph. Forget about x e to the power j omega or anything, just find the energy of this particular graph and then divide by 2 pi, that will be the answer. So how will you find the energy of this particular graph? So it is made from two signals, two standard signal whose energy we know. So it is made from these two signals, but both are not orthogonal to each other. So this goes between minus pi to pi with the amplitude of 1 by 3, right? And the other one goes from minus 2 pi by 3 to plus 2 pi by 3. Minus 2 pi by 3 to plus 2 pi by 3. And here it is triangular with the amplitude of 1 by 3 only. Why amplitude is 1 by 3? Why not 2 by 3? Think about it. Basically you need to add both of the graph, no? So how will you add the both of the graph? Between minus pi to minus 2 pi by 3. Between minus pi to minus 2 pi by 3, one is 1 by 3, another one is 0. So 1 by 3 plus 0 will be 0. Between 2 pi by 3 to pi, one is 1 by 3, another one is 0. So 1 by 3 plus 0. Between minus 2 pi by 3 to plus 2 pi by 3, here 1 by 3 plus 1 by 3 will be 2 by 3. So this kind of two graphs you are getting. Both are not orthogonal to each other. So what will happen? What will be the energy? You remember energy of first one plus energy of second one plus 2 into area of first into second. Do you remember this thing? Energy of first one plus energy of second one plus 2 into area of first into second. If they are orthogonal to each other, then this area would become 0. But here this is not the case, they are not orthogonal to each other, so this area will not become 0. So what is the energy of first one? That you can know that it will be 1 by 9 into 2 pi. Plus what is the energy of this one? A square by 3. A square by 3 into 4 pi by 3 plus 2 into area of both of them. That means you need to multiply both of them. So should I do it fairly? Let's do it fairly. So if I multiply both of these signal, what I will be getting? If I multiply both of these signal, then between minus 2 pi by 3 to plus 2 pi by 3, I will be getting, this is 1 by 3, this is 1 by 3, so this will be 1 by 9. Between minus 2 pi by 3 to plus 2 pi by 3. So what will be the area? This is 4 by 3. So 2 into half into base into height. Is that clear to you? Okay. 2 into half into base into height. So this is the total energy you are getting. So patience, this question requires patience. Although it might not be asked in the examination, but if you solve these kind of questions, then you surely learn a lot of new things. So we started with this particular thing. We started from here. Then we got to know that superimposition is there. We need to add both of the graph. Then I need to take care of between minus pi to pi only. So this kind of graph I am getting between minus pi to pi. And then I got to know that these are the things I can see here. E1 plus E2 plus 2 into area of first into second. Okay. So 2 into half base into height. So 4 pi by 27. 4 by 3. So what I am getting? 2 by 9 plus 4 by 3 into 4 pi by 27. look here, what is the scenario? 4, 2 and 2 will get cancelled out. It is 4 pi by 27. Here you are getting 4 pi by 27 and here you are getting 4 pi by 27 into 1 by 3. So what did I do? I took 4 pi by 27 outside and 1 plus 1 by 3 will be 4 by 3. So this is how I can write it down, right? Okay. But this is not the energy of x of n, right? What will be the energy of x of n? What will be the energy of x of n? So energy of x of n will be equals to, that would be equals to E divided by 2 pi. So the answer would be 1 by 9 plus 8 by 81. This is 81, 4 to the 8, 8 divided by 81. So here 9 plus 8, what that would be? 17 by 81 answer is coming. क्या हो रहा है यार ये? पहले तो अलग आंसर आ गया, अब अलग आंसर आ गया. 17 by 81, 2 pi if I divide, 4 to the 8 only you are getting, 8 divided by 81. 17 by 81, not 23 by 81. Let me check the calculation, guys. Let me check the calculation. Yeah, guys. So I checked the calculation. I am getting 17 by 81 only. Okay. So here you can see that 9 I can multiply. So it will become 9 by 81 plus 8 by 81. So it will be 17 by 81. So this is the only answer I am getting. So I don't know previously why I got 23. So here you need to change it. It is 17 by 81. Okay. Okay. 17 by 81. Well and good. So this is the answer, 17 by 81 only. So here also, like in convolution, here we saw this convolution property, no? We saw this convolution property that you are convolving both of them. So here in convolution as well, if there is something that is superimposing, that means you need to add them up. Here it was not superimposing, and 99.99% chances are there that in the examination it will not superimpose. There will not be any aliasing. But if there is aliasing, then you should know that how I can frame it. Okay, so if there is aliasing, like let's just say in this question, in place of 2 pi by 3, if I have put some 3 pi by 2 n, right? In place of 2 pi by 3, I would have put 3 pi by 2 n. Then scenes would have been different, right? Scenes would have been different, then here answer would have been different. There would be some aliasing, you can add them up. Is that clear to you? All fine, all good? So yeah, this is how we can get the answer. Okay, let's see the accumulation property. In the last we can see the accumulation property as well. Although we are not going to use it anywhere, but in 1 mark the question can be asked that what will be the Fourier transform of discrete time Fourier transform of minus infinity to n x of k, right? So what is the DTFT of x of n? That is x e to the power j omega. So what do you mean by this? X of n convolution with u of n. So what will be its DTFT? You know that convolution in time domain will be resulting in multiplication in frequency domain. So 1 upon 1 minus e to the power minus j omega plus pi del omega minus 2 pi L, where L goes from minus infinity to infinity. So what do you get? X e to the power j omega divided by 1 minus e to the power minus j omega plus pi x e to the power j omega. L goes from minus infinity to infinity, del of omega minus 2 pi L. Now what is this? This is an impulse train, right? It is an impulse train. 0, 2 pi, 4 pi and so on. Minus 2 pi, minus 4 pi and so on. And amplitude is pi. Now x e to the power j omega is being multiplied with this particular thing. X e to the power j omega. Let's just say this is x e to the power j omega, which will be periodic only basically. Let's just say this is x e to the power j omega between minus pi to pi, and again it will be periodic only. After that it will be periodic only. After that it is periodic only. It is being multiplied with this impulse train. So what is this thing? This is your pi del omega minus 2 pi. Pi del omega 0 is also there, and pi del omega plus 2 pi is also there. This will be multiplied with x e to the power j omega. So you know the property, no? X of t delta of t minus t naught. So this t naught goes here. So similarly, what will happen? X e to the power j omega minus 0. It will go here and then del omega, right? Here pi del omega minus 2 pi will be multiplied with x e to the power j omega. So pi as it is, e to the power del omega minus 2 pi will be multiplied. So 2 pi will go here, del omega minus 2 pi. Then what will happen? Pi del omega plus 2 pi will be multiplied. So pi as it is, e to the power j, 2 pi will go here, minus 2 pi will go here, del omega plus 2 pi. And in the same manner, 4 pi, 6 pi, 8 pi, minus 4 pi, minus 6 pi, minus 8 pi. All these things will keep on going. X e to the power j omega is equals to, pi is already there, x e to the power j omega. Here also pi was there. X e to the power j omega is equals to x e to the power j 2 pi is equals to x e to the power minus j 2 pi is equals to x e to the power j 4 pi. So here what you can write down actually? This will become x e to the power j 0. Say yes or no. Is that clear to you? What did I do here? So basically x e to the power j omega is being multiplied with the impulse train. And what will happen? The same value will be reflected there, no? Whatever the value that you are getting at 0, the same value you will be getting at 2 pi as well. X e to the power j omega is periodic with 2 pi. So whatever the value that you get at 0, the same value you will get at 2 pi, the same value you will get at 4 pi, the same value you will get at 6 pi, the same value you will get at minus 2 pi, minus 4 pi, minus 6 pi. So what we can do? I can write it down in this manner. X e to the power j omega 1 minus e to the power minus j omega plus pi x e to the power j 0. L goes from minus infinity to infinity, del of omega minus 2 pi L. Is that clear to you or not? So this is the discrete time Fourier transform from here. This is the final answer. Okay. So in options it could be mentioned that in place of writing down x e to the power j omega, they will write down x e to the power j 0. Why is that so? Because you know that x e to the power j 0 would be equals to x e to the power j 2 pi would be equals to x e to the power j 4 pi and so on. Similarly here as well, x e to the power minus j 2 pi, x e to the power minus j 4 pi and so on. Is that clear to you? All good. So this is the final answer. This is the DTFT. Okay, so we will proceed with DTFT only. More points we are going to see. More questions also we are going to solve. So let's meet in the next lecture. In the next lecture as well, we are just going to continue our discussion on DTFT. So most probably what we can see in the next lecture, we can see the concept of eigenvalue, eigenfunction. Along with that, we can see the concept of filters as well. And after that, we can solve some problems. So filters, eigenvalue, eigenfunction, and some problems we can see. And duality theorem also we can study. What we are going to study? Duality theorem. Okay, so all these things we are going to see in the next lecture. Okay, so let's meet in the next lecture. Thank you very much. You can revise this particular lecture before going to the next one. It was very simple, just basic analysis we need to do. Thank you very much. Hi everyone, welcome to PrepFusion. So in this video we are continuing our discussion on discrete time Fourier transform only. So we need to study about filters first. We will study about digital filters and then we will study about eigenvalue, eigenfunction. But before that, let's see some prerequisites, some basic concept we are going to see that what if I multiply my sequence, what if I multiply my x of n with minus 1 to the power n. Then we will see what if I multiply my x of n with cos pi by 2n. So what will happen? What will happen to the frequency domain? So same kind of thing we have seen in continuous time as well. We were multiplying with e to the power j omega naught t, cos omega naught t, sin omega naught t. So what was happening? Shifting. So same thing will happen here as well. So let's check that. If I am multiplying with minus 1 to the power n, so what I can write it down as, what is minus 1? Is it e to the power j pi? Yes, minus 1 is e to the power j pi because e to the power j pi is equals to minus 1. So can I write it down in this manner? Say yes or no. E to the power j pi n x of n. So let's write it down in a good manner. E to the power j pi n x of n. Do you remember the property? If x of n is having x e to the power j omega, then e to the power j omega naught n x of n, what it will have? Just the graph shifted by omega naught. Graph shifted by omega naught. If omega naught is positive, that means it will be shifted by right hand side, and if it is negative, then it will be shifted to the left hand side, right? So e to the power j pi n. So what will be your x e to the power j omega? X e to the power j omega, x e to the power j omega minus pi. That means whatever the center that was at 0, so it will be shifted. The center will be shifted to pi. Are you able to understand this point? So this is your x e to the power j omega, x e to the power j omega. So basically, let's just call it x of omega only. And now you need to draw x of omega minus pi. What does that mean? That means you will shift it towards the right hand side. So now the waveform will be shifting towards the right hand side. So let's take an example. What you need to do? Sine pi by 6n divided by pi n. You know how to draw the frequency spectrum of this one. What you will say is that, sir, minus 1 can be written as e to the power j pi n x of n. So x e to the power j omega minus pi, e to the power j omega minus pi. So what kind of response you will get? The center is at pi. Previously center was at 0. If center was at 0, so this kind of waveform you are getting, minus pi by 6 to plus pi by 6, center being at 0, and then it was repeated with 2 pi, right? This was the thing that we were getting. Now center will be at pi. Now the center will be at pi. Center will be at pi. Center will be at pi. So pi by 6 backward and pi by 6 ahead, right? Center will be at pi. So pi by 6 backward and pi by 6 ahead. Seven pi by 6 and here 5 pi by 6, right? Now what will happen? It is periodic with 2 pi. So center is at pi. So pi minus 2 pi, what that would be? Minus pi. Basically it is periodic with 2 pi. That means pi plus 2 pi, pi plus 4 pi, pi plus 6 pi. In that manner it will keep on going. Along with that, pi minus 2 pi, pi minus 4 pi, pi minus 6 pi. So in that manner it will just keep on repeating, right? So similar thing is happening this side as well. So this center was at pi. So this point will be minus pi, right? Then it is periodic with 2 pi. That means the next center will be at 3 pi. Next center will be at 3 pi. Three pi plus pi by 6, 19 pi by 6, 17 pi by 6. Okay, and this point was minus pi plus pi by 6, and minus pi minus pi by 6, that would be minus 7 pi by 6. And same thing is happening towards the negative hand side as well. So did two similar thing here as well. Minus का 3 pi, minus 17 pi by 6, minus 19 pi by 6. So this would be your y e to the power j omega. Now just let me know one thing. What is our matter of concern? I told you one thing. Always our matter of concern is between minus pi to plus pi. And I will only look at the plus side, because I know that negative frequency doesn't matter. It is just to make sure that it is real or imaginary. So I will only look at the plus side. So what is this? This is the low frequency for me. This is the low frequency for me. And this is the high frequency for me. High frequency for me. Right? I told you omega equals to 0 is the low frequency and omega equals to pi is the high frequency. Right? And I am not looking at the negative side, because negative side is just symmetric. So I will only look at the positive side. In the continuous time as well, what we used to do? We used to see here only, and the same thing was happening this side as well. Right? So only the positive part I am going to see. So what I can see? The low frequency is not being passed. The low frequency is not being passed, but high frequency is being passed. Right? Here the gain is 1 and here the gain is 0. So what kind of filter it is? High pass filter. And here what was the scenario? If I say this is my minus pi and this is my plus pi. Minus pi plus pi. This was low frequency and this was high frequency. So what you could see here, that low frequency is being passed but high frequency is not being passed. Low frequency is being passed but high frequency is not being passed. That means what it was? Low pass filter. So when you multiplied a low pass filter with minus 1 to the power n, it became high pass filter. If I say x of n is a low pass filter, and then I ask you what will be your minus 1 to the power n x of n, what will be your answer? Sir, it will be high pass filter for sure. Is that clear to you or not? And opposite process is also true. Opposite process is also true. What if I say that x of n is a high pass filter? So what will be your minus 1 to the power n x of n? That would be a low pass filter. This opposite process is also true. This is also true and this is also true. So multiplying with minus 1 to the power n, what it will do? Convert low pass to the high pass to the low pass. You can do this process on your own. And directly you can see, no, this is a high pass filter, no. If I call this as y of n, that my y of n is a high pass filter. If I multiply with minus 1 to the power n y of n, what I will get? Minus 1 to the power n, minus 1 to the power n x of n. What will be the value of this one? It would be 1 only, because minus 1 would be plus 1 to the power n would be equals to x of n. So if I multiply my y of n with minus 1 to the power n, I am getting x of n. That means if you multiply your high pass filter with minus 1 to the power n, you will get low pass filter. And you can check as well, very easy. Just multiply this particular function with minus 1 to the power n. Then what it will happen? It will be shifted by another pi. It will be shifted by another pi. That means this minus pi will come to 0. This 0 will go to pi. This pi will go to 2 pi. That means this same waveform you will be getting again. So high pass filter is being multiplied with minus 1 to the power n. It will give you low pass filter. Is that clear to you? Very simple thing. Very simple thing. So this is one of the good conclusion that we have made. All good? All fine? So you don't need to mug it up. Even if you forget, in the examination you can derive it. You can follow the process. Very simple process I have told you. What will happen if you multiply with cos omega naught n? This process you should be doing on your own. Okay, do it on your own. So this x of n is given. I am multiplying with cos pi by 2n. Along with that, I am multiplying with 2 as well. Okay, I am multiplying here with 2 as well. Why I am doing so? You would have understood. So let's call this as x of n. So what we will be getting? 2x of n e to the power j pi by 2n plus e to the power minus j pi by 2n divided by 2. So this 2 and this 2 will get cancelled, right? So now what will happen? Y e to the power j omega, that will be x e to the power j omega minus pi by 2 plus x e to the power j omega plus pi by 2. That means shifted right, shifted left and then added. Is that clear to you or not? Shifted right, shifted left and then you need to add them up. So what I will do, I will shift it right by pi by 2, I will shift it left by pi by 2 and then I will add them up. So this center will move to pi by 2. The center will move to pi by 2, pi by 2 minus pi by 6, pi by 2 plus pi by 6. So let's see what happens. The center will move to pi by 2. So pi by 2 plus pi by 6, pi by 2 plus pi by 6, 4 pi by 6, 2 pi by 3 and pi by 2 minus pi by 6, pi by 3. Okay. Now this center only will move to minus pi by 2 as well. This center only will move to minus pi by 2 as well. So what is happening? This center has moved to minus pi by 2. So this will move to minus pi by 6, minus pi by 2. Basically, this point will move to minus pi by 6, minus pi by 2. So what it would be? Minus pi by 3. Basically, minus pi by 2, minus pi by 6. 3 minus 2 pi by 3. Really sorry guys, it would be minus 2 pi by 3. Sorry guys, minus 2 pi by 3. And this point will be minus pi by 3. All clear? With the gain of 1. With the gain of 1. Next, what will happen? Whatever the center that we were getting here, this center, basically 0, this was 2 pi actually. This was 2 pi. So now this 2 pi center will be moved to minus pi by 2 and plus pi by 2. 2 pi minus pi by 2, 2 pi plus pi by 2. Right? So both of the things will happen. 2 pi minus pi by 2, 2 pi plus pi by 2. So what will be 2 pi minus pi by 2? That would be 3 pi by 2. 3 pi by 2. So center will be moved to 3 pi by 2. And what will be 2 pi plus pi by 2? What will be 2 pi plus pi by 2? That would be 5 pi by 2. That would be 5 pi by 2. Basically, all these lobes will be having two clones at plus pi by 2 and minus pi by 2, plus pi by 2, minus pi by 2. This will also have plus pi by 2 and minus pi by 2. Basically, this is your minus 2 pi, no? So it will also have plus pi by 2 and minus pi by 2, right? So 2 pi plus pi by 2 and 2 pi minus pi by 2. So what will be 2 pi minus pi by 2? That would be 3 pi by 2. And what would be 2 pi plus pi by 2? That would be 5 pi by 2. Say yes or no? Right? So here what you are getting? 3 pi by 2. Basically, what is the width? 3 pi by 2 minus pi by 6. 3 pi by 2 minus pi by 6. So 9 pi by 6. 8 pi by 6. 4 pi by 3. Okay. And 3 pi by 2 plus pi by 6. 9 pi by 6. So 10 divided by 6. So 5 pi by 3. Right? The width is actually pi by 3 only. So very easily I can find it out. Next, here what will happen? 5 pi by 2 minus pi by 3. 5 pi by 2 minus pi by 3. So what I need to do? 15 pi divided by 6. 5 pi by 2 minus 5 by 6 actually. 15 pi divided by 6. 14 by 6. So it would be 7 by 3. 7 pi by 3. And then plus pi by 3, that would be 8 pi by 3. So 5 pi by 2 plus pi by 6. Yeah. So this is the thing that is happening. And ditto same thing will be happening towards the negative hand side as well. And what will be this center? What will be this center? You can check the center of both of them. What that would be? It would be 2 pi only, no? Basically, this center is 0. What will be this center? This center will be 2 pi only. This center will be 2 pi. You can check 5 pi by 3 plus 7 pi by 3 divided by 2. This would be the center. So what you are getting? 12 pi divided by 6. So this center will be 2 pi. What about this center? This center will be pi. 2 pi by 3 plus 4 pi by 3. 6 pi by 3. That is 2 pi divided by 2. So this center will be pi. So similar thing, whatever that I made here, the same thing will be made here as well. Now some people might be thinking that sir, periodicity got changed. Is that so? Do you feel like that periodicity got changed? No. See it clearly. This would be minus 4 pi by 3. This would be minus 5 pi by 3. What this would be? 7 pi by 3. This would be minus 8 pi by 3. Right? And this point will be minus pi. So between minus pi to plus pi. If you see, and what did I tell you? I will always look at the positive side only. I will always look at the positive side only. So what do you think? What kind of filter is that? I am looking only between minus pi to pi, and I will always look towards the positive side only. So here what I can see, low frequency is also not getting passed, and high frequency is also not getting passed. So low frequency is also not getting passed, high frequency is not getting passed, but mid frequency is being passed. What does that mean? It is a band pass filter. So process you can do on your own. Although in the examination, if this kind of question is coming and you want to follow the process, then what you will do? You will not make these lobes. I told you one thing, whenever you talk about DTFT, our matter of concern is always between minus pi to pi. So I will make this lobe only and this lobe only. I will get to know that, okay, my matter of concern is between minus pi to pi, my job is done. Is that clear to you? In the examination, I will never ever care about whatever that is happening after pi. So I will make this lobe and then I will get to know that, okay, there is no superimposition. Common part is not being superimposed. That means my job is done now. Between minus pi to pi only I need to make. I can see that low frequency is not being passed, high frequency is also not being passed, only the mid frequency is being passed. That means it is a band pass filter. So whenever you multiply your x of n with cos omega naught n or sin omega naught n, so this was a low pass filter. When I multiplied with cos omega naught n, this became a band pass filter. So don't mug it up, follow the process. Process is clear to you, then you will be able to solve all the question in the examination. So low pass filter, high pass filter, band pass filter, everything we have seen. We will see the notch filter as well, or you can say band stop filter. So band stop filter also we will see. So let's get started with digital filters. So let me know what do you mean by low frequency in case of a discrete time, omega equals to 0. And what do you mean by high frequency? Omega equals to pi. What is the value of z here? Z equals to 1. And what is the value of z here? Z equals to minus 1, because z equals to e to the power j omega. So omega equals to 0, z equals to 1, omega equals to pi, z equals to minus 1. And if I talk about mid frequency, that means you can put omega equals to pi by 2. Any day, if you feel like that, sir, I need to talk at mid frequency as well. So what you will do? You will put omega equals to pi by 2. It will be rarely used. It will be rarely used, but if you want to talk about mid frequency, then you can put omega equals to pi by 2 as well. And what will be the value of z at pi by 2? That would be j. Okay. So value of z would be j. So any day in any question, if you feel like that, sir, I need to talk about mid frequency, then you will put omega equals to pi by 2. What do you think? What kind of filter is that? Low pass filter, right? Because you know the frequency spectrum, minus pi by 3 to plus pi by 3, and then after that it will be repeated, but till pi and till minus pi, you can see that low frequency is being passed and high frequency is being stopped. So what kind of filter is that? Low pass filter. Okay. So a very rough diagram I can make, but in a good manner I will make it. Between minus pi to pi is my matter of concern, nothing else. Between minus pi to pi is my, sorry, this would be minus pi by 3 to plus pi by 3, but my matter of concern is between minus pi to pi. So this is a low pass filter. Now delta n minus sin pi by 3n. What is the frequency spectrum of delta n? That is 1, right? Frequency spectrum of delta n is 1. Basically what is happening here is that if I talk about B, okay, I need to add a page. If I talk about B, so B is given as delta n minus low pass filter, right? This is a low pass filter only, no? So delta n minus low pass filter. What is the frequency spectrum of delta n? The frequency spectrum of delta n is always 1, always 1. So from 1 low pass filter is being subtracted. So what will be the final answer? So here what will happen? 1 minus 1, here what was the gain? 1. So 1 minus 1, that would be 0. But here 1 minus 0, that would be 1. So between pi by 3 to pi, you will have something. And whatever that is happening after that, I don't care. I only care till pi only. So basically between minus pi by 3 to minus pi you are having something, and between pi by 3 to pi you are having something. That means what kind of filter is that? It is a high pass filter. So it is very obvious, no? From delta n, here your frequency spectrum was 1. From 1 you are subtracting something which is low pass filter. So what you will get? High pass filter only. Very obvious. And what will be your delta n? It will be all pass filter. Right? All pass filter. It is passing everything. It is passing everything. It is all pass filter. What about this one? This was your band pass filter. Right? This we have already seen. This analysis I spent so much time here just because this question would become very easy for you. So this would be your band pass filter, and what about this one? What about this one? This will be your band stop filter, or you can call it notch filter as well. Notch filter. Okay, because this is your band pass minus 1. So from 1 band pass is being subtracted. That means whatever that was being passed, that will not be passed, and whatever that was not passed, that will be passed now. Okay, so this analysis is good enough for you. You will get to know that this will become a band stop filter or notch filter. So what kind of response you will get for this one? This is your A, B, C, D, E. So for E, what kind of response you will get? You will get this kind of response, that it is a notch filter. That means it will pass everything, but it will block something in between. It will pass everything, but will block something in between. Passing everything, but blocking something in between. So this point is minus pi, this point is plus pi. Okay, so only the positive part I will see. Passes low frequency as well, passes high frequency as well, and you can see the frequency content as well. What is mentioned here? Pi by 6. Pi by 6. So, and here it is cos pi by 2. So center will move to pi by 2 minus pi by 6. Center would have moved to pi by 2 minus pi by 6, pi by 2 plus pi by 6. So this point will be pi by 2 minus pi by 6. So this would be 2 pi by 6 or pi by 3, and this would be 4 pi by 6 or 2 pi by 3. How did I get to know? Just draw the waveform of this one. Just draw the frequency spectrum of this one. First you will make the frequency spectrum of low pass filter. That means it will be there between minus pi by 6 to plus pi by 6, right? It will be there between minus pi by 6 to plus pi by 6. Then multiply with cos pi by 2. That means it will shift ahead, shift backward. So I made only one shift ahead. So the center will move to pi by 2. So this point will be pi by 2 minus pi by 6. This point will be pi by 2 plus pi by 6. So what do you understand by that? When you subtract it from 1, that means this part will not be passed. So which part is not being passed? Pi by 2 minus pi by 6, pi by 2 plus pi by 6. So center is pi by 2 only. Well and good. And here also in the negative side as well, the same thing will be happening. Okay, very simple concept. What about this one? What kind of filter is that? X of n is given. How will you solve it? How will you solve it? X of n is given where there is an arrow, that means that is the center. Basically this is n equals to 0. This is your n equals to 0, and this would be your n equals to 2. So what is your x of n? X of n is delta n minus 2 delta n minus 1 plus delta n minus 2, right? Delta n minus 2 minus 2 delta n minus 1 delta n. So what is your x of z? That would be 1 minus 2z inverse plus z to the power minus 2. What is the low frequency? What is the meaning of low frequency? Low frequency means z equals to 1. So what is the value of x of z at z equals to 1? That would be 1 minus 2 plus 1, 0. And what is the meaning of high frequency? High frequency means z equals to minus 1. So value of x of z at z equals to minus 1. So that would be 1 plus 2 plus 1. If you put minus 1 here, minus 1 to the power minus 1, that would be minus 1 only, minus 1 to the power minus 2. Minus 1 to the power minus 1, that means 1 upon minus 1 to the power 1. So that would be minus 1 only. And minus 1 to the power minus 2, that means 1 upon minus 1 to the power 2, that would be plus 1. So plus 1 plus 2 plus 1. So answer would be 4. So what does that mean? High frequency is being passed, low frequency is not being passed. High frequency passes, but low frequency doesn't pass. What kind of filter is that? High pass filter. So this is how we need to analyze. Any x of n is given, you find out its Z transform, then you know that low frequency is Z equals to 1, e to the power j0 and e to the power j pi. E to the power j pi Z equals to minus 1. So low frequency, high frequency you put, you get your answer. This was your A. What about B? So what would be your x of z? Directly I will write x of z. So x of z would be delta n, 1 plus 2 z to the power minus 1 plus z to the power minus 2. Is that clear to you? 2 delta of n minus 1 plus delta of n minus 2. So 1 plus 2 z to the power minus 1 plus z to the power minus 2. So low frequency means z equals to 1. So x of z, you can clearly see that it will be passed. And high frequency means z equals to minus 1. So 1 minus 2 plus 1, because minus 1 square would be plus 1 only. So you can see that it is not being passed. So here what you can see, low frequency is being passed but high frequency is not being passed. What does that mean? It is a low pass filter. X of n as 1 0 minus 1, center is at minus 1. That means this is n equals to 0 and this is your n equals to minus 2. So what is your x of n here? Your x of n is actually minus delta n plus 0 delta of n plus 1, right? 0 delta of n plus 1, because it is in the negative side, and delta of n plus 2. Is that clear to you? Minus of delta n plus 0 of delta n plus 1 plus delta of n plus 2, 1 into delta of n plus 2. So what is the x of z you are getting? Minus 1 plus z to the power 2. Is that clear to you? Minus 1 plus z to the power 2. This would give you z to the power 2, this would give you minus 1. So at low frequency, if you check, so let's do it on the next page. So our C is x of z equals to minus 1 plus z to the power 2. Okay, so let's check at low frequency. Low frequency means z equals to 1. So x of z at low frequency is coming out to be minus 1 plus 1, that would be 0. And let's check at high frequency, that would be z equals to minus 1. So x of z at z equals to minus 1, what it is coming out to be? Minus 1 plus minus 1 square would be plus 1 only. That means low frequency is also not passing, high frequency is not passing. That means surely some mid frequency will pass, right? It is not always equals to 0. It is not always equals to 0, right? At some point it is equals to 0, at some point surely it will pass. Mid frequency will surely pass. Is that clear to you or not? Or you can check as well. You can check at mid frequency. Z equals to e to the power, what is the mid frequency? Omega equals to pi by 2. So what is z? E to the power j pi by 2. That means j. So z equals to j. So what will be your x of z at z equals to j? That would be minus 1 plus j square. That would be minus 1 minus 1. So the gain is minus 2. So yes, mid frequency is being passed. So what does that mean? What kind of filter is that? It is a band pass filter. And it is obvious as well. If you just check at a low frequency and high frequency and you saw that it is not being passed, that means surely some mid frequency will pass. It is very obvious. You don't even need to check this mid frequency. It is very obvious that some mid frequency will pass. D 101. So can you write down x of z directly? Yes, I can write down x of z directly. So this is your n equals to 0, delta n, let's write down from x of n only. So what will be your x of n? X of n will be 1 into delta n plus 1 into delta of n plus 2, right? 1 into delta n plus 1 into delta of n plus 2. So what will be your x of z? 1 plus z to the power 2, right? Now what I will do? Z equals to 1 being passed. X of z at z equals to 1. Low frequency is being passed. At z equals to minus 1, high frequency is also being passed. If you put z equals to minus 1, what it would be? Minus 1 square, that would be also 2. So low frequency and high frequency is being passed. That means somewhere in between some mid frequency will not be passed. It is not all pass filter, right? It is not always equals to 1. Is it always equals to 1? No. It will be always equals to 1 only when z equals to 0. So no, it is not always equals to 1. That means it can be surely equals to 0 as well. This x of z can surely be equals to 0, no? 1 plus z square could be equals to 0. That means z equals to plus minus j. And what is the meaning of z equals to plus minus j? A to the power j omega, a to the power j plus minus pi by 2. So that means omega equals to plus minus pi by 2 frequency will not pass. Only this frequency will not pass, which is omega equals to plus minus pi by 2. Along with that, plus minus 2n pi as well. Along with that, plus minus 2n pi as well. Why is that so? Because it will be periodic with 2n pi. So you can say that some mid frequency will not pass. That means I can put z equals to plus j or minus j. So what will be your x of z at z equals to plus j? That would be 1 plus j square. That would be 0. So low frequency, high frequency, both are being passed, but somewhere in between some mid frequency is not being passed. What does that mean? That it is a band stop filter, or you can call it notch filter. Well and good. Let's go to the next one. So now you are going to draw the frequency response of practical filters. Only magnitude spectrum we are going to draw. So basically for low pass filter, what kind of response we saw? This kind of response we saw. That for low frequency it gives the gain of 1, and after that it gives the gain of 0. But actually practically you will never be able to design this particular thing. What I am saying, practically this will never be designed. That you cannot make any filter which will give you a constant gain of 1. That means any filter which is flat and then suddenly drops down to 0. So this flat and then this sudden decay, flat plus sudden drop, this is not possible. Practically you can never design this kind of flat response. So always what kind of response you will get? So I am first talking about analog filters. So what kind of response you will get? That at 0 frequency you are getting a gain of 1. But after that the gain will continuously decrease and slowly it will come down to 0. So gain will just keep on decreasing. So gain will just keep on decreasing. Gain will just keep on decreasing. So this kind of filter you can practically design. Now sir, how to design this kind of filter? So that we will study in analog electronics and network analysis. So in analog electronics and network analysis we will design these kind of filters. So the thing is, practically you can never make this filter. If someone asks you what is the ideal low pass filter, then this is the ideal low pass filter. But practically you will never be able to make it. So this kind of filter you can make. And do you remember from where this kind of response would come? A to the power minus 80 ut. What was the response here? A to the power minus 80 ut. 1 upon j omega plus a, 1 upon under root omega square plus a square. So at omega equals to 0, the gain was 1 by under root a, and at omega equals to infinity, the gain was 0. So this is how it was decreasing. I hope you remember the magnitude spectrum. We draw this kind of magnitude spectrum only. Okay. So practically you can make these kind of things. Okay. But this you will never be able to make. From where you were getting this kind of a response? Sin 80 by pi t. Right? Sin 80 by pi t. Sin 80 by pi t. Can you draw the graph of sin 80 by pi t? Yes. This is your sin 80 by pi t. In time domain. In time domain, this is your sin 80 by pi t. Sin 80 by pi t. And can you draw e to the power minus 80 ut? Yes. This is my e to the power minus 80 ut. What is this? Sorry. What is this? Non-causal. And what is this? Causal. So all the practically non-realizable filters are non-causal. Whenever you see that there is a flat response and then there is a sudden decay, there is a flat response and then there is a sudden decay, that means practically you can never realize it. What do I mean by realize it? That means practically you can never make it. Practically you can never make this kind of filter. All the practically non-realizable system, all the system which you cannot make practically, those are non-causal systems, or you can say non-causal filter. And you can check as well. I gave you the proof. This was the ideal low pass filter from where we were getting it, sin 80 by pi t. So this was your sin 80 by pi t, which is non-causal. So ideally in the actual scenario, in the real world, you will never be able to get this kind of impulse response. this can never be your h of t. This is just an ideal way. This is just the ideal thing that you desire to have. So we want to go to near to this particular thing. We want to go to near to this particular thing, but we will never be able to reach to this particular thing. That means people want to go to the content of PrepFusion, but they will never be able to reach the content of PrepFusion, right? They will never be able to reach this quality, but they will try to be near to PrepFusion's quality. So similarly, we will always try to be near to ideal. I am not saying we are ideal, okay? We also have some flaws. Everyone have some flaws. I was just kidding, nothing else. Yeah. So people will just try to, we will just try to go near to sin 80 by pi t, but we will never be able to reach it. So if I make some 3 or 4 diagrams and I ask you which of them is coming from, this is the frequency response I am drawing. This is the frequency response I am drawing, and I ask you which of them is coming from a non-causal signal. So what you will see, if you see any flat response or there is some decay, then you will see that surely it is coming from some non-causal signal. Is that clear to you? So this flat and then sudden decay, this is only possible from non-causal, and this kind of response are possible from causal as well. Although these questions will not be coming in the examination, but surely for knowledge purpose these are very helpful. So if you are making the notes, if you are studying from PDF, then somewhere you can write down these points, whatever that I told you. In the PDF only there would be enough space. You can write down here, or on some back pages, here, anywhere you can write down. Or I will leave a page. I will leave this page for you guys. You can write down whatever that I told you here on the previous page. Here you can write it down. I will leave this page for you. Okay. Or if you are making your own notes, then you can surely write down anywhere you want. Yeah, so this was your low pass filter. So this we are drawing h of omega versus omega. So sir, how do we define the cutoff frequency? Sir, how do I define the cutoff frequency now? Because there the cutoff frequency was, it was giving a gain of 1 and then 0. So I could say that, sir, this is my cutoff frequency. Here what do I say? This is continuously decreasing. So where I can tell my cutoff frequency? So when the gain is 1 by root 2 times of the maximum gain. What is the maximum gain here? 1. So when the gain becomes 1 by root 2 times of the maximum gain. 1 by root 2 times of the maximum gain. So here maximum gain is 1. So at which frequency the gain will become 1 by root 2 times of the maximum? That is known as the cutoff frequency. Okay. That is known as the cutoff frequency. Although all these points we will again see in our analog electronics. In analog electronics we will again see these points, and then we will calculate these cutoff frequency as well. Omega c and these cutoff frequency omega c we will calculate. Okay. In case of analog electronics. In analog electronics we are again going to see these points. And what will be your high pass filter? So ideally high pass filter was like this, 0 gain and then 1 gain. But 0 gain will not be there. The gain will continuously keep on rising and then it will reach a maximum value. The gain will continuously keep on rising and then it will reach a maximum value. So this is what will happen. This is the response of a high pass filter. Okay. So this is your high pass filter. So only 0 gain you will be getting at omega equals to 0. After that the gain is just keep on rising up. So let's just say maximum gain is 1. Let's just say maximum gain is 1. So when you will have the gain as 1 by under root 2, the gain as 1 by under root 2. So this will be known as cutoff frequency. That means after this it will pass in a good manner. After this it will pass in a good manner, but before this it will give very lesser gain. Here also before this it will pass in a good manner, but after that it will give the lesser gain, because it is supposed to be low pass filter. So it should pass low frequency in a good manner and high frequency in bad manner. And here it should pass high frequency in a good manner but low frequency in the bad manner. So this kind of high pass filter response you will get. Okay. Ideally we will get this kind of response. What about band pass filter? So this was the band pass filter, right? But ideally what will happen? The gain will keep on rising, right? What will happen? The gain will keep on rising. At some point it will provide you maximum gain, and after that the gain will keep on decaying. Here also the same thing, because the filter would be real only. So if the filter is real, the same thing will be happening towards the negative side as well. So the gain will keep on rising from 0. It will, here the gain will be 0, and here also the gain will be 0. At infinity as well the gain will be 0, but at some point it will reach the maximum. At some point it will reach the maximum gain. Let's just say I am calling the maximum gain as 1. I am calling the maximum gain as 1. So this is known as center frequency. What it is known as? Center frequency. Center frequency. Now when the gain becomes 1 by under root 2 times, 1 by under root 2 times here and 1 by under root 2 times here. So when the gain becomes 1 by under root 2 times, so this is known as lower cutoff frequency and this is known as higher cutoff frequency, and this is known as, what this will be known as? Bandwidth. Okay, bandwidth of a band pass filter. Omega h minus omega l, that will be the bandwidth of a low pass band pass filter, that I don't need to write, that you already know. So similar thing is happening towards the negative hand side as well. Similar thing towards the negative hand side as well. So omega center, this is minus omega L, this is minus omega H. So these are the practical filters that we are making. What about band stop filter? So band stop filter, initially it will provide the gain of 1, then the gain will keep on decaying, and at some point it will become 0, and after that it will keep on increasing, and then it will again become 1. Actually it will keep on increasing and at infinity it will become 1. What I mean to say is that it will provide a 0 gain, and then it will keep on increasing and at infinity it will become 1, right? So this is how it will go. So again here as well the same thing will be repeated towards the negative hand side as well. And what was the scenario? This was the scenario in actual, right? Okay, so this is your band stop filter. Here also you can define lower cutoff frequency, higher cutoff frequency, so I am not going to write it down. You would know the same concept, right? Lower cutoff frequency, maximum gain is 1, so where will be the lower cutoff frequency? This will be the lower cutoff frequency, this will be the higher cutoff frequency. Right, and this is the maximum gain, which is 1 only. And what is the bandwidth of a band stop filter? What is the bandwidth of a band stop filter? The bandwidth is infinity always, right? Because it will pass infinite frequency content. So bandwidth is infinity for a band stop filter. All these basic points we have already seen. What about all pass filter? What about all pass filter? So the response of all pass filter will be like this only. It is practically possible. This is your mode of omega plus, this is your mode of h of omega versus omega. How it is possible? Just a simple wire. If I say here there is V in potential, what will be the potential here? V. If I say here there is the square wave, so just a simple wire is there, so what will be the square wave here? That will also be the same only. Are you able to understand this point? So surely you can make any low all pass filter. What is the simplest all pass filter? Simplest all pass filter is a simple wire. That's it. It is a simple wire. This is the all pass filter. But the thing is, on a wire as well, if you go from one point to another point, on a wire, if I say here there is something and then here there is something, if I say here this is the Wien waveform and here also the waveform will be Wien, then it is not true. There will be surely some delay. What I mean to say is that Wien will surely take some delay to travel from here to here. if any signal travel across the wire, there will be surely some delay. You cannot say that, sir, there is a wire, this is a circuit, sir, I apply V in here and immediately it will reach here. Ideally, we will solve the problem in network analysis and in all the in analog electronics as well. We will solve the problem in this manner only, that I will apply V in and at that time only V in will reach here. Like there is no delay of the wires. But practically this doesn't happen. Every wire will have some delay. It cannot happen that no delay is there. Every particular wire will have some delay. Are you able to understand this point? Okay, and in the EMFT as well, we will deal transmission line. So there I will tell you what kind of delays would be there, why the delays will be introduced. So there I will discuss. But the thing is, practically always there will be some delay. So what do I understand by that? What do you understand by that? Let's just say a signal wants to travel from, this is the signal which is xt, and it wants to travel from here to here. So what will be your yt? Yt would be equal to xt only, but with some delay. Let's just say this square wave wanted to travel from here to this particular point. So what will happen? This particular wire will provide some delay. So here, this kind of waveform you will get. Delayed waveform you will get. Is that clear to you or not? So what I mean to say is that practically what will happen is that xt, but your output yt will be x of t minus td. That means this I can call as x of omega and this I can call as e to the power minus j omega td x of omega. This is my y of omega, right? So what is my h of omega? My filter is e to the power minus j omega td. And what is the magnitude of this filter? What is the magnitude of this filter? That is 1 only. Magnitude of this filter is 1 only, but there is some phase. So people would be thinking that, sir, why do we need all pass filter? Like all pass filter is doing nothing. It is passing all the frequencies. But all pass filter can be used to introduce some delay in particular signal. If I want my square wave to be delayed by some amount, so what I can use? I can use a all pass filter which will give me a gain of 1. That means this 1 should not be changed. This gain A and this gain minus A should not be changed. This waveform should also be square waveform only. Basically, the nature of this waveform should also not change. Amplitude should also not change. Nothing should change. Only thing I want is I want some delay. And if you want some delay, that means you can use all pass filter. Is that clear to you or not? So the use of all pass filter is that it will provide you some delay. The gain, keeping the gain as 1, or it could have any gain as well. It could have some gain A as well. But it will not change the nature of the waveform. If it was a square wave, then here also you will get the square wave only, but delayed by some amount or amplified by some factor as well. If it is having, let's just say, if it is having a gain of 3, that means your waveform will be amplified by a factor of 3, and it will be delayed as well. Is that clear to you? So this is the meaning of all pass filter, and this is how you can design it. So this kind of signal is surely possible, that it is always providing you a gain of 1. Okay. So all these points we are not going to write down, or in a short manner we can write it down. How we will write it down? That it is a all pass filter which is providing a gain of, which is providing a shift of td. This is x of t. It is giving a shift of td, and this is y of t. So y of t is x of t minus td. So y of omega e to the power minus j omega td x of omega. So your h of omega is e to the power minus j omega td. So your mode of h of omega is 1. Okay. So this is a kind of all pass filter only. Mode of h of omega is always 1. All good? All fine? Now digital filter. Practical digital filter. What we are going to make? Practical digital filter. So what kind of practical digital filter you will see? That, sir, it will provide a gain for it at omega equals to 0, it will provide the maximum gain, and then it will keep on decaying. Then it will keep on decaying, and at pi it will become 0. Is that clear to you? Did you understand this point? Right? And similar thing is happening here as well. At minus pi it will become 0. Say yes or no. Similarly, now this will keep on repeating. and it is not necessary that it will become 0 only. It can have some value as well. Do you remember the response of a to the power n un? What kind of response you were getting? This kind of response you were getting, right? This kind of response was there. At 0 there was some there was like, I don't remember, a upon root 1 minus a square was the magnitude, and here it was some magnitude was there, I don't remember. So the gain was not 0, but the point was that lower frequency are being passed with the higher amplitude, and higher frequencies are being passed with the low amplitude. Low frequency being passed with the higher amplitude and higher frequency being passed with the lower amplitude. That means it is a kind of low pass filter only. Not ideal low pass filter, but a kind of low pass filter only, which is passing the lower frequency with the higher amplitude and higher frequency with the lower amplitude. Okay. And now after that what will happen is that it will just keep on repeating. It will just keep on repeating with the center at 2 pi, and in that manner it will just keep on repeating. So this is your low pass filter. Similarly, make the high pass filter as well. What will happen? Lower frequency not being passed, higher frequency being passed. Lower frequency not being passed, higher frequency being passed. Right? And after that what will happen? The same thing will be repeated. This is 0. The same thing will be happening at 2 pi as well. Around the 2 pi as well, the same thing will be happening. That means around center, from here these frequencies will be passed, and rest of the, and after that basically whatever that is happening, this particular same waveform will be taking place around 2 pi as well. So minus pi will become plus pi, 0 will become 2 pi, and plus pi will become 3 pi. So this kind of response you will get. Yeah, in that manner. Okay, so this is your high pass filter. What about band pass filter? 0, and let's just say this is pi and this is minus pi. Band pass filter. So somewhere in between it will pass, and after that it will not pass. Sorry, somewhere it will band pass filter. Okay, sorry, band pass filter. Somewhere in between it will pass, and after that it will not pass. Somewhere in between it will pass, and after that it will not pass. Similar thing will be repeated. So this is your, only this much I need to see, that 0 and higher both not being passed, somewhere in between it is being passed, right? So if any kind of response is given, you will be able to tell whether it is band pass, band stop, all pass, whatever it is, you will be able to tell, right? Now band stop. Band stop. 0, pi, minus pi. Band stop means it will pass 0 as well, it will pass higher as well, it will pass 0 as well, it will pass higher as well. Okay, and then the same thing will be just repeated. This is what will happen is that this particular part will be repeated. So minus pi will move to pi only. Yes, this part will be repeated. And here also the same part will be repeated. I don't care about that particular part basically. You can just see I only care about this much part. That 0 is being passed, pi is also being passed, somewhere in between it is not being passed. And what about all pass filter? All pass filter will simply be 1 to the power n. What did I say? 1 to the power n? No, 1 to the power n is not a all pass filter. Really sorry guys, I should not have said 1 to the power n. 1 to the power n is not a all pass filter. What is 1 to the power n? It is a all pass filter or low pass filter, high pass filter, what it is? 1 to the power n. What do you think? Low pass filter, high pass filter, or what? Low pass filter, right? 1 to the power n. X of n is 1 to the power n. What will be x e to the power j omega? That would be 2 pi del omega, right? So only at omega goes to 0 you are having the impulse, then at 2 pi and then minus 2 pi. So 0, 2 pi, minus 2 pi. So between minus pi to pi, only 0 frequency is being passed. Between minus pi to pi, only 0 frequency is being passed. That means 1 to the power n is a low pass filter. Okay. So all pass filter will be simply what? Delta n. All pass filter will be delta n. Right. Or I told you about the delay, the same thing, delay, just the delay. Here your x of n is there and this will be x of n minus n naught. So e to the power minus j omega n naught x e to the power j omega. That would be equals to y e to the power j omega. So what would be your h e to the power j omega? That will be e to the power minus j omega n naught. And what will be its amplitude? That would be 1. So practically you will not be able to design delta n, but practically you can design a delay filter. You can just give a simple delay, right? So practically delta n is not possible, but surely a delay is possible. All good, all fine. So this is your all pass filter. Okay, so these were the practical filters that we wanted to make and we have made it. Now let's see some question. X of n is given, y of n is given. You need to tell which is your possible h of n. So what do you think what is happening here? X of n was having two frequency component, pi by 3 and 2 pi by 3. Basically what was the frequency spectrum of x of n? You will be having an impulse at pi by 3, at minus pi by 3, at 2 pi by 3 and minus 2 pi by 3, and then the same thing will be repeated. Same thing will be repeated here, the same thing will be repeated with the center at 2 pi. So 2 pi minus pi by 3, 2 pi minus 2 pi by 3, 2 pi plus pi by 3, 2 pi plus 2 pi by 3, and similarly here as well, minus 2 pi plus pi by 3. In that manner it will just be repeated, right? So frequency components are pi by 3 and 2 pi by 3, but in the output only 2 pi by 3 frequency component is present. That means this has been eradicated. So you need to find that filter, you need to find that kind of filter which will kill this frequency spectrum, right? So what I will do, I will find h of h e to the power j omega in all of them, and then I will see that what is happening at pi by 3 frequency and what is happening at 2 pi by 3 frequency. Is that clear to you? So let's try doing it. So what is, let's check option A. We need to check the options. So in option A, what will be my h e to the power j omega? So where is the center? Center is at minus 1 by 2 plus you will get 1 by 2 e to the power j omega, 1 by 2 e to the power j omega. Basically what is your h of n? If you are not getting, if you are not understanding it, what is your h of n? My h of n is minus 1 by 2 delta n, right? Minus 1 by 2 delta n plus 1 by 2 delta n minus 1 plus 1 by 2 delta n plus 1. 1 by 2 delta n plus 1. This is your delta n minus 1. This is 1 by 2 delta n plus 1, right? So what you are getting, h e to the power j omega would be minus 1 by 2 plus 1 by 2 e to the power minus j omega plus 1 by 2 e to the power plus j omega. So you are getting minus 1 by 2 plus cos omega. This is your h e to the power j omega. Say yes or no for option A, right? H e to the power j omega. Now what you need to do, you need to check the gain at omega equals to pi by 3 and omega equals to 2 pi by 3. So h at omega equals to pi by 3, pi by 3, h e to the power j pi by 3. that would be minus pi 1 by 2 plus cos pi by 3. That would be minus 1 by 2 plus 1 by 2. So you can see that it is providing a gain of 0. And this is what you wanted. Pi by 3 should be eradicated. So it is providing a gain of 0. But not only at pi by 3, you need to check at omega equals to minus pi by 3 as well. Why is that so? Because the input is having plus pi by 3, minus pi by 3, plus 2 pi by 3 and minus 2 pi by 3. Input is having the impulses at pi by 3, 2 pi by 3, minus pi by 3 and minus 2 pi by 3. So you need to check everywhere. Okay, so what I will do is that I will just make the frequency spectrum of input as well, so that you don't get confused when you revise it. So what is my matter of concern? Always my matter of concern is between minus pi to pi. So between minus pi to pi, what all impulses you are having? At pi by 3, at 2 pi by 3, at minus pi by 3 and at minus 2 pi by 3. So I need to check at pi by 3 as well. I need to check at 2 pi by 3 as well. I need to check at minus pi by 3 as well, and I need to check at plus pi by 3 is minus 2 pi by 3 as well. Luckily, what we got to know is that we are having cosinusoid here. So whatever that is happening at pi by 3, the same will be happening at minus pi by 3 as well. Because here if I put minus pi by 3, the same answer I will get. That means neither positive frequency is being passed, neither pi by 3 is being passed, neither minus pi by 3 is being passed. That means they are eradicated, they are gone. Let's check what is happening at 2 pi by 3. Now who knows even 2 pi by 3 is not being passed. So if I check at 2 pi by 3, so what answer I will get? One thing is pretty sure, whatever that I will get at 2 pi by 3, the same I will get at minus 2 pi by 3 as well, because this is even, right? Cos omega is even only. So minus 1 by 2 plus cos 2 pi by 3. So minus 1 by 2 plus cos pi minus pi by 3 can I do? No. In the second quadrant, cos is negative. So here I need to add a negative sign as well. Oh, sorry guys. So 2 pi by 3 can be written as cos pi minus pi by 3. 2 pi by 3 can be written as cos pi minus pi by 3. So cos pi minus pi by 3, that means second quadrant. So what is the answer you are getting? What it would be? Minus 1 by 2, minus 1 by 2. So minus 1. Okay. So what you are getting at omega equals to 2 pi by 3 and minus 2 pi by 3. Your h e to the power j 2 pi by 3 is, that would be equals to h e to the power minus j 2 pi by 3, that is equals to minus 1. This is the scenario you are getting. So the gain is minus 1. So first answer should be there, right? No. Because the gain is minus 1, no, not plus 1. Basically what you got to know that pi by 3 and minus pi by 3 is cancelled. But the component at 2 pi by 3 and minus 2 pi by 3, that will be multiplied with minus 1. So what would be your output? Minus cos 2 pi by 3n. Are you able to understand this point? What I mean to say is that filter of AHN, if I apply and my applied input is cos pi by 3 plus cos 2 pi by 3n, then what will happen is that this component will pass. Nothing. So what will happen is that this component will not pass, but this component will pass, but with the gain of minus 1. With the gain of minus 1. So what will be the output? Output will be minus cos 2 pi by 3n. This will be the output, not this output. But you need the gain to be plus 1, right? Not minus 1. So this is wrong. Understood? Okay. So this was the beauty of this question, that people will feel that okay, this is not being passed and this is being passed, so this is the answer. But here minus should have been multiplied, which is not multiplied here. So provided gain is minus 1, not plus 1. What about the next one? Minus 1 is there. So directly I am writing down h of z. This would be n equals to 0. This would be n equals to 2 and this would be n equals to minus 2. So what will be your h e to the power j omega? Minus 1 plus e to the power j2 omega plus e to the power minus j2 omega. So what you are getting? Minus 1 plus 2 cos 2 omega because multiplied with 2 divided by 2. So this is your h e to the power j omega. Again let's check where we will check at omega equals to pi by 3 and 2 pi by 3. Again you can see that it is even only if I check at pi by 3. So what is the value of cos 2 pi by 3 that I saw here only? It is minus 1 by 2. Cos 2 pi by 3 is minus 1 by 2. Minus 1. Okay, it is gone here only. Minus 2. So you don't even need to check at 2 pi by 3 because you know that even pi by 3 component is not being cancelled. Right? We are understanding this point, right? Or I did something different. Did I do anything wrong? No, minus 1 was there, 1 was there. E to the power j 2 omega, e to the power minus 2 j omega, e to the power plus 2 j omega, and e to the power minus 2 j omega would come. Right? So 2 cos 2 omega. 2 cos 2 omega. When I check at pi by 3, what is the response I am getting? 2 into cos 2 pi by 3. What is the value of cos 2 pi by 3? That is cos pi minus pi by 3. Cos pi by 3 is 1 by 2. So minus 1 by 2. So minus 2. You don't even need to check ahead now. You don't even need to check at 2 pi by 3 because you know that this is also getting a gain of minus 2. So let's check what let's just check. So if we are checking, what we go to know? That minus 1 plus 2 cos 4 pi by 3. Right? 2 cos 2 omega. So even in the fourth quadrant it is negative only. So same thing you are getting. The value of cos 2 pi by 3 and value of cos 4 pi by 3 is same only. Right? Both is minus 1 by 2. So basically you are getting gain of minus 2 only. At both of the frequencies you are getting the gain of minus 2 only. So what would have been your output? Your output would have been whatever the input is there, that being multiplied with minus 2 plus cos 2 pi by 3n. Right? So these frequencies are just being multiplied with the gain of minus 2. So even option B is wrong. Right? What about this one? Can you make the response of option C? Yes, surely I can make the response of option C. So for the response of option C, I can surely make. So you know that all of the above cannot be the answer. So this has to be the answer. Option C has to be the answer. And surely I can see that it is a band pass filter. Right? Band pass filter. Here you can see that sin pi by n, sin pi by 6n divided by pi by n. This would have given this kind of response. Minus pi by 6 to plus pi by 6. Now what will happen? The center will move to 2 pi by 3. The center will move to 2 pi by 3. So center will move to 2 pi by 3. Center will move to 2 pi by 3. So 2 pi by 3 minus pi by 6. 2 pi by 3 minus pi by 6. So that would be 4 pi by 6 minus pi by 6. That would be pi by 2. Right? Pi by 2. And plus pi by 6. So that would be 5 pi by 6. So basically which component is being passed? Here 2 pi by 3 component will pass with the gain of 1. Here the gain of 1 would be there because 2 is being multiplied, no? So gain of 1 would be there. And here also this point will be minus 2 pi by 3. And this point will be minus pi by 2. And this point will be minus pi by 6. So gain of 1 would be passed. So basically 2 pi by 3 and minus 2 pi by 3 will be passing with the gain of 1. And here will be pi by 3. Because this is 90 degree, pi by 3 is 60 degree. So pi by 3 would be somewhere here. And minus pi by 3 would be somewhere here. Right? So this is your h e to the power j omega. So when you write down the output, you don't see at the mode. This is not you want to see. This is what you want to see. So this is the scenario. What is the scenario? That 2 pi by 3 component is being passed with the gain of 1. And pi by 3 and minus pi by 3 components are being passed with the gain of 0. So this will be the correct answer. If you pass your x of n with this filter, then you will get the correct answer. Well and good. Okay. So answer option C would be there. So concept of eigenvalue and eigenfunction now we want to study because we have seen the concept of filters in a very good manner. So I will take a pause and then I will come back. We will start studying about concept of eigenvalue and eigenfunction. Okay. And let's take another point. What is the point? That your x of n is 1 to the power n. What kind of filter is that? And if your x of n is minus 1 to the power n, what kind of filter is that? So what is 1 to the power n? If you make the diagram, you will know what kind of filter is that. You know surely it is a low pass filter. But if you make the diagram, this is your 1 to the power n, right? 1 to the power n. So always 1 1 1 1, always 1 1 1 1. 0 1 2 minus 1 minus 2. It is always 1. This is your x of n. X of n versus n. And what is x to the power j omega here? That is 2 pi del omega. If I talk about only between minus pi to pi. If I only talk about between minus pi to pi. What does that mean? That means only omega goes to 0 passed. Right? At omega goes to pi is not passed. Only omega goes to 0 is passed. Rest all the frequencies are not passed. That means it is a low pass filter. Low pass filter. And you will call it the best low pass filter. Because it is only passing the 0 frequency. What is the use of low pass filter? That it should pass low frequencies. It is passing only the 0 frequency, which is the lowest frequency. After that, it is not even passing. So your time domain signal x of n is not rapidly changing, no. It is always 1. So time domain signal is not even changing. If your time domain signal is not even changing or it is changing slowly, that means it will be kind of low pass filter. It will be near to the low pass filter. Let's just say if I make, or let's just explain about minus 1 to the power n. So what do you think? What kind of filter would be minus 1 to the power n? Can you write down? One thing you know that if your x of n, if your 1 to the power n is being multiplied with minus 1 to the power n, that means if your x of n, which is a low pass filter, if it is being multiplied with minus 1 to the power n, then it will become a high pass filter. So surely it will be a high pass filter. And how you can check? Right? Say yes or no. Right? So 1 to the power n has 2 pi del omega. So what this will have? This will have 2 pi del omega minus pi. And similar thing at minus pi as well. So omega plus minus pi. 2 pi del omega minus pi. 2 pi del omega minus pi would be there. 2 pi del omega minus pi would be there. So basically it will have an impulse at pi. But it should be periodic with 2 pi, no? So periodic with 2 pi, that means pi minus 2 pi, another impulse you will have here. At minus pi as well you will have the impulse. So between minus pi to pi it will have these impulses. That means it is passing the highest frequency only. So that means only omega equals to pi is being passed. Only omega equals to pi is being passed. That means it is a high pass filter. So let's make x of n. So if I make, or let's call this as y of n. Let's call this as y of n. So if I make the diagram of y of n. So here what is the scenario? At n equals to 0 you will get plus 1. At n equals to 1 you will get minus 1. At n equals to 2 you will get plus 1. Then minus 1, plus 1 and minus 1. And similarly here as well. Minus 1, plus 1, minus 1, plus 1 and so on. Right? N equals to 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So what you can see, x of n was changing, it was not even changing. Forget about changing rapidly, it was not even changing, it was always 1. But this is changing rapidly. 1 minus 1, 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 1 minus 1. So if your time domain signal changes rapidly, that means there will be more of a high pass nature. And if your time domain signal becomes, if it changes in a lesser rapid manner, in a less rapid manner, that means it will have a low pass nature. What I mean to say is that let's just say I make two kind of signal. I make this kind of signal. So 3, 2, 1 and then 0. Then again the same thing is being repeated, or this kind of signal is there. Basically this is the signal, that's it, nothing else. And another signal is this 3, 2, 3, minus 2, plus 1, 3, minus 2, plus 1. So which will have more high pass nature? What I want to say, which is a better high pass filter? Which is a better high pass filter? What will be your answer? This is a better high pass filter because it is changing more rapidly. And if I ask you which is a better low pass filter, then this would be the answer, better low pass filter. So if your time domain signal changes more rapidly, that means it is near to the high pass filter. That means it will show the high pass filter in a better manner. It will show the nature of high pass filter in a better manner. And if it changes slowly, that means it will show the nature of low pass filter in a better manner. So all these points are like very, very deep points. Okay. In the gate examination till now, these points are not introduced. So that's why I thought that if someone asks you, even in the interview, if someone asks you about low pass filter, high pass filter in the discrete domain, in the digital domain, then this is how you can tell. 1 to the power n, what is the meaning of minus 1 to the power n? I hope you understood the importance of minus 1 to the power n, and now you have understood the importance of 1 to the power n as well. Right? So minus 1 to the power n can change from low pass to high pass, from high pass to low pass as well. And minus 1 to the power n means it is very rapidly changing, very fast rapidly changing. That means it is only passing the omega equals to pi frequency component, omega equals to pi frequency component only. Is that clear to you? All good, all fine. So now we are going to study about concept of eigenvalue and eigenfunction, which is nearly the same that we study in continuous time. So nearly the same kind of a concept would be there. Okay, well and good. Thank you very much. And more questions on digital filter we will see in this video only. Like here I will add up more parts. So in some questions we will see more questions we can see on the concept of digital filter. Okay, yeah, thank you. Hi everyone, welcome back. So now we need to study about concept of eigenvalue and eigenfunction. So you guys already know what is the meaning of eigenvalue, and you guys already know what is the meaning of eigenfunction. So if there is a LTI system having an impulse response of h of n and applied input is x of n, then how the output y of n is given? X of n convolution h of n. Now the output y of n is just equals to x of n only, but multiplied with the constant factor. Output y of n is equals to x of n only, but multiplied with the constant factor. This is a constant factor. So then your x of n will be known as eigenfunction and your alpha will be known as eigenvalue. There you go. Okay. So this is the concept of eigenvalue and eigenfunction. If we solve the same concept, if we solve the same block in case of DTFT, then how will we solve it? Y e to the power j omega would be given as x e to the power j omega multiplied with h e to the power j omega. And the same block could be solved as z transform as well, x of z multiplied with h of z, because convolution in time domain will be equals to multiplication in frequency domain and z domain. Right? Well and good, very easy. So your y e to the power j omega could be given as some constant value x e to the power j omega. Here also it would be given as some constant value x of z. So this constant value will be eigenvalue and this will be eigenfunction. Right? So let's see the example. There is a h of n whose z transform is h of z. The z transform of h of n is h of z. So what is your h of z? H of z is basically summation n going from minus infinity to infinity, h of n z to the power minus n. This is your h of z. Okay, you need to find y of n. Right? So what will be your y of n? Y of n will simply be, if I call this as x of n, so y of n will simply be x of n convolution with h of n. So what will be your y of n? Summation, you know how to define the x of n, how to define the convolution? Yes, I know how to define the convolution. X of k, or what I would do is that I would keep h of k as it is, and I will invert and then shift the x of k, and I will put the limit of k, not n. I will put the limit of k. So this is how you define the convolution, right? Now what I would do is that I would keep h of k as it is, What is your x of n? X of n is z to the power n. X of n is z to the power n. So what will be your x of minus k plus n? That would be z naught to the power minus k plus n. Say yes or no. So it can be written as z naught to the power minus k into z naught to the power n. Basically, in place of n, what I am going to put minus k plus n. So z naught to the power minus k into z naught to the power n. Now this z naught to the power n can be taken outside because limit is put of k only. So you are putting the limit of k. So k going from minus infinity to infinity, h of k z naught to the power minus k. So if this is your h of z, if this is your h of z, then what would be your h of z naught? That would be n going from minus infinity to infinity, h of n z naught to the power minus n, right? So here can I replace k with n, or what I can do here, I can replace n with k, because n is just a variable, right? In place of n I can put k as well. So k goes from minus infinity to infinity, h of k z naught to the power minus z naught to the power minus k. So basically what this is your h of z naught only. So what you are getting, z naught to the power n into h of z naught. This is your y of n. So what you can see here, what you can see, your applied input was z naught to the power n. This was your applied input, z naught to the power n. So same applied input is being reflected at the output. Just in place of, in h of z, in place of z you just put z naught, and this will be your eigenvalue. This is your eigenvalue and this is your eigenfunction. But there is one more factor. What is the factor? That z equals to z naught. In place of z you are putting z equals to z naught, right? In place of z you are putting z equals to z naught. So z equals to z naught you are putting in place of z. So z naught should be in the ROC of h of z, right? So this is another point. I hope you have already seen the value. I hope you have already seen the video of eigenvalue and eigenfunction in case of continuous time. So in case of continuous time we have done that deep discussion. That's why we are moving a bit faster here, right? In case of continuous time the discussion is deep and we have done it. So that's why we are moving a bit faster here. So what is the eigenvalue? What is the eigenfunction? Eigenfunction is z naught to the power n, and the z transform of h of n is h of z. So what this is known as? This is known as transfer function of LTI system. Transfer function of LTI system. What is this h of n? This is known as impulse response of LTI system. So transfer function of LTI system is h of z, and applied input is z naught to the power n. So what will happen? At the output as well you will get z naught to the power n, but multiplied with the constant factor. What will be that constant factor? That constant factor would be that you just need to put this z naught here. You just need to put this z naught in place of z. But the point is that z equals to z naught, z equals to z naught should lie in the ROC of h of z. Then only you will be able to put it, otherwise you will not be able to put z equals to z naught in h of z. If you want to put z equals to z naught, then it should be in the ROC, no? Basically h of z should converge at z equals to z naught. H of z should be converging at z equals to z naught. Let's just say at z equals to z naught, your h of z is going to infinity. Then there is no meaning of that, right? So your h of z should be converging at z equals to z naught, right? So that means the z equals to z naught should be lying in the ROC of h of z, or you can say that h of z should be converging at z equals to z naught, or it can be written as that z equals to z naught should lie in the ROC of h of z. Okay, so z naught to the power n will be reflected at the output, but it will be multiplied with the constant factor. That constant factor will be in h of z. You just need to put the z naught value. Let's see the question. This is your h of n, 1 by 2 to the power n un. You need to find output y of n. So what is your h of z? H of z is z upon z minus 1 by 2. What is the ROC? ROC is mod of z. Since there is un, so mod of z greater than 1 by 2, right? So this is the ROC. ROC is mod of z greater than 1 by 2. So can you make the ROC? Surely you can make the ROC. So ROC is mod of z greater than 1 by 2. Okay, so these are the ROCs. This is the ROC, right? Now 2 to the power n. What is the ROC? Mod of z greater than 1 by 2. So this point, this is the z naught point, right? What will be the output? Output will be simply 2 to the power n. What is the form? Here the form is z naught to the power n. Here also the form is z naught to the power n. Now z naught could be anything. It could be real imaginary, it could be purely imaginary, it could be anything. Real imaginary complex, it could be anything. So it is basically z naught to the power n only. The form is z naught to the power n. So z naught to the power n only will be reflected, but it will be multiplied with the constant factor. What is that constant factor? That in place in h of z, in place of z you need to put z equals to z naught. What is the value of z naught? That is 2. But the condition is it should be lying in the region of convergence. Is it lying in the region of convergence? Yes. Because what will be this point? This point will be 1 by 2 and this point will be 2. So yes, it is lying in the region of convergence. So what you can do, what will be your output? 2 to the power n, and in place of z you need to put 2. So 2 divided by 3 by 2. So 4 by 3. 4 by 3. So 2 to the power n into 4 by 3. This will be the output. Well and good. So this is the final output. This is the final answer. This is the final answer. Now minus 2 to the power n. In case of continuous time, I said that minus 2 to the power t is not an eigenvalue. Sorry, minus 2 to the power t is not an eigenfunction. Why is that so? Because e to the power ln minus 2 is not even defined. So in the continuous time, it was not a eigenfunction. But here in discrete time, minus 2 to the power n. So where will be minus 2? What is the value of z naught here? Z naught value is minus 2, right? Z naught value is minus 2. So minus 2 would be somewhere here. So yes, it is lying in the ROC. Surely it is lying in the ROC. And if it is lying in the ROC, that means yes, it is eigenfunction for sure. So what will be your y of n? So what will happen is that whatever the input that is applied, z naught to the power n, that will be coming as it is. But in h of z, in place of z, you need to put the value of z naught. What is that value? That is minus 2. So minus 2 to the power n, here you need to put minus 2. So that would be minus 2, 4 by 5. Answer would be minus 2 to the power n into 4 by 5. Well and good. Okay. What about this point 1 plus j divided by 2? What is the value of z naught? 1 plus j divided by 2. So this point will be 1 by 2. So 1 by 2, this point is 1 by 2, right? Because ROC is mod of z greater than 1 by 2. So this point will be 1 by 2 only. Now the point is 1 by 2 plus 1 by 2j. 1 by 2 plus 1 by 2j. So 1 by 2 plus 1 by 2j. The point would be somewhere here. But some guys may think that, sir, whether it will be lying inside or outside. So what is the point? The point is whatever the points that are there inside the circle, whatever the points that are there inside the circle, they will have the magnitude. They will have the magnitude less than 1 by 2. Say yes or no. And whatever the points that are there outside the circle, they will have the magnitude greater than 1 by 2. What I am saying, whatever the point that is lying inside the circle, they will have the magnitude of less than 1 by 2, and whatever the points that are there outside the circle, they will have the magnitude of greater than 1 by 2. Is that clear to you? Say yes or no. That's why we say ROC is mod of z greater than 1 by 2. That means ROC is outside. ROC is outside. So all these points will be having the magnitude of greater than 1 by 2. What is the magnitude for this one? What is the mod of z naught for this one? That is 1 by 2 under root 2. So that will be under root 2, and it is surely greater than 1 by 2. Say yes or no. Right? Sorry, the magnitude will not be. What will be the magnitude? 1 by 2 is coming outside 1 plus j. So 1 by 2 into under root. So 1 by under root 2. Sorry, the magnitude will be 1 by under root 2. 1 by under root 2, which is 0.707 something, which is greater than 1 by 2 only. Right? 1 by under root 2 is surely greater than 1 by 2. That means yes, it is also lying in the ROC. This point also lies in the ROC. Are you able to understand this point? So what will happen is that, sir, whatever the input that is applied, that will come at the output. Whatever the input that is applied, that will come at the output. But in h of z, what I need to do is that I need to put this z naught. which is 1 plus j divided by 2, right? So here what will be h of 1 plus j divided by 2? That would be 1 plus j divided by 2, 1 plus j divided by 2 minus 1 by 2, right? So 1 plus j divided by j, it would be equals to 1 plus j divided by j. This calculation you can do on your own, right? In place of z, what you need to put? 1 plus j divided by 2. This is what you need to put. So in place of z, I put 1 plus j divided by 2. So 1 plus j divided by 2 minus 1 by 2. So 2 and 2 is getting cancelled out. 1 plus j divided by j. So what we are getting? 1 plus j divided to the power n, and surely this is lying in the ROC for sure. How will you check whether it is lying in the ROC or not? What you will do, you will calculate the magnitude of z naught. Magnitude of z naught is coming out to be 1 by under root 2, which is surely lying outside the ROC only, sorry, which is lying inside the ROC only. That means outside this mode of z equals to 1 by 2 circle. So it is lying outside the mode of z equals to 1 by circle. That means surely it is lying in the ROC. So better than pointing out the point, what we will do, we will just calculate the magnitude. Here what will be the magnitude of mode of z naught? Here mode of z naught would be 2. Here what is mode of z naught? Here mode of z naught is 1 by under root 2. And here what is mode of z naught? It is 2. Which is greater than 1 by 2? This is also greater than 1 by 2. And this is also greater than 1 by 2. So if it is greater than 1 by 2, your job is done. That's it. Okay. And then simply this output will be reflected. And in h of z, you need to put this z naught value, that is 1 plus j divided by 2. So if you put that, you are getting 1 plus j divided by j. So 1 plus j divided by j. Okay. Let's see this one. What is the value of z naught here? E to the power j pi by 3. What is the mode of z naught here? 1, which is surely greater than 1 by 2. Are you able to understand this point? Here, what is your mode of z naught? That is 1, which is greater than 1 by 2 only. So yes, here also this point is lying in the region of convergence only. Yes, it is lying in the region of convergence. That means whatever the input is there, that will be applied as it is. But in h of z, in place of z, you will put the value of z naught, which is e to the power j pi by 3. So what is your h of z? Again I am writing down here, that is z upon z minus 1 by 2, or you can write it down as 1 upon 1 minus z inverse, right? This was your h of z. So this is what you can write down. So what will be the answer? E to the power j pi by 3, and this will come as it is, into 1 upon 1 minus 1 by 2 e to the power, in place of z you need to put e to the power j pi by 3, so it can be written as this particular thing, right? So this would be the answer. Okay. Well and good. So this is the answer. So whatever the input is there, that is coming as it is, just multiply with a constant factor. This is a constant factor. Now 1 by 4 to the power n. 1 by 4 to the power n. So what is the value of z naught here? 1 by 4. What is mode of z naught? 1 by 4, which is less than 1 by 2. That means y of n will tend to infinity. Why is that so? Why is that so? Because z naught equals to 1 by 4 doesn't lie in the ROC of x of z. Okay. Now what you need to find? In the next one as well, you need to find y of n. So let's take this block diagram to the next page. So here what is my input? What you can see? This 3 e to the power j pi by 3. This could be a constant factor, no? So only what I will do, I will tell the output with respect to e to the power j pi by 4n. And this is a constant value only, no? This is constant. Do you remember one thing? In case of LTI system, if my applied input is x of n, then what is my output? Y of n. And if your applied input is alpha x of n, if your applied input is alpha x of n, then what will be your output? This is your LTI system, which is not changing, h of n only. Forget about the concept of eigenvalue, eigenfunction. I am just talking about LTI system only. So if I apply x of n, what do you get? y of n. If I apply alpha x of n, what do you get? Alpha y of n. So here what I am doing, I am only telling the output with respect to this e to the power j pi by 4 n. So here what is the value of z naught? This is the value of z naught. So value of z naught is e to the power j pi by 4. So what is your mode of z naught? That is 1 greater than 1 by 2. That means yes, it is lying in the ROC for sure. So what will happen? Whatever the input is there, that will be coming as it is. But in h of z, you need to put z equals to e to the power j pi by 4. Just you need to put the value of z naught. Now, if I had applied e to the power j pi by 4 n input, then this would have been my output. But now what I am applying? I am multiplying this particular thing with the constant factor. That constant factor is 3 e to the power j pi by 3. 3 e to the power j pi by 3. So again it can be written as 3 e to the power j pi by 4 n plus pi by 3, and in place of h of z, what is your h of z? 1 upon 1 minus 1 by 2 z inverse. So in place of that you need to put this particular value. There you go, this would be the answer. So what did you understand here? That this is my h of n and my applied input is a e to the power j omega naught n plus phi. A e to the power j omega naught n plus phi. And what I am saying is that ROC includes z equals to 1 circle. ROC of h of z includes z equals to 1 circle, because here what will be the value of z naught? E to the power j phi will be a constant value, right? Here what you can write down, a e to the power j phi will be a constant value. Only the concept of eigen function will go for this particular function. So here what will be the value of z naught? Z naught will be e to the power j omega naught. What is the mode of z naught? That is 1. And now I am saying that ROC includes mode of z equals to 1 circle. What does that mean? That means this point will be in the ROC for sure. And if this point is there in the ROC, then what will happen is that your y of n, whatever the input is there, basically a e to the power j phi will also come and this part will also come. So whatever the input is there, which is a e to the power j omega naught n plus phi, whatever the input is there, that will come as it is. Just in h of z, in place of z, what you need to put? E to the power j omega naught. Is that clear to you? Okay. Or if you don't want to remember this particular thing, this is just a conclusion. This is just a conclusion. If you don't want to remember this conclusion, then you can solve in this manner as well. Very simple thing, very straightforward, nothing complex is there. E to the power j omega naught n plus phi plus some phase is there. So that phase is actually a constant value only. So constant value I took outside, then only I need to focus on e to the power j omega naught n, where ROC should include unity circle. If ROC is including the unity circle, that means e to the power j omega naught, z naught value of e to the power j omega naught will surely lie in the region of convergence. And if it is lying in the region of convergence, then your job is done. In place of z, you can simply put the value of z naught. Is that okay for you? Right? And what if this question is coming? So what would be your y of n? Y of n would be somewhat like this, 2 to the power n un. Then in place of h of z, you put z equals to 2. Is that so? Wrong. Right? This is absolutely wrong. Why is that so? Because when we started talking about, we were talking about z naught to the power n. Un is not there. Z naught to the power n. Un is not there, right? We were talking about z naught to the power n, but this is your z naught to the power n un. So it is not an eigen function. Right? So what would be your y of z? Sorry, you need to find y of n, right? So y of n would be x of n convolution with h of n. So either you can perform the convolution, or what you can do, y of z is equals to x of z dot h of z. So your y of z would be, what is your x of z? Z upon z minus 2 into z upon z minus 1 by 2. But whenever you do it, you know that this will say that ROC is mod of z greater than 2 because of un, and this will say that ROC should be mod of z greater than 1 by 2. So yes, there is a common part. that means ROC would be mod of Z greater than 2. This is the final ROC. So ROC is important there, and then you can solve it. So what I would do, y of Z divided by Z, Z upon Z minus 2 into Z minus 1 by 2, and from here you will get the value of y of n, which will be a causal signal, right? So you can solve it on your own. As far as I remember, the answer was 2 to the power n plus 1, because there was a way of writing it down. 2 minus 1 by 2 u of n. As far as I remember, this was the answer we will get. This is the answer we will get. I am not sure, okay, because I also don't remember the technique. So I also don't remember the final result. I will solve it. You can do the partial fraction and you will be able to solve it. Most probably this is the answer we get as far as I remember. But it could be wrong as well. Or shall I solve it for you guys? So let me solve it only. So Z minus 2 plus 1 upon Z minus 1 by 2. So this would be A, this would be B. So let's find out the value of A. So what I would do, I would put the value as 2. So 2 divided by 3 by 2. What you will be getting? 4 by 3. So here I am getting 4 by 3. Value of A is coming out to be 4 by 3. Okay. And what will be the value of B will come out to be? So for B, what I will do is that I will put 1 by 2. So 1 by 2 minus 3 by 2. So that value will come out to be minus 1 by 3. So this will be minus 1 by 3. So from here, what is the y of Z you are getting? The y of Z, this is y of Z divided by Z. So what will be your y of Z? Y of Z is coming out to be 4 by 3 into Z upon Z minus 2 minus 1 by 3 into Z upon Z minus 1 by 2. So what you are getting? 4 by 3 into 2 to the power n un. Why I am taking un only? Because you know that this is the ROC. Because of this ROC, you will take the causal signal only. And minus 1 by 3 into 1 by 2 to the power n un. So this is the answer you are getting, which is same as 2 to the power n plus 1 minus 1 by 2 to the power n plus 1 divided by 2 minus 1 by 2, 3 by 2 u of n. Is it the same? Let's check. 2 to the power n into 2 divided by 3 by 2. So 4 by 3 to the power n. Yes. 1 by 2 to the power n into 1 by 2 divided by 3 by 2 divided by 3. Yes, they are the same only. Okay, so trick, if you don't remember, then you can solve it as well. And if you remember the trick, then this is how you will be able to write down the answer. But with the help of trick, you will never be much confidence in the examination hall. You will not be much confident in the examination hall. If you want the confidence, that means you should be able to solve with the conceptual part, not just with the trick. So tricks are also important and concepts are also important, but there should be an equilibrium, right? So this is the answer you have got. Okay, so 2 to the power n un is not an eigenfunction. This is how we need to solve it. Now we will understand the same concept using the concept of DTFT. And when the DTFT will be defined, when ROC includes the ROC of h of z will include the unity circle. What it is? It is known as unity circle. And if it is including the unity circle, that means in place of z, if you put e to the power j omega, then h e to the power j omega will be defined. So y of n is given as x of n convolution with h of n. But if I write down in terms of x e to the power j omega, or I write it down as h e to the power j omega. So y e to the power j omega is given as x e to the power j omega dot h e to the power j omega. So you can understand the same concept with respect to the DTFT as well, right? So let's just say this input is applied e to the power j omega naught n. So let's understand this particular question with respect to z transform. So this would be your z naught to the power n, and can I write it down as h of z? Surely I can write down, right? Do you understand this point? This I can write down as h of z only. So what would have been your y of n? Y of n would have been z naught to the power n, z equals to z naught. But the point is, ROC should include unity circle. ROC should include a unity circle. Now if h e to the power j omega is defined, that means ROC is surely including the unity circle. Here what is the value of z naught? Here the value of z naught is e to the power j omega naught. So what is the magnitude of z naught? That is 1. So that means you will be able to put this z naught here, you will be able to put this z naught here if ROC includes the unity circle. If ROC includes the unity circle, then only you will be able to put this z equals to z naught here. Your ROC is surely including the unity circle because h e to the power j omega is defined. That what I am saying is that if h e to the power j omega is defined, that means what does that mean? That z naught equals to 1 includes in ROC, or you can say z naught equals to 1 lies in the ROC, because h e to the power j omega will only be defined if it includes the unity circle, right? So now what is the value of z naught? Z naught is, what is z naught to the power n? That is e to the power j omega naught n, e to the power j omega naught n. Now in place of z, what you can put? Z naught. And what is your z naught? E to the power j omega naught. So this is the answer you are getting. What is your y of n? Y of n is, your y of n is coming out to be e to the power j omega naught n, h e to the power j omega naught. So whatever the h e to the power j omega naught is given, whatever h e to the power j omega is given, you will see the value of omega naught. You will see the value of omega naught, and that omega naught value you will put here. Rest whatever the input is there, that you can write down. Basically what is this input? This input is e to the power j pi by 3 e to the power j pi by 2n. So this will come as a constant value, right? And this will also be reflected at the output because it is a eigen function, right? So what will be your output? Your output y of n will be simply this input will come outside. Whatever the input that you have applied, that will come outside, and in h e to the power j omega, this is h e to the power j omega is given. In place of omega, what you need to put? Omega naught. So what will be the answer? One upon 1 minus 1 by 2 e to the power minus j pi by 2, right? And what is the value of e to the power minus j pi by 2? That would be minus j. So answer would be 1 e to the power j pi by 2n plus pi by 3 into 1 upon 1 plus 1 by 2j. Okay, so answer would be 2 upon 2 plus j. So this would be written as 2 upon 2 plus j, 2 upon 2 plus j. This is the answer. Well and good. Okay, a very simple thing. Whatever that we studied in Z transform, the same thing is being reflected here as well. Nothing different is there. I am just saying that if h e to the power j omega is defined, that means ROC includes the unity circle. If it is including the unity circle, then only with respect to omega naught directly you can solve. Now what if the input is cos omega naught n? So same thing, whatever that we did in continuous time, the same thing we are going to do here. E to the power j omega naught n plus e to the power minus j omega naught n divided by 2. So this 1 by 2 is a constant value. Now what will be your y of n? So let's write down the output with respect to 1 by 2 e to the power j omega naught n. So output would be, this will come as it is, but multiplied with the constant factor. In place of omega you need to put omega naught. Then 1 by 2, this will come as it is, but multiply with the constant factor. In place of omega you need to put minus omega naught. So this will be your y of n. And now what if h e to the power j omega naught is equals to h e to the power minus j omega naught? So what will happen? They can come outside. So y of n would be equals to 1 by 2, and that I am calling equals to h e to the power j omega naught only. So it can come outside, and here you will be left with e to the power j omega naught n plus e to the power minus j omega naught n, and this divided by 2 can go here. So what you are getting? You are actually getting your y of n as, just in place of what you are getting, again cos of omega naught n you are getting as it is. Whatever the input that you applied, you are getting that as it is. In h e to the power j omega, it is multiplied with the constant factor. That constant factor is h e to the power j omega, but in place of omega you need to put omega naught. That would be the answer. So now you can say that yes, it is a eigenfunction, and this is a eigenvalue. But array yaar, yeah, this is the eigenfunction, this is the eigenvalue, but it is only true for this condition, a very important condition, only for this condition. So this is not generally a eigenfunction. This is cos omega naught n is generally not an eigenfunction. It will be an eigenfunction only when h e to the power j omega naught is equals to h e to the power minus j omega naught. That means whatever that you see at the positive frequency, the same thing you need to see at negative frequency as well, if only at omega equals to omega naught. So what is the point? Cos omega naught n will be an eigenfunction to a stable LTI system only when the gain at positive frequency is equals to the gain at negative frequency. But only you need to check at omega n, sorry, only you need to check at omega naught. Only you will check at omega naught only. So at omega naught frequency and at minus omega naught frequency, if I am getting the same gain, that means surely yes, it will work as eigenfunction. Otherwise, it will not work as eigenfunction. This is the bottom line. Okay. The same analysis you can do with sine omega naught n as well. So let's do the analysis for sine omega naught n divided by 2j divided by 2j. So what will be your y of n? So this will come as it is, e to the power j omega naught n divided by 2j. Minus h e to the power minus j omega naught e to the power minus j omega naught n divided by 2j. This is the answer you are getting. But if your h e to the power j omega naught is equals to h e to the power minus j omega naught, then what will happen is that your y of n could be given as, what will happen? This will come outside and inside you will get sine omega naught n only. So y of n would be whatever the input that you applied, that is coming as it is, just it will be multiplied with the constant factor, that will be in place of omega you will put omega naught. There you go. So generally it is not known as eigenfunction. Sine omega naught n is not an eigenfunction of LTI system. But if h e to the power j omega naught is equals to h e to the power minus j omega naught, then yes, condition will be satisfied and it will become an eigenfunction. So it will be eigenfunction for a given condition, the same condition whatever that I have written here. Okay. So these are the points. Which of these are true? All of them are true only. So e to the power j omega naught n is always an eigenfunction of a stable LTI system. Stable LTI system. What do you mean by stable? That means ROC includes mod of z equals to 1 circle. So instead of writing e to the power j omega naught n, I should have written e to the power j omega naught n plus phi. Okay, And similarly here as well, I should have written A cos omega naught n plus phi. Basically these shifts are constant thing, right? Here if I introduce a shift here, so what will happen? Cos omega naught n plus phi. So here also another shift will introduce. Basically here if I introduce a shift, what I am saying, if this was A sin omega naught n plus phi, so what would have happened here? A e to the power j omega naught n e to the power j phi divided by 2j minus A e to the power minus j omega naught n e to the power minus j phi divided by 2j. So here what would have been the scene? Let's write down the y of n again. So y of n would have been A e to the power j omega naught n plus phi divided by 2j. This will come as it is. Just in place of omega naught, h e to the power. Basically this is constant, this is constant, this is constant. So constant part aside, and e to the power j omega naught will come as it is. What will happen is that just it will be multiplied with a constant factor plus A e to the power minus j A divided by 2j e to the power minus j phi. This is a constant part that will come outside. E to the power minus j omega naught n, that will come as it is. So what will happen? Omega naught n plus phi divided by 2j, although there is minus in between, and then h e to the power minus j omega naught. This is the final answer you are getting. This is your y of n. Right? This is your y of n. And if both are equal, if these two are equal, then what we can do is that we can take them common. A also I can take common, and inside what I will get? Sin omega naught n plus phi. Basically, what would be your y of n? Can you see what I will take common? If both of them are equal, so what I would do? I will take h e to the power j omega naught common, and a also I am taking common, and inside what I am getting? E to the power j omega naught n plus phi minus e to the power minus j omega naught n plus phi divided by 2j. So what you are getting? A h e to the power, or you can say a cos omega naught, a sin omega naught n, a sin omega naught n plus phi, because this is sin omega naught n plus phi only. So a sin omega naught n plus phi, h e to the power j, in place of omega you put omega naught. This is your y of n. Okay, so yes, it is an eigenvalue and eigenfunction only when these two are equal. So instead of writing e to the power j omega naught n, I should write with the phase as well and with the amplitude as well. And here as well I can write down a sin omega naught n plus phi, a cos omega naught n plus phi, a sin omega naught n plus phi, a cos omega naught n plus phi, a sin omega naught n plus phi. So the first one, a e to the power j omega naught n plus phi is always an eigenfunction. Yes, stable means it is including the mod of z equals to 1 circle. That means h e to the power j omega is defined. H e to the power j omega is defined, and if it is defined, that means only in place of omega you need to put omega naught, then your answer will be there. A cos omega naught n plus phi and a sin omega naught n plus phi are not the eigenfunction always. Yes, this is also true. A cos omega naught n plus phi and a sin omega naught n plus phi are eigenfunction only when h e to the power j omega naught is equals to h e to the power minus j omega naught. So whatever the gain you get at positive omega naught frequency, the same gain should be there at negative omega naught frequency as well, right? And if h of n is even, if it is even, what does that mean? That means this particular thing is there. Basically, if it is even, that means h of n is equals to h of minus n. Now, what is the Fourier transform of h of n? That will be h e to the power j omega. And what is the Fourier transform of h of minus n? That would be h e to the power minus j omega. So this particular thing is true. And if this particular thing is true, what does that mean? That means if this is true, that means at any particular omega naught, this will also be true. This will also be true. So surely they will be eigenfunction. Right? So similar thing, whatever that we studied in continuous time, did to same thing we are studying in discrete time as well. Now, if h of n is real, so in continuous time we have derived this expression. Again, we are not going to derive the expression. So if your h of n is real, you know what was the expression we were getting. So what you need to do, you will pick this omega naught. If your h of n is real, only real, not even, it is not even. If it is even, then what will be the answer? This will be the answer. If it is only real, if h of n is only real, then what would be the answer? Then answer would be, what you need to do, you will pick this omega naught and you will put it in h e to the power j omega. So this will have a magnitude as well, and this will have a, this particular thing will have a magnitude as well, and it will have a phase as well, right? Magnitude and phase. What you will do, you will pick this omega naught, you will put here, so it will have a magnitude and a phase. So what would be your y of n? Your y of n would be, magnitude will be multiplied with the magnitude only, and phase will be going inside the phase only. So this thing we have seen in continuous time as well. Say yes or no, right? Do you remember this thing? And similar thing we can do with sinusoid as well, only when it is real, right? This is the condition, only when it is real. So again, I will pick this omega naught, I will put it here, then I will calculate the magnitude and the phase. What I will do is that, h e to the power j omega naught sine omega naught n plus phi plus angle of h e to the power j omega naught. Based on that, we can solve a problem as well. So let's solve this question. Okay, should be given that it is causal as well. Sorry, should be given that, yeah, it is not given. Let's just say it is not given that it is real. So this is the scene that h of z is given, applied input is given, you need to find the y of n. So what would be your y of n? So what you will see here, that what would have been my h of n? My h of n would have been 1 by 4 to the power n un, because it is causal. That means it is surely real. And you can see that here, what would be your h e to the power j omega? Since what is the ROC? Since it is causal, so ROC is mod of z greater than 1 by 4. That means it is stable. And if it is stable, that means it includes the unity circle. And if it is including the unity circle, what does that mean? If it is including the unity circle, what does that mean? H e to the power j omega is defined. So if it is defined, then it would be 1 upon 1 minus 1 by 4 e to the power j omega, e to the power minus j omega, because it can be written as 1 upon 1 minus 1 by 4 z inverse. So 1 upon 1 minus 1 by 4 e to the power minus j omega. Well and good. Okay. So h e to the power j omega would be this. From here you go to know that it is real. Another thing you know that h of omega will not be equals to, basically h e to the power j omega naught is not equals to h e to the power minus j omega naught. Or you can surely see that h of n is not even. It is not even. And another thing you can see that h e to the power j omega naught. What is the value of omega naught? From here I can pick the value of omega naught. Omega naught is pi by 3. So if you put pi by 3 here and if you put minus pi by 3 here, both are not giving you the same result. If you put pi by 3 and if you put minus pi by 3, both are not giving you the same result, right? So that means this is also not true. What does that mean? That applied input is applied sinusoid is not an eigen function. So this is the case of only real. This is the only conclusion we can make, that it is real. And if it is real, then we know that what will be the output. The output will be 3 h e to the power j omega naught. What is the value of omega naught? Pi by 3 sine of pi by 3n plus pi by 3 plus angle of h e to the power j pi by 3. There you go. Okay. So h e to the power j omega we already know. What I need to calculate? H e to the power j pi by 3. That would be, in place of omega I need to put pi by 3 only. So what you are getting? 1 minus 1 by 4 cos pi by 3 minus j sin pi by 3. That would be equals to 1 upon 1 minus 1 by 4. I hope I don't do any calculation mistake. So cos pi by 3. What is the value of cos pi by 3? Cos 60. 1 by 2. Right? Pi by 3 means 60. So 1 by 2, and this would be under root 3 by 2. So I need to add a page now. Okay, already there. So just I will copy this particular expression. H e to the power j pi by 3 is coming out to be this particular thing, right? So what you are getting? 1 upon 1 minus 1 by 8 plus j under root 3 by 8. Say yes or no? 1 minus 1 by 8 plus j under root 3 by 8. So what you are getting? 1 upon 7 plus j under root 3. On the upper side you are getting 8. This is your h e to the power j pi by 3. Right? So what will be the magnitude of this particular thing? That would be a upon 49 plus 3. 49. I was about to say 49. In Hindi, you call 49 as 49. So 8 upon under root 49 plus 3. And what will be the angle? Minus tan inverse under root 3 by 7. So you calculate the magnitude here, you calculate the angle here as well. Okay, so I will do the calculation. I will pause the video and do the calculation. Yeah, so I did the calculation. It is coming out to be 1.109 and this angle is coming out to be minus 13.89. Let me once recheck the calculation. 3 under root divided by 7 tan inverse. Yeah, minus 13.89. So yes, now what will be the output y of n? So input here was 3. So 3 will be multiplied with 1.109 sine omega naught n pi by 3n plus pi by 6. What is the value of pi by 6? That is 30 degree. Pi by 6, 30 degree minus 13.89 degree. So what is the answer you will get? 3 into 1.109. Oh, sorry. 3 into 1.109. 3.32. 3.32 sine pi by 3n plus 30 minus 13.89 16.11 degree. This is your y of n. This is the y of n you are getting. There you go. Okay, so this is how you are supposed to solve. In the examination, if this kind of question is coming, the calculation would be easier. They will try to introduce pi by 2 here, or pi by 3 here, whatever, pi by 2 or pi by 4 or 3 pi by 2, so that calculation becomes easier. So here I introduced pi by 3, so calculation was a bit time taking, but just as you see this question, okay, causal, you will see it is real at omega naught and minus omega naught, it will throw different. That means it will surely not be an eigenfunction. If it is not an eigenfunction, then I know that it is real, and if it is real, then I can apply this particular method. Get the phase, get the magnitude. So magnitude and phase you will get, and you will multiply, and this is how you will get the answer. Okay, well and good. Now we will see some general questions. This is also based on eigenvalue, eigenfunctions only. So you give the answer of this particular question. The applied input is C1 e to the power minus j pi by 2n plus C2 e to the power j pi by 2n. H of n is 1ab. Okay, 1ab where n equals to 0 is 1. And your y of n should be equals to 0. Your y of n should be equals to 0. So what will be the value of a and b? So what would be your y of n? Your y of n would have been, let's first find out h of e to the power j omega. So now you should have the habit of writing down h e to the power j omega. That would be delta n plus a into delta n minus 1 plus b into delta n minus 2, right? Now what would have been my y of n? So my y of n would have been y of n. Is this an eigenfunction? Eigenfunction, yes. Is this an eigenfunction? Yes. So same output will come, but just multiply with h e to the power. What is the value of omega naught here? Minus pi by 2, right? Value of omega naught is, in h e to the power j omega, you need to put minus pi by 2. And what will happen? This will also come as it is. Just you need to put plus pi by 2. Okay. So C1 e to the power minus j pi by 2n. 1 plus a e to the power. Here what you are doing, in place of omega, what you need to put? Minus pi by 2. So in place of omega, I need to put minus pi by 2. So it will become plus pi by 2, right? Plus b e to the power minus pi by 2 I need to put, so it will become plus pi plus C2 e to the power j pi by 2n. 1 plus, in place of omega you need to put minus pi by 2 plus b e to the power, in place of omega you need to put plus pi by 2. So here you will put plus pi by 2. So this is what you are getting. Now the same thing will be reflected here. The same thing will be reflected here. What this would be? Ja, because e to the power j pi by 2 is j minus b plus whatever, the same thing here, the same thing here as well. 1 minus j minus b, because e to the power minus j pi is minus. Now you need it equals to 0. So let's not do this. Let's write down the expression only. What we are going to do, we are going to write down the expression only. So if you need it equals to 0, what does that mean? That this should also be equals to 0 and this should also be equals to 0. So what you are getting from here, that 1 plus j minus b should be equals to 0 and 1 minus j minus b should be equals to 0. Both should be equals to 0, no? Because they cannot be equals to 0. They cannot be equals to 0. So they have to be equals to 0. Whatever the eigenvalue you are getting, that eigenvalue should be 0. Eigenfunction cannot be 0 because you are applying something. So eigenvalue could be 0. So these eigenvalues could be 0. Now what you can see, 2 minus 2b is equals to 0. If I add both of them, so value of b is coming out to be 1, right? Value of b is coming out to be 1. and from if I put a value of b equals to 1 here, then what you can see, a is coming out to be 0. A is coming out to be 0. So a has to be 0 and b has to be 1. Okay, very simple, very straightforward. Now this is a general question, it is not based on eigenvalue and eigenfunction. So basically our topic has ended. Eigenvalue and eigenfunction, that particular topic has ended. So basically most of the concept of DTFT has ended. Now in this video we are going to solve some question, one question, two question, then this third question, and after that we will solve more question as well. And one more concept is left, that is duality. So duality also we will see, in between solving the problems only we will see the duality as well. So basically we are starting the questions now. So this question we will solve, in between some small concept are also left, that also we will see. So let's start solving this question. So h of n is given -1, -2, -3, 4, 3, 2, 1. A finite length 3 finite impulse response g of n of h of n has to be obtained such that, basically you need to obtain a g of n. And what they are saying, it is having a finite length of 3. That means it is having a length of 3. So here there will be 3 samples. What it will have? It will have 3 samples. 1 sample, 2 sample and 3 sample. It will have 3 sample. So g of n should be coming from h of n only. G of n of h of n, that means it should be coming from these samples only. That means the value of sample could be -1, -2, -3, 4, 3, 2 or 1. So 3 samples you need to pick from h of n. So g of n is actually coming from h of n only. It should be obtained in a manner that this particular thing is minimum. This particular thing is minimum. What should be minimum? This should be minimum. G e to the power j omega square d omega. This should be minimum. Let's call this as x e to the power j omega. So what is given? X e to the power j omega whole square d omega. And I can multiply with 1 by 2 pi here as well. So I can divide with 2 pi and multiply with 2 pi. So what is this? Energy of action, right? This is your energy of action. Do you agree to this point? This is known as energy of action. Basically it is 2 pi into energy of action. And what is action? If your x e to the power j omega is h e to the power j omega minus g e to the power j omega, that means what would have been your action? So your action would have been h of n minus g of n. That means if this should be minimum, then energy of h of n minus g of n should be minimum. So what they are saying? Basically now the statement has reduced to that energy of hn minus gn should be minimum. This is what they are saying from this statement. Is that clear to you or not? Basically I assumed h e to the power j omega minus g e to the power j omega as x e to the power j omega. X e to the power j omega is given as h e to the power, basically this function is equal to x e to the power j omega. So kind of it is energy only. If I multiply and divide by 2 pi, then I can get to know that it is given as energy only, right? If it is given as energy, that means it is energy of x of n. And what is x of n? X of n is h of n minus g of n. So that means energy of h of n minus g of n should be minimum. This is what they are saying. Now just let me know one thing. If you want this energy minimum, if you want energy of any signal minimum, what could be the minimum energy? What is the minimum energy? 0. E minimum is 0, right? And what is E maximum? That is infinity. So energy cannot be negative. If I ask you what is the energy of h of n, what you will do? -1 square plus -2 square plus -3 square plus 4 square plus 3 square plus 2 square plus 1 square. This is what you will do. And basically all the negative sample will also be positive sample and they will be squared and added. And if I ask you what is the energy of h of n minus g of n, then whatever the sample you are getting in h of n minus g of n, whatever the sample that you are getting in h of n minus g of n, what you will do? You will take their square and you will add them up. Now g of n depends on me. I can pick g of n from my own side. So g of n depends on me. So what do you think, what kind of g of n I should pick such that the energy becomes minimum here? H of n is fixed. This h of n is fixed. So from this h of n, what should I subtract such that this h of n minus g of n, energy of this particular thing becomes minimum? What do you think what I should do? I should subtract the maximum samples. Basically here 4 is given, right? So what I would do, at n equals to 0 I will keep 4 only. At n equals to minus 1 I will keep minus 3 only. And at n equals to plus 1 I will keep 3 only. So now what will be my h of n minus g of n? That would be, this is minus 1, this is plus 1. And what is this? 0, minus 1, minus 2, minus 3. This is your n equals to minus 3. And this is your n equals to plus 3. So h of n minus g of n, minus 1 minus 0, 0. Sorry, minus 1 minus 0, that would be minus 1. Basically here n equals to minus 3 is minus 1. What is your g of n? Your g of n is 0, 0, 0, minus 3, minus 2, minus 1. Sorry, minus 3, minus 2. And then there are 3 samples. These 3 samples could be anything. These 3 samples could be anything. It is not necessary that it will be minus 1, 0 or 1 only. But I am saying that it will be minus 1, 0 and 1 only because they are the maximum samples, no? If let's just say minus 3 was here, so what I would have done? I need to take only 3 non-zero sample. So if minus 3 was here, what I would have done? In place of 0, I would have put minus 3 here. Because what I would do, I will subtract them. So minus 3 will be subtracted from minus 3, you will get 0 only. Is that clear to you or not? So what we are doing, we are putting minus 3 here, 4 here and 3 here. Now h of n should be subtracted from g of n. So what you are doing, minus 1 minus 0 minus 1, minus 2 minus 0 minus 2, minus 3 minus 3 0, 4 minus 4 0, 3 minus 3 0, 2 minus 0 2, 1 minus 0 1. So the maximum samples are gone. These were the maximum samples. These were giving you the maximum power. These were giving you the maximum power. Minus 3 whole square, 4 whole square and 3 whole square. That means 9 plus 9 plus 16. So 18 plus 16. You are getting 34 out of these components only. And these components I killed. So whatever the power you get, that power will be minimum now. So basically this is your g of n. Your g of n is minus 3, 4, 3. Is that clear to you or not? Okay. So let me add a page now. Okay, another page is already there. I always ignore these kind of things. So basically my g of n is coming out to be now minus 3, 4 and 3. Minus 3, 4 and 3. So what will be the value of g of minus 1? That would be minus 3. And what will be the value of g of 1? That would be 3. What you need to calculate? A is equals to tan into g of minus 1 plus g of 1. So that would be minus 27. This is the answer. Okay. Now I am asking a question. What if h of n was this? What if your h of n was this? That was 4 minus 2 minus 1 3 2 minus 4 and minus 1. If this was the scenario, and same question. So what would have been your g of n? So your g of n would have been, you need to take 3 non-zero sample. You need to take 3 non-zero sample. So what you will do, you will want to cut this part and this part, because they are resulting in maximum. They are resulting in maximum energy, right? So what you would do, you would want to kill this part 4, 0, 0, 3, and then you would want to kill this part as well and 0. So here what you can see is that h of n minus g of n, what that would be equals to 0 minus 2 minus 1 0 2 sorry 0 minus 2 minus 1 3 minus 3 0 2 minus 0 2 minus 4 0 and this would be minus 1. So this will give you the minimum power. So this would have been your g of n. That means your g of 0 would have been 3, g of 1 would have been g of 2 would have been minus 4 and g of minus 1 minus 2 minus 3 would have been 4. This would have been the values. So is the concept clear to you? You just want the energy to be minimum. If you want energy to be minimum, that means h of n minus g of n should have minimum energy. And if you want the minimum energy, that means the samples having the maximum amplitude, that should become cancelled. So samples having the maximum amplitude should be cancelled. So they are cancelled now. Your job is done. Okay, well and good. Let's go to this question, this kind of question. What kind of filter is that? What kind of filter is this? So let me take a break. Okay, I will take a break now and I will come back. I will solve this question. Okay, because I am tired, I will solve this question. Yeah, so let's see this question on filter. Very simple question. Basically a block diagram is given. So how to read this block diagram? X of n is there. So x of n will come here. It will be multiplied with 5. So what you will get here? 5x of n. X of n will be multiplied with 5. Here what is written? Unity delay. That means x of n, it will go here. Unity delay means here you will get x of n minus 1. Then another unity delay. That means you will get x of n minus 2. Okay, delayed. X of n minus 1, x of n minus 2. Whenever they talk about delay, you will do right shift. X of n minus 1, x of n minus 2. Unity delay, then another unity delay. So delay by 2. And then what will happen? This will come and it will be multiplied with 5. So 5x of n minus 2. Now what is your y of n? So in y of n you will say that, you can see that this will be multiplied with plus sign. And this will be multiplied with a negative sign. So this is your y of n. So y of n, 5 of x of n minus 5 of x of n minus 2. You need to find the type of filter. So how do we find the type of filter? With h e to the power j omega only. So my target is to find h e to the power j omega. So y e to the power j omega is equals to 5x e to the power j omega minus 5 e to the power minus 2j omega x e to the power j omega. Right? Shift is there. So you know that you can apply the property e to the power j omega n naught. Value of n naught is minus 2. So y e to the power j omega divided by x e to the power j omega, that would be equals to h e to the power j omega, and that will be equals to 5 into 1 minus e to the power minus 2j omega. And why do I need e to the power j omega? Why should I carry e to the power j omega? I should have carried with h of z only, no? Why do I do h e to the power j omega? So let's write down h of z only. Needlessly I did all this calculation. So basically it would be 5 into 1 minus z to the power minus 2. Say yes or no, right? Z to the power minus 2. Now low frequency and high frequency. So at low frequency if I check h of z at low frequency, so what I am getting? 0. And h of z at high frequency, what I am getting? Again 0. Right? H of z at low frequency and h of z at high frequency as well, because minus 1 to the power minus 2, that would be plus 1. So low frequency, high frequency I am getting 0. So somewhere in mid frequency I will be getting some gain, and you can check at h equals to j, sorry z equals to j. So if you put z equals to j here, what you are getting? 1 minus j to the power minus 2. So that would be 10, because j to the power 2 would be minus 1. So it would be 10. So yes, mid frequency is being passed, low and high frequency is not being passed. What does that mean? It is a band pass filter. So very easily you can solve these kind of questions. So just write down the h of z or h e to the power j omega, whatever you want to write down. So here I would have put omega equals to 0, omega equals to pi, and then I would have put omega equals to pi by 2. One thing I saw that low frequency, high frequency both are not being passed. That means surely some mid frequency will be passed. Surely it will be a band pass filter. So two terms can be introduced in your examination. It could be written FIR filter or it could be written IIR filter. So what is the meaning of FIR? FIR means finite impulse response. Finite impulse response filter. Impulse response. And IIR means infinite impulse response. Infinite impulse response filter. Okay. What do you mean by that? That means number of samples will be finite. H of n has finite length. That means number of samples will be finite. Samples will be finite. It can have 1 sample, 2 sample, 3 sample, 4 sample, 1000 sample, 1 lakh sample, 2 lakh sample, but number of samples will be finite. And here number of samples will be infinite. That's it. So if I write down my H of n as, H of n is 1, 2, minus 1, 3, minus 2, 1 by 2. Okay, this is your H of n. So this is a finite length. No? 1, 2, 3, 4, 5, 6. 6 samples are there. So finite length. So it is a FIR filter. FIR. Okay, FIR system or FIR filter, whatever you want to call it. And what about IIR? Just a to the power n un. Or H of n equals to un only. Or H of n equals to sin omega cn upon pi n. So you can see that value of n can go from 0 to infinity and it can go from 0 to minus infinity as well, or minus infinity to 0 as well. Basically here what is the length? Infinite length is it there, no? So how many samples are there in H of n? A to the power 0, a to the power 1, a to the power 2, a to the power 3, a to the power 4, a to the power 5, till a to the power 100, a to the power 1000, a to the power 1 lakh, a to the power 1 crore, a to the power infinity. So infinity samples are there. Same goes for un as well. 1, 1, 1, 1, 1, 1. It will be repeated for infinity times. And sin omega c by pi n, this kind of graph you will be getting. This kind of graph like decreasing, and then basically this kind of graph. It is continuous I am making, but just sample it. This is the continuous I have made, but if you sample it, then this kind of graph you will be getting. So here also infinite samples are there. So all these are IIR. Okay, so if you see these names, you should not be getting confused. Sir, what is IIR? What is FIR? So this is the meaning of IIR and FIR. You can see one of the question. So H of n is given. H of 2 is equals to 1. H of 3 is equals to minus 1. And H of k is equals to 0 otherwise. So basically this is your H of n. H of n is only non-zero things are 1 and minus 1. 1 and minus 1. So this is your n equals to 2 and this is your n equals to 3. Rest all are 0. Rest all are 0. So this is your H of n. So is it FIR? Surely it is FIR. Finite impulse response. Is it low pass or high pass? Low pass, high pass, band pass, whatever it is. So let's check that. So what is your H of n? Your H of n is delta of n minus 2 minus delta of n minus 3. So z to the power minus 2 minus z to the power minus 3. So you check at low frequency. At low frequency if I check 0, and if I check at high frequency, so this will give me 1, but this will give me minus 1, because minus 1 to the power minus 3 will be minus 1 only. So high frequency is being passed, so it is a high pass filter. Okay, so it is coming out to be a high pass filter. So this statement is wrong. So very easily we can solve this question. Well and good. Okay, so now we will see more questions, but I have to pause the video because I need to change the slides. So I will change the slide and we will see more questions. Yeah, welcome back. So we were solving some questions. Now we need to study about duality theorem. Some important points we are going to see, some points about duality theorem, and then about the summation. So those points we are going to see now. So there is a question, x of t is given, you need to find its exponential Fourier series coefficient. What is this Cn? This is exponential Fourier series coefficient. So you need to find this exponential Fourier series coefficient. Then in this question only another question is given that some particular C of n is defined where this is n equals to minus 1, this is n equals to 0 and this is n equals to plus 1. And you need to find C of e to the power j omega, that means you need to find its discrete time Fourier transform. Okay. So can you let me know what will be Cn? So here you know that C1 value will be 1 by 2j and C of minus 1 value will be minus 1 by 2j. We already know it. Can I write it down in this manner? That it is a C of n minus 1 by 2j at minus 1. At 0, what is the value of C of 0? That is 0 only. What is the value of C of 0? That is 0 only. And what is the value of C of 1? That is this only. Right? This is your C of 1. So I can surely write it down as a discrete time sequence because it is a discrete sequence only, right? Or Cn could be written as minus 1 by 2j delta of n plus 1 plus 1 by 2j delta of n minus 1. Do you agree to this point? At n equals to 1, 1 by 2j, at n equals to minus 1 by 2j. So similar C of n is plotted here, right? This is the second question, although this is the second question, but similar C of n is there, no? The similar, right? So now I need to find C of e to the power j omega. So what would be C of e to the power j omega? So that would be, from here only I can see, minus 1 by 2j, delta of n plus 1 will throw e to the power j omega, plus 1 by 2j, e to the power minus j omega, right? So if I take minus sign common, what I am getting? E to the power j omega minus e to the power minus j omega divided by 2j. What it would be equals to? Minus sine omega. And can I write it down as sine of minus omega? So what is your C of e to the power j omega is coming out to be? Sine of minus omega. Sine of minus omega. This was sine t, it is coming out to be sine of minus omega. From sine t, it is coming out to be sine of minus omega. So as of now, you don't need to see the results. You don't need to remember the results. We will see the conclusion. Okay. One thing you let me know, what was the time period here? 2 pi, right? What was the time period? 2 pi. Because omega naught value is 1, so time period was 2 pi. So this question we have seen. Similarly, we will see this question. Just let me know what will be the value of C1 and C of minus 1. What will be your C of n? The same C of n will be coming here as well. So C1 will be equals to 1 by 2j and C of minus 1 will be equals to minus 1 by 2j. Right? The same C of n would come. Although I have made sine of 2t, but this is a different question. How would you write down sine of 2t? Sine of 2t you would write down as, you know that even if I change the frequency, it doesn't mean that Cn will change. Cn will not change. So this is the continuous time. So e to the power j 2t minus e to the power minus j 2t divided by 2j. And what is the value of omega naught here? Omega naught is equals to 2 and t naught is equals to pi. So this is your omega naught only. So basically you can write it down as e to the power j omega naught t, e to the power j omega naught t, e to the power minus j omega naught t, right? So what will be the value of C1 here? C1 will be 1 by 2j and C of minus 1 will be minus 1 by 2j. So what will be your C of n? C of n would be 1 by 2j minus 1 by 2j, 0 and 1 by 2j. This is the C of n, and the same C of n is going here. But what is this? This is your n equals to minus 1 and this is your n equals to 1. So again your C of n could be written as minus 1 by 2j delta of n plus 1 plus 1 by 2j delta of n minus 1. And the same C of n is given here. This is your n equals to 0. This should have been shown in the question only. Okay, this is your n equals to 0. This would be your n equals to 1 and this would be your n equals to minus 1. So same C of n is shown here. So what will be C e to the power j omega? That we have already derived, right? In the last question, the same C of n was there. We have already derived it. It is coming out to be sine of minus omega. So here also it is coming out to be sine of minus omega. Here also it is coming out to be sine of minus omega. So what really happened? Initially, your sine t was there. What you did? You find out it's a Cn. Now if this Cn, this is a discrete, right? This Cn is a discrete. Now if this Cn becomes your n domain signal, this was a discrete in frequency. Now what I am saying, the Cn becomes my n domain signal. So what will be its DTFT? Here what you find out? Continuous time Fourier series, and this was your exponential Fourier series coefficient, right? So you find out exponential Fourier series coefficient, then you made it as a discrete time sequence, and now you are finding out its DTFT, and that is coming out to be sine of minus omega. But here sin t was having a time period of 2 pi. It was having a time period of 2 pi. But when the time period became pi, so my answer was not sine of minus omega. My answer was not sine of minus 2 omega. My answer was sine of minus omega only. What I am saying, listen to my statement again. When the time period was pi, when it was sine 2t, so my answer did not came out to be sine of minus 2 omega. No, it came out to be sine of minus omega only. So when the time period is pi, you need to apply this property smartly. So how will you apply it? I will let you know later on. But as of now, what did you understand? That if your time period is 2 pi, then you can apply this property very easily, that sine t is having a Fourier series coefficient, exponential Fourier series coefficient of Cn, or xt is having a exponential Fourier series coefficient of Cn. Now if Cn becomes your n domain signal, then its discrete time Fourier transform would be x of minus omega. The point is, this Cn is aperiodic plus a discrete, and you find a discrete time Fourier transform for which kind of sequences? What I am saying, you find a discrete time Fourier transform for which kind of sequences? The sequence has to be discrete and aperiodic. You can find it for periodic as well, but first we started with the concept that if your discrete time sequence is aperiodic, then how will you comment on the frequency content? So for that you need to find DTFT. So yes, it is a aperiodic plus a discrete sequence. It is a aperiodic plus a discrete sequence. If you are having a aperiodic plus discrete sequence, then you can find its discrete time Fourier transform, and that is coming out to be sine of minus omega. But important part is this 2 pi. The time period is 2 pi. Even if the time period is not pi, still you can apply this property. How will you apply this property? You will understand that. So this is known as duality property. So if x of t is having continuous time Fourier series of c of n, that means it is the exponential Fourier series coefficient. Considering that time period of xt is 2 pi. Then if c of n becomes your time domain signal, if c of n becomes your time domain discrete sequence, then what will be its discrete time Fourier transform? That would be x of minus omega. Is that clear to you? Okay. Now there is a question. So one thing is that this question can be asked in 1 mark. In 1 mark, in the statement wise only this question can be asked. That a continuous time continuous time signal xt is given, whose exponential Fourier series coefficient is c of n. Now if c of n becomes your discrete time sequence, then what would be its discrete time Fourier transform? Then option would be mentioned 2 pi x of minus omega, x of minus omega, minus x of omega, 2 pi x of omega. Then you would click on x of minus omega. Is that clear to you? Okay. So in 1 mark this question can be asked. Along with that, you don't need to forget the duality property that we already studied. Duality property in CTFT. We will solve this question, but as of now you don't need to forget this duality property that we studied in CTFT. So if xt signal is there, then its continuous time Fourier transform was x of omega. Now this x of omega, if this x of omega becomes your x of t, then what would be its continuous time Fourier transform? That would be, this guy comes here, 2 pi x of minus omega. Right? I hope you remember this duality property that we studied in CTFT. But we are going to study duality property in DTFS as well and DFT as well. So everywhere we are going to study duality property. 2 more duality property would come. So total 4 duality property would be there. This is the first one. This is the second one. And 2 more properties would come. So you need to remember everything. And that's why we take the example, no? Like if you remember the example in your mind, then you will not be forgetting it. Okay, we took the example of sine t, then c of n came, then c of minus omega, then sine of minus omega we got. So based on that, you will be remembering this duality property, and this duality property we used it a lot of times. Okay, like 99% chances are there that this duality property would be used in the examination, but 1% chances, and people are asking questions in GATE examination from 1% chances only. Okay, nowadays from 1% chances only the questions are coming, but till this date only from this property the questions have come, only from this duality property, and that's why you would find that this property is there in everyone's notes, but these properties are not there. But we will write down all the duality property. So x of t is having x of omega, then if this becomes your time domain signal, then what will be its Fourier transform? That would be 2 pi x of minus omega, that you already know. Now for this particular property we wrote down that period of xt is 2 pi, then only this would work. But what if the period of xt is not 2 pi? What if the period is 3? Okay, and here also the same thing has happened. What kind of same thing? Just 1 second guys, let's write it down in a good manner, that this c of n is coming here and this guy is going there. Okay, yeah. So xt is having a period of 3, it is not 2 pi, it is not 2 pi. Then what will be its exponential? If then its exponential Fourier series coefficient is Cn. Xt is a periodic signal with time period 3, its exponential Fourier series coefficient is Cn. Now considering Cn as a discrete time sequence, what will be its discrete time Fourier transform? Now you will say that sir, I will apply the duality property, but duality property says that time period of xt should be 2 pi. Then how will you apply it? So just let me know one particular thing, that if your xt is having a exponential Fourier series coefficient of Cn, then what will be the exponential Fourier series coefficient of x of alpha t? That will also be Cn only, no? But the only fact is here the time period is t naught and here the time period will become t naught by alpha. Is that clear to you? So what is given to us? What is given here? Given that this is having Cn with the time period of 3, but what I would do, I would make x of alpha t, it will also have the Fourier series coefficient of Cn only, but what will be its time period? That would be 3 by alpha. And what I need to make it, what I need, that my 3 alpha should be equals to 3 by alpha should be equals to 2 pi, right? Because if I want to, I got to know that I will have to apply duality property here. This is something I got to know, that I will have to apply. Cn is coming, DTFT they are asking, I have to apply the duality property. So my first target would be to make that time period equals to 2 pi. Now if I put alpha equals to 2 pi by 3, my job is done, my time period is 2 pi. So if I put alpha equals to 2 pi by 3, so sorry. So this particular signal is having a time period of 2 pi, which is having a exponential Fourier series coefficient of Cn. So if Cn comes here, because this Cn will not change even if you do anything in time domain, basically if you do the scaling in time axis, the Cn will not change. I hope you remember this particular thing. So Cn doesn't change, and here also we have seen it, sin t is also having the same thing, and x of 2t sin 2t is also having the same Cn. So Cn doesn't change. If you do x of alpha t from xt, if you go to x of alpha t, the Cn doesn't change, right? So now if your C of n comes here and they ask you DTFT, so what would be the answer? The answer would have been x of minus 2 pi by 3 omega. So this would be the answer. Okay, this would be mentioned in one of the options. Is that clear to you? All fine? Okay, so this is how I will solve the problem. My first target would be to make the time period equals to 2 pi so that I can apply this duality theorem. Okay, so I made the time period equals to 2 pi. Cn comes here, DTFT would be, this guy comes here, this guy comes here. Just in place of t, you need to put minus omega. Your job is done. Okay, and you could have solved this problem as well. How you would have solved this problem? That if my sine of 2t is giving you C of n, right? What is the time period here? Time period is equals to pi. What I need to make? I need to make time period equals to 2 pi. That means in place of t, what I need to put? T by 2. But in place of t, if I put t by 2, still my Cn would be the same only. Now what will be the time period? Time period would be equals to 2 pi. Now if your Cn becomes your time domain sequence, then what would be its DTFT? What would be its DTFT? So that would be this particular sequence, this particular signal you will take, because here the time period is 2 pi. So answer would be sine of, in place of 2 into 2 will get cancelled, in place of t what you will put? Minus omega. So are you getting the same answer? Yes. So always our task is replace the t with something, replace the t with alpha t, and make sure the time period becomes 2 pi, and after that you can apply this duality property. So I am expecting that in near future one good question could be coming from this particular duality property between CTFS and DTFT. Okay, all good, all fine. Let's move to our next point. So here this is the formula of x of e to the power j omega that you already know. Summation n goes from minus infinity to infinity, x of n e to the power minus j omega, e to the power minus j omega n, right? If I put omega equals to 0 in x e to the power j omega, if I put omega equals to 0, what I will be getting? This particular thing I will be getting. So if they give me a sequence and they ask me summation n goes from minus infinity to infinity, what would be its value? And I already know x e to the power j omega, then in place of omega I can already put 0 and I will get my answer. And the same thing we saw with the Z transform as well, right? So with the help of Z transform or with the help of this Fourier transform, you can find these values. So basically the point is you need to remember the formula. If you remember the formula, then you will put any value and you can get the answer. Now just let me know what is this particular thing. Isn't it like x of minus 2 plus x of minus 1 plus x of 0 plus x of 1 plus x of 2 and so on, right? Starting from x of minus infinity to x of plus infinity. Say yes or no, right? Now in place of omega, if I put pi, what will happen? This will become n goes from minus infinity to infinity, x of n e to the power minus j pi n. What is the value of e to the power minus j pi? That is minus 1, right? E to the power minus j pi is minus 1. So can I write it down as minus 1 to the power n? In place of omega, I put pi, e to the power minus j pi, that is minus 1 to the power n. Now you start putting. You put n equals to minus 2. So what you will get? X of minus 2 only. Basically, I am starting from n equals to minus infinity only. But I will see at n equals to minus 2. If I put n equals to minus 2, I will get x of minus 2 only. If I put n equals to minus 1, so minus 1 to the power minus 1, that would be minus 1 only. So x of minus 1. If I put n equals to 0, I will get x of 0. If I put n equals to 1, I will get x of minus 1. If I put n equals to 2, I will get x of 2. And then you keep on adding. So this you call as equation 1 and this you call as equation 2. When you add both of these equations, what you are getting? When you add both of these equations, x e to the power minus j, x e to the power j omega at omega equals to 0 and at omega equals to pi. So what is the answer you are getting? So what will happen is that this odd component will cancel out if I add both of them. X of 1, x of minus 1, x of minus 1, x of minus 1. So basically all the odd components will cancel out, only the even component would left. So basically x of minus 4 will be left, x of minus 2 will be left, but twice of that. So I will have to multiply with 2 as well. X of minus 4 plus x of minus 2 plus x of 0 plus x of 2 plus x of 4 and so on. So can I write it down in this manner? 2 into n goes from minus infinity to infinity, x of 2n. Say yes or no? 2 into n goes from minus infinity to infinity, x of 2n. If you put n equals to 1, what you are getting? X of 2. If you put n equals to 0, x of 0. If you put n equals to minus 1, x of minus 2. If you put n equals to minus 2, x of minus 4. If you put n equals to plus 2, x of 4. Then x of 6. Then x of 8. So this is how you can write it down. So this question have been asked. Okay. So basically what they would say that in your discrete time Fourier transform, if you put omega equals to 0 and omega equals to pi, then what will be happening in the time domain? So this is what will be happening in the time domain. So you don't need to mug it up, you can always derive it. Let's just say in examination if they are asking this kind of question only, and you are having the expression of x to the power j omega, What I am saying, in the examination they are asking, they would give you some x of n and they ask you this particular question. So either what you can do is that for x of 2n you can find out if x of n is having x e to the power j omega. So what x of 2n will have? This x of 2n will have, right? This was the property or something else? I also forgot it. No, sorry. X of 2n doesn't have any property, no. X of, sorry guys, it is a big blunder from my side. X of n naught will have a property. So e to the power j omega n naught. I told you, if you are expanding the sequence, then only the property is applicable. So here there is no property applicable. If they are asking x of 2n and you are having x e to the power j omega, so you cannot go here. You cannot find x e to the power, you cannot find its discrete time Fourier transform, right? So for that you have to think in this manner only, that x e to the power j omega at omega goes to 0 and x e to the power j omega at omega goes to pi divided by 2 will give me this particular expression. So in any way they can ask in the examination, just remember that if even components are there, then something will happen with 0 and omega. Something will happen with 0 and omega. That's it. And if you remember this particular thing, that something will happen with 0 and omega, then you will be able to solve any question. And if you subtract them, then what will happen? From 0, if you are subtracting 8, so what is happening? So if you are subtracting, then even components will cancel out, right? And odd components will be added. So what will happen? What will be the final result? X of minus 3 plus x of minus 1 plus x of 1 plus x of 3 and so on. So write down its expression. How will you write it down? X of 2n plus 1. Put n equals to 0, what you are getting? X of 1. Put n equals to 2, sorry, put n equals to 1, what you are getting? X of 3. Put n equals to minus 1, you are getting x of minus 1. Put n equals to minus 2, you are getting x of minus 3. Put n equals to minus 3, x of minus 5. Put n equals to 2, you will get, if you put n equals to 2, you will get x of 5. If you put n equals to 3, you will get x of 7. So in that manner you can check, right? So this is the way. So this is how you can write it down. So no need to remember the final results. Only thing you need to remember is that something I can do with 0 and omega and I will get these expressions. All good, all fine. Let's see more things. So do you remember this property, that if x of n is having x e to the power j omega? Look, all these things I don't need to write down. This is something that you should think on your own. But just we are writing down in the notes that at least you should remember that this kind of things we have studied. If these kind of things are coming right in the examination, then you should have the confidence that at least we have studied. Even if you don't study it, still you can get these answers, right? This is just simple mathematics, nothing else. Conceptual part we have already seen. Only the mathematics part we are going to see now. Now what will be the Fourier transform of nx of n? That would be j d by d omega x e to the power j omega, right? So if your x e to the power j omega was, summation n goes from minus infinity to infinity, x of n e to the power minus j omega n, then what will be its value? Here what you have written, nx of n. If you wrote x of n, x e to the power j omega, x e to the power j omega, x of n. Now you have written nx of n. That means what they are asking? They are asking the discrete time Fourier transform of, this is basically what they are asking, discrete time Fourier transform of nx of n. This is what they are asking. Just in terms of formula I have written. So discrete time Fourier transform of nx of n would be j d by d omega x e to the power j omega, right? And now if they ask in the examination, if they ask summation n goes from minus infinity to infinity nx of n, then what you can do, if you are having this particular expression, what you will do is that j d by d omega x e to the power j omega, and in place of omega what you will do, in the whole expression, after calculating this particular expression, in place of omega you will put omega equals to 0. Let's just say in the examination I ask you n 1 by 2 to the power n goes from 0 to infinity. What you will do? You will do nothing, you will apply mathematics. I told you, if they ask you this kind of question, you will just apply mathematics. Forget about signal system. If I am able to solve a question with mathematics, I will solve it with mathematics only. N equals to 0 you put, then I told you 1 by 2, then 2 into 1 by 2 square, then 3 into 1 by 2 to the power 3, and so on. Then what you need to do? S by 2. So what you will get? This is 1 by 2 square plus 1 by 2 to the power 3, 2, and then you subtract them, s minus s by 2. So this question we have seen in jet transform, the same question we have seen. So if you are able to solve a particular question with mathematics, then solve with mathematics. Forget about jet transform, Laplace transform, Fourier transform, nothing. Simple mathematics, in these kind of question we have seen in our class 11, 12th class as well, and in mathematics also we will see these kind of questions. So if mathematics is working, solve with mathematics. If mathematics doesn't work, then think about signals and systems. Okay. So just why we are writing down this formula? What if in 1 mark they are just asking this particular expression, nothing else? If they directly ask you this particular expression, that summation n going from minus infinity to infinity, n x of n will be equals to what? And then options are mentioned, so that you can directly click that j dy d omega x e to the power j omega, omega equals to 0. Okay, that's why we are writing down this expression. We are never going to use it for solving some problem, but directly the expression is coming. That's why we are writing it down. Okay. And similarly, in Parseval's theorem, what we do, if I need to calculate the energy of x of n, what I would do, I will calculate the energy of x e to the power j omega and then divide it by 2 pi. Okay, if I need to calculate the energy of x of n, I will calculate the energy of x e to the power j omega. This is the energy of x e to the power j omega for one time period. Energy for one period, energy of x e to the power j omega for one period. Energy of x e to the power j omega for one period in 2 pi period. I will write down in 2 pi period and then divide by 2 pi. So similar thing I will do here as well. What I would do, I would find out the Fourier transform of n x of n. What I would do, 1 by 2 pi, and now I will calculate the energy of Fourier transform of n x of n. What will be the energy of Fourier transform of n x of n? That would be minus pi to pi, and you take the mode of this one. You take the mode of this. That would be j dy d omega x e to the power j omega whole square d omega. So j would be gone, right? If you take the mode, j would be gone. Minus pi to pi x e to the power j omega dot d omega. Okay, so this might be used somewhere. Okay, if they are asking n x of n square, then it might be useful somewhere. Okay, but very rare, very rare. Till now there has not been any question. But what if they ask you in the statement wise directly? So this would be the answer. So you don't need to be thinking, okay sir, what will happen? So n x of n directly you will calculate. That sir, it would be j dy d omega x of omega. Then Parseval you will apply, you will get this answer. Okay, very easily, very straightforward. Now what they expect me to do? Okay, so here, if x of n is like this, then n x of n would be 1 by 2 pi minus pi to pi, 1 by 2 pi minus pi to pi. So here what you are writing down, x of n is your discrete time sequence, and here you are having your Fourier transform. So here n x of n is my discrete time sequence, here I will have my Fourier transform. Okay, so this is the thing, that it is very rare that they will be used in any question, but you should be knowing that okay, with n x of n something may happen. If x of n is not clicking to me, then n x of n should click to me. Okay, so don't take any pressure of these kind of expression, that sir I need to remember these expression. No, you don't need to remember any expression. You can simply write it down there in the examination hall itself. Now what if this question is coming? Find out the value from minus infinity minus pi to pi d by d omega x to the power j omega d omega. This is what you need to find. So you can see one thing, that my n x of n, from where this d by d omega would come? I know that it would come from n x of n. Now if any Fourier transform is there in the integration, that means what would have happened? You would have just calculated the inverse Fourier transform. This is what is this? This is inverse DTFT, no? Inverse DTFT. So you have to calculate the inverse DTFT, IDTFT. So that would be equals to 1 by 2 pi minus pi to pi j dy d omega x e to the power j omega e to the power j omega n d omega. What they are asking? D by d omega x e to the power j omega e to the power j omega n. They are not asking e to the power j omega n. That means n equals to 0 you need to put. So if I put n equals to 0, so what will happen? N x of n, here you need to put n equals to 0. This 2 pi can come here divided by j, right? Are you able to understand what we are doing? N equals to 0 I need to put, I go to know n equals to 0 if I need to put. So n x of n, this 2 pi can come here, j can come in the division. So that this side what I am getting now, minus pi to pi d by d omega x e to the power j omega d omega. Okay, so this is what I was supposed to calculate. So what is the answer I am getting? In place of n x of n, in place of n x of n, you are putting n equals to 0. What will be the answer you will get? 0 only. So this is what you are getting. Basically n is there, no? So 0 into anything would be 0 only. 0 into x of 0 into 2 pi divided by j, that would be 0 only. So this is the answer of minus pi to pi d by d omega x e to the power j omega d omega. This is the answer you are getting. Okay, now this is the last question of DTFT. Try solving it on your own. Last question of your complete DTFT. You need to find the value of I from 0 to pi x e to the power j omega cos square 2 omega d omega. I know one particular thing, that I never ever solve cos square or sin square. What I do, I always remember this formula, that cos 2 theta is equals to 2 cos square theta minus 1 minus 2 sin square theta. So whenever I see cos square theta or sin square theta, I go to this cos 2 theta guy, because what it will do, it will make it linearize. So I want to linearize it. So what I would have done is that my I would be from 0 to pi x e to the power j omega cos 4 omega plus 1 divided by 2 d omega, right? So 0 to pi, this is the method 1 we are going with. 0 to pi x e to the power j omega cos 4 omega plus x e to the power j omega. Again here also basically x cos 4 omega d omega plus 0 to pi x e to the power j omega d omega. Divided by 2 was there, so this 2 can come here. Well and good. Okay, divided by 2 was there, this 2 can come here. Now 2i is equals to 0 to pi x e to the power j omega e to the power j 4 omega divided by 2 d omega plus 0 to pi. I hope you are able to understand how I am writing down this step. What I am doing, I am just putting cos 4 omega as e to the power j 4 omega plus e to the power minus j 4 omega divided by 2. So this is how I am separating it, and why I am separating it you would understand, right? So all these questions require patience. You need to have some patience, otherwise you will not be able to solve. Well and good, everything is going fine. Now what do I know? Let's call it equation 1. Now what do I know? I know this particular thing, that in the integration if I need e to the power j omega, that means surely inverse DTFT would have been calculated. So 1 by 2 pi minus pi to pi x e to the power j omega e to the power j omega n d omega, right? Now what is the issue? They are asking from 0 to pi, right? They are asking from 0 to pi, but what I have from minus pi to pi, but they are asking from 0 to pi. Just see this integration. What is the question? 0 to pi x e to the power j omega cos square 2 omega d omega. let's keep here. The question was 0 to pi x e to the power j omega cos square 2 omega d omega, right? Is this even? How will you decide? Looking at x of n. So x of n is even or not? Minus 1, 2, 2, 0, 0, 1, 1, minus 3, minus 3. So from here you can see that x of n is even. So what you can comment? That x e to the power j omega is also even. So this is even and this is even. So what does that mean? That means whatever that is happening from minus pi to 0, the same thing is happening from 0 to pi. So can I write it down in this manner, that 2i would be equals to minus pi to pi x e to the power j omega cos square 2 omega d omega. Say yes or no. If I multiply here by 2, so here also it will be multiplied with 2. Both will be multiplied with 2. This 2 can be written down as minus pi to 0 plus 0 to pi. So in this manner I have written it down. Is that clear to you or not? Basically, whatever the value of I you are getting, the same value you will be getting from minus pi to 0 as well, no? So that's why I can write it down in this manner. So what would be your I equals to? So I would be equals to 1 by 2 minus pi to pi x e to the power j omega cos square 2 omega d omega. This would be your I equals to. Here what I have find out, that my 2i is equals to this particular thing. Now after this only I can go with these steps. Basically what I can do now, so I would be equals to, now this particular step I have already solved. This particular thing I have already solved. X e to the power j omega cos square 2 omega was already there. X e to the power j omega cos square 2 omega was already there. Just the only thing is, in place of 0 to pi, now I need to put minus pi to pi. So this will be of no use for me actually. Here I just spend the time needlessly. Are you able to understand this point? So what I need to do, I will again do the same step here, because I got to know that here 0 to pi they are asking, but I know the formula for minus pi to pi, because I know this formula for minus pi to pi. So these steps are of no use for me, but I can directly copy the answer from here, because I know that cos square 2 omega will be converted to cos 4 omega plus 1 divided by 2, cos 4 omega plus 1 divided by 2. Then what will happen? Cos 4 omega will be converted to cos e to the power 4 omega divided by 2. So what will happen basically here? What I can do is I will keep it equals to 2i only. From here also what I can do is that I can make it 4i. Or let's do it. 2i equals to minus pi to pi x e to the power j omega cos 4 omega plus 1 divided by 2 d omega. So from here what I will get is that 4i would be equals to minus pi to pi x e to the power j omega cos 4 omega plus 1 d omega. 4i would be equals to minus pi to pi x e to the power j omega e to the power j 4 omega minus pi to pi x e to the power j omega e to the power minus j 4 omega minus pi to pi x e to the power j omega d omega. Okay, look, it is not tough, right? It is not tough. Basically you need to follow the process. In the following the process, here we did the mistake that needlessly we wasted the time here, because here we got to know that both are even. So this is how we can break it down. So this is our 4i is coming out to be equals to. So our 4i is equals to. Now just let me know one particular thing. X e to the power j omega e to the power 4 omega. What this would be equals to? Minus pi to pi into 2 pi. So from here what I can see, that 2 pi into xn, 2 pi into xn is equals to minus pi to pi x e to the power j omega e to the power j omega n d omega. So x e to the power j omega dot d omega dot d omega. So x e to the power j omega e to the power j 4 omega dot d omega. So that means in place of n, if I can put 4, so what I will be getting here, this particular thing will be equals to 2 pi into x of 4, 2 pi into x of 4 divided by 2 plus what this particular thing would be equals to, that would be equals to 2 pi into x of minus 4 divided by 2, 2 pi into x of minus 4 divided by 2 plus what this would be equals to 2 pi into x of 0, 2 pi into x of 0. So what you are getting now, this 4 comes down here, so pi by 8, if this 4 comes down here, so pi by 4, what is the value of x of 4? X of 4 and x of minus 4 both are minus 3 3, so minus 3 plus minus 3. What I am doing, 2 and 2 get cancelled out, this pi by 4 comes out, x of 4 and x of minus 4 both are minus 3 3 plus 2 pi into what is the value of x of 0? X of 0 is minus 1, x of 0 is minus 1. So here it get cancelled out, what is the answer we are getting? Minus 2 pi. Okay, so it was a simple question only, just requires some patience and you will be able to get the answer. Just the thing is even, so this was the beautiful thing here, that both were even and you could get the answer in this manner. Okay, method 2 is also there, method 2. If it may click to you that here what is happening, in the frequency domain there is multiplication of two signal, this is also one signal, this is also another signal. Can you get time domain signal from here? Yes, you already know it. And if I say that this is also my frequency spectrum, if I say that this is also my frequency spectrum or this is also my DTFT, so can I get the time domain signal from here as well? What I mean to say is that if I am saying that my h e to the power j omega is cos square 2 omega, so can I get h of n? Yes, surely you can get. How will you get h of n? So h e to the power j omega is equals to cos 4 omega plus 1 divided by 2, right? So 1 by 2 is already there, plus 1 by 4 e to the power j omega plus 1 by 4 e to the power minus j omega. So from here h of n is surely coming out to be 1 by 4, 1 by 2 and 1 by 4. This is your n equals to 0. Is that clear to you? Why we are doing so, you will be able to understand. This would be n equals to minus 1 and this would be n equals to 1. If this was your h of n, then this would have been your frequency spectrum, this would have been your Fourier transform, right? So from the Fourier transform I can calculate my h of n as well. Now what do you remember? You remember this particular thing. What was the answer for this one? 1 by 2 pi. Just before the Parseval's theorem we studied it, right? X e to the power j omega, h e to the power minus j omega d omega. No, wrong. Not minus j omega. Yeah, sorry, minus j omega only. In place of omega you need to put minus omega. Yeah. So this was the answer. So 1 by 2 pi minus pi to pi. X e to the power j omega I am keeping as x e to the power j omega only. What is my h e to the power j omega? That is cos square 2 omega. And even if you put minus sign, doesn't matter, right? Because cos will take it. Now I know one thing, that this is even and this is also even. So complete function is even. I can convert it to 0 to pi and then 2 outside, x e to the power j omega cos square 2 omega d omega. So what is the answer you will get? The I would be equals to, and this is equals to I. This particular thing is equals to I. So 2 and 2 will get cancelled and pi goes here. So I would be equals to pi into summation n goes from minus infinity to infinity x of n multiplied with h of n. So first you need to multiply with x of n and h of n, and then you need to add all the samples. So what is the multiplication of x of n dot h of n? That would be equals to, so x of n is going from minus 4 to this is your minus 4 and this is your plus 4. So x of n is going from minus 4 to plus 4, but h of n is going from minus 1 to 1 only. That means the rest all sample will be 0. What is the value at minus 1? What is the value at minus 1? This is n equals to minus 1 and this is n equals to plus 1. So value at minus 1, 2, and this is 1 by 4. So this would be 1 by 2. What is the value at n equals to 0? 1 by 2, and here it is minus 1. So it would also be minus 1 by 2. And here it is 1 by 4 and here it is 2. So it would be 1 by 2. And when you add all of them, what you are getting? One by 2. So what is wrong here? Something is wrong. Something is surely wrong. Oh, sorry guys. Really sorry guys. Here I did the mistake. No. 1 by 2. Here what will happen? 1 by 4 e to the power j4 omega. No. Plus 1 by 4 e to the power minus j4 omega. Right? Here 4 omega is there. No. So what would be your h of n? H of n would be 1 by 4 minus 3 0 minus 2 0 minus 1 0, and then this would be the scenario. No, this would be n equals to 0, this would be n equals to minus 4, and this would be n equals to plus 4. Okay, so this is the mistake I did, and now I need to multiply both of them. So x of n multiplied with h of n, and then I need to add all of the samples. So 1 by 4 multiplied with minus 3. So you will get minus 3 by 4. And then 0, 0, 0. And then 1 by 2 will be multiplied with minus 1. So you will get minus 1 by 2. And then 0, 0, 0 and minus 3 by 4. So if you add all of them, when you apply the summation here, what is the answer you are getting? Minus 3 by 2, minus 2 answer you are getting. So here you are getting the answer minus 2. So minus 2 pi. So answer is minus 2 pi. There you go. This is the answer. Here also you got the answer minus 2 pi. So whatever it may click to you, that may click to you in the examination, you will be able to get the answer. A lot of things are there. Anything may click to you. If I had been the student, then this would be the first thing that would click to me. X to the power j omega cos 4 omega plus 1 divided by 2, and this is how I would have solved it. Okay. Although these steps were needless, although the first thing I would see is that even, then it would be even only, and this is how I would have broke it down. Here only I would have broke it down, and we would get the answer minus 2 pi, or if this is clicking to you, then this is also fine. All good. Now what we are supposed to study? We are supposed to study DTFS and DFT. But first we are going to study a topic called circular convolution, because that will be used in DTFT as well, that will be used in DFT as well. So our next topic would be circular convolution, and then we will move to DTFS. So our DTFT ends here. Okay. So next topic would be circular convolution. Yeah. Thank you very much. Happy learning. Hi everyone, welcome to PrepFusion. So in this video we need to study about circular convolution. So there is something called circular convolution. We have studied about linear convolution. Now we need to study about DTFS and DFT. So in DTFS and DFT we will again and again use circular convolution. So what is this circular convolution that we need to study? But before starting this circular convolution, we will study some prerequisites. We will be understanding the meaning of some terms. So in the examination, it might be written n point xn, or they might be writing 4 point xn. What is the meaning of n point? What is the meaning of this n point? That means it is just showing that x of n is having n number of samples. If I am saying 4 point xn, that means x of n is having 4 samples. 1, 2, 3, 1. These are the 4 samples. One is having amplitude of 1, other one is having amplitude of 2, then amplitude of 3, and then amplitude of 1. Now when they write down 4 point xn, they will not show the arrow. They will not show this arrow. That means they will not show what is n equals to 0. So by default, the first element will be n equals to 0. They will not show it. You have to understand that first element is n equals to 0. So 4 point xn means 1, 2, 3, 1. The first element is n equals to 0. Now if you need to write down any random 3 point xn, that means number of samples should be 3. So any random I can write down. I am writing down minus 2, 1, minus 1. So number of samples should be 3. So there are 3 samples. By default, the first sample would be n equals to 0. So by default, it would be n equals to 0. So I don't need to show it. I'm not showing it. Okay. So this would be your n equals to 0. Even in the examination, it will not be shown. You have to understand that this is my first sample. So n point xn means the number of samples it is representing. Okay. It doesn't mean that x of n is periodic. Some people think that, sir, n point xn, that means x of n is periodic. That is absolutely wrong. No. N point xn means the number of samples they are representing. That's it. Nothing else. It is not periodic. Okay. That is a misconception. People think that because usually they represent this kind of n point xn thing in DFT or in DTFS. So, and in DFT and in DTFS, our sequence is usually periodic. So people think that x of n is periodic, but no. If I am saying n point xn, that means I am just representing the number of samples, nothing else. When you represent a periodic signal, how will you represent that? That also I will tell you. Okay. Now x of n is given. This is our general x of n. The x of n that we studied in our basics of signal. In our basics of signal, this is how we used to write down x of n, 1 and 2. Now they are asking us to write down 4 point xn. This is our x of n. They are asking us to write down 4 point xn. How will you write down 4 point xn? 4 point x of n. How will you write it down? You know that only non-zero samples are 1 and 2. Nothing else. Only non-zero samples are 1 and 2. But you need to write down 4 samples. That means the rest of the sample would be 0. And here I don't need to show the arrow. Look, here arrow should be shown that this is n equals to 0, this is n equals to 1. And even if they are not showing it, you will consider that this is n equals to 0 and this is n equals to 1. The first element would be n equals to 0. Now you need to write down 4 point xn. That means you have to pad up 0. This is known as 0 padding. What it is known as 0 padding. So what they expect you to write, 4 point xn they expect you to write. That means you need to write down 4 samples. So 1, 2, 0, 0. I don't need to show the arrow because by default the first element would be arrow. Now this time the x of n looks similar, 1, 2 only, but now it is periodic. Now it is periodic. Now your x of n is periodic. Now you need to write down 4 point xn. So what would be your 4 point xn? 4 point x of n. What that would be? Will that be 1, 2, 0, 0? 1, 2 and 0, 0 I should write. No. I need to pick 4 samples from here. I need to pick 4 samples from n equals to 0. So 1, 2, then 1, 2. So if your x of n is periodic and if your x of n is aperiodic, you are having different kind of 4 point xn, and this thing will be used somewhere. It will be used somewhere in your analysis. Okay, in DFT I will be again and again using this particular thing, that we will solve problems in 2 different manner. If x of n is periodic and if x of n is aperiodic. This is a very, very important point which a lot of students miss because they are not sure about the terminology. So 4 point xn or n point xn or 3 point xn or 2 point xn, they just mean that the number of samples. So from x of n you can get 4 point x of n, or they can directly represent 4 point x of n is 1, 2, 3, 1. That means they are just talking about the number of samples. It doesn't mean that it is periodic. Doesn't mean that it is periodic. Now in mathematics we use something called mode, MOD mode. So what is the meaning of this mode? If I am writing down 7 mod 3, what does that mean? That I will divide 7 by 3 and I will see the remainder. So what is the remainder you are getting? 1. So 7 mod 3 is equals to 1. You divide 2 by 3, what is the remainder? 2. You divide 8 by 4, what is the remainder? 8 divided by 4, remainder is 0. So they just represent the remainder. Remainder. So mode means just the remainder. If you divide 5 by 2, what is the remainder? 1. If you divide minus 1 by 3, so what is the remainder? So what you need to do, in minus 1, you will add the multiple of 3 so that it becomes positive. So in minus 1, if I add 3, it becomes positive. So 2 mod 3 it would be. Basically this can be written as minus 1 plus 3. I will add the multiple of 3. What is the multiple of 3? 3, 6, 9, 12. So I will add the multiple of 3 such that it becomes positive. So I added the multiple of 3, it became positive. So this could be equals to 2 mod 3. And when you divide 2 by 3, what is the remainder you get? 2 only. Let me think of another example. What example should I think? Okay, minus 7 mod 4. So in minus 7, what I will add? Multiple of 4. So if I add 4, what I am getting? Minus 3 only. That means this will not work. Then again I will add 4. Now what I am getting? Plus 1. Yeah. So now my job is done. So that means in minus 7, I need to add a multiple of 4. If I add 4, my job is not done. Then I have to add 8. That means 1 mod 4. And when you here you are getting answer to 1 mod 4. That means when you divide 1 by 4, what is the remainder you will be getting? You will be getting the remainder of 1. Okay, so this is the meaning of mode. This is just mathematics. This is not signal system. Now we are going to introduce the signal system thing. So in your examination, someday these kind of things could be written. Everyone is read by same name. You will call it x of n modulo n. X of n modulo n. X of n modulo n. So representation is different, but the name is same. X of n modulo n. X of n modulo n, or you can say x of n modulo n. Okay, and also I can call it mode as well. So x of n mode of n. So we will understand that, but just let me know the answer of this particular thing. Very straightforward question. X of n is given, you need to draw x of n. So in basics of signal we have seen these kind of things, that how will I draw x of n. Nothing else is given. They did not say 4.xn, they did not say mode of xn modulo n, nothing they said. Simple x of n is there, you need to draw it. So 1, 2, minus 1, 1. So this is your n equals to 0 and this would be your n equals to 4. So simply you can draw it, right? Simply you can draw it. 1, 2, minus 1 and plus 1. There you go. 1, 2, minus 1 and plus 1. This is your x of n, right? Now what they have said, that 4.x of n is defined like this. This is your 4.x of n. That means there are 4 samples in x of n and this would be your n equals to 0. So 4.x of n is defined like this. You need to find, or you need to draw x of n modulo 4. It can be written as x of n mod 4. It can be written as x of n modulo 4. Any way it would be written. And sometimes they write it down as x of n over 4 as well. Over 4. So what is the meaning of this? So we will be able to understand by this particular term. So what I'm going to do, I'm going to define another function y of n, which is equals to x of n modulo 4. Okay, or I can write down x of n modulo, just 1 second guys, x of n modulo 4. And another ways are also there, I don't care about that. These ways are also there, I don't care about that. So this is what I am defining as y of n. So let me know the value of y of 0. So y of 0 would be equals to, let's see this one, x 0 mod 4. What is the value of 0 mod 4? When 0 is divided by 4, what is the remainder you will be getting? 0 only. So what is your answer? X of 0. And your x of 0 is, your x of 4.x of n is 1, 2, minus 1, 1. So here I am writing down 4.x of n was 1, 2, minus 1, 1. And by default, this is your n equals to 0. So 1. What about your y of 1? So simply your y of 1 would be 1 mod 4. That would be equals to x of 1. And that value is 2. What would be your y of 2? So again and again I will have to write down these things. So what I would do is that I will take this down, I will copy it, and again I will keep on pasting. So what would be your y of 2? So y of 2 would be 2 mod 4. That would be x of 2, and that would be equals to minus 1. Right? You will understand what we are doing. What would be your y of 4? What would be, sorry, what would be your y of 3? Y of 3 would be x of 3. That would be plus 1. This is your n equals to 0, 1, 2 and 3. What would be your y of 4? What would be your y of 4? So y of 4 would be equals to 4 mod 4. When you divide 4 by 4, what is the remainder you will be getting? 0. So y of 4 would be equals to x of 0. What that would be? Again 1. What do you think? What will be your y of 5? Are you able to understand what is happening here? What would be your y of 5? 5 mod divided by 4. That means 5 is divided by 4. That means what is the remainder? 1. So what is the answer you will be getting? 2. Then 6 mod 4. What you will be getting? X of 2 minus 1. Then 7 mod 4. X of 3 plus 1. In that manner 1 2 minus 1 1 1 2 minus 1 1. In the negative direction as well the same thing is happening. What I mean to say is that what will be the value of y of minus 1? What I am saying, what is the value of y of minus 1? So minus 1 mod 4. What I told you? Minus 1 mod 4. You need to add a number such that it becomes positive. So 3 mod 4. What is the remainder you are getting? What is the remainder you are getting? You are getting the remainder of 3. So what is happening here? This would be x of 3. Basically, what is the value of minus 1 mod 4? Minus 1 mod 4 is equals to 3. Because I told you if there is a negative number, I need to add a multiple of 4 such that the number becomes positive. So if I add plus 4, I am getting x of 3. Right? And what is the value of x of 3? X of 3 is plus 1. What is the value of y of minus 2? Then I need to check at y of minus 3 as well. And lastly, I will check at y of minus 4 as well. So you will be able to understand what is actually happening. So y of minus 2. So minus 2 4. So minus 2 plus 4 x of 2. It would be equals to x of 2. That is minus 1. Y of minus 3. It would be minus 3. Minus 3 plus 4. That means it would be equals to x of 1. X of 1 is 2. Then here what I will write down? Y of minus 4. Here what you will write down? Minus 4 mod 4. That means in minus 4 you will add plus 4. What you will be getting? X of 0. And x of 0 is equals to 1. So what do you think what is actually happening here? So what is the answer of y of n? Don't forget that what is your y of n equals to? Y of n is actually equals to x of n modulo 4. Or you can write down x of n mod 4. This is coming out to be equals to y of minus 5 would also be there. Y of minus 5 would also be there. Y of minus 6 would also be there. In that manner, any number could be there. That means it will be spread from minus infinity to plus infinity. Right? It will be spread from minus infinity to plus infinity. What is the value at y of minus 4? 1. Then y of minus 3? 2. Then minus 1? 1. Then what is the value of y of 0? 1. Then 2 minus 1? 1. 0, 1, 2, 3. This was your y of 0. Right? This was your y of minus 4. This was your y of 0. Then 5, then 4, 5, 6, 7. So what you will be getting? 1, 2, minus 1, 1. Again you will be getting 1, 2, minus 1, 1. So in that manner, what are you able to understand? This would be your n equals to 0, 1, 1, 2, minus 1, minus 3, minus 2, minus 1, 1, 2, minus 1, 1. Oh, sorry. This was your n equals to 0, no? Really sorry, guys. This was your n equals to 0. Then 1, 2, minus 1, 1, then 1, 2, minus 1, 1. So what you were having, you were actually having this 4.x of n. You were actually having this 4.x of n. When you made this modulo 4, what actually happened? It became periodic with 4. That's it. The same samples are being repeated and it became periodic with 4. So if they give you 4.x of n and they ask you x of n mod of 4, will you be able to write it down? Yes. You will not have to do this analysis. You will not do this analysis. I just gave this analysis to make you understand that what is the proper meaning of x of mod of 4. So first we understood about 4.x of n. First we understood about 4.x of n. Then we already know what is our simple x of n that we studied in our basics of signal. This is our simple x of n. Now what is the meaning of 4.x of n? After that, what is the meaning of x of n modulo 4? That means your 4.x of n is periodic with 4 now. So this is your periodic signal, right? This is your periodic signal with the 4, periodic with 4, periodic with periodic with 4 samples, periodic with 4 samples, and these are just simple 4 samples, and this is periodic with 4 samples. So there is huge difference in both of the terms. People think that this term and this term both are same. No, there is very huge difference. And if they want to frame a good question in DFT, then they will surely frame the question with the terminology only. They will confuse you with the terms. So you should be knowing the basic meaning of mode, because it can be used anywhere in mathematics. Along with that, you should be knowing the basic meaning of terms as well. Is that clear to you? Okay, so we have understood about the terms. And what would be the graph of x of n modulo 4, x of n modulo 4? So this would be the graph of x of n modulo 4, 1 2 minus 1 1, 1 2 minus 1 1, 1 2 minus 1 1, just being periodic with from minus infinity to plus infinity. So it is just a periodic signal. So 1 2 minus 1 1, 1 2 minus 1 1, 1 2 minus 1 1. So this is your x of n mod of 4, which is 1 2 minus 1 1, 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 and so on. Okay, now next question, try doing it on your own. Okay, whatever the conclusion that you are getting from here, that is important. Not this question is not important, but whatever the conclusion that you get, that will be important. You let me know what will be your x of n modulo 5. For x of n is given, or I should have written 4 point x of n is given, and you will be able to understand 4 point x of n as well. So here better it should be written 4 point x of n is given, because I did not show the arrow here. So 4 point x of n is given, and you need to find x of n modulo 5. Will you be able to find it? Do it on your own. So you know that what I will do is that I will write that my y of n is equals to x of n modulo 5. So you know that one thing, you know that your y of 0 would be equals to x of 0 modulo 5 would be equals to x of 0 only. What is your 4 point x of n? That is given as 1 2 minus 1 2 3 4, 1 2 3 4, 4 samples are there. So y of 0 would be equals to x of 0 only, y of 1 would be equals to x of 1 only, y of 2 would be equals to x of 2 only, because this is n equals to 0, and y of 3 would be equals to x of 3 only. Now what would be your y of 4 equals to? So y of 4 would be x of 4 mod 5. That means it would be equals to x of 4. So this is n equals to 0, this is n equals to 4. Sorry, this is n equals to 3. 0, 1, 2, 3. What is the, where is x of 4? It's not there, right? X of 4 is not there. Are you able to understand this point? So what is the value of x of 4? Only 3 samples are there, no? From 0 to 3, only 3 samples are there. So x of 4 is not even there. What is the value of x of 4? That is 0. Are you able to understand this point? What will be your y of 5? Y of 5 would be 5 mod 5. 5 mod 5. That means it would be equals to x of 0 only. So again the repetition has started. Then 1, 2, 3, 4, and then again 0. 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. And if I ask you what is the value of, randomly let's just say what is the value of y of minus 2. So that would be equals to x of minus 2 mod of 5. So you need to add plus 5 here, you will get x of 3. What is the value of x of 3? That is 4. But if I ask you what is the value of y of minus 3? Y of minus 3 is also fine. But if I ask you what is the value of y of minus 1? So that would be x of minus 1 mod of 5. You need to add plus 5 here. What you will be getting? 4. So 4 mod 5 will be x of 4 only, which is 0. So what you can see in the negative direction? X of minus 1 is 0. X of minus 2 is 4. Then x of minus 3 would be minus 3 mod 5. That would be equals to x of 2. 3. Then 2. Then 1. Then again 0. So this process will keep on going. So what is actually happening? Did you understand this point? What is my x of n modulo 5? That is coming out to be 1, 2, 3, 4. But here it should be periodic with 5. This 5 shows that this is the periodicity. It should be periodic with 5. But what you are having only 4 non-zero samples. you are having only 4 non-zero sample. So from where you will bring your fifth sample? That fifth sample will be 0. Then again 1, 2, 3, 4. This is your n equals to 0. Then fifth sample I am not having. Then again 0. 1, 2, 3, 4, 0, and it will keep on going. Is that clear to you? 1, 2, 3, 4, 0. Basically, you are given 4.x of n, but they expect you to write x of n modulo 5. That means you need to make it periodic with 5. That means I will have to pad another 0. If they expected you to write x of n modulo 7, then what would be your answer? You have to pad 3 zeros. X of n modulo 7 means you have to pad 3 0, right? Because you are having only 4 samples, but they expect you to make it periodic with 7. That means you will have to pad 3 zeros. Are you able to understand this point? Okay, so this is the meaning of modulo n. Is that clear to you? So somewhere in your examination, somewhere in your analysis, these things can be used. So very simple thing, whatever that we have studied, 4.x of n or n.x of n means simply the number of samples, and the by default first term will be n equals to 0. Then we understood the meaning of mode. Then we understood x of n mode of n. That means it should be periodic with n, should be periodic with 4. So if you are having 4 samples, that means it will be periodic with 4 only. But if you are having 4 samples only, but they expect you to make it periodic with 5, that means you will have to pad a 0. So we have padded a 0. Okay. Now simple calculation. This calculation you have already seen, right? 4.x of n is given. You need to find x of n plus 1, x of n minus 1, and x of minus 1. 4.x of n, that means by default this is n equals to 0. So what will be your x of n plus 1? X of n plus 1 means the samples will be shifted towards the left hand side. Samples will be shifted towards the left hand side, right? So 1, 2, 3, 4. This is what will be happening. The sample will be shifted towards the left hand side. So these samples are shifted here, or you can say that arrow is shifted here. Samples are shifted here. So basically whatever that was happening at n equals to 0, that will happen at n equals to minus 1. Whatever that was happening at n equals to 1, that is happening at n equals to 0. So this we have already studied. What will be your x of n minus 1? Samples will be shifted towards the right hand side. So what will happen? 0, 1, 2, 3, 4. Basically what will happen? Arrow will be shifted here. So what is the sample? This is your x of n. Then actually the sample is 0, 0, 0, 0, 0, 0 are there. Then 1, 2, 3, 4. Then 0, 0, 0, and then 0, 0, 0 are there. So now here there was an arrow. Now what is happening? The samples have been shifted toward the right hand side. So this 0 has come here, right? So arrow has gone here. So 0, 1, 2, 3, 4. So this is the basic thing that we have studied in basics of signal. So now how the things are changing, that we are understanding. Now what is the meaning of x of minus n? That means all the samples have been shifted opposite. Basically you have taken the mirror image. Basically this one was here at origin only, but you have taken the mirror image you have taken. That means 2 goes here, 3 goes here, and 4 goes here. This was the scenario. 1, 2, 3, 4, right? And after that there was 0, 0, 0. Before that there was 0, 0, 0. But once you have taken the mirror image, what is the meaning of x of minus 1? Just you need to take the mirror image. There you go. Just you need to take the mirror image. But now if I ask you this particular question, the question looks similar, but here what I have done, x of n plus 1 modulo 4, x of n minus 1 modulo 4, x of minus n modulo 4. So what will be your answer now? This is the question. Think about it and tell your answer on your own. Okay, write down the answer and then match it. So my first target would be to find x of n modulo 4. What that would be? Sir, 1, 2, 3, 4, 1, 2, 3, 4, that would keep on repeating. Because x of n modulo 4 means it is periodic. Because now we are going to understand DTFS and DFT. So every calculation will be going for periodic signals only, right? And this is your n equals to 0. I could have taken this as n equals to 0 as well. Any one I could have taken n equals to 0, because for n greater than 0 there are infinite samples, for n less than 0 as well there are infinite samples. So everywhere infinite samples are there. So this I am taking as n equals to 0. Now x of n plus 1 I need to do. x of n plus 1 modulo 4 I need to do. What will happen? What will happen? X of n plus 1. That means samples will be shifted towards the left hand side. So this arrow would be shifted here. Sample will be shifted towards the left hand side, or you can say that arrow will be shifted to that 2. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So arrow will be shifted here. So this is your answer. It is fine. That means now your origin has become at 2. Now from here, if I need to get 4 point x of n plus 1, then what would be my answer? From here, if you ask me what will be your 4 point x of n, then what would be the answer? The answer would be, whenever you write down 4 point x of n, by default the first term is n equals to 0. So you will write down 2, and from here you need to pick 4 samples. What that would be? 2, 3, 4, 1. This would be the answer. This is the important point, a very, very important point. This will be your 4 point x of n plus 1. So if they give you that 4 point x of n is given and they ask you 4 point x of n plus 1, that means they are expecting that first you will take the modulo and then you will calculate the 4 point x of n. Okay? They will not tell it that first you take the modulo and then you calculate 4 point x of n plus 1. What they would say that 4 point x of n is given and you need to calculate 4 point x of n plus 1. If they want to ask the simple question, then this is how they will ask you. They will not even say here 4 point x of n plus 1. They will just say that x of n is given and tell x of n plus 1, x of n minus 1, x of minus n. Now, but if they are saying that 4 point x of n is given and then you need to find 4 point x of n plus 1, that means first you find the modulo, first you make it periodic. Once you have made it periodic, after that you calculate the 4 samples, and always the sample will be starting from n equals to 0, but you don't need to show the arrow. You will not be showing the arrow. From n equals to 0, you need to pick 4 samples. So n equals to 0, n equals to 1, n equals to 3, n equals to 4. So 2, 3, 4, 1. These 4 samples are there. So n plus 1 here and n plus 1 here, both are giving very different results. So how will you solve in the examination? Like, will you do this process that first I will find the modulo or anything? No, this is not how I will do it. What I will do is that I will directly write down this particular thing. I know that 1, 2, 3, 4 is repeated. 1, 2, 3, 4 are repeated, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. What I need to do, x of n plus 1. That means arrow will be shifted here. So that means 2, 3, 4, 1 would come. So directly this step I will be able to write down. If you are able to think all these things in your mind, this will not take much time. Hardly it will take 10 seconds. You know that if they are giving 4 point x of n and they are asking 4 point x of n plus 1, that means it will be periodic with 4 point. 1, 2, 3, 4, 1, 2, 3, 4 and 1, 2, 3, 4 backward as well. X of n plus 1, that means arrow will be shifted ahead. Arrow will be shifted ahead, that means arrow will move to 2. So 2, 3, 4 and 1. Is that clear to you? Try writing down 4 point x of n minus 1 directly. This was the first one. Now you need to write down 4 point x of n minus 1 directly, but here what I will do is that I will first write down the modulo. So what will happen? The arrow will be shifted backward. The arrow will be shifted to 4. Shifted backward. Arrow will be shifted backward, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the arrow here, which will be shifted here. Arrow will be shifted backward, right? X of n minus 1. That means samples will be shifted ahead, or you can say that arrow is shifted backward. From n equals to 0, you need to pick 4 samples. What those 4 samples would be there? 4, 1, 2, 3, right? So what would be your 4 point x of n minus 1? That would be 4, 4, 1, 2, 3. 4, 1, 2, 3. Okay. This is very important. X of minus n. Very, very important. So what you will write down? First you will write down 4 point x of, sorry. First you will write down x of minus n modulo 4. What is the meaning of this? This will stay at origin and everything else will be inverted. this guy will stay at origin and everything else will be inverted. So what will happen? 2 will go here, 4 will come here. Look, 2 will go here, 4 will come here. 3 will go here, 3 will come here. 2 will come here, 4 will go here. Right? Are you able to understand this point? Just this 1 remains there same. The 1 remains there same. And around this what is happening? 2 is coming here. 2 is coming here. The 4 is coming here. Then 3 both are same only. So 3 is coming here, 3 is coming here. So 3 remains the same. This remains at that place, that place only. Then the 4 goes here and 2 comes here. And 2 comes here. I don't need to write down more things. Why I don't need to write down more things? Because what is my job? From n equals to 0, I need to pick 4 samples. So what is the answer of 4.x of minus n? One, 4, 3, 2. There you go. So there is, you can see that there is huge difference in x of minus n, and this x of minus n. There is huge difference. This x of minus n is 4, 3, 2, 1, and this is your 1, 4, 3, 2. Usually these things are understood with respect to a circle, that they will make the circle and then they will place all other element with respect to this origin, and then they will remember some properties, that if x of n plus 1 is given, then you will shift it like this, x of n minus 1 is given, then you will shift it like this, then x of minus n is given, then you will shift in some another manner. So these properties will be tough to remember, right? Whatever the property that we studied in basics of signal, the same property we are applying here. Ditto same property we are applying here. Just the thing is 4.x of n was given, then we find its modulo. Modulo means it will be periodic. Now with the periodic, what will happen? If you are doing a right shift, that means, sorry, if you are doing a left shift, x of n plus 1. So whatever that will happen, that I will write down, and from there, from origin, I need to pick 4 samples. From origin, I will pick 4 samples. So 2, 3, 4, 1. There you go. So if you have already studied this particular topic, then you would have studied it with respect to a circle. In the books as well, it is taught in the same manner, but that will just confuse you in the examination, because you will have to remember another thing. One thing you already remember in basics of signal, then here you will have to remember another thing. So that I don't want. Just calculate the modulo and then solve in this manner. It will give you much more confidence in the examination rather than remembering some method or anything like that. Okay. So confidence is important in the examination hall. So if you solve by this manner, then you will be much more confident in it. Right? X of minus 1 also you will be able to do that. Whole samples will be shifted towards the right hand side. So arrow will be shifted backward. So from origin 4, 1, 2, 3. And what would be your x of minus n? That means origin stays the same, rest everything is inverted. So this 2 goes here, 3 goes here, and 4 goes here, right? And from there, rest of the things are coming ahead. All clear to you? So 2 is coming, sorry, this 4 is coming here. What you can do in the examination, what I would do is that I know that 1, 2, 3, 4. And here also the same thing is happening, 1, 2, 3, 4. This is what I will write down. And I know that here is my origin. Now what I need to write down, x of minus n. That means what will happen? This 4 will come here, 3 will come here, and 2 will come here. I don't need to care about these guys, because I already don't care about these guys, because I know that origin remains the same. And after that I need to write down 4 samples. So what I will do? This 4 will come here, 3 will come here, and 2 will come here. So I will only care about 1, 4, 3, 2. Because after origin, I need to write down these 4 samples. So my matter of concern will always be after origin 3 samples, or you can say total 4 samples. So I will not care where these guys will go. I just care that what will come here, what will come here, and what will come here. So x of n you will be able to write down. Okay. Let's do more practice. Let's do more practice for x of minus n only. 4.x of n is given. That is 1, or let's take minus 2, 1, minus 1, 3. You need to write down 4.x of minus n. Okay. So solve it. You know that this is my origin. So first what you will find out, x of n modulo 4. X of n modulo 4. So what that would be? minus 2, 1, minus 1, 3, minus 2, 1. Now some people will be having the doubt, sir, that sir, what if here they have written 5.x of minus n, 6.x of minus n, 3.x of minus n. So that will not happen. If they have given 4 samples, then they will ask on 4 samples only. Are you able to understand this point? This will not happen. And even if it happens, that means what you will do? 4.x of n is given and they are asking you 5.x of minus n. So what you will do? First you will calculate 5.x of n. What that would be? Minus 2, 1, minus 1, 3 and then 0. 0, I am saying that 0.001% chances are there that this thing will happen. But even if it happens, then first you will calculate x of n, 5.x of n, and then you will do the same thing. Then you will calculate x of n modulo 5, and after that x of minus n modulo 5, and from there you will get 5.x of minus n as well. So same process you need to follow, but very rare that these things will happen. If they have given 4 point, they will ask 4 point only. Yeah, so minus 2, 1, minus 1, 3, minus 2, 1, minus 1, 3, minus 2, 1, minus 1, 3, and so on, it will keep on going. I need to write down x of minus n, 4.x of minus n. X of minus n. So what do I care about? 3 comes here, minus 1 comes here, and 1 comes here, starting from minus 2. So 3 comes here, minus 1, and then plus 1. There you go. And this is the origin which I don't need to show. So actually what is happening? This guy stays and then all other guys invert their places. But this trick will be tough to remember. Just write it down in this manner: minus 2, 1, minus 1, 3, minus 2, 1, minus 1, 3, and then fix one guy, and then you see that what will happen? Everything else will be inverted. Everything else will be inverted. So 3 comes here, minus 1 comes here, and plus 1 comes here. So this will be your 4.x of minus n. Right? Very easily you will be able to write it down. Very, very easily. Or this is solved by a circle as well. What they would do is that first this is the origin, right? Minus 2. Then they will write down 1 here, minus 1 here, and 3 here. I just represented 4 samples starting from here. In any direction you can write down minus 2, 1, minus 1, 3. So I wrote down in this manner, right? For x of n, I choose this direction. So when I write down x of minus n, what I will do? I will just choose the opposite direction. It's not that you have to write down in anti-clockwise only. In any direction you can write down. But whenever you write down x of minus n, you have to choose the opposite direction. So when I read minus 2, 1, minus 1, 3. So minus 2, 1, minus 1, 3. Now I will write down x of minus n. That means I will read opposite now. So how will I read? Minus 2, 3, minus 1, 1. Minus 2, 3, minus 1, 1. So yes, are you getting the same answer? Yes, the same answer is there. So this is how it is solved. So for inversion, you can remember this trick. For inversion, you can remember this trick, but don't remember any trick for x of n minus 1, x of n plus 1. I don't recommend that particular thing. Okay. So for x of plus 1, x of n minus 1, you will solve by this. For x of minus n, you can remember the trick that you will draw a circle. You will write down the samples in any manner, clockwise, anti-clockwise, in any manner you can write down. But whenever you take the inversion, you will read it opposite. So opposite you will go minus 2, 3, minus 1, 1. In that manner you can solve it. So in the books as well, it will be mentioned in this particular manner. And if you are a dropper, if you are studying it again, then you would have also seen this particular method somewhere. But circle method I don't recommend, because another thing we need to remember which will be tough for us to remember. So that's why we go by this particular method. Okay. Now we are moving towards our topic. So 40 minutes of discussion was there, which was actually only prerequisite. It's not that this question would be coming in the examination. Okay. This question will not be coming. But now you will have a very clear idea of DFT and DTFS. Otherwise that becomes very complex. DFT and DTFS becomes very complex because you are not sure about the terminologies. And you don't even know what is actually happening there. Right? People think that DFT is calculated only for periodic signal. Is that so? You can calculate DFT only for periodic signal. Is that so? Absolutely wrong statement. Do you remember that 3 hour of video where we understood about DTFS, CTFS, CTFT, DTFT and DFT? So there what we did? First we had x of n, which was aperiodic. Then we got x to the power j omega, and then we sampled it. And this we were calling as DFT, DFT of x of n. So DFT can be calculated for aperiodic as well, and it can be calculated for periodic as well. For both kind of signal, it can be calculated. So people think that if 4 point x of n is written, that means it is written that x of n is periodic. No, absolutely wrong. 4 point x of n is written, that means there are 4 samples of x of n starting from n equals to 0. This is the meaning of 4 point x of n, nothing else. Okay, so this is a very big confusion, right? Although in the examination modulo is not introduced till now, they did not introduce the modulo at all, but any day they can introduce it. So modulo is different and 4 point x of n is different. Both are complete different thing. Okay. So all these things we are going to understand, but this is a prerequisite for DTFS as well, for DFT as well. So you know how to do the linear convolution, right? X of n is given, h of n is given, starting with n equals to 0. Starting with n equals to 0, you need to do the linear convolution. So this tabular method we follow. 1 2 3 1 1 2 3 and here 4 5 6. What we do? Cross multiplication. So 4 8 12. I hope you remember this particular method. In basics of signal we have studied this particular method in basics of signal. So 4 8 12 5 10 15 6 12 18. So 4 13 16 plus 12 28 27 and 18. So what would be your y of n? So y of n would be 4 13 28 27 and 18. Now what would be n equals to 0? How do you recommend that? How do you find that? This is your n equals to 0, right? Here also this is your n equals to 0. So this would be your n equals to 2. So lower limit added, 0 0 added, you will get 0 only. Higher limit added, 2 2 added, this will be your n equals to 4. So from 0 to 4 it is there. How many number of samples are there? How many number of samples are there? Number of samples. These are 3. And how many number of samples are there? These are also 3. And here how many number of samples are there? 3 plus 3 minus 1. So number of samples here are 3 plus 3 minus 1. If it was having n sample and this was having m sample, then here the number of sample would have been n plus m minus 1. So all these we have studied in basics of signals, right? This is how we do the linear convolution and this is how we write down the number of samples. So 3 plus 3 minus 1. So number of samples are 5. So here you can see that number of samples are 5. All clear, all fine, very basic, this we already know. Now what is your circular convolution? So circular convolution is defined in this manner: x of n convolution with h of n. So this is how your circular convolution is defined. So how will you solve this problem? That you need to find circular convolution of x of n with h of n, and it is known as periodic convolution as well. It is known as periodic convolution as well. So how will you define this circular convolution? So circular convolution, what you will do is that y of n would be equals to, what you will do, you will make a matrix. So this is 3 point, this is 3 point, that means 3 samples are there. So you will make a matrix. Now you can pick anything, you can pick x of n as well, you can pick h of n as well. Basically whatever the property that we were applying in linear convolution, the same you can apply here as well, that h of n, this thing is also true. Okay, so what you will do, 1 2 3, this is how you will write down. Any sample you can pick the sample of 4 5 6 as well. Okay, so let me make the matrix in a good manner. What I am doing, first I am making the matrix. What I am doing, any of the sample you can pick, 4 5 6 as well you can pick, or 1 2 3 as well you can pick. So I am writing vertically from up to down, 1 2 3. Now what will happen, this last sample will go upward, last sample 3, and then you will write down again from top to bottom, 3 1 2. Again what will happen, the last sample will go upward, then again you will write down from top to bottom, 3 1. Is that clear to you what I am doing? Again I will repeat. Okay, 1 2 3, last sample goes upward, then again start from top to bottom. 3, 1, 2. 1, 2, 3, last sample goes upward, 1, 2. Then this last sample goes upward, 2 goes upward, then again start from ahead, 3, 1. Is that clear to you? And then another one you will write down, that also from top to bottom only. So this is the matrix we have made, that would be 4, 5, 6. And now you just need to solve this matrix, you will get your answer. That will be the answer of your circular convolution. Is that clear to you? So 4, what will be the answer you will be getting? So this is a 3 cross 3 matrix and this is a 3 cross 1 matrix. So you will be getting the answer as 3 cross 1 only. So you need to solve the matrix. I hope you know how to solve the matrix. So 4 into 1 plus 3 into 5 plus 2 into 6. So 12, 15 plus 4, 19 plus 12, that would be 31, right? 4 plus 15, 19, 19 plus 12, that would be 31. Next you need to solve 8 plus 5 plus 18. 8 plus 5 plus 18. So that would be 31 again. And next 12 plus 10 plus 6. This would be 28. Okay, let me check back the calculation. 8 plus 5 plus 18. 31. 12 plus 10 plus 6. That would be 28. So 31, 31, 28. So what is your y of n is coming out to be? So you can write down my 3-point y of n. That would be equals to 31, 31, 28. Here also this will also be the origin. But here what is the thing? Number of samples were 3. Number of samples were 3. And here also the number of samples are 3. So if you do 3-point x of n, you do 3-point h of n, and this is known as 3-point circular convolution. Circular convolution. So you are having 3-point x of n, you are having 3-point h of n, and you are doing the 3-point circular convolution to get a 3-point y of n. And this is how you will do it. Is that process clear to you? First we need to write down the matrix. How we will start? Any of these we will pick. 1, 2, 3. 1, 2, 3 I wrote down. 3 goes upward, then top to bottom. 3, 1, 2. 2 goes upward, then top to bottom. And then the other matrix 4, 5, 6, and then we will solve it. This is the answer we are getting. Or what you can do? You can make that row matrix as well. That first what you will write down. First you will pick any matrix. Let's pick 1, 2, 3 only. So in a row I am writing it down. 1, 2, 3. 1, 2, 3. Okay. Next what I will do? I will pick that another one. So here I wrote down in row only. 1, 2, 3 I wrote down in row only. So 4, 5, 6 also I will write down in row only. 4, 5 and 6. Now what will happen? This 6 comes here. This 6 comes here. And then from here only 4, 5. Then what will happen? This 5 comes here. And then from here only 6, 4. Okay. What we did here? 1, 2, 3. 3 goes upward, top to bottom. 3, 1, 2. 2 goes upward, top to bottom. So last element goes upward and then top to bottom. Last element goes upward, top to bottom. So I will remember this particular method. I will use this particular method. Personally, I use this particular method. This row method also you can use. Okay. Just remember that here if you are writing down in column, then here also you are writing down in column. Here you are writing down in row. So here also you write down in row only. You solve it, you will get the same answer. Okay. This is your 1 cross 3 and this is your 3 cross 3. So you will get 1 cross 3 only. So 1 into 4, 12 plus 15. So 31. Next 1, 2, 3, 5, 4, 6. So 5 plus 8 plus 18. 31. And then 6 plus 10 plus 12. 28. So you are getting the same answer only. So any of the method you can follow any of the method you can follow, right? Whatever you want to follow, that you can follow. I will personally prefer which method? This particular method. Okay. Now let's see a important conclusion. So your x of n was this was your h of n. What was the result of your linear convolution? The result of your linear convolution was, this was the linear convolution. So this was the result: 4, 13, 28, 27, 18. 4, 13, 27, 28, 13. 4, 13, 28, 27, 18. अरे यार 28, 27 क्या कर रहा हूँ मैं? Now what is the result of 3 point x of n h of n? So here what you can see, this is 3 point, this is 3 point, the answer is also 3 point. So from the beginning, what was the result here? 31, 31, 28. This was the result. In the linear convolution, from the beginning, third sample, first sample, second sample, third sample, this sample, and here the third sample, first sample, second sample, third sample, both will be same. Look, the question has been asked on this particular method. Okay, the question has been asked on this particular conclusion. Although this looks like a stupid conclusion, but the question have been asked. What I am saying, in the linear convolution and in the circular convolution, what we are calculating? 3-point circular convolution we are calculating. So from the beginning, third sample of the linear convolution and third sample of the circular convolution, both are same. Because the question have been asked, that's why we are doing so. Is that clear to you? Okay, so this is this and this is same. Now secondly, what you will see, 4 plus 27, what that would be? 31. 4, 13, 13 only you will get. Just 1 second guys, I need to check the calculation. 13, 27, 18. This was 18. Sorry, this was 18. Nothing guys, nothing. So what you will see, 4 plus 27, what that would be? 31. 13 plus 18, what that would be? 31. So this third sample would be same, right? This sample would be same. This sample would be same. And after that, what you need to do? After that, you will check this first sample. After 28, this is also the first sample. This is the beginning sample, and after 28, this is the beginning sample. So if you add both of them, you will get the first sample of this one. Basically, from linear convolution, you can write down the result of circular convolution. How will you write down that? I am telling. So what you will do, 3-point x of n is there. That means third sample from beginning, and from here the third sample. Third sample means 0, 1, 2, 0, 1, 2. That means first sample, second sample, third sample. So this 28 and this 28 will be the same. Now here, after 28, this is the first sample and this is the beginning sample. So 4 plus 27, it will give you 31. 13 plus 18, it will give you 31. So this is how you can write down the rest of the samples. Again, it feels like that, sir, it is a stupid result, but question have been asked on this particular property that the third sample would be the same. This question have been asked. Third sample means n equals to 2 would be the same. This is your n equals to 2, right? Third sample means n equals to 2. So in both of them, n equals to 2 are same. Okay, but question have been asked, that's why we need to see it. And we will elaborate this property more. So let's see more examples and then we will be elaborating this property more. So this is the question, x of n, h of n. Now here the interesting point is, this is 2-point x of n, this is 3-point x of n, but here I am asking you different kind of things. That you need to calculate 3-point circular convolution, 2-point circular convolution and 4-point circular convolution. What you will do is that you will just see it, whatever the results we get, after that we will make the conclusion and you will be able to remember the conclusion as well. Don't worry about that. So don't get frustrated that, sir, this conclusion is coming, that conclusion is coming. In the end, I will summarize all and everything you will be able to remember. Don't worry about that, but have patience, have some patience. Okay, you need to have some patience, then only you will be able to proceed. So 1, 2, 3, 4, 5, you need to do the circular convolution. So you need to do the linear convolution. So very easily we can do the linear convolution and we will get the result. So 1, 2 I am writing down here and 3, 4, 5. So what I will get 3, 4, 5. 6, 8, double of this 10. The first element 3, then 10, 13, and then 10. So what is the linear convolution? 3, 10, 13, 10. Here it should have been shown that this is your n equals to 0. It would be given in the question. N equals to 0, 1 and 2. So this would be n equals to 3. All fine, all good. This is your 2 point x of n, this is your 3 point h of n. They are asking 3 point x of n convolution h of n. What does that mean? That means 2 point x of n should be converted to 3 point x of n, and 3 point h of n is already there. If you need to calculate that 3 point circular convolution, that means both x of n and h of n should be written in 3 point only. Why it is necessary? Let's try to calculate the first one. Let's try to calculate the first one. What we need to calculate? 3 point circular convolution. X of n circular convolution with h of n. This is what we need to calculate. So what we will do? I told you I will prefer the column 1. So let's just say first I write down this 3, 4, 5, because I can see that here there are 3 points. That means there are 3 samples. So 3, 4, 5. This is how I will write down. 5 goes upward, then from top to bottom 3, 4. 4 goes upward, then from top to bottom 5, 3. Multiplied with next I need to write down x of n. But here I am having only 2 samples. 1, 2 only. So where will I get the third sample from? That has to be 0. Basically, what would have been my 3 point x of n? My 3 point x of n would have been 1, 2. If I am having only 2 samples, that means the third sample would be non-zero. This would be the non-zero sample. Is that clear to you? Okay. Now you solve it. What you are getting? 3 plus 10, 13. 4 plus 6, 10. 5 plus 8, again 13. This is the answer you are getting, right? 3, 10, 13, 4 plus 6, 10, 5 plus 8, 13. And what was the result of your linear convolution? One thing I know that 3 point x of 3 point, if I am calculating, if I am doing the 3 point circular convolution, that means the third element would be the same. The third sample would be the same. So first sample, second sample, third sample. So 13 here, first sample, second sample, third sample, 13 here. This would be the same. Now from here, now I will stand here, right? So this is same. So 3, 10, 13, 10. 3, 10, 13, 10. Now I will stand here. What I will say? After this, this is the first sample, and here this is the first sample. So both added, 10 plus 3, what you will get? 13. Now 10 here, but here there is no sample, so I will have to add a 0. So 10 plus 0, what you will get? 10. This guy and this guy added, what you are getting? 10. And this is how I can write down the rest of the samples. But this will not always work. This thing will always work. Which thing will always work? That the n point sample would be the same. That means the third sample would be the same. This trick will always work. There is no doubt about that. But this particular thing that you stand here, and then you calculate the first sample from here and first sample after this. You add both of them, and then second sample here, second sample after this, you add both of them, and then you get the result. This will not always work, but this will always work. That the third sample would be the same, and question have been asked on this particular point only. Okay. But we will see all the results and we will surely see the conclusion. As of now, your job is just to see what I am doing. Let's calculate 2 point circular convolution now. What they are saying? You need to calculate 2 point x of n convolution with h of n. Now you would say that, sir, I am fine with 2 point x of n, but I need to find 2 point h of n. What does that mean? That means you need to kill this sample. Starting from n equals to 0, you need to pick 2 samples. What is the meaning of 2 point h of n? This is your 3 point h of n. What is the meaning of 3 point h of n? Starting from n equals to 0, you need to pick 3 samples. if I write down 2 point h of n, what is the meaning of that? Starting from n equals to 0, you need to pick two samples. So 1, 2, 3, 4. Basically, your 2 point x of n is already given, but what would be your 2 point h of n? That would simply be 3, 4. Then third sample you have to kill, right? So how will you solve it? 1, 2, this goes upward, this goes in this manner, and then 3, 4. I hope you are able to understand. 1, 2 I wrote down from up to down. Then this 2 goes here. Then from up only I was writing down. So only 1 I was able to write down. That's it. So 1, 2, 2, 1, 3, 4. What you are getting? So 3 plus 8, 11. And what you are getting? 6 plus 4, 10. And what was the result of your linear convolution? That was 3, 10, 13, 10. What did I tell you? The second sample would be the same. 2 point x of n, no? Second sample would be the same. That means this sample and second sample from here, this sample. Second sample means n equals to 1. Third sample means n equals to 2. Second sample would be the same. Second sample would be the same. Is that clear to you? Second sample is same. 10 and 10. So n point x of n convolution h of n, if they are asking, then you know that nth sample will be the same. What is the meaning of nth sample? N equals to n minus 1. So if I am saying that I am doing 16 point circular convolution, that means the 16th sample would be the same. Or you can say n equals to 15th sample would be, n equals to 15 would be the same, right? 16th sample means n equals to 15 because you start from n equals to 0, right? First sample is n equals to 0, second sample is n equals to 1. So 16th sample would be n equals to 15, right? So this question have been asked, okay? But here you can see that if I stand here and I say that I will add 3 plus 13, I am not getting the correct answer. I am actually getting 11 here. So this trick that you stand here and then you calculate 3 plus 10, then you calculate 10 plus 0, this always does not work. Is that clear to you? Okay. Now next one is more interesting. 4 point x of n. What we are going to calculate? 4 point x of n convolution h of n. Before that, you let me know how many samples are there. 4 samples are there, right? In the linear convolution, how many samples are there? 4 samples are there. When you calculate 4 point x of n convolution h of n, how many samples would be there? This will also give you 4 samples. This has given you 4 samples. This will also give you 4 samples. Let's see it and let's see the result. The result would be the same. Whatever the result you are getting here, when you calculate the 4 point x of n convolution h of n, the result would be the same. Let's do it, okay? So let's do it. You will get the same result. What I need to do? I need to calculate 4 point x of n circular convolution h of n. I am saying have the patience, don't get frustrated. Every conclusion we are going to write down and you will be able to remember as well, okay? But these conclusions are actually important. I guess if they can ask this particular question that this sample would be the same, then they can ask anything. And this is also very important property that if number of samples in your linear convolution and in your circular convolution, if number of samples are same, that means the result will also be the same. Here there was no same result, right? 13, 10, 13, 3, 10, 13, 10. Here the result was 11, 10, 3, 10, 13, 10. But now the result is going to be the same. 4 point x of n. What that would be? 1, 2, and I have to pad 0. And what would be your 4 point h of n? That would be 3, 4, 5, and I have to add a 0. Let me recheck. 3, 4, 5, I have to add a 0. Okay. So let's do it. So I always prefer this particular column matrix. So what I will write down? Let's write down this one. 3, 4, 5, 0. 3, 4, 5, 0. Then this 0 goes upward. This 0 goes upward. And then top to bottom. 3, 4, 5. Then this 5 goes upward. 5 goes upward and then top to bottom. 0, 3, 4. This 4 goes upward and then top to bottom. 1200. So what is the answer you are getting? 3, 10, 13, 4, 6, 10, 5, 8, 13, and then 10. What was the result of your linear convolution? That was 13. अरे ये क्या हो गया? 3, 10, 13, 10. 3, 10. First element I am getting 13. Okay, it is 3 only. Yeah, sorry guys. 3 into 1 will be 3, 0, 0. Yeah, it is 3 only. So 3, 10, 13, 10. 3, 10, 13, 10. That means if the number of samples are same, then your job is done. Right? Then both circular convolution and linear convolution will give the same result. So what is the important point you need to remember? What do you think? Only two conclusions you need to remember. If number of samples in linear convolution and your circular convolution are same, that means you will get the same result. And another thing you need to remember is that the nth sample would be the same. The nth sample would be the same. What I am saying? The nth sample would be the same. So 4-point convolution I am doing. That means fourth sample would be the same. Although here completely it is the same. Here completely it is the same, but surely fourth sample is surely the same. If you do 1-point circular convolution, if I had done 1-point circular convolution, that means 1 will be multiplied with 3. That means first sample would have been the same. So 3 and 3, first sample would have been the same. 2-point convolution, 2-point circular convolution, that means second sample was same. 3-point convolution, that means third sample was same. And 4-point convolution, that means fourth sample would also be the same. And if the number of samples in linear convolution and circular convolution are same, what does that mean? That means that your result will also be the same. This is the conclusion that you need to remember. Is that clear to you or not? Okay, very, very straightforward thing, very, very easy thing. And if you want to remember, what you can remember is that this trick, that this added here, that means first you stand at the nth sample. Basically here you are saying 3-point convolution. So first I will stand at the third sample, and then I will pick the first sample from here, first sample from here, first sample from here, and first sample from here. That may work, but only in some specific cases. That may work only in some specific cases. If the question is coming in the examination hall, let's just say in the examination hall, what they say, that they give you the result of linear convolution. They give you the result of linear convolution. Let's just say I am giving you the result of linear convolution. -1, 1. And I am saying that write down the result of 2-point, not 2-point, 5-point, or neither 5-point. Write down the result of 3-point circular convolution. I am asking you the result directly. So what you would do? Now I know that that trick would be surely applicable. So third sample would be the same, third sample would be the same. So this third sample would be the same. Now I will stand here, this sample, 3 minus 1, that would be +2, and 4, 1, that would be 5. So 252, that would be the result. So somewhere you can write down this particular thing, that if the question is coming, if they are asking the question in the examination hall, that means surely the property, this property would work. This is not a property, you can say this kind of trick would work if they are asking the question like this. But I am saying 0.01% chances are there that they will ask this kind of question. They will surely ask that which sample would be the same. So you know that if I am doing the 2-point circular convolution, second sample would be the same. 3-point circular convolution, third sample would be the same. But if they are asking that you need to write down the complete result, that means surely the trick would be applicable. Is that clear to you? Okay, well and good, fine. And if you want to remember, I will tell you when the trick is actually applicable. Here the trick was not applicable. Why is that so? Because if I stand here, then I will see that this is my first sample and this is my first sample. But if I see what would be my second sample here, that would be 10 only. But here my second sample is another 10. Are you able to understand this point? Basically, samples should not be remaining here. First sample, then second step is that where you are standing. If you are standing here, but here the second sample is also remaining. Are you able to understand what I am saying? I don't think you are able to understand what I am saying. What I am saying is that if I need to apply this trick, what I will do, I will stand here. That means now what I will do, I will pick the first sample from here and first sample from here. That means 3, 13, I am able to pick it. I am not writing down the answer that 3 plus 13, 26. No. So sorry, 3 plus 13, 16. That I am not writing down. I am just saying that I am able to pick the first sample, pick the second sample. But after 10, before 10, I am not able to pick the second sample. Here before 13, I was able to pick the second sample, that was 10. But after 13, here there was no sample, so I could add the 0. But here you cannot add the 0, right? 3, 0, 10, 13, 0, that would make this particular result absolutely wrong. Basically, I have the option of adding a 0. So here I could say that before 13, this was the second sample. After 13, this was the second sample. So you add them, 10 plus 0, answer is 10. Now here if I stand, if I ask you, after 10, what is the second sample? 10. But before 10, what is the second sample? It is not even there. So you cannot apply this trick. Is that clear to you? So this is where this trick is applicable. But again saying, 0.001% chances are there that they will ask you anything like that. Even if they ask, if they are asking, that means surely it is applicable. Otherwise, they are not asking. That's it. So only two results you need to remember. What is the bottom line? The bottom line is 2-point circular convolution you are doing, 3-point circular convolution you are doing, n-point circular convolution you are doing. The nth sample would be the same in linear convolution and circular convolution. Along with that, if the number of samples in linear convolution and circular convolution are same, that means the result will also be the same. That's it. This is the bottom line. There you go. Okay. Nothing else you need to remember. And when the trick will be applicable, the trick will be applicable if they are asking the question. That's it. If they are asking the question in the examination, that means the trick is applicable. Otherwise, it is not applicable. So you stand at the middle point. Before 13, first sample. After 13, first sample. Before 13, second sample. After 13, second sample. Add them, you will get this result. Okay. So this is the relation between circular convolution and linear convolution. Now let's just say this question is coming in the examination. X of n is given, y of n is given, h of n is given, sorry. And they are asking you to write down x of n convolution, h of n, circular convolution. This question is wrong because they did not even specify that this is 3-point x of n, this is 2-point x of n, and how many points of x of n, h of n you need to calculate. Question is wrong. In GATE it will not come, but in some PSU examination or even in ESC these kind of questions can come, or in some like any local examination these kind of questions can come. GATE will not do this kind of questions. Okay, they will write down 3-point x of n is there, 2-point h of n is there, and what you are supposed to calculate. 3-point circular convolution, 2-point circular convolution, 1-point circular convolution, 4-point circular convolution, 5-point circular convolution, what you are supposed to calculate, they will write it down. But if it is not written, then what you will do? You will drop the question? No. Basically, you will make both of them same and you will calculate it. So what does your intuition say? What I should do in the examination? What you will do? You will simply calculate 3-point circular convolution. No. What I will do here, 1 minus 1, 3 is already given. Here I will add 1, 2 and 0. So what I would do? I will calculate 3-point circular convolution. Okay. Although these things will not come in your examination, but in any local examination, if you find out x of n, h of n, calculate the circular convolution. This question does not make any sense. You need to specify the number of samples and how many samples you want here, that also you need to specify. But even if it is coming, what you will do is that you will pad up the 0 from your own side. 3 comes here, 1 minus 1. Minus 1 goes here, 3, 1. So I will pad up from my own side. That would be 1, 2 and 0. And I will solve it on my own. Okay, so you can solve it, you will get the answer. Okay, you can solve it. So just I am telling that in some local examination, if these kind of things are coming, then you will be able to solve it. Okay. Another important observation that I have already taught. So that observation only we are going to write down. So x of n was there, h of n was there, x of n convolution, h of n was this one, 3-point x of n, 2-point circular convolution was there, 2-point circular convolution was there, and now I have taken 4-point x of n, h of n, and performed 4-point x of n circular convolution with h of n. The result was 3, 10, 13, 10, which was same as x of n circular convolution with h of n. Okay. So number of samples here and here were same, you will get the same answer. Is that clear to you? Well and good. Okay, so this conclusion we have already written. So this conclusion again we are writing down. So everything that we have studied in this particular lecture, that we are going to write down. So x of n convolution with h of n will be equals to n point x of n circular convolution with h of n when the number of sample, when n is equals to, this n would be equals to the number of samples in x of n convolution with h of n. Basically x of n convolution with h of n is giving you n samples. So n point x of n convolution with h of n, how many samples it will give you? Basically 2 point circular convolution is giving you 2 samples, 3 point circular convolution is giving you 3 samples, 4 point circular convolution is giving you 4 samples, 5 point circular convolution will give you 5 samples, 10 point circular convolution will give you 10 samples. So n point circular convolution will give you n samples. But here it depends on x of n and h of n, right? Here it depends on x of n and h of n. This number depends on x of n and h of n, but this number depends on, this particular number depends on this particular thing, right? So in both of them, if the number of samples are same, then your job is done, right? Now what I am saying, let the number of samples in x of n is n, and the number of samples in h of n is m. So how many number of samples would be there in x of n convolution with h of n? That would be n plus m minus 1. You agree to this point, right? I told you 3 samples, 3 samples. So 3 plus 3 minus 1. So number of samples are 5. Here also you can see. Here also you can see. Number of samples 2. Number of samples 3. So 2 plus 3 minus 1. Number of samples were 4 here. Right? Number of samples n plus n minus 1. And number of samples in alpha point circular convolution, that would be alpha, because here it depends on this point circular convolution. If it is n point circular convolution, that means here there will be n sample. If it is alpha point circular convolution, that means there will be alpha samples. The result of x of n convolution h of n would be equals to the result of n plus m minus 1 point circular convolution. Did you understand this point? Because this will be having number of samples equals to number of samples equals to n plus m minus 1. Let's just say the n value is 3, n value is let's just say 6, m value is 4. So how many number of samples would be there in x of n convolution h of n? That would be 9, right? So if you are doing 9 point x of n circular convolution with h of n, then your results would be the same. Well and good. Very easy to understand, right? Very straightforward. Nothing is there. Now you see this question, and also that thing also I could have written. What I could have written, that the nth sample would be the same, right? That thing also I would have written. What does that mean? The nth sample, not nth sample, I will write down alphath sample. Another point I am writing down. These are the points I have written down. So here I could write down alphath sample in linear convolution would be equals to alphath sample in alpha point circular convolution. Did you understand this point? In 3 point circular convolution, here it is written. In a 3 point circular convolution, third sample was same. In 2 point circular convolution, second sample was same. In 4 point circular convolution, fourth sample was same. So in alpha point circular convolution, alphath sample would be the same. So alphath sample in x of n convolution h of n and alphath sample in alpha point x of n convolution h of n, both would be the same. This is the question that you need to solve. After that, there is no question. So try this question on your own. I will take a break and then this lecture will end. And in the next lecture, we will start discrete time Fourier series. So there is nothing difficult in this lecture. First thing is that you understood how to do the circular convolution. This is the thing you need to remember, and this slide you need to remember. That's it. So I have tried to break down this lecture in a very good manner. It took me roughly around 2 to 3 hours to make these slides. Okay, because I thought that how I should represent this particular lecture. Because the problem in DTFS and DFT is that you actually never understood the terminologies. First thing is that you don't even understand the concept that how the DFT is derived, how the DTFS is derived. So that we have already seen. So there is no issue. The second thing is what is the meaning of these terminologies. So first important point was that we understood the meaning of modulo and we understood the meaning of n-point any discrete time sequence. That we understood. After that, our target was to understand the linear convolution and the circular convolution. And from there, two interesting results we are getting. That when both of them will give the same results if number of samples are same, and which sample could be the same in any kind of circular convolution, in any kind of linear convolution, the alpha sample would be the same. If I am doing the alpha point circular convolution, if I am doing the 3-point circular convolution, then third sample would be the same. If I am doing the 8-point circular convolution, then 8th sample would be the same. Is that clear to you? So these conclusions we have seen, and if some question is coming, then from here the question may come. Okay. Next we need to solve this question that you will solve on your own. This particular question is given that x of n is a 13-point sequence, h of n is a 9-point sequence, z of n is defined as linear convolution. Z of n is defined as linear convolution. Linear convolution. Now y of n is defined as n-point circular convolution. Y of n is defined as n-point circular convolution. If y of n is equals to z of n, then you find out the value of n. Okay. If y of n is equals to x of n, then you need to find out the value of n. That means what point circular convolution I need to do such that my linear convolution is equals to circular convolution. So linear convolution is equals to circular convolution. When do you get it? When the number of samples are same. That means number of samples should be the same. Should be the same. Right? So what would be the number of sample in linear convolution? Number of sample in linear convolution. That would be 13 plus 9 minus 1. 13 plus 9 minus 1. That would be 21. And number of samples in n-point circular convolution. That would be equals to n. Number of samples in n-point circular convolution will be equals to n, and number of samples in linear convolution will be equals to 3 plus 9 minus 1, which will be equals to 21. Right? So what is the value of n? N is equals to 21. There you go. That's the answer. How many zeros should be padded in x of n and h of n such that y of n is equals to z of n? How many zeros should be padded in x of n and h of n such that y of n is equals to z of n? What would be the answer of this? Look, y of n should be equals to x of n. The point is y of n should be equals to z of n. Sorry, y of n should be equals to z of n. Again, the thing is linear convolution should be equals to circular convolution. That means what you will be doing? You will be doing the n-point circular convolution. That means you will be doing 21-point circular convolution. 21-point circular convolution. Just let me know one thing. If 1, 2 and 5, 6, 7, if I do the linear convolution of both of them, let's just say I am getting the result y of n, and if I do the linear convolution of 5, 6, 7, 0, 0, I am talking about linear convolution. If I do the linear convolution of both of them, will the result be different? No, the result would be the same. In case of linear convolution, in case of circular convolution, if you are padding up the zeros, the result would be changing. But in case of linear convolution, the result will not change. So in x of n and in y of n, in x of n and in h of n, if I pad the 0, will my linear convolution change? No. The result of my linear convolution will not change, but the result of my circular convolution will change. And if I need y of n equals to z of n, that means I need to do 21-point circular convolution, that means what I need? I need, if you need to do 21 point circular convolution, that means you need 21 point x of n and you need 21 point h of n. That means x of n was having 13 sample. X of n was already having 13 sample. So I need to add how many samples? 13 plus 8. And here I was already having 9 samples. So I need to add 12. So these many samples should be added. In x of n you need, sorry, these many zeros should be padded. So in x of n you need to pad 8 0. 8 zeros, 8 0 padding would be there. 0 padding. And here you need to add 12 0. Is that understandable to you? Okay, last one. Let 13 point x of n convolution h of n is equals to g of n. Find the value of k for which gk is equals to zk. So the 13 point circular convolution you are doing, that means the 13th sample would be the same. So what is the meaning? 13th sample would be the same. 13th sample would be the same. 13th sample would be the same. What does that mean? K is equals to 12. If you are saying that g of k is equals to z of k, what is g of k? G of k is the circular convolution, and what is z of k? Z of k is the linear convolution. So one sample of linear convolution and one sample of circular convolution is same. So which sample would be the same? The sample would be 13th sample. So 13th sample would be the same. So k equals to 12, right? Because first sample is k equals to 0, second sample is k equals to 1, third sample is k equals to 2. In that manner, 13th sample would be k equals to 12. So k equals to 12 would be the same. That means the result of linear convolution at k equals to 12 and the result of circular convolution at k equals to 12 would be the same. So this question is just giving you the conclusion of everything that we have studied, and you need to know how to do the linear convolution. You need to know how to do the circular convolution as well. Is that clear to you? Is everything clear to you or not? I hope you have understood everything, every single thing about linear convolution and circular convolution in case of discrete time. Well and good, right? So this is how we will be proceeding. Okay, so let's meet in the next lecture. In the next lecture, we are going to start DTFS. Okay then, thank you very much. Hi everyone, welcome back. So now we are going to study about discrete time Fourier series, DTFS. So basic intuition behind the DTFS, we have already seen that x of n would be periodic and you will represent it in terms of complex exponentials. That we have seen, and then we got to know that it's exponential Fourier series coefficient. The exponential Fourier series coefficient of x of n would be ck, and this would be periodic, right? Exponential Fourier series coefficient. This is your x of n, which is periodic with period n, and it can be represented in terms of complex exponentials. So summation I would put in terms of complex exponential, that complex exponential Fourier series coefficient is ck. Coefficient is ck, and you will represent it in terms of complex exponential. That would be e to the power j k omega naught n, where omega naught value is 2 pi by n. N is the period. So this thing we have already seen. How we will represent everything we have seen, right? And here the summation would go, since you need the final answer in terms of n, so summation would go with the range of k, right? And it will go from k equals to 0 to n minus 1. Why n minus 1? Because you need to take n samples. So 0th sample you will take, first sample you will take, second sample you will take, third sample you will take, fourth sample you will take. So how many samples you have taken? 5 sample you have taken. So if your time period was 5, you would go from n equals to 0 to 4, right? So this is the formula of x of n, which we already know. Like this is how we represent c1 e to the power j, value of k is 1 omega naught n, plus c2 e to the power j 2 omega naught n, plus c3 e to the power j 3 omega naught n, and it will keep on going. It can go in the negative direction as well, like it could be c naught as well. This will be the DC value, c1 e to the power minus j omega naught n, c of minus 1 e to the power minus j omega naught n, c of minus 2 e to the power minus j 2 omega naught n, and in that manner it will keep on going. Okay, what will be the value of ck? The value of ck was 1 by n. All these things we have already seen. We are just revising it. We will see some formula, we will see some property, and with that our DTFS will be completed. A very easy topic, and in the end I will tell you how many questions have come from this particular topic, not in the beginning, because in the beginning if I tell you, then you will be less concentrated, but you need to be concentrated enough, because what I feel is that in the upcoming GATE examination the question can come from here, because it's been a long time since they asked anything on DTFS. So any day the question can come now, and in our test series as well you will see a lot of question on DTFS only, because what I feel is that in the upcoming examination there could be one question from DTFS. So what was the formula here? CK, here also summation e to the power, since n is here so minus sign would come, jk omega naught n. Final answer you need in terms of k, so you will put the limit of n. N will go from 0 to n minus 1. So I have told you that how will you write down a formula as well. I am not telling you to mug up any formula. I have told you the way how to write down the formula, right? Ck goes here, so here 1 by n. Now x of n is discrete, that's why summation would come. E to the power, if n is here, n is coming here as well, that means there is negative sign. If n was here, n is coming here as well, then there was a positive sign. So n together, negative sign. E to the power minus jk omega naught n. And what limit you will put? You will put the limit of k or n. You will put the limit of n because you need the final answer in terms of k. So n will be gone, only the final answer will be remained in terms of k. So these were the formula of x of n and c of k, right? Let's see how we can solve the problem. So if this question is there, you need to find the ck and you need to tell the value of c13 and c of minus 11. How would you do it? What is the value of omega naught here? You can see that omega naught 1 is pi by 3. Omega naught 2 is 5 pi by 3. Then what is the value of omega naught? That would be HCF of, अरे यार 1 क्यों लिख रहा हूँ मैं? It is pi by 3. Sorry guys, it is pi by 3. Omega naught 1 is pi by 3. No, why I am writing 1? Brain fade movement. Omega naught 1 is pi by 3. Omega naught 2 is 5 pi by 3. So what will be omega naught? What will be the fundamental angular frequency? That would be HCF of pi by 3 and 5 pi by 3, which you can directly see that HCF of pi by 3 and 5 pi by 3 will be pi by 3 only. Say yes or no? Are you able to understand this point? Right? It would be pi by 3 only. So how you can write down your x of n? X of n could be written in terms of 2 plus 3 sine omega naught n plus 2 cos 5 omega naught n, right? So what you can do? E to the power j omega naught n minus e to the power minus j omega naught n divided by 2j plus 2 e to the power j 5 omega naught n plus e to the power minus j 5 omega naught n divided by 2, right? This is how it can be broken down. Look, you should know the basics of continuous time Fourier series, and you should know these much basics, that how will you break down sin omega naught n, how will you break down cos omega naught n. So these basic things you should know, then only you will be able to proceed. So what you are getting? 2 plus 3 by 2j e to the power j omega naught n, 3 by 2j e to the power minus j omega naught n plus e to the power j 5 omega naught n plus e to the power minus j 5 omega naught n, right? Now can you compare? Look, whenever anything is coming in terms of sinusoid or cosinusoid, and I am asking you to find out ck, so will you apply this formula? No. Whenever any question is coming, let's just say your x of n is sinusoid. What I am saying, your x of n is sinusoid, and they are asking you exponential Fourier series coefficient. So you will never apply this formula. You will always compare your sinusoid with this formula, whether it is DFT or it is DTFS. What I am saying, let me repeat the statement again. If the x of n is in terms of sinusoid or cosinusoid, you will never apply the Fourier series coefficient formula, or in any transform, in Fourier transform or in Fourier series or in discrete Fourier transform, never ever you will apply this formula. You will always compare it with x of n formula. Are you able to understand this point or not? Let's just say I am saying that x of omega is equal to sin omega. This is given, and you need to find x of n. What you will do? X e to the power j omega, not x of omega. X e to the power j omega is given as sin of omega, and you need to find x of n. What you will do? Will you apply any formula? Nothing. Nothing you will do. You will do this thing. divided by 2g, and then you will compare it with x of n, and you will get to know that sir, it is written as 1 by 2j delta of n plus 1 minus 1 by 2j delta of n minus 1. This is your x of n, because sir, if you find out the transform here, that would be 1 by 2j e to the power j omega minus 1 by 2j e to the power minus j omega. This would be the answer you will be getting, right? And that would be equal to sin omega. So whenever sinusoid or cosinusoid anything is coming, like in we are next topic would be discrete Fourier transform. So we are going to study discrete Fourier transform. So there as well x of n could be some sinusoid, sin pi by 3n. So there also you are never going to use this particular formula. You will write down this formula of x of n and you will compare it. That's it. Okay. So always whenever sinusoid cosinusoid is coming, we are always going to compare with this particular approach. So what I'm going to do, I'm going to write down the formula of x of n only. That is actually equals to k going from 0 to n minus 1. What is the value of n naught here? That would be 6. So time period here is 6. So you will take samples from 0 to 5. Ck e to the power jk n omega naught. So now c naught plus c1. Omega naught value we already know, but we are not going to put it here. Plus, look, the thing is guys, if I write down c1, c2, c3 in that manner, then I will not be able to compare this c of minus 1, right? C of minus 5. These I will not be able to compare. So what I am going to do is that, what we can do is that, I will, this limit, basically I need to take 5 samples. In any window I can take 5 samples, no? So can I take the samples from minus 2 to plus 3? Can I do this? Or I can take the samples from minus 3 to plus 2 as well. Basically, I need to take 5 samples. So what I am doing, n equals to minus 2 sample I am taking, or k equals to minus 2 also you can take. K equals to minus 2, k equals to minus 1, k equals to 0, k equals to 1, and k equals to 2. Sorry, from minus 2 to plus 2 I will put. Is that clear to you? Basically, what I am saying is that I will take some samples in the negative direction as well and some samples in the positive direction as well. Is that clear to you? So I am taking k from minus 2 to 2. Why I am doing so? So that I would be able to compare. Is that clear to you? Okay. So what I am getting? C of minus 2 e to the power minus 2 omega naught n plus C of minus 1 e to the power minus j omega naught n plus C naught plus C1 e to the power j omega naught n plus C2 e to the power j 2 omega naught n. So what I can see here, e to the power minus j omega naught n, e to the power minus j omega naught n, e to the power plus j omega naught n, e to the power plus j omega naught n. So what you can see, C of 1 is equals to 3 by 2j, and C of minus 1 is equals to minus 3 by 2j, and C of 0 is equals to 2. So C of 0 is coming out to be 2. C of minus 1 is coming out to be minus 3 by 2j, and C of 1 is coming out to be 3 by 2j. But you can see something, this thing you can see here. So according to this, what you will say, that sir, my C of 5 and C of minus 5 is coming out to be 1 1. What you will say is that, sir, my C of 5 is 1 and C of minus 5 is 1. This is what you will be saying. Say yes or no? What I am saying, if you see this coefficient, and here let's just say I have put the limit in a manner that I am able to take the fifth sample as well. Basically, if I am able to take C5 e to the power j5 omega naught n, if I was able to take this sample as well, then I would have written C5 e to the power j5 omega naught n, C of minus 5 e to the power minus j5 omega naught n. This is what I would have written. So according to you, this is the thing that is coming. Now what else we have studied? We have studied that C of k is periodic. What we have studied? C of k is periodic. Very interesting conclusion we are going to see from here. Have your patience, and you are never going to find this kind of conclusion in any textbook. Okay, forget about the lectures. Even in the textbook, this conclusion is not there. So have some patience. What we say? C of k is periodic. Periodic with this and not only. This we say, right? Periodic with this and not only, right? So what is the value of this and not? That is 6. So C of k is periodic. So you know one thing, that C of k plus 6 would be equals to Ck. Periodic with n naught, which is equals to 6. So according to you, C of k plus 6 will be equals to Ck, right? If you put k equals to minus 1, if I put k equals to minus 1, so C of minus 1 plus 6 would be equals to C of minus 1. So what you are getting? C of minus 1 is equals to C of 5. What is C of minus 1? Minus 3 by 2j. But here you are saying that C of 5 is equals to 1. So something is wrong here. Let me repeat what I did. Here I saw that, sir, according to me, this would be my C of 5, this would be my C of minus 5. So my C5 should be coming as 1, C of minus 5 should be coming as 1, right? But sir, I know one thing, that I got my C of minus 1 as minus 3 by 2j and C of 1 as 3 by 2j. Now I know that my Ck is periodic with the time period of 6. So whatever the value you are getting at C of k, that same value you will get at C of k plus 6 as well. The same value you will get at C of k minus 6 as well. The same value you will get at C of k minus 12 as well, right? Is that clear to you? So according to you, if you put k equals to minus 1, so C of this is your C of minus 1 and this is your C of 5. So C of minus 1 should be equals to C of 5. C of minus 1 is minus 3 by 2j and C of 5 is 1. So where you are going wrong? What went wrong? Go back to this expression. When you solve this expression, what you will realize, that this particular thing and this particular thing is throwing the same frequency. Did you understand this point? What I mean to say is that, let's take this expression again. Okay, let's analyze this expression once more. So you will notice something pretty good out of it. What is that? Forget about this 2. This is a DC value. Don't care about that. Pi by 3n plus 2 cos. Can I write it down as 2 pi n minus pi by 3n? Say yes or no. 2 pi n minus pi by 3n. That would be 6 pi minus pi pi by 3. So cos 2 pi n minus theta. That means you are in the fourth quadrant, and in the fourth quadrant cos is positive. So what will be the answer? The answer was plus 2 cos, basically cos 2 pi minus theta, that is actually equals to cos theta only, because it will be in the fourth quadrant. Cos 4 pi minus theta, that will also be equals to cos theta only. So it will only lie in the fourth quadrant only. Are you able to understand this point? So they will all be equals to cos theta, and n could be negative as well. So you can take n as negative as well. Cos minus 2 pi minus theta. What is minus 2 pi? Minus 2 pi is basically 0. So that would be equals to cos theta only. So all are lying. Basically from here you would get to know that cos of 2n pi minus theta is equals to cos theta only. So this looked like 5 pi by 3 n frequency, but it was actually pi by 3 n frequency only. Did the n naught value change? No, n naught is still 6. Everything is same. Everything is same. But you got to know that this particular thing and this particular thing was same only. Basically from here what you were getting, n naught is still same. X of n was 3 plus 3 by 2j e to the power j pi by 3n, and pi by 3 is actually omega naught. So what I can do is that I can write down this as omega naught minus 3 by 2j e to the power j omega naught n plus e to the power j omega naught n plus e to the power minus j omega naught n. I hope you understood what I am doing. 2 cos omega naught n, that would be e to the power j omega naught n plus e to the power minus j omega naught n divided by 2. So 2 and 2 got cancelled. So what you understood here, that your x of n is actually, what you understood, that your x of n is actually coming out to be 2 plus 3 by 2j plus 1, right? 3 by 2j plus 1 e to the power j omega naught n plus minus 3 by 2j plus 1 minus 3 by 2j plus 1 e to the power minus j omega naught n. This is the answer it is coming out to be. Are you able to understand this point? So what is your actual C naught value? That is 2. What is your actual C1 value? That is 3 by 2j plus 1. And what is your actual C of minus 1 value? That is 1 minus 3 by 2j. This is the correct answer. This is the correct answer, and it is periodic with 6. So if someone asks you what is the value of C5, so you can say that, sir, it will be C of minus 1 plus 6. That would be 1 minus 3 by 2j. So both these answers were wrong. This was also wrong. These were also wrong. So sir, if this question is coming in the examination, then in the examination, how I will be solving? Sir, if this question is coming in the examination hall, so in the examination hall, how I will be solving? Do I need to care about this particular thing again and again? No. What you will do is that you will solve in this manner only. You will follow the same process. Follow the same process. You will get these values C0, C of minus 1, C of 1, C of 5 and C of minus 5. What you will do? From here only you will compare. You will write down the value of C0, C of 1, C of minus 1, C5 and C of minus 5. Then you will see one thing, that it should be periodic. So one thing I got to know, that if I do minus 1 plus 6, then I am getting C of 5. But this guy is saying that it is 1 and this guy is saying that it is minus 3 by 2j. That means there is something wrong. And if there is something wrong, that means this guy and this guy is actually same. That means they both will be added. So if here someone would have asked me what is the value of C of minus 1, so what I would have checked, that sir, C of minus 1 I am getting, but along with that my C of minus 1 would be equals to C of 5 as well. Along with that it would be equals to C of minus 7 as well. But am I getting C of minus 7 here? No. It would be equals to C of minus 13 as well, because minus 1 minus 12, then minus 1 minus 18 as well. What I am saying, minus 1 will be periodic with minus 1 plus 5. Sorry, it is periodic with 6 now. So minus 1 plus 6, minus 1 plus 12, it would be periodic with minus 1 minus 6, it would be periodic with minus 1 minus 12, minus 1 minus 18. So in that manner it will be periodic. So I will check if they are talking about C of minus 1, that means I will check there that C of minus 1 along with that C of 5 as well, both should be throwing the same value, but both are throwing the different values. That means both should be added. Actually both are the same frequency component. This frequency component and this frequency component both are the same. That means they should be added. So what I would do is that I will write down my answer as minus 3 by 2j plus 1. This is what I would do. So what I would have checked is that I would have checked in this manner, that they are asking me C of minus 1. So I will say that, sir, C of minus 1 plus 6 would be equals to C of 5 as well. So actually my C of minus 1, that would be equals to C of 5, addition of both. A very, very important point which 99.95% of the students will miss. Okay, that's the guarantee I can say, because it is not there anywhere. And these kind of examples are yet to be introduced in the examination. In the examination, they did not ask this kind of question till this date. So surely this is coming. Any day it could be coming. Is that clear to you? Is this point clear to you? A very, very good discussion. And similar thing would go with C of 1 as well. If someone asks you what is the value of C of 1, what you will do? If someone is asking me, sir, what is the value of C of 1? What you will do? Sir, I know that C of 1 would be equals to C of 1 minus 6 as well. It could be equals to C of 1 plus 6 as well, but I don't care about C of 7. I don't care about C of 7 because it is 0 here. So I don't care about that. I only care about C of 1 minus 6, that is equals to C of minus 5. And C of minus 5, I know that C of minus 5 is 1 and this is 3 by 2j. That means it would come out to be equals to 1 plus 3 by 2j. There you go. So in the examination, you don't need to follow this process. I did by this process just to let you know that these answers were wrong actually. I followed this process just to let you know that why these answers were wrong and what was the issue here. But did you understand the whole point here? What is the point? Question would be coming, I would be solving in this manner. I would get to know that C1, C of minus 1, C5, C of minus 5, all these values are coming. I will write them down and then I will see that which values should be same. If there are two kind of things, like what do I mean by that? That C of minus 1 was equals to C of 5. C of minus 1 was equals to C of 5 and both are coming different values. C of 5 is giving me one value and this is giving me minus 3 by 2j value. So actually they are coming from the same frequency component. That means I need to add them up. And if I add them up, my job will be done. That would be my final answer. Is that clear to you or not? Okay, so a very good discussion. I hope you enjoyed this one. But actually they asked C of 13 and C of minus 11. Right? What they asked? What was the question? Question was C of 13. So in the examination, C of 13 would be coming. Then I will get to know that, okay, C of 13. So my period is 6, right? What they want me to find? C of 13 they want me to find. My period is 6. My period is 6. So what I will calculate? 13 mod 6. What is the value? 1. 13 mod 6. You remember what is the meaning of mod? divide the 13 divided by 6, what you will be getting? 6 into 2 plus 1. 13 is equals to 6 into 2 plus 1. So what is the remainder? Remainder is 1. So if the remainder is 1, that means C of 13 would be equals to C of 1, and that is equals to 1 plus 3 by 2j. So C of 1 plus 6 plus 6, that means C of 13 you will get. So any number is there, you just need to find its mode with the period. Next, what they want me to ask? C of minus 11. So what you will do? C of minus 11 I need to find. So minus 11 mod 6. What that would be equals to? Minus 11 mod 6. What I need to do? I need to add multiple of 6. If I add multiple of 6, that means minus 5 mod 6, again negative. Then again I need to add mod 6. So what I will be getting? 1 mod 6. So minus 11 mod 6 is equals to 1 only. That means this will also be equals to C of 1 only. That would be this. Am I doing something wrong? Minus 11 C of minus C of 1. So if I subtract 12 from here, you will get C of minus 11 only. Basically here C of 1 would be equals to C of 1 plus 6, C of 1 plus 12, C of 1 plus 18, and C of 1 would be equals to C of 1 minus 6, C of 1 minus 12, C of 1 minus 18 as well. So what you will be getting here? C of minus 5, C of minus 11, C of minus 17, and here you will be getting C of 7, C of 13, and C of 19. So C of 13 they asked, C of minus 11 they asked. Both are equals to C of 1 only. So basically they asked the value of C of 1, and a lot of people will say that C of 1 is minus 3 by 2j, looking at this expression. But little they care about this particular thing, that this is also having a frequency component of pi by 3 only. So if you are, what I would have done as a student, that first I will make all the frequency components less than 2 pi. Basically what I would see here is that I can reduce it. So as a student, what I would have done, first I would have tried reducing it. Let's see other examples, you will understand more. So let's see this example, what you would have done looking at this question. So what I would do, here I can see that it is pi n plus pi by 3, pi n plus pi by 3, and here I can see that it is 2n pi plus pi by 3. So something I can do, surely something I can do. Can you do anything with pi n plus pi by 3? No, because cos pi n plus pi by 3 will throw different results with respect to different values of n. So don't do anything with pi. What I am saying, cos pi n plus pi by 3. If n value is 1, let's just say n value is 1. So cos pi plus pi by 3, where it will go? It will go into the, if what I am saying is that if n value is 1, so it will go in the third quadrant, right? And in the third quadrant, cos is negative, right? And if n value is 2, then where it will go? It will go in the first quadrant, 2 pi plus pi by 3n, and in the first quadrant cos value is positive, right? So here it is positive, here it is negative. So I will not do anything with that. Basically it will needlessly make my question complex. So I will keep this as it is, but I would do something with this for sure, because this I can say that it is periodic with 2 pi, right? Because 7 pi by 3n could be written as 2n pi plus n pi by 3, right? Okay, so x of n is 2 plus 3 sine, let's break it down. Let's not do anything with this, let's keep this as it is. But this one directly I can see that for this one what I can do, some people will say that sir you can do 2n pi minus 2 pi by 3. In this manner you can reduce it, 2n pi minus 2 pi by 3, right? In the fourth quadrant cos is positive only, so this way I can surely reduce it, this way I can surely reduce it. But let's not reduce it as of now, let's not reduce it as of now. This would be 2n pi plus pi by 3, and you know that 2n pi plus n pi by 3 will be n pi by 3 only. Okay, and surely I can see that my omega naught value is pi by 3 only here, because what you need to do, you need to take the HCF of pi by 3 4 pi by 3 and pi by 3, that is equals to pi by 3. X of n as 2 plus 3 sin omega naught n plus 2 cos 4 omega naught n minus cos omega naught n. Three plus 2 plus 3 by 2j e to the power j omega naught n minus 3 by 2j e to the power minus j omega naught n plus e to the power j 4 omega naught n plus e to the power minus j 4 omega naught n minus e to the power j omega naught n divided by 2 minus e to the power minus j omega naught n divided by 2. Right, simple mathematics, nothing else. Simple, very simple mathematics. I am just worried about some calculation mistake. I hope those mistakes are not there. 3 by 2j minus 3 by 2j 1 by 2. Okay, fine. So directly I can see that C naught value is 2, no doubt about it. C1 value is coming out to be 3 by 2j from here and minus 1 by 2 from here. And let's just say if I had keep this as C of 7 only, because here what would have come? 7 omega naught. If 7 omega naught would have come, so my C of 7 value would come out to be minus 1 by 2. C of 7 value would come out to be minus 1 by 2, and this C of 1 value would come out to be 3 by 2j. And I would get to know that 1 plus 6 would give me C of 7 only. So 3 by 2j minus 1 by 2 I would have done, right? So this thing is clear to you, right? This thing is absolutely clear to you. So here if I had not done anything, then what I would have done is that C of 7 would have been equals to C of 1. Right? Now C of minus 1 would be equals to minus 3 by 2j minus 1 by 2. Right? Minus 3 by 2j minus 1 by 2. And from here it feels like that it is C of 4. C of 4 is equals to 1 and C of minus 4 is also equals to 1. Right? But someone would have said that, sir, it is C of 2, because you know that this 4 pi by 3n could have been written as 2n pi minus 2 pi by 3. Right? 2n pi minus 2 pi by 3n. Basically what I look at 4 pi by 3 only. So from there I understand that it is 2 pi minus pi by 3. Then I need to multiply with n. Sorry, 2 pi minus 2 pi by 3. 2 pi minus 2 pi by 3. So it would be 4 pi by 3n. Right? So here this would have become as 2 cos 2 pi by 3n. And that would be equals to 2 omega naught. That means these value would have been C2 is equals to 1 and C of minus 2 is equals to 1. Right? C2 would have been equals to 1 and C of minus 2 would have been equals to 1. But here you are getting C of 1 equals to 1, C of minus 4 equals to 1. Right? So C of minus 2 is equals to 1. If C of minus 2 is equals to 1, then what you would do? C of minus 2, and it is periodic with 6. What is the value of n naught? If omega naught is pi by 3, then n naught is 6. Right? So C of minus 2 would be equals to C of minus 2 plus 6. That means it would be equals to C of 4. Are you getting the same thing? Yes. So C of minus 2 would be equals to C of 4. That should be equals to 1. Are you getting the same thing? Yes. And here what you would have done? C of 2 minus 4 would have C of 2 minus 6, because it is periodic with 6, that would have been equals to C of minus 4. Are you getting C of minus 4 equals to 1? Yes. Is that clear to you? Are you able to understand what I am saying? I am saying that even if you have changed the frequency component, nothing would matter. You would have still got the same answer. Even if you have applied this particular thing, still you would have got the same answer. This is what I am saying. In this question, if someone asks you what is the value of C of 2, will you be able to tell? Yes. You will say that C of 2 would be equals to C of minus 4 plus 6. That would be equals to C of 2, that would be equals to 1. And if someone asks you what is the value of C of minus 2, what you will say? Sir, this would be equals to C of minus 2, that would be equals to, sir, that would also be equals to 1. And if in this place, in place of 4 pi by 3n, if you had put 2 pi by 3n, then also you would get the same answer. Because you know that 4 pi by 3n could be written as 2n pi minus 2 pi by 3n, which is equals to cos 2 pi by 3n only. Because it will be in the fourth quadrant, and in the fourth quadrant cos is positive. So still you would get the same answer. So what I am saying is that even if you change the frequency components, you would get the same answer. Just only one thing you need to take care. If you are getting the different answers, that means basically they will be actually added. If you are getting the different answers, here you would have got C of 7 and here you would have got C of 1. So C of 1 should be equal to C of 7, but here it would give you minus 1 by 2 and here it would give you 3 by 2j. What does that mean? That means both will be actually added. Both are actually coming from the same frequency component. It feels like that they are different, but they are actually same. If they are same, then there is no issue about that, both should be added. So if I had solved this question, without even converting this, without even doing anything, if I had solved this question purely, then I would get to know one thing, that C of 1 would be equal to C of 7. Then actually I would have added both of them. So even if you want to use your zero brain, still you will be able to get the answer, right? Even if you want to use the zero brain, still you will be able to get the answer correctly. Just only one recheck mark you need to do, that whatever the non-zero value I am getting, are any two values same? If these are same, that means they should be added. That's it. Is that clear to you? Is this discussion clear to you? A very, very important discussion which is ignored by a lot of students and by a lot of educators, by a lot of textbook as well. So this is what we have done, right? What they were actually asking? They were actually asking the value of C of 13 and C of minus 11 again. So C of 13 would be equals to C of 1 only, and that is equals to 3 by 2j minus 1 by 2. Let me check the calculation. I am pretty sure no error is there. Yeah, and C of minus 11 would be also the same only, because you know that C of 1 minus 12 would be equals to C of minus 11. So this would also be the same only. So answers are these. Okay. So surely this kind of concept is soon going to be introduced in the GATE examination. They will give you multiple frequencies and you will think that C of 1 is equals to C of 7, which is not coming. That means there is something wrong in the question. But no, there is nothing wrong in the question. The point is they are the same frequency component. That means that they should be added. Let's go to the next one. X of n is given. This question is GATE question. Okay. So in the GATE till now, they have given only one frequency component. So there is only one frequency component. No. If I had made another 11 n pi by n and I ask you the value of C1, then this question would become interesting, right? If I give this question and I ask you the value of C1, what would be your answer? 1 by 2j? No, the answer would be 1 by 2j plus 1 by 2, because 1 by 2j will come here and 1 by 2 will come from here as well, because here you can see that this will throw C of 1, that is 1 by 2j, and this will throw C of 11, that is 1 by 2. But you know that both are same, because it is periodic with what? What is the value of omega naught here? Omega naught value is pi by 5. So what will be the value of n naught? That would be equals to 10. So it is periodic with 10. That means C of 1 would be equals to C of 11. That means both should be added. So 1 by 2j plus 1 by 2. Okay. But this is not the question. The question is this, which they asked, which is very simple. So exponential Fourier series coefficient is Ck. Ck is non-zero for k equals to bm plus minus 1, where m belongs to an integer. So what is the value of b? So you can see here is that x of n is n naught value is 10, which I don't care. I can see that x of n is sine omega naught n, which will be written as e to the power j omega naught n minus e to the power minus j omega naught n divided by 2j divided by 2j. So from here I am getting C of 1 as 1 by 2j and C of minus 1 as minus 1 by 2j. It would be same as C of 1 would be same as C of 11 as well, C of 21 as well, C of 31 as well, and so on. Along with that, C of 1 minus 10, that would be C of minus 9, C of 11 minus 10, sorry, C of 1 minus 20, that would be equals to C of minus 19. All these will be equals to this one, and here what will happen? This would be equals to C of 9, C of 9 plus 10, 19, C of 29, and so on. And same in the negative direction as well. C of minus 11, C of minus 21. Basically, I am adding up plus 10 and subtracting minus 10. So C of minus 1 would be equals to C of minus 1 minus 10. That means C of minus 11, C of minus 21, and so on. So basically, it is non-zero equals to, for k equals to tan m plus minus 1. That means if I put m equals to 0, so what I am getting? C1 and C of minus 1. If I put m equals to 1, what I am getting? If I put m equals to 1, I will be getting 11 and 9. So I will be getting 11 and 9. If I put m equals to 2, what I will be getting? 21 and 19. So I will be getting 19 and 21. If I put m equals to minus 1, what I will be getting? Minus 11 and minus 9. So minus 11 and minus 9. So you got the point, right? It will be periodic with tan, that's it. So C1 is non-zero, C of minus 1 is non-zero, periodic with tan. So C1 is non-zero, C1 is non-zero, and C of minus 1 is non-zero, and it will be periodic with tan. So this was given, Bm plus minus 1. This was given. So what is the value of B? Value of B is tan. Right? So basically they were asking you the time period here. So the time period was n. So your x of n is periodic with a time period of 10 seconds. This was the question actually. What was the question? What is the period of x of n? That is 10. They just made a different way of asking it. Is that clear to you? Okay. Now from DTFS, from DTFT, we have studied DTFT. From DTFT, how would you calculate DTFS? Do you remember from x of omega, how did you go to C of n? Actual concept is you come from C of n to x of omega. What is the actual concept? First we study CTFS, then we study CTFT, right? So actual concept is that from C of n you come to x of omega, but from x of omega also we can go to C of n. Do you remember the process? What I used to say? What I used to say? That in x of omega you put omega equals to n omega naught, but only what you need to do? You need to take it only for one cycle and then divide by t naught. You take xt for one cycle, you find its x of omega, then in place of omega you put n omega naught and then divide by t naught. So this is the method we developed for finding out C of n. So similar method we can do here. How will you find out x of k? You can see the formula of x e to the power j omega. This is the formula of x e to the power j omega, and this is the formula of C of k. So what you would do for one period you will take x of n, then you will find its x e to the power j omega, and then in place of omega what you will do? You will put k omega naught. Sorry, here what you will put? K omega naught, because you need in terms of ck, and then divide by the period. You can directly see in this particular expression, in place of omega, if I put n omega naught, what I am saying in equation 1, in place of omega, if I put k omega naught, what I will be getting? X e to the power j omega. In place of omega, what I am putting? K omega naught. So summation n goes from minus infinity to infinity, x of n e to the power minus j k omega naught n. Right? This is what I will be getting. In place of omega I am putting. Now this particular expression you can directly see, which is equals to this one as well. But what is the point here? The point is here n goes from minus infinity to infinity because x of n was aperiodic. But here it will be periodic. So what you will do? You will take x of n for one time period. What you will do? This kind of question would be there. Basically this kind of question would be there. So what you will do is that for one time period, you will take x of n, and then you will find out it's x e to the power j omega. Can you let me know what is the x e to the power j omega for this one? That would be equals to sine, non-zero sample are 5. Is it symmetric? Yes. Sine 5 omega by 2 divided by sine omega by 2. But only for one period. Only for one period. So here I should write down x n naught e to the power j omega. Actually, x of n is periodic. But what I am saying is that I will take one period and I will find out its frequency. I will find out its Fourier transform. I have found out its Fourier transform. Then in place of omega, what I need to do? Now, if I need to find C of k, then what I will do? In place of omega, what I am going to put? In place of omega, I am going to put k omega naught divided by 2. In place of omega, what I am putting? here in place of omega what I am putting k omega naught. In place of omega you need to put k omega naught. So in place of omega I am putting k omega naught. So k omega naught divided by 2, 5 is already there, 2 is already there. In place of omega k omega naught divided by sine k omega naught by 2. Along with that it should be divided by 1 by n naught. So there you go, this is the answer. This would be the C of A. So you don't need to follow any process, any method or anything like that. What you need to do is that simply you find out, you consider one period of x of n, then you find out it's x e to the power j omega. In place of omega you put k omega naught and then divide by the time period. Let me know what is the time period here. How many samples are being repeated? 6 minus 2, 8. Basically from here to here, what is the time period? Minus 2 is same as minus 6. That means minus 2 is same as plus 6. That means here 8 would have been added. So this is the time period. X of n plus n naught is equals to x of n. So my n naught is the time period, no? So x of minus 2 plus n naught is equals to x of 6. So basically your time period is 8. So what is the value of n naught? That is 8. So value of n naught is 8. So what will be the value of omega naught? That would be 2 pi by n naught. That would be equals to pi by 4. So what is the answer you are getting? 1 by 8 sine k sine 5 pi by 8k. Omega naught by 2 will be pi by 8 sine 5 pi by 8k. Divided by sine, what is the value of omega naught? Omega naught is pi by 4. So sine k pi by 8. Sine pi by 8k. Sine pi by 8k. Sine 5 pi by 8k divided by ck. So this is the answer you are getting. This is your C of k. Okay. So the process is clear to you, that you find out the Fourier transform. Then in place of omega you put k omega naught. Then this is the expression you are getting. But you need to take x of n for one time period. So what I am doing now, if I take x of n for one time period, I am taking x of n for n naught time period, and then I am putting omega with k omega naught. What I will get? N goes from 0 to only for one time period I am taking. So this would become x of n for one time period. So you are getting this kind of expression only. So basically the thing is, ck would come out to be equals to, for one time period you take the frequency spectrum, or you can take the Fourier transform, and in place of omega you put k omega naught and then divide by the time period. If you have seen the continuous time, then also we followed the same method. In the continuous time as well we followed the same method, right? We take xt for one time period, then we find out its Fourier transform, and in Fourier transform in place of omega we used to put n omega naught and then divide by t naught. This process we used to follow in Fourier transform, and in continuous time. In continuous time this process we used to follow. The ditto same process we are following here. For one time period I will take the frequency spectrum, or I can say Fourier transform I will take. In place of omega I will put k omega naught and then divide by time period. Although not very famous, till this date no question have been asked from here. But who knows, it might be asked. So what people would be doing, they will be applying some formula and then they will be deriving it. But it would take a lot of time. What if they are asking the value of C of minus 31? So you know that it is periodic with 8. So what your C of minus 31 would be equals to? C of minus 31 would be equals to, it is periodic with 8. So C of minus 31 would be equals to periodic with 8. That would be equals to minus 31 plus 32. That would be equals to C of 1. So what they are asking? They are asking the value of C of 1 only. So what is the value of C of 1, which is equals to C of minus 31? That would be equals to 1 by 8 sine 5 pi by 8 divided by sine pi by 8. Right? Sine 5 pi by 8 divided by sine pi by 8. So this can be written as 4 pi sine pi by 2 plus pi by 8, right? So let's find out the value. You can just put these values sine pi by 8 in the calculator and sine pi by 8 in the calculator. You will get the final answer. Okay, that I am leaving up to you. You can get the final answer on your own. So sine pi by 8 you can get in the calculator, sine pi by 8 as well you can get in the calculator. You will divide them and then multiply with 1 by 8. So this is the multiplication with 1 by 8. You will get the correct answer. So what people would usually do is that they will remember this particular thing, that x e to the power j omega, and then in place of omega they will put k omega naught, but they will forget to divide by n naught. So this you need to remember. Okay, with a lot of students this thing would happen, that they will forget to divide by n naught. So don't forget dividing by n naught. Okay, you need to divide by n naught as well. What is the value of n naught? N naught value is 8. Is that clear to you? Okay, fine. Now this is a very interesting topic now. So this is just a property. We are going to prove a property with this particular question. So what is the target? You need to find C of k for this x of n. Then you need to find x of n by 2, x of n by 2 with 0 adding, 0 adding. Basically, if you find x of n by 2, that means your x of n will be expanded. So x of n can be expanded with 1 by alpha, 2, beta, 1, anything, right? But what you need to do, in place of alpha you need to put 0, in place of beta you need to put 0 only. So you need to expand it, but expand with 0. Okay, expand with 0. Then you let me know what is the value of dk and gk. So do it on your own. I will take a break because it's been roughly around 50 minutes I am speaking. So I will take a break and then we will see the answer, and you will see very interesting observation here. Okay, something regarding this only would come. This kind of expression only would come. Like first you find out the ck, then you do this particular thing, something interesting you will observe, and then we will write down the conclusion. So this is a property only. So let's get started. So you do it on your own. Yeah, welcome back. So did you try this one? So first let's take for x of n we need to find c of k. So did you try finding c of k? Which method did you apply? Which method did you apply to find c of k? You can apply the method of our, what you will do for one period. What is the period here? The period here is 2. So for one period you will find its Fourier transform. So Fourier transform would be 1 plus 2 e to the power minus j omega. But in place of omega, what you are going to do? In place of omega, you are going to put k omega naught. What is the value of omega naught here? Omega naught will be 2 pi by 2, that would be equals to pi, divided by n naught. Value of n naught is 2. Ck would be equals to 1 plus 2 e to the power minus j k pi, divided by 2. So what would be your C0? C0 would come out to be, if you put k equals to 0, that would be 3 by 2. C1 would come out to be minus 1 by 2. Ck is equals to, that would be 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, 3 by 2 and minus 1 by 2, and it will keep on repeating. Did you understand this point? Right? It will just keep on repeating, no? 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2. It will be a periodic waveform basically. So 3 by 2 is at center, minus 1 by 2. Basically, C of 1 would be equals to C of minus 1 as well. Are you able to understand this point? Because I know that C of 1 would be equals to C of 1 minus n naught. What is the value of n naught? N naught value is 2. So that would be equals to 1 minus 2, that means C of minus 1. So basically it will be repeated with the time period of 2. Repeated with the time period of 2. Repeated with the time period of 2. Let's call it n naught 1. What about x of n by 2? So what will be your x of n by 2? So you need to know that I will expand it, but I will expand it with zeros. So it is 1 0 2 0, 1 0 2 0, 1 0 2 0, 1 0 2 0, and in that manner it will keep on going. So this is your x of n, which is your here n equals to 0, and I am calling this as y of n. So what would be my y e to the power j omega? Sorry, what I need to find? I need to find its exponential Fourier series coefficient, that would be equals to dk. So my dk would be equals to 1 plus 2 e to the power minus j2 omega In place of omega, what I need to do? In place of omega, I need to put omega equals to k omega. This I am calling as omega 2. So k omega naught 2. What is the value of n naught 2? N naught 2 value is 4. So omega naught 2 value is 2 pi by 4. That would be equals to pi by 2. So that would be equals to k pi by 2. Right? But here what I am going to do is that I forgot something. Yeah, divided by 2 I did. Divided by n naught I need to do, no? So this is divided by n naught, divided by 2. Here what is the time period? In place of omega, what I need to put? I need to put k pi by 2. Right? In place of omega, I will put k pi by 2. But divide by n naught. What is the value of n naught here? 4. Right? N naught value is 4. So what answer you will be getting? Dk is coming out to be 1 plus 2 e to the power minus j k pi divided by 4. The conclusion is very important, okay? Conclusion is very important. So let me know what will be the value of d of 0. That is 3 by 4. What is the value of d of 1? That is minus 1 by 4. And in the same manner, you can find out the value of d of 2 as well. That would also be equals to d of 0 only. D of 2 e to the power minus j 2 pi. That would be 1. So 1 plus 2, 3 of 4. In that manner, it will keep on going. What will be the value of d of 3? Why I am finding 4 values? Why I am finding 4 values? Because d of k should be periodic with 4. What I am saying, if your y of n is having exponential Fourier series coefficient of dk, and you are saying that my y of n is periodic with 4 period. My y of n is periodic with 4 period. So dk will also be periodic with 4 period only, no? Here, why did you find out only c of 0 and c of 1? Because it was periodic with 2. But this will be periodic with 4. So you need to find out till 3 points. Sorry, till 4 points. 0, 1, 2, 3. So that's why I am finding out 4 points. But you will realize something good here. What you are getting? What is the value of d of 3? That would be e to the power minus j 3 pi. That would be minus 1 only. So minus 1 by 4. So what you can do? Let's take 1 by 2 outside. What I am saying? Let's take 1 by 2 outside. So 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, then 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, again 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2. So from x of n, when I went to x of n by 2, this was my ck, periodic with 2. Now this should be, let's just say, this is my origin, this is my n equals to 0. So this is periodic with 4 because x of n by 2 should be 4 only. So this will be periodic with 4. This is what you are saying. But you can see that this did not actually change. Ck, here also it is ck only, 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2. The only point is it is divided by 2. It is divided by this 2. We will surely write down the conclusion, but can you see something like there is something good happening here? There is surely some relation. Did you understand this point? When x of n was having ck, so x of n by 2 is having actually ck by 2. Your dk is coming out to be ck by 2. Ck is same, but this ck was periodic with 2. Here it should be periodic with 4, but actually the minimum period is 2. Again, let me repeat my statement. The minimum period is 2. What I am saying? The minimum period is 2. But surely it is periodic with 4, no? If you say that x of n by 2 has a period of 4, if you are saying that x of n by 2 is having a period of 4, that means its exponential Fourier series coefficient, should also have a period of 4. So is it having a period of 4? Yes. You are fulfilling the requirement. You have fulfilled the requirement that it should have a period of 4. After every 4 samples, it should be repeated. So 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, again it is being repeated. But what is the minimum period? Minimum period is actually this. But I don't care about that. I only care about one thing, that it should be periodic with 4. Is it being periodic with 4? Yes. But the thing is, these 2 samples are also being repeated. So minimum period is 2. So here what I am saying, periodic with 4 for sure. Periodic with 4. This was periodic with 2. Ck was periodic with 2. Right? Ck was periodic with 2. But here it is periodic with 4, but minimum period is 2. Minimum period is 2. Is that clear to you or not? So if x of n is given and you have the c of k, can you write down the exponential Fourier series coefficient of x of n by 2? What you will do, sir, 1 by 2 and then the same thing. That's it. 1 by 2, the same thing, not changing anything. What will be the answer? Sir, x of n by 2 will have the exponential Fourier series coefficient of 1 by 2, the same thing. What about x of n by 3? It will be 1 by 3 and the same thing. Let's do it. Let's do the process. What will be your z of n, which is given as x of n by 3, which will be equals to 1 to 1 2 is there, no? So it would be, since x of n by 3 is there, so I will include 2 zeros. Right? What is the period here? This is the period. 6 samples. This is the period. Right? What will be your z, what I am calling it, g of k. So let's call it g of n. If you are calling it g of k, then call it g of n. No? So what would be your g of k? First, for one period, what you need to do? This is n equals to 0, n equals to 1, n equals to 2, n equals to 3. For one period, what you need to do is that you need to find out its Fourier transform. So that would be equals to 1 plus 2 e to the power minus j3 omega. I hope you know how I am writing down this thing. If you don't know, that means you need to study DTFT. You don't know DTFT. Basically, it is delta of n plus delta of n minus 3 plus 2 delta of n minus 3. So 1 plus 2 e to the power minus j3 omega. In place of omega, what I need to put? I need to put k omega naught. What is the value of omega naught here? That would be pi by 3. Right? So what will be the value of omega? That would be k omega naught 3. That would be equals to k pi by 3. And divided by n naught. N naught is 6. So what is the value of g of 0? That is coming out to be 3 by 6. What will be the value of g of 1? Value of g of 1 is minus 1 by 6. G of 2, all these process should be done by you. G of 2 would be e to the power minus j2 pi, that is 1 only. So what is the answer you will get? 3 by 6. What will be the value of g of 3? You put 3 here, e to the power minus j3 pi, that would be equals to also minus 1 only. So minus 1 by 3. Sorry, minus 1 by 6. What will be your g of 4? G of 4 would be equals to again 3 by 6. And what would be your g of 5? That would be equals to minus 1 by 6. Okay. So what would be your g of k? So that is coming out to be, what I am doing is that I will keep 1 by 3 outside. 1 by 3 I am keeping outside. So what we are getting? 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, and the similar things are being repeated towards the negative hand side as well, towards the positive hand side as well. Basically, towards the negative hand side here as well, 3 by 2 minus 1 by 2, and so on. It will just keep on repeating. Basically, this is the thing. This is the complete sample which is being repeated. Actually, this thing is also being repeated. Minimum period is still 2, but I will take the period to be 6. I will take the period to be 6. Why I am taking the period to be 6? Because I know that my g of n is periodic with 6. My g of n is periodic with 6 samples. Periodic with 6 samples. So its exponential Fourier series coefficient g of k should also be periodic with 6 samples. No? Is that clear to you? So that's why I will take the samples to be 6. But what did you understand here? That your g of k is actually coming out to be 1 by 3 of ck only. So if x of n is giving you ck, then x of n by n naught, what it will give you? If this was your ck, 3 by 2 minus 1 by 2. So what is your decay coming out to be? 3 by 4 minus 1 by 4, 3 by 4 minus 1 by 4. But I will say it is periodic with 4. Minimum period is still 2. What I am saying, minimum period is still 2. But surely it is periodic with 4 as well. So whatever your requirement was there, that is being fulfilled. And here also the same thing is happening. Just it is divided by 3 because we did n by 3. Is that clear to you? So is this graph clear to you? So if you are expanding your time domain signal, what will happen? X of n by alpha. So you will get ck by alpha. But in the continuous time, what used to happen? Ck by alpha, okay, just write it down in a good manner. Ck divided by alpha. That means magnitude is divided by alpha. Magnitude, sorry, not magnitude, the complete Ck is divided by alpha. Is that clear to you? Okay, considering alpha is positive integer. Alpha is equals to positive integer. Because if it is negative, then x of minus n, basically x of n gives you ck. Then actually x of minus n will give you c of minus k. And x of minus n by 3 will give you c of minus k divided by 3. Okay. So for negative 1, this is how I will solve it. For positive 1, I know that if x of n by 3 is there, if x of n by 3 was there, then I would have already got c of k divided by 3. So whatever the ck is there, the same ck you will get. Just the thing is, it will be periodic with 3 n naught. Here what I am saying, this is periodic with, what is the period? Period is n naught. Here what will be the period? Period will be n naught. Here what is the period? Here what is the period? Period is alpha n naught, right? Here what is the period? Period is alpha n naught. Period has to be alpha n naught. But what is the minimum period? The minimum period. What is the minimum period? Minimum period is n naught only, right? Minimum period is n naught only. So this question is given, x of n is somewhat, x of n is something that I don't know, or d of 37. Okay, so x of n is this. It will have some Fourier series coefficient that I don't know. You need to find the Fourier series coefficient of x of n by 4. So if x of n, and then you need to find these values, x of n is having a Fourier series coefficient of ck, then x of n by 4 will have a Fourier series coefficient of ck by 4, right? So what I would do, so first I need to find the value of ck, which very easily I can find out with the help of DFT. But as of now I did not teach you DFT, so I will have to find out manually, right? So ck would be equals to 1 minus 2j e to the power minus j omega plus, look, 1 minus 2j e to the power minus j omega plus 0 into e to the power minus j 2 omega. So 0 multiplied with anything will be 0, plus 3 into e to the power minus j 3 omega, right? So what is the value of omega naught here? Omega naught will be 2 pi by 4 because n naught value is 2, sorry, n naught value is 4. So here in place of omega, what you will put? K pi by 2 and then divide by 4. So this is the ck value you are getting, 1 minus 2j e to the power minus j k pi by 2 plus 3 e to the power minus j 3k pi by 2 divided by 4. So you don't need to solve it. This is the answer of ck you are getting. This is the answer of ck you are getting. Is that clear to you? This is your ck. 1 minus 2j e to the power minus j omega 3 plus e to the power minus g 3 omega omega k pi by 2 divided by 4. Okay, fine. Now this is actually our dk. So dk is ck by 4. What I need to find? D of 37. So I will write down my dk here. What will be my dk? Dk will be 1 minus 2j e to the power minus j k pi by 2 plus 3 e to the power minus j 3k pi by 2 divided by 4. Here the period here was 4. Here there was a period of 4. So what will be the period here? 16. So what will be the period of this one? That will also be 16. But you will say that, sir, minimum period is still 4. Yeah, it is correct. Minimum period will be still 4. But period will surely be 16 as well, no? If I am saying that something is periodic with 4, something is periodic with 4, then surely it is periodic with 8 as well, surely it is periodic with 12 as well, and surely it is periodic with 16 as well. What is the beauty of this decay? That looking at the x of n by 4, I know that surely it should be periodic with 16, but minimum period is still 4. So if you want to use this information, you can use it. Otherwise, without using this information also we can solve it, that it will be periodic with 16 for sure. Periodic with 16 for sure. 16 for sure. For sure I am not writing periodic with 16, but minimum period is still 4. Minimum period is still 4. Even if you forget this information, then also it is fine. Minimum period is still 4. The only information you need to remember is that it would be dk would be equals to ck by 4. Okay. So dk is coming out to be, sorry, not dk. What you need to find? D of 37. So can this be equals to 32 plus 5? And would that be equals to d of 5? Look, what you need to find? D of 37. And you know that it is periodic with 16. So what you will find? 37 mod 16. So divide 37 by 16. What you will be getting? 5. So it would be equals to d of 5. So you put 5 there. What you are getting? 1 minus 2j e to the power minus j 5 pi by 2 plus 3 minus j 15 pi by 2. And one error I did here. dk was actually equals to ck by 4. So it would be equals to divided by 16. So what is the answer you are getting? 2 pi minus pi by 2, it would be minus j. So 1 minus 2j 5 pi by 2. 5 pi by 2, 2.5 minus j e to the power minus j 5 pi by 2. What you can write it down? E to the power minus j 2 pi plus pi by 2, right? So e to the power minus j 2 pi is 1. So this would be equals to minus j, right? And 15. So what you will get? E to the power minus j. अरे यार टेबल बहुत आवाज करती है ये. 7 pi plus pi by 2. So minus 3 e to the power minus j pi by 2. So this would be equals to 3j. So this is coming out to be 3j. What is 15 pi by 2? 15 pi by 2 e to the power minus 15 pi by 2. So 7 cycles you covered in the anti-clockwise direction. Not 7 cycles. 14, yeah. E to the power minus j 7 pi. That means you covered e to the power minus j pi only. Basically what I am doing here, did you understand this point? This was e to the power 7 pi plus pi by 2, right? So e to the power minus j 7 pi, e to the power minus j pi by 2. This will throw minus 1, right? Because this is the multiple of pi, odd multiple of pi. So this will throw minus 1 and this will throw minus j. So what you are getting? Plus 3j. So plus 3j divided by 16. So here what I am getting? J will throw minus 1, 1 plus 2 minus 1, minus 1 plus 3j divided by 16. This is the answer. Okay. 1 plus 2j into j, 1 minus j, minus 1 plus 3j divided by 16. Okay. Yeah. Minus 1 plus 3j divided by 16. This is the answer. This is the answer of D of 37. So all these properties and everything, if you know all these properties, then this is how you will be solving in the examination. Let's just say I don't know anything in the examination. I don't know any property, I know nothing. Still, I will be able to solve this question. Still, I would be able to solve this question. What I would do, x of n by 4, I will call this as y of n. What would be my y of n? That I can write down, that is your x of n by 2. Sorry, x of n by 4. Right? What I need to find? I need to find d of k. So what would be my d of k? What is the period here? 16. Period here is 16. So what would be the answer? 1 by 16 summation n goes from 0 to 15 y of n e to the power minus j omega naught e to the power minus j k omega naught n. What is the value of omega naught? Since period n naught is 16, so value of omega naught will be pi by 8, right? So here I will put pi by 8 only. N naught goes from 0 to 15 y of n e to the power minus j. Very basic, with the very basic, right? With the very basic we are solving it. One thing I am gonna tell now, that whenever you struggle in case of signal system, in the examination, whenever you struggle, always go to the first formula. Okay, you remember this line, always remember my line. In signal system, whenever I will struggle, I will always go to the first formula that I studied. That means I started with x of omega, x of t, c of n, x of t, x of s, x of n, z, x of n, x of z, x of n, x e to the power j omega, x of n, ck, and then I am gonna study x of n, x of k. So always whatever the first formula that you have studied, you will go there if you are struggling with signal system, any question in signal system. Is that clear to you? So I know nothing, I don't know any property, just the point is they are asking me d of 37. So I am on my way to find d of 37. This is my target now. So till this point I have seen, till this point I have done the work. Till this point I have done the work. What I need to find, this is my d of k. I need to find d of 37, which I know that would be equals to d of 5, because it is periodic with 16. This will also be periodic with 16 only. Periodic with 16 only. It would be equals to d of 5. So in place of k, I can put 5. Summation n goes from 0 to 15 y of n e to the power. In place of k, I can put 5. So 5 pi by 8 n. Okay. Now what was your x of n? X of n was 1 minus 2j 0 3. It was 1 minus 2j 0 3. This was your n equals to 0. This was your n equals to 1. This was your n equals to 2. And this was your n equals to 3. Just let me know one thing. If I find x of n by 4, what will happen? These will be expanded, no? 1. X of n by 4 is there. If you find x of n by 2, that means 1 0 you put. If you put x of n by 3, that means you put 2 zeros. If you find x of n by 4, that means you will put 3 zeros. So 3 zeros. And then minus 2j. So basically what you get to know that this is actually becoming n equals to 1. For y of 1, for y of n, this is n equals to 0. So really sorry. This is n equals to 0. And what this is becoming? 1, 2, 3, 4. This is becoming n equals to 4. So this guy would become n equals to 4 in y of n. This guy would become n equals to 8. And this guy would become n equals to 12. And rest all the things would be equals to 0 only. What I mean to say is that the next 0, 0 would come. 3 times 0 would come, and then this again 0 would come, then again 3 times 0 would come, then this 3 would come, and then again 3 times 0 would come, and then things will be repeated. So this was your n equals to 4, 5, 6, 7, 8. This would be your n equals to 8. 9, 10, 11, 12. This would be your n equals to 12. Why I am doing so? Because I need to put the value of n now. What I need to do? I need to put the values of n. So this is the process I am following. N equals to 0, n equals to 4, n equals to 8, n equals to 12. Because I know that rest of the values will be 0, so I don't need to care about that. So what I am getting? D of 5 is equals to 1 by 16 summation. I need to solve this summation now. So I will put n equals to 0. What I will be getting? Y of 0 plus e to the power something 0, that would be 0 only. Then will I put n equals to 1? Even if I put n equals to 1, I know that y of 1 is 0. So I don't care about that. I will directly go to n equals to 4. Y of 4 e to the power minus j 5 pi by 2. Y of 4 e to the power minus j 5 pi by 2 plus. Will I go to n equals to 8? No, I will directly go to n equals to 12. So what I am getting? Y of 12 e to the power minus j. Here I will put 12. So 5 pi by 8 into 12. So 15 pi by 2. And just let me know you have got the same thing. In the previous answer as well, you have got the same thing. This is your equals to d of 5, that is equals to d of 37. Y of 0. What is the value of y of 0? Y of 0 is equals to x of 0, that is 1, plus what is the value of y of 4? That is equals to minus 2j e to the power minus j 5 pi by 2. What is the value of y of 12? Y of 12 is 3 e to the power minus j 15 pi by 2. There you go. Did you get the same thing? 1 by 16, 1 minus 2j e to the power minus j 5 pi by 2 plus 3 e to the power minus j minus 15 by 2. You get the same thing here. Here also I am getting the same thing. So if I don't know anything, what I will do is that I will say to myself that I have studied from PrepFusion. I can solve any questions from the basics as well. Even if I don't know anything, even if I don't know anything, my teacher has taught me in a manner that you can solve any question with the right basics as well. So believe me guys, like this question will not even be solved by the educators as well. Forget about the student. Even educators will struggle here. But the point is, you know the techniques as well, you know everything, you know these kind of things as well, that x of n by n naught is happening, then ck divided by 3, minimum period is n naught only, but surely it will be periodic with alpha n naught as well. And you will get these answer, you will get this answer. So this method is also there for you. Right? Here what you did, first you find out the value of ck, from ck you went to dk, and then you find out this value. Here ck, dk, nothing. Here simple thing, y of n I know, surely I know. Y of n I know, right? If I know y of n, do I know its period? Yes. Can you write down its decay? You wrote down the basic formula. What they asked? D of 37, D of 5, there you go. This is the answer. This is the answer. And which will come out to be equals to minus 1 plus 3j divided by 16. So is that clear to you? So this is just an example to prove that whenever you struggle in the examination, always remember that basics are still there. With the help of basics, you can solve any question. Okay. So this thing I'm gonna do with the DFT as well. In the DFT as well, first we will learn some techniques, that this thing is there, that property is there, this property is there. But 90% of the gate question I will solve with only one formula, and that formula is x of k. So by the formula only I will solve all the question in DFT. Okay, we are going to solve all the gate QIQs by using the formula only. No technique, nothing. So techniques may fail, but these basic formula is never going to fail in the examination. Is that clear to you? Is my point clear to you? Okay. But what did we learn now? What did we study? That if I am expanding my x of n, then in case of continuous time, I was getting c of n only. But what was the thing here? Here the time period was t naught. Arey yaar, here what I am writing down. Really sorry guys. Yeah, fine. Sorry. Yeah, it is fine. Nothing here. So here time period was t naught. So here what would be the time period? Here the time period would be t naught by alpha. Here alpha is downward, here alpha is upward. So time period would be t naught by alpha. Right? And this is aperiodic only. Aperiodic. And this is also aperiodic only. Here the time period x of t was having a time period of t naught, x of alpha t will have a time period of t naught by alpha, but c of n was not changing. In case of continuous time, do you remember sin t and sin 2t? What was the c1 value for sin t? That was also 1 by 2j, and c of minus 1 was minus 1 by 2j. And what was the value of c of 1 for sin 2t? That was also 1 by 2j and minus 1 by 2j. So c of n value was not changing, but here the scenes are different. Here if you do x of n by alpha, it is coming out to be c of k divided by alpha. Is that clear to you? So it is being divided with half. It is being divided with alpha, right? Period will be alpha n naught, but minimum period will still be n naught. Just the thing is that the same thing would be there, the same ck whatever that you get here, the same ck would be there, right? So you have find out the value of d of 37. What you need to find out, you need to find out dk at 15 pi radian, 15 pi radian per second frequency, 15 pi radian per second frequency. What will be the exponential Fourier series coefficient? So x of n by 4 is having a omega naught value of pi by 2. So 15 pi is equals to k pi by 2. 15 pi is equals to k pi by 2. That means from here value of k is coming out to be 30. So what they are asking? They are actually asking the value of d of 30. Is that clear to you? They are actually asking you the value of d of 30. Is that clear to you? Did you understand what I am saying? You need to find exponential Fourier series coefficient of x of n by 4. That means you need to find dk at this particular frequency. Dk at this particular frequency. What do you mean? Let me add a page. What you need to find? Dk at 15 pi radian per second frequency. 15 pi radian per second frequency. So y of n is associated with dk. And what is the period of y of n? Y of n is actually x of n by 4 with the period of, so x of n was having a period of 4. So here the period will be 16. Omega naught will be 2 pi by 16, that means pi by 8. Okay, really sorry guys. Really sorry. Here, really sorry guys. X of n by 4 is having a period of 16, no? X of n was having a period of 4. So x of n by 4 is having a period of 16. So it is having a period of 16. So omega naught value is 2 pi by 16, right? So it would be equals to pi by 8. So this would be equals to k pi by 8. What they are asking, 120. So they are asking d 120 value. So from here k value is coming out to be 120. So omega naught value is 15 pi by 8. But they are asking dk at 15 pi radian per second. That means if I draw the graph of dk versus k, dk versus k, so this will be k equals to 0, k equals to 1, k equals to 2. In terms of frequency, what it is? Omega naught. In terms of frequency, what it is? 2 omega naught. So at k, in terms of frequency, what it would be? K omega naught. So k omega naught should be equals to 15 pi. That means k pi by 8 should be equals to 15 pi. So k is coming out to be 120. So this is 120th component. That means you need to find d of 120 value. What you need to find? You need to find the value of d of 120. This is what you need to find. So what you will do? 120 mod 16. That would be 7, right? That would be equals to 8. Okay, 120 mod 16, that would be equals to 8. So you need to find d of 8, and that would be equals to c of 8 divided by 4. That would be equals to c of 8 divided by 4. So what you are getting? D of 8 is equals to c of 8 divided by 4. Right? Is that clear to you? Okay. Now your C8 is periodic with 4. Your CK is periodic with 4, no? Your CK is periodic with 4. This CK is periodic with 4. So this C of 8 is actually equals to C of 0. Are you able to understand what I am saying? Or you are not able to understand? Simply you can find y of d of 8 as well. What I am saying, you find out d of 8. You already know the value of dk. You already know the value of dk. This value of dk is there. You just put the value in place of what you need to do. This is the value of dk. You need to find at 120. So at k equals to 8 I need to put. K equals to 8 I need to put. K equals to 8 I need to put. So 1 minus, this would become e to the power minus j4 pi, which is equals to 1 only. So 1 minus 2j. What this will become? 12 pi. That would also be same, divided by 16. Right? So what I am getting? 4 minus 2j divided by 16. Or you can say 2 minus j divided by 8. This is the answer. This is the answer that we are getting. So is that clear to you? Is the process clear to you? Like, I know a lot of things are there, but I hope you are understanding the point. We started with here that if x of n is there having a exponential Fourier series coefficient of ck, then x of n by n naught will have a exponential Fourier series coefficient of ck by n naught. X of n by n naught or x of n by alpha will be having a period of alpha n naught. So similarly, this will also have a period of alpha n naught only, right? But only the point is minimum period will also be n naught. So dk you can write down very easily. If you know the value of ck, then you can write down dk very easily. X of n by 4 would be simply divided by ck divided by 4. So if they are asking me the value of d of 37, what I can do is that I can find out c of 37 divided by 4. Right? So c of 37 divided by 4, that also I can find out. Or what I can do is that first I can find out the value of ck, from there I can get the value of dk, and then I divide by 4. And dk is periodic with 16, minimum period is 4. So some people would be having a doubt that, sir, will it be equals to d of 1? Yes, it will be equals to d of 1 only. D of 5 will be equals to d of 1. Yes, surely it will be d of 1. Because what did I tell you? That dk is having a period of 16, but minimum period is still 4. So d of 1 would be equals to d of 1 plus 4. That would be equals to d of 5. So if they are asking d of 1, then it would come out to be the same only. This would be equals to d of 1 only. D of 1 would be equals to d of 5, would be equals to d of 9. For sure. The period is expected to be 16, which is there, but actual the minimum period is 4 only. Is that clear to you? Okay. Right? And then we saw this question that you need to find at 15 pi by radian per second frequency. That means the value of k is coming out to be 120, which I don't need to write down here. Let's not write down here because we have solved it later on. So this was your B. 15 pi by radian per second frequency, that means x of n by 4, which was having a period of 16, omega naught value was pi by 8. From there, k value came out to be 120, and then we find out the value. So this was equals to d of 8. So d of 8 will actually be equals to d of 0 as well. So even if you find out d of 0, you will get the same answer. Even if you had to find out d of 0, you would have got the same answer. So d of 8 would be equals to d of 0 as well. There is no doubt about that. Is that clear to you? Okay. Both will be equals. Both will be equal. Or second thing you could have done is that you can solve everything with the basics as well. Forget about property or anything. Just apply the basics that you know and you will be able to solve. Simply the basics. Now you answer me this question. I am asking you this question, that if x of n is having a period of n naught, ck will have a period of n naught only. This is the exponential Fourier series coefficient. What will be the Fourier series coefficient of x of n divided by 3? Simply it will be also divided by 3 only. And what will be the exponential Fourier series coefficient of x of n by 3? That will also be equal to ck by 3. So what is the difference between these two guys? Are both of them same? If I call this as gk and if I call this as dk, so you write down the definition of gk and dk. I am calling this as gn and I am calling this as y of n. Okay. So you write down the formula of dk and gk. Did you understand what I am saying? X of n is having an exponential Fourier series coefficient of ck. So x of n by 3, linearity property. Basically, x of n by 3 will have an exponential Fourier series coefficient of ck by 3. Whatever the constant value I multiply here, the same constant value will be multiplied here. And next property we have already seen, that x of n by 3 will be equals to ck by 3. Let's write down it properly. It would be equals to ck by 3. So what is the difference between these two guys? Are both of them same? X of n by 3 and x of n by 3 both are same? No, they are not same. Here period is n naught. Here what will be the period? Let's call period as 4. So here what will be the period? Period will be 3 n naught. So that would be 12. What you will say, sir, here what will be the period? Period will be n naught, that would be 4. Here what will be the period? Sir, you will say, sir, period will be 12. 4 into 3, 12. But you know that deep inside you know that the minimum period is 4 only. What I am saying here, deep inside you know one thing, that the minimum period will be 4 only. The period was expected to be 12, but here the minimum period actually is 4 only. So what I am saying is that these two are having the same exponential Fourier series coefficient. Actually they are having the same Fourier series coefficient. Actually they are having same exponential Fourier series coefficient, but two different x of n, two different gn and yn, both are giving the same exponential Fourier series coefficient. How is this possible? Basically, if I write down the formula of gk, what I will write down? The summation, something will come here, then g of n, here I will divide by the time period as well, 1 by n naught. What is the value of n naught? Here n naught value is 4. G of k e to the power, अरे यार क्या कर रहा हूँ, g of n e to the power minus j k omega naught. What will be the value of omega naught? That would be 2 pi by 4 n, and the value of n will go from 0 to 3. So this will be the definition of this dk. What will be the definition of this dk? What will be the definition of this dk? The definition of this dk would be 1 by 16. N goes from 0 to 15. Y of n e to the power minus j k 2 pi by n naught, which will be 12 n. Do you remember this thing? Here we wrote down the definition, no? So I know that minimum period will be 4. Here also I know that dk will have a minimum period of 4. But did I put 4 here? For finding out the value of omega naught, did I put 4 here? No, I put 16. Because I know that x of n by 4 is having a period of 16. So whatever the period of x of n by 4 or y of n is there, that period I will put here. Is that clear to you? Right? So both will give you the same result. This will also throw ck by 3, and this will also throw, let's write down properly, ck divided by 3, and this will also throw ck by 3 only. But both are having complete different definition. The definition is different. Is that clear to you? Very, very deep points we are discussing. Okay guys, like if you follow some crash course or anything, these points will not be there, but I'm pretty sure one good question is coming from these points only in the examination. So x of n is having ck, x of n by 3 is also having ck by 3, and x of n by 3 also having ck by 3 only. But definitions are different. Is that clear to you or not? Did you understand this point? Right? So in place of g of n, what I can put? X of n by 3. X of n by 3 I can put. And in this place of, here I can put x of n by 3. Both will give you the same final answer, but the thing is definitions are different. So in the examination, if g of k is defined and d of k is defined, and they ask you what is the relation between g of k and d of k, will you be able to tell? Yes, surely you will be able to tell, because you would see that, okay, x of n by 3, x of n is having a period of 4, okay, so basically they are calculating the exponential Fourier series coefficient of x of n by 3, and then here you will get to know that, okay, x of n is having a period of 4, that means x of n by 3 will have a period of 12. Arey bhai, sorry guys, it will have a period of 12. It will have a period of 12 that I have written here. So okay, it will have a period of 12. That means they are actually calculating the exponential Fourier series coefficient of x of n by 3, which will also be ck by 3. So both are equals. Is that clear to you? Well and good. Let's understand the duality property. So now there is a duality property. Okay. So we will understand this example. So if there is some x of n, and it is having a exponential Fourier series coefficient of ck. Now if this ck comes here, if this ck becomes my time domain signal, what I am saying, if this ck becomes my time domain signal, then what will be my exponential Fourier series coefficient? That would be 1 by n x of minus n. Okay, so my exponential Fourier series coefficient would be 1 by n x of minus n. This is the exponential Fourier series coefficient. Let's just say for ck I am saying that exponential Fourier series coefficient is dk, so that would become 1 by n x of minus n. Is that clear to you what I am saying? Basically 1 2 3 4 1 2 3 4 was having an exponential Fourier series coefficient of this, which you don't need to find that from where this came. You just need to tell that okay, this is the answer. You don't know how this came. When you do the calculation, this is the exponential Fourier series coefficient we were getting. Now if this comes here, that means if this becomes your time domain signal, if this becomes your discrete time signal, then what will be the exponential Fourier series coefficient? This will be multiplied with 1 by n, and you will get, and you just need to invert it. What you need to do, you need to take the mirror image. So center 1 will remain the same. Now this 4 will come here, 4 will come here, 2 will go there. So I should have written the other path as well. Basically what I need to do, I need to take the mirror image. I need to take the mirror image. So 1 remains here, 2 goes here, 3 goes here, and 4 goes here. So 4, 3, 2, 1. Then again this 4 would have come here, 4, next 3 would have come here, 3, then 2 would have come, and then 1, and so on. And 1 by 4 also will be divided. So this will be the exponential Fourier series coefficient. So till now, what kind of duality properties we have seen? Don't get confused, okay? One more duality property we will see in DFT, and then I will write down all the 4 duality property that we have seen. So first started with x of t was having x of omega. Now this x of omega becomes the time domain signal. Then what really happens? This also comes here, 2 pi x of minus omega. This was the first one that we saw. And then what we saw, if x of t is having a Fourier series coefficient of c of n. Now this c of n becomes your time domain signal. Then what will be its frequency spectrum? Because x of t is having c of n. What is this? This is aperiodic. And if your discrete time signal is aperiodic, that means you can find its Fourier transform only. So what will be its Fourier transform? That would simply be x of minus omega. This will simply come, no multiplication, nothing. Do you remember the example of sine of t? Sine of t was having 1 by 2j minus 1 by 2j. Now 1 by 2j minus 1 by 2j comes here, then we were getting sine of minus omega. But the condition here was period should be equal to 2 pi. Only one condition was there, that period should be equal to 2 pi. So if you keep the example in your mind, if example is there in your mind, then it will be not tough to remember. Okay, this was the first one, and this was the second one. So it will not be tough to remember if you keep the example in your mind. So example should be there in your mind, right? What is the example? Sine of t. And here 1 by n is divided. Okay, you will study the same duality property in DFT as well. In DFT what will happen? X of n will be having a discrete Fourier transform of DFT. It will have a n point DFT of x of k. So what will happen? X of k will come here. This x of k will come here. So DFT is just the brother of Fourier transform only. What I am saying? DFT is brother of Fourier transform. So whatever the work 2 pi was doing, the same work in the DFT n will do. So this is the way to remember. If x of k is having x of n is having x of k, then x of k comes here, so it will become x of n into x of, here what was happening? T was replaced with minus omega. Basically there was an inversion, so here also there will be an inversion. I will write down x of minus n. Basically this signal will come here with an inversion, multiply with n. Similar thing is happening here as well. One thing did you notice? Everywhere there is an inversion. Everywhere there is an inversion. So inversion will happen. Only concern will be, sir, in DTFS this will be divided by n, and in CTFS this will be multiplied with, in DFT it will be multiplied with capital N. Multiply with capital N divided with n. So how will you remember it? You will remember that DFT is a friend of Fourier transform, and in Fourier transform you remember one duality property. X of t, x of omega comes here, it will become 2 pi x of minus omega. That means there 2 pi is being multiplied. So here also 2 pi will be multiplied. So in DTFS opposite thing will happen, it will be divided with n. So what my concern is that in 1 mark question they can directly ask you the statement that a discrete time signal is having a exponential Fourier series coefficient of Ck. Now Ck becomes your discrete time sequence, then what will be its exponential Fourier series coefficient? So that would be x of minus n divided by n. So in 1 mark question they can directly ask you these kind of questions. Is that clear to you? That's why we are writing down this duality property, but rarely, very rarely you are going to use it anyway. Is that clear to you? Okay. So a very good question we are going to see, and from that question we are going to make a conclusion. So is this process clear to you what I am saying? So will you be able to remember the duality property? I know it is a bit more pressure thing on your brain, but believe me guys, I have tried to reduce the pressure on your brain to my level best. DFT is a friend of Fourier transform. Because from Fourier transform only you will get the DFT, no? Because I told you e to the power j omega, and in case of omega, what do you put? N point DFT k. Do you remember? X of omega we got, x e to the power j omega we got, and then we sampled it. So DFT is nothing but the sampling in the frequency domain. Sampling in the frequency domain is equal to DFT. Right? So same thing we are doing. So we started with the Fourier transform only. So it is the friend of Fourier transform. In Fourier transform, what do we do? Inversion is surely there, just that it will be multiplied with 2 pi. So here it will be multiplied with n. So in DFT, if you are multiplying with n, so in DTFS, it will be divided by n. So very easily you will be able to remember. This kind of question I am expecting very soon in GATE examination. X of n is given. You need to find, I should not have written DTFS, exponential Fourier series coefficient. Okay, exponential Fourier series coefficient. These are actually the exponential Fourier series coefficient. No, x of n is having exponential Fourier series coefficient of Ck, then Ck is having exponential Fourier series coefficient of 1 by n x of minus n. So here I should have written exponential Fourier series coefficient, exponential Fourier series coefficient, exponential Fourier series coefficient, exponential Fourier series coefficient, exponential Fourier series coefficient of x of n is equal to c of k. You need to find these values. So let's see what they are saying. Let's assume that exponential Fourier series coefficient of x of n is dk. Okay, what I am saying, exponential Fourier series coefficient of x of n is dk. Is that clear too? So what I am saying is that exponential Fourier series coefficient of x of n is dk. Now one thing I know, that if this dk comes here and you find out its exponential Fourier series coefficient, then what do you get? Exponential Fourier series coefficient. How will you think? That surely inversion would be there, no doubt about it. Inversion would be there. Now multiply with n or divided by n. So you will think, okay, DFT is a friend of a Fourier transform. There multiply with 2 pi, so that will be multiplied with n. So here divided by n. And what is the period here? N means period. N means period here. Okay, this I forgot to tell. N means period. Just 1 second, guys. Just 1 second. Yeah. So what I was saying, that this capital N is period of x of n and period of c of k as well, because you know that both will be having the same period. So it is period of x of n as well and period of x of k as well. Both are having the same period, right? So 1 by n x of minus n. This would be the answer. So if someone asks you what is the exponential Fourier series coefficient of d of k, so that would be 1 by n x of minus n. So if you see, what is the first one? If I solve this bracket, what I am left with? Exponential Fourier series coefficient of x of n is dk. So what I am left with? Exponential Fourier series coefficient, exponential Fourier series coefficient, exponential Fourier series coefficient of x of n. So another exponential Fourier series coefficient is there. So exponential Fourier series coefficient of x of n is dk. So that I have solved, right? And this also I have solved. What is the exponential Fourier series coefficient of dk? That is 1 by n x of minus n. So what I am left with? Exponential Fourier series coefficient, exponential Fourier series coefficient, and what is the value of this thing? That is equals to 1 by n x of minus n. Now it is a constant value, no? 1 by n is a constant value, so 1 by n can get out. So 1 by n exponential Fourier series coefficient of exponential Fourier series coefficient of x of minus n. Now this I did not teach you, but you can guess it, right? If x of n is having c of k, or let's call it y of n. If y of n is having c of k, then y of minus n will have c of minus k. Right? This basic thing you can understand on your own. And what this y conjugate n will have. Although we will write it down, but the same thing is happening from CTFS. From continuous time Fourier series, the same thing is happening. The same thing happened with the continuous time Fourier transform as well. The same thing happened with the Laplace transform as well. Same thing with the jet transform, and same thing with the discrete time Fourier transform as well. So here also the same thing will happen. C conjugate minus k. Okay, so these also points you can note down. Y of n will have ck, y of minus n will have c of minus k, and y conjugate n will have c conjugate of minus k. Is that clear to you? Is that clear? Okay. So exponential Fourier series coefficient of x of minus n. What will be the exponential Fourier series coefficient of x of minus n? X of minus n will have d of minus k, because x of n was having dk, so x of minus n will have d of minus k. So if someone asks you what is the exponential Fourier series coefficient of x of minus n, that will give you d of minus k. So what will be the value of this one? That would be equal to d of minus k. So what I would do is that in the examination it will not take much time. Okay, here I am explaining, that's why you feel like that it is taking time, but not in the examination hour. So 1 by n, this was already there, exponential Fourier series coefficient of what we got, x of minus n. So I got to know that this particular value, exponential Fourier series coefficient of x of minus n, is equals to d of minus k. So what I am getting, 1 by n exponential Fourier series coefficient of d of minus k. This is what I am left with. I know that dk is having an exponential Fourier series coefficient of 1 by n x of minus n. dk is having an exponential Fourier series coefficient of 1 by n x of minus n. So d of minus k will have an exponential Fourier series coefficient of 1 by n x of plus n. Here n was replaced with minus n. N was replaced with minus n. So k was replaced with minus k. Here k is replaced with minus k. So n will be replaced with, so minus n will be replaced with plus n. So what will be the answer for this one? So what I am saying is that exponential Fourier series coefficient of d of minus k would be equals to 1 by n x of n. So the answer here will be 1 by n into 1 by n x of n. So what is the answer you will get? 1 by n square x of n. What is the answer? 1 by n square x of n. So what is the answer you are getting for this particular thing? So what is your ck equals to? Ck is coming out to be 1 by n square x of n. And do you know x of n? Surely I know. What is the value of n? Value of n is 4. And what is x of n? X of n is 3, 2, minus 2, 1. 3, 2, minus 2j, 1. And then same thing is being repeated here and there. This is your n equals to 0. So this 1 by 16 can go inside. Basically every particular factor will be divided by 16. Okay. So this is your n equals to k equals to 0. Since it is ck, no, so I can call it k equals to 0. So ck value I got. What they asked you to find? C11 C of 2. So C11 plus C of 2, and then they ask you to take the mode as well. Since I know that it is periodic with 4. Is it periodic with 16? Do you say that it is periodic with 16 because it is divided by 16? No, it is periodic with 4 only, no? We started with here. This was periodic with 4. Then you took again periodic with 4, periodic with 4. So periodicity is not changed. Periodic with 4 only. This will be periodic with 4 only. Periodic with 4. Periodicity is not changed, no? So you know that this would be equals to C of 3, right? What will be the value of 11 mod 4? That would be 3. And what will be the value of 2 mod 4? That will be equals to 2 only. So I don't need to write it down. So basically they have asked C of 3 plus C of 2 and then take the mode. What is the value of C of 3? That is 1 by 16 minus 2j by 16, and then you need to take the mode. 1 by 16 minus 2j by 16. So 1 by 16 can come outward, and mode of minus 2j and 1 would be 5. So answer would be under root 5 by 16. So I can write it down in a better manner. 1 by 16 is coming outward. Mode of 1 minus 2j is 4 plus 1 under root. So under root 5 by 16. This is the answer. So did you understand the process? Now a very good conclusion I can make. If I take 2 times exponential Fourier series coefficient, so what I was getting? 1 by n x of minus n. Okay, what I am saying is that from here I will make a good conclusion. What kind of conclusion I will make? That when I was calculating 2 times exponential Fourier series coefficient of x of n, I was getting 1 by n x of minus n. So basically one inversion I got. Then what I needed to do, I needed to calculate it for the 4 times. What I am saying, I needed to do it for the 4 times in the question. So what I could have done, exponential Fourier series coefficient x 1 by n x of minus n. What it will deliver you? Look, this particular function, what this particular function is doing, that it will multiply this x of n with 1 by n and then it will take the mirror image. So 1 by n is already there in our case. In our case, this is equals to 1 by n exponential Fourier series coefficient of x of minus n. So let's forget about this 1 by n because this is a constant value. Now what this particular function is doing? This particular function is multiplying your x of n with 1 by its period. And then it is taking the mirror image. X of n is changed to x of minus n. So x of minus n will change to x of n. So 1 by n square x of n. So now I can generalize it. Are you able to understand this point? If I had asked that you need to calculate exponential Fourier series coefficient 6 times, if this was the question, exponential Fourier series coefficient 1 time, 2 time, or what I am saying, there is a function called exponential Fourier series coefficient. This is the function. Okay, this is what I am defining as a function. There is a function called exponential Fourier series coefficient. So you need to find f of x of n. 1, 2, how many close bracket would be there? Here there was 4, so here also there will be 6. 1, 2, 3, 6. So you know that 2 times what it will give you? 1 by n x of minus n. Then 4 times what it will give you? Another 1 by n it will give you. So 1 by n square and then another inversion. So x of n will be changed to x of minus n will be changed to x of n. And then 6 times what it will do? If you are doing it for the 6 times, then what you will do? 1 by n cube x of minus n. So another 1 by n it will give you, another inversion it will give you. So what will be the answer? 1 by n cube x of minus n. Is that clear to you? And what if they ask you 5 times? What if they ask you 5 times? What you will do then? What if I am asking you, let's ask you for 3 times only. So for the 5 times you will be able to tell. What if I ask you this question? So you know that this will be your C of k. Basically 2 times you know that what it will do is that 1 by n and 1 by n x of minus n. 2 times it will happen. Or you don't need to remember all these things. X of n will give you ck. By this method also you can solve. We are just making some conclusion here. The 2 times it will give you, again x of minus n will come, again x of n will come, but inverted, and then it will be divided with its time period. So what you will be left with? You will be left with this particular thing. So 1 by n can come outward, and that would be equals to exponential. What is function f? Function f is exponential Fourier series coefficient of x of minus n. So what is the exponential Fourier series coefficient of x of minus n? That was c of minus k, right? It was equals to c of minus k. Basically, what will be your target? Your target would be to find the exponential Fourier series coefficient of x of minus n, and then this will be the answer. Is that clear to you? So 3 times also you will be able to solve. If I am saying that x of n is having an exponential Fourier series coefficient of ck, so x of minus n will have an exponential Fourier series coefficient of c of minus k. So let's just say in the examination x of n was given and they asked you this particular thing. So what you will do, your answer will be 1 by n c of minus k. Basically, you need to find the exponential Fourier series coefficient of this particular thing, and then you need to divide it by n. Also, you need to invert it as well. So just follow the process. If you follow the process, these kind of questions are very, very easy. Exponential Fourier series coefficient 4 times. So 1 time dk, then here 1 by n x of minus n, then 1 by n is going outward, c of minus k, exponential Fourier series d of minus k, here we were calling it dk. Here actually we were calling it dk. So here also I should write down dk only. I should not change it. We were calling it dk. dk means Dinesh Karthik. Yeah. So where we were? Yeah, here we were. So exponential Fourier series coefficient of dk was 1 by n x of minus n. Then exponential Fourier series coefficient of x of minus n was d of minus k, and then here I got 1 by n x of plus n. So this is the process you need to follow. Any question you will be able to solve. Okay, is that clear to you? So a very good concept which might be introduced very, very soon in the examination. Everyone will study it with respect to DFT, but with respect to DTFS as well, this concept can be asked. Is that clear to you? All good? All fine? Let's go to the next question, and from here we will make an interesting conclusion as well. So this will give you a very, very good conclusion, and this is a good question as well. So try doing it. If you are able to do it, then like you have done pretty good. You need to use your brain here. What we are doing, x of n is there. Its exponential Fourier series coefficient is ck, which is equals to 1432. How did it come? You don't need to worry. You know the process, you can get this value. X of n is given, ck is also given. It's an exponential Fourier series coefficient. Periodic with 4, this is also periodic with 4. Now dk is defined as c of k by 3. That means you are expanding with zeros. Now g of n is having an exponential Fourier series coefficient of dk. This dk is the exponential Fourier series coefficient of some signal g of n, and you need to find out the value of g of n at n equals to 2. So what would click to me if no property, nothing is clicking to me, and I need to find the value of g of n at a particular point? So what should be my strategy in the examination? What I would do? Sir, blindly, if I am stuck in any question, my way is always write down the formula. What I need to find? G of n. Find the formula. Write down the formula. What is the formula of g of n? If I am saying that g of n is having an exponential Fourier series coefficient of dk, g of n is having exponential Fourier series coefficient of dk. So sir, I will write down the formula now. That is equals to dk e to the power j k omega naught n, where k goes from 0 to some value, right? Now the point is, what will be the time period of gk? What will be the time period of gn? Here what is the time period? N naught equals to 4. Surely here also the time period will be 4 only. Now if your exponential Fourier series coefficient is having a time period of 12, so what will be the time period of this one? That will also be 12. Is that clear to you? Right? So 0 to 11. So what will be the time period here? 12. So what will be the value of omega naught? 2 pi by 12, that means pi by 6. So we are going near to our question. So g of n will be equals to k 0 to 11 pi by 6 n. Is that clear to you? Okay, all fine, all good. What I need to find? G of n at n equals to 2. My job is done. That's it. Sir, this calculation will be very large. You feel like that, sir, this calculation will be very large. Do you think? No, it will not be very large. We will solve it smartly. E to the power j k 2. What is the answer you are getting? dk. Okay. Now we need to put the values of dk, right? I will put k equals to 0. So d0 e to the power j0, d1 e to the power j, this thing, that thing, all these things will happen. But I know one thing, that this is my n equals to 0. This is my dk. What is my dk? Here I am having my dk. So let's copy this dk. Arey yaar. So this is my dk, which is having a period of 12, but it is non-zero only for k equals to 0. This was actually k equals to 0, because this is dk, no? So forget about ck by 3. This is your d of k. So d of k is non-zero for k equals to 0, k equals to 3, k equals to 5, and k equals to 3, 4, 5, 6, 6 and 9. 0, 3, 6, 9. So you can put these values here. So g of n at n equals to 2. I will put d of 0 e to the power j0. What that would be? D of 0 is 1, e to the power j0 will also be 1. So d of 3 e to the power j, put 3 here, what you will be getting? Pi plus, okay, d of 3 is 4, really sorry guys, d of 3 is 4. Then I will put d of 6 only, because d of 5 is 0, d of 6 is, d of 4 is 0, d of 5 is 0, then d of 6 would come. So d of 6 is 3 e to the power j 2 pi, then 7, 8, 9, 9 pi by 3, that would be equals to 3 pi. So 1 minus 4 plus 3 minus 2. What is the answer you are getting? Minus 2. So in the examination, I could have solved the question in this manner. Answer is minus 2. There you go. Very simple, very straightforward. Did not use any property, nothing like that. Did not use my brain at all. Do you really think that you can use the previous property that you have studied? In the previous property, what did we study? This was the scene, right? And here, this was x of n was being expanded. X of n was being expanded. Then answer was c of k divided by 3. But here what is happening? C of k by 3. That means c of k is being expanded. So x of n was there, c of k is there. Now if you expand c of k, what I am asking, x of n is there, c of k is there. If you expand this c of k, then what will happen here? This is what I am asking. Is that clear to you? Did you understand this point? Right? This is the question. Is that clear? What is the question? That x of n is here and it is having an exponential Fourier series coefficient of ck. So previously what we studied, that if this particular thing is happening, then answer would be ck divided by 3. ck divided by 3. But now what I am asking, this is your x of n which is having some ck. Now if this is what I am doing, then what will happen here? From where it would have come? From where it would have come? This is what I am asking. So you know one thing, that sir, if something in the left hand side is expanded, something in the left hand side is expanded, then I know the property. If something in the left hand side is expanded, then I know the property. But if something is expanded in the right hand side, then I don't know any property. So what my brain will say, that sir, you do one thing, you know that x of n will throw ck. Sir, you keep this ck here, you take this ck here, what it will throw? 1 by n x of minus n. Sir, period is 4, 4, period is 4, 4. So I am just writing down the period is equals to 4, period is equals to 4. period is equals to 4, and here also the period is equals to 4, and in place of n I will put 4 here. Now one more thing I know. What do I know? That if I do C of k by 3, n by n naught, what will happen here? This whatever the divided by 3 you have done, the same thing will be done here as well. N by 3, so this is 1 by 3 went here, so 1 by 4 was already there. Basically what happened here is that 1 by 3, this 1 by 4 also goes there, and x of minus n, rest all the things remain same. But did you notice one thing? Here what is the period? Period will be 12. Here the period will be also 12, but minimum period will be minimum period will be 4 only, right? If you expand here also the period you can say that 12, but minimum period will still be 4. Is that clear to you? But what do you want? You want this guy here. You want this guy here. This is your exponential Fourier series coefficient. Here this becomes the time sequence. If this is your time sequence, then this will be your answer. Do you agree to this point? If this is my time sequence, then this will be my answer. But actually what do you need? You need this guy here. Is that clear to you? What I am doing? You need this particular guy here. So what I will do? I will keep this guy here. So what I will be getting? 1 by 12. Again I am applying the duality. So 1 by 12 x of minus n. This guy is here, right? Now what will happen? This particular guy will come here, but it will be divided with, what is the duality property? Again I am writing duality property. X of n will throw ck. Now this ck comes here. This will throw 1 by n x of minus n. So now this particular guy is coming here, 1 by n x of minus n. What will happen here? This will go here, x of n will go this side, but multiply with the negative sign. This will go this side, multiply with the negative sign, divided with the time period. What will be the time period? 4 or 12? Time period of this guy, that is 12. What do you see now? This and this is getting cancelled. If x of n is having c of minus k by 3, x of minus n is having c of minus k by 3. So x of n will have c of k by 3. There you go. What does that mean? That means x of n will not even change. But the thing is, period, this is also having period of 12. This will also have a period of 12 only. But the same, ditto same x of n you will get. So what I actually asked you, g of n at x n over g of n at n equals to 2. So c of k by 3 is dk, which is having g of n. That means what is your g of n coming out to be? G of n is coming out to be x of n only. But this will be periodic with 12. But again you will know that minimum period shall still be 4. Minimum period of x of n is 4. And you are saying that g of n is equals to x of n. But g of n should have a period of 12. So what will happen? These will be repeated again and again. So what will be your g of n? Did you understand the point? What will be your actual g of n? Your actual g of n is coming out to be the same sequence. Whatever the sequence that you got, the same sequence it is coming out to be. Tan minus 2 plus 2j minus 2 minus 2 minus 2j. Tan minus 2 plus 2j minus 2 minus 2 minus 2j. But g of n should have a period of 12. Sir, you know that if it is having this kind of exponential Fourier series coefficient, that means exponential Fourier series coefficient is having a period of 12, then g of n will also have a period of 12. So it should have a period of 12. But minimum period will be 4 only. Basically, this will be repeated in this manner. So 12 samples are being repeated. Period is 12. N naught value is 12. But minimum period is 4. So what did I ask you? G of 2. This was n equals to 0. 0, 1, 2. What is the answer? Minus 2. So did you understand the conclusion that your x of n was having two things we have seen. X of n was having c of k. When I expanded my time domain signal, here nothing got happened. Nothing happened here. But there was a change. This was the change. And here what I did, here I was already having ck. But now what I am doing, c of k by 3 I am doing. So what was the change here? The same action you are getting. Now people will be having a doubt that, sir, how two same, this x of n is having ck, this x of n is also having ck. Sorry, this x of n is having ck and this x of n is also having c of k by 3. How, sir, this is possible? How the same x of n can get two different answers? So the answer of this particular question is that the period of this one is, this is computed over time period 4 and this is computed over time period, this is computed over time period n and this is computed over time period 3n. Because what will be the period of this one? That would be equals to n. And what will be the period of this one? That would be equals to 3n. So x of n both look similar, but definition of both of these guys are different. Is that clear to you? If I call this guy as g of n, if I call this guy as g of n, so what will be the definition of g of n? What will be the definition of x of n? You already know that would be different, and we are going to write it down as well. In the conclusion only we are going to write it down. Again we will see the conclusion, the same conclusion, we will write it down. And here what was the difference? Here the period was n. Here also the period was n. And period was 3n, but minimum period is n only. Minimum period, if they ask you, that is n only. Now here the period was n, ck by 3. So it feels like that, sir, here amplitude is divided by 3 only. So yes, the minimum period is n only. Minimum period is n only, but you saw the definition. Definition would be different. Minimum period is n only. But here what will be the period taken? That would be 3n. Definition would be different. So here what was the definition of gn? When you applied this definition, what did you take? The period equals to 11 you took. Are you able to understand this point? And here what will be the period? Period will be 3n only. So this is the complete conclusion. Complete conclusion of everything that we have studied. Again we are going to write down the same thing only, which we are going to write down here. So in DTFS this kind of conclusion is there. Same kind of property, ditto same kind of property we are going to study in DFT as well. But opposite thing will happen in DFT. In DFT what will happen? Here there will be no effect. In this particular property there was a effect, no, divided by 3. It was divided by 3, right? If you did x of n by 3, divided by 3. When you did c of k by 3, no effect. Nothing changed. So in DFT what will happen? If you do this process, x of n by 3, then nothing will happen here. It will be x of k. X of k only. But if you do x of k by 3, then what will happen? 1 by 3 x of n. So that property we will see in DFT, and then we will compare DFT and DTFS, and we will see our one good conclusion. So you will be able to remember the conclusion as well. And from these properties only 2 to 3 questions have been asked. Okay, but not in DTFS. In DTFS they have rarely asked any question. Since it's been roughly around 2 hours 15 minutes, so I can tell you that from DTFS till this point 3 to 4 questions have come. But you can see how interesting DTFS is. Like DTFS is very interesting, but it is taught on a very surface level. So what I expect is that it's been a very long time that they are making some good question from DTFS. So very soon some very good question is coming from DTFS, very soon. Okay, so yeah, that's why I thought that DTFS should be taught in a good manner, and that I'm going to do now. So depth of DTFS we have seen. So period n, period 3n, period 3n here, period n, period 3n, period 3n here. Right, all good, all fine. But it is computed, this is computed over period 3n, this is computed over n. Both look same, but both are different. Definition is different. Here also both look same, but definition is different. And they surely look different. They surely look different. Only these two guys look same, and these two guys also look same. but definition is different. Okay, so this conclusion we have wrote down already, so there is no need. This conclusion have been wrote down already. Okay, but the point would be that they will expect that definition from my side. So what I will do is that I will bring it back. What I am going to do, that x of n will be having ck. So c of k by 3, c of k by 3 will also come from x of n only. It will also come from x of n only, right? But the point is, let's just say this was having a period of 4. So what this will have? This will have a period of 12 actually. So if I want to find, let's call this as g of n. So what will be the value of first x of n? That would be period k goes from 0 to 3, c of k e to the power j k omega naught n. And what will be the value of omega naught here? Omega naught will be pi by 2. Omega naught will be pi by 2. And here what will be your g of n? Zero to 11, c of k by 3 e to the power j k, period is 12 now. So omega naught value will be 2 pi by 12, that is pi by 6. So point is, definition is different. Okay, nothing else. Is that clear to you? So what I want to say is that if these kind of question are coming, this one question we have seen, right? Another question also we have seen. This one question you should do on property only. Here you cannot apply the basic concept. Here if you apply the basic concept, a lot of mess up will happen. And here it was easy as well. This question was easy as well. This particular question which felt like, okay, something different is there. Just as you applied the basic formula, you got the answer. Here also, this particular question. Here also you felt like that, okay, something different is happening. But just as you applied the formula, you got the answer. So what I would say, in the examination, if any question is coming, trust on the basic formula, trust on the basic method. Once you feel like that, sir, I can apply the property, I am confident with the property, then go with the property. Otherwise, go with your basic approach. Whether the question is from DTFS or it is from DFT, go with the basic approach if it is possible for you. And basic approach will give you answer in a very easy manner. See the question, write down the definition, solve it. Okay. Otherwise, these properties and everything I am already teaching you. Okay, so here conclusion is written. So this is the, what is this? This is the duality property. Duality. So x of n is having c of k. Now this becomes my time domain signal. So what answer I will get? 1 by n. This will come here. Since I am representing in terms of k, here the axis is k, here the axis is n. So here if k is going here, then it becomes the axis of n. So if n comes here, this will become the axis of k. And surely inversion would also be there. So this was your duality property. Period was n and n only. So no need to worry about period. Here x of n was having a period of c of k. Now x of n by 3, what will happen? C of k by 3. Period will be 3n. It will be defined over a period of 3n. Here also period will be 3n. But here I know one thing, that my minimum period is n only. Okay. And here c of k by 3 is there, period n, period will be 3n. But here what will happen? Nothing will happen. So don't do the error of x of n by 3. Don't do this error. Okay. It will be x of n only. So period will be 3n. But you know that minimum period will be n. Is that conclusion clear to you? Okay. All good, all fine. So this video we can stop here. From the next video we will continue DTFS only, because it's been roughly around 2.5 hours. So let's stop it here. I tried to complete DTFS in one video, but it is not possible. DTFS will take 2 videos. So in the next video we will see this question. This particular question we will see completely based on the basic formula. what they are asking, dk will be non-zero for k equals to what? Okay, this question we will see, and then we will see multiplication and convolution properties. So some basic properties we are going to see, then some other properties which we already know. X of n is having ck, x of minus n, x of n plus n naught x e to the power j k omega naught n. So these properties we will see, and then we will see some questions, and Parseval's theorem we will see, and then predicting x of n with ck. So first I will predict the nature, and then I will predict the exact waveform. So with that, this particular lecture will be completed. So let's meet in the next lecture. I guess that would also go roughly around 1.5 hours. So with that, we will be able to complete our DTFS. Okay, yeah, thank you. Hi everyone, so welcome back. We are continuing our discussion on exponential Fourier series coefficient only. We are studying DTFS. So just continuing our discussion from the previous video. So this question you need to solve. X of n is given, and the exponential Fourier series coefficient defined for this x of n is this dk, and they are asking you dk will be non-zero for k equals to what? So you saw this dk, that means you know that e to the power j omega naught n plus e to the power minus j omega naught n divided by 2, that means d of 1 will be equals to 1 by 2, and d of minus 1 will be equals to 1 by 2. So value of k is equals to, sir, plus minus 1. This answer you will say, and that is absolutely wrong. Absolutely wrong. Why is that so? Because you did not see the definition of dk. You would have got this answer if the definition was, what is the omega naught value here? 2 pi by 3. So here if we had put omega naught value as 2 pi by 3, what will be the value of n naught? That would be 6. N naught should have been put at, sorry, n naught value will be 3, really sorry guys. 2 pi by omega naught, that would be 3. So n naught value should have been put as 3, but here it is 9. So definition of dk is different here. Are you getting this point? Definition of dk is different than what we study. So what we will do, we will solve it fundamentally. With the fundamental concept we are going to solve. Whenever you see sinusoid or cosinusoid, what did I tell you? That rather than writing down the formula of d of k, you will always write down the formula of x of n. Whenever you see sinusoid, cosinusoid, no matter, even if you are asked to find exponential Fourier series coefficient, or even if you are asked to find DFT as well, in both of the cases you will write down the formula of x of n rather than writing down the formula of d of k or x of k. So you will write down the formula of x of n. What does the formula say? Summation d of k e to the power j k omega naught n. What will be the value of omega naught here? Here omega naught is different. What will be omega naught here? 2 pi by 9. And here limit of k will go from 0 to what? It will go from 0 to 8. So this will be your x of n. Now from this definition what you can get? X of n is actually coming out to be e to the power j 2 pi by 3n. This is our actual x of n divided by 2 plus e to the power minus j 2 pi by 3n divided by 2. Right? What you need to do? You need to compare these exponential component with this particular thing. What I mean to say is that 2 pi by 3n is equals to k 2 pi by 9n. So this and this get cancelled. So k is equals to what you are getting? 3. Are you able to understand this point? K equals to 3 you are getting. And then 2 pi by minus 3n is equals to k 2 pi by 9n. So n get cancelled. K is equals to minus 3 you are getting. So k is equals to plus minus 3 you are getting. K equals to what you are getting? Plus minus 3. That means basically it is non-zero for k equals to plus minus 3. That means d of 3 is equals to 1 by 2, and that is equals to d of minus 3, and the value of k is plus minus 3. This is the answer. Are you able to understand this point? With the basic definition we saw, no? If you put k equals to 1 here, what I mean to say is that this was your x of n. Let's copy this to the next page. Let's copy this to the next page. And for limit I am taking from 0 to 8, right? So what I would do is that I would take the limit, instead of taking from 0 to 8, I would take the limit from minus 4 to 4. Can I do this? Yes, 9 samples. Between minus 4 to 4, there will be 9 samples. Between minus 1 to 1, how many samples are there? 3. Between -2 to 2, how many samples are there? 5. So similarly, between -4 to 4, how many samples would be there? 9. And you need to take 9 samples only because 0 to 8. So how will I open it up? I will open it up in this manner, that d of -4 e to the power minus j 4 8 pi by 9n plus d of -3 e to the power minus j 6 pi by 9n, then d of -2, d of -1. In that manner it will keep on going. What do I actually require? I actually require 2 pi by 3n. I actually require -2 pi by 3n. This is what I require. And then I got to know that what is this? This is actually 2 pi by 3n only. So if I put k equals to -3, what this is? 6 pi by 9, that is equals to 2 pi by 3n only. So when I put k equals to -3 and when I put k equals to +3, when I put k equals to +3, then I am getting my required condition. When I put k equals to +3 and rest all the components are 0. So if I say what is my dk coming out to be? So dk of -4, that is also 0. dk of -3, that was coming out to be 1 by 2. Then again 0, dk of -2 is 0. Then dk of -1 is 0, d of 0 is 0, 1, 2, and there you go. Total 9 samples are there, right? Total 9 samples are there. So this is my n equals to 0. N equals to 0, 1, 2, 3. This is your n equals to 3. And this is your n equals to 3 as well. Now if I say purely if cos 2 pi by 3n was there, if cos 2 pi by 3n was there, if cos 2 pi by 3n was there, and I would have defined what is the value of n naught here? What is the value of n naught? N naught value is, this is just the method 2. Your question has been solved. We are just seeing what all could be concluded from here. What all things could be concluded from here, that we are seeing now. Okay, so we are just understanding what all things we can understand from here. So considering n naught equals to 3, if I had find out what is my ck, what would have been the answer? 1 by 2, 0 and 1 by 2 with the period of 3. And this would have been your n equals to 0. This would have been your n equals to 1, and this would have been your n equals to, sorry, n equals to -1, this would have been your n equals to 1. This would have been your ck directly if you had find out considering n naught equals to 3. Say yes or no, right? But what if I do ck by 3? Ck by 3. So what will happen? Zeros will be included, right? Zeros will be included, right? Ck by 3 if I do, or what I need to do? Ck by 2 you need to do, not 3. Period is 3, but period is 9 here. Yeah, 3 only you need to do. So 2 zeros would be included. After that as well, there would be 2 0. Yeah. So basically two zeros would be included. 3 samples are there, so it would be 9 samples. So 1 by 2, then 2 zeros will be included, then another 0 is already there, then another 2 0 would be included, 1 by 2, and then another 2 0 will be included. In that manner, it will keep on going. So if after 1 by 2 there is 0, before that as well there would have been some 0. So basically what did you get to know? That whatever that was there at n equals to 0, whatever that was there at n equals to 0, that is there at n equals to 0 only. Whatever that was there at n equals to 1, that would be there. I should not say n equals to 1, really sorry guys, this would be k equals to. This is k equals to -1, this is k equals to +1. So whatever that was there at k equals to 0, that is there only. But whatever that was there at k equals to 1, that has been there at k equals to 3, and this has been there at k equals to -3. Isn't it your dk only? This is your dk only. So what will happen here? X of n, ck, c of k by 3, nothing will happen here. It will remain the same. It will remain the same. That means this x of n remains the same. But the only point is it will be computed over 3 into n naught. That means it will be computed over 9. Is it being computed over 9? Yes. So in the examination, I am not going to solve with this method, because this much brain will not work in the examination hall. Here it is working because we just now studied the property. So that's why it is working. The same question have been asked in case of DFT. Ditto same question have been asked. This much brain will not work in the examination. What will work? Basics will work in the examination. Always I am telling you, no matter how many properties you study, if you are preparing in 1 year, basics will work. So always I focus on basics. Basics are clear, you will be able to solve the problem in this manner. But the question paper setter would have thought of this thing. He would have thought the problem in this manner, and then he made this particular question. This is a shortcut method only. If I had been a student who is like, it's been roughly around 4 to 5 years since I am working in this gate field, so I would have seen it 2 pi by 3, 2 pi by 9, because like it's been longer time. If I had been a student in 2022, in 2021, then I would not be able to understand, right? So it would take time to understand these kind of things. It would take time. So better part is you do by basics in the examination. Okay, and if it clicks to you that okay, C of k by 3 they have done, that means x of n will not change. Just the thing will happen is that it will be computed over 9. It will be computed over 9. That means 3 times what they have done, they have expanded the C of k 3 times. So previously my C1 and C of minus 1 are non-zero. So they have expanded it 3 times. Now D3 and D of minus 3 will be non-zero. That means k is equals to plus minus 3. What I will see here is that here the time period is 3, but here the time period is 9. That means they are computing the same x of n at 3 times of time period. That means your C of k will be expanded by 3. So C1 and C of minus 1 are non-zero. So D3 and D of minus 3 will be non-zero. If this clicks to you, just by looking at the question, you will be able to tell the answer that it would be plus minus 3. Otherwise, go by the basics. Very easily performing the basics as well, you will be able to tell the answer. Is that clear to you or not? Okay. So did you understand the actual meaning behind these properties? These properties. So these properties are not that straightforward. What was the scenario? That x of n, C of k. Now if you expand your time domain signal, then what will happen? Nothing will happen with ck, just the amplitude will be divided by 1 by 3. But the definition of this particular thing will change. What would be the definition that we have previously written? That it will be computed over 3n time period. Similarly here, in place of k, if you put k by 3, that means if you are expanding your exponential Fourier series coefficient, then nothing will happen to x of n, but its definition will change. It will be computed over 3n. Still being the minimum period as n only, but it will be computed over 3n. Is that clear to you or not? So if dk is being computed over 3n, that means this is actually being expanded. dk has been expanded. So previously our C of 1 and C of minus 1 was non-zero, but now our D of 3 and D of minus 3 are non-zero. Is that clear to you? The depth of the question is clear to you. Let's go to the next one. Let's see the multiplication and convolution property. Very rarely we are going to use it. So multiplication in time domain, convolution in the frequency domain, but it will be a circular convolution. Okay, and here it will be multiplied with n naught. Convolution, circular convolution in time domain will be equals to multiplication in frequency domain, right? Why we are doing the circular convolution here? Because this is periodic, no? Periodic. This is periodic, and this is also periodic. So this is your periodic with n1. This is also periodic with n1. This is also periodic with n2. So xn dot h of n will give you periodic convolution of ck and dk. But how much point convolution you are going to do? Basically, when I defined the circular convolution, we used to define n point circular convolution, right? We used to say n point circular convolution. Circular convolution. This is how we used to define, right? N point circular convolution between x of n and h of n, or similarly I can define n point circular convolution between C of k and T of k. So what will be the value of that n? That will be LCM of n1 and n2. Okay, LCM of n1 and n2. You are rarely going to use these properties. Okay, very rarely. And even if in the examination, if the property is coming, then surely period would be same. Even if it is not same, what you need to do? Take the LCM. Okay, LCM of n1 and n2. And here also, what will be the, here you are going to define n point circular convolution. This is also n point circular convolution. What I would say, period is equals to n. So this I am saying that this is your n point circular convolution. So circular convolution is defined with respect to some certain points. So this is your n point circular convolution. N point circular convolution, value of n is LCM of n1 and n2. So I am writing down that this is your n. Is that clear to you? And here also the same thing you are going to do. What you will do is that you will calculate x of n convolution with h of n, but that convolution you are doing n point circular convolution. Again I am telling you bro, very rarely you are going to use this property. Okay, till this point there has been not any question on these properties, and even in the future as well there would be rarely any question. And what is the meaning of this n naught? This n naught is actually the LCM of n1 and n2. Okay, people here always get confusion that sir here n naught should come or here n naught should come, right? Like which one will be multiplied with n naught? So in case of Fourier transform, what we have studied, multiplication in time domain is equals to convolution. So there I told you whenever convolution come, divide by 2 pi, right? And here if there was convolution, then multiplication was, then simply there was multiplication x1 omega dot x2 omega. Do you remember this property in case of Fourier transform? So in case of Fourier series is completely opposite of Fourier transform. This is what you remember. Okay, this is how you need to remember it. So in case here it was being multiplied, here what was happening, when there was a convolution then something was coming, and here when there is multiplication then something would come. That's it. If there is multiplication then something would come, here there was convolution then something was coming. This is how you need to remember. What will happen in case of DFT? What do you think? In case of DFT, what will happen? I told you DFT is a friend of Fourier transform. So in case of DFT, what will happen? x1k convolution, circular convolution with x2k divided by n naught. This will happen in DFT. Circular convolution divided by n naught, because in DFT is a friend of Fourier transform. So in Fourier transform, whenever there is convolution, we divide by 2 pi. So here also whenever there is convolution, we will divide by n naught. And here multiply with n naught, but in case of multiplication. So everything different happens in case of Fourier series. Do you remember the properties of continuous time Fourier series? There also the same thing was happening. But I am telling you, very rarely any question would come from discrete time Fourier series. But those properties that we have seen in the previous video, those properties which we have seen, those are very important. Okay, from there I guess question is surely coming. In near future, from those properties, surely the question is coming. This is what I feel. Now these properties x of n, x of minus n will have c of minus k, x conjugate n will have c conjugate minus k, right? Similar whatever that was happening in continuous time Fourier series, continuous time Fourier transform, Laplace transform, jet transform, discrete time Fourier transform, the same properties are there. Here what will happen? E to the power j k omega naught n naught ck, right? E to the power j k omega naught n naught ck. And what will happen here? C of k minus k naught. Basically this should be a function of n. Yeah, it is a function of n. And this should be a function of k. Yes, it is a function of k. Here it is a function of n. Yes. Here it is a function of n. Yes. It should be a function of k. Yes. Is it a function of n? Sorry, is it a function of k? Yes. So this is how you need to remember. And omega naught is constant. Everywhere omega naught would be there. Omega naught will fix its place everywhere. Okay. So ditto same properties were there everywhere, and those same property we are going to see. We have seen same properties. Okay. So these same properties we have already seen. Let's solve a question. Although very rare chance that it would be asked, but still try solving it. So e to the power j 4 pi by 3n x of n plus 2. I always told you that always treat this one separately. So first what you will get started with, x of n is having c of k. So x of n plus 2 will have e to the power j, this should be a function of k. So e to the power j k omega naught n naught. N naught value is 2 ck, right? What is the value of omega naught? Omega naught is 2 pi by 3, because period is 3, so omega naught is 2 pi by 3. So what you are getting? 4 pi by 3 ck. This I am calling as gk. I am calling. So this is the Fourier transform of x of n plus, this is the Fourier series of x of n plus 2, which is your, I am calling this as g of n. Now what is happening? Your g of n is being multiplied with e to the power j 4 pi by 3n. E to the power j 4 pi by 3n is being multiplied with gn. So how you can write it down? E to the power j, omega naught I need, What do I need? Omega naught surely I need. So e to the power j k omega naught I already need, and e to the power j k omega naught n multiplied with gn multiplied with gn. Is that clear to you? Did you understand what is happening here? E to the power j k omega naught n. What was the property? E to the power j k, sorry, e to the power j k naught omega naught n. So e to the power j k naught omega naught n. Omega naught comes everywhere. Omega naught was coming here as well. Omega naught comes everywhere, right? So here 2 pi by 3 was there. So 2 k naught value is 2. Omega naught value is already there, g of n. So what will be the answer? Here the answer was gk. Answer would be g of k minus k naught, that is 2. G of k minus 2. Answer would be g of k minus 2, right? So answer is g of k minus 2. So finally this is your dk, right? Because this is what we wanted. So your dk is coming out to be g of k minus 2, and this is your gk. So e to the power j, in place of k you need to put k minus 2, 4 pi by 3 c of k minus 2. There you go. This is your dk that we are getting. Is that clear to you? This is the answer. Very simple process. Started with x of n, which is having ck, and these kind of questions we have solved a lot of time, so you should be comfortable with that. X of n plus 2 will have e to the power j k omega naught n naught c of k. So this is the answer you are getting. What is the value of omega naught? Omega naught is 2 pi by 3. So e to the power j k 4 pi by 3 c k gk. Now g of n is being multiplied with e to the power j k naught omega naught n. J k naught value is 2, omega naught value is 2 pi by 3 and g of n. So what will be the answer? G of k minus 2. Omega, if k naught is positive, so here k minus 2. So that is equals to dk. So dk is equals to g of k minus 2. So in place of k, what you need to put? K minus 2. We are moving it faster here because we have seen these kind of problems previously, right? Previously we have seen these kind of problems. That's why we move a bit faster here, right? Let's see the next one. This is a gate question actually. You need to find the value of a. So if you see this question, what will click to you in the examination? What will click to you? Sinusoid is there. Always sinusoid can be composed to exponentials, right? Sinusoids can be broken into exponential for sure. So what I would do, my a is equals to summation n goes from 0 to 4 x of n e to the power j minus e to the power divided by 2j. Is that clear to you? This is how I can break it down. Why I am breaking down like this? Why I am breaking down like this? Because one thing I know, if this is my x of n, can I define a of k from here? Yes. What will be my ak? Ak will be 1 by n naught. What is the value of n naught? If omega naught is 2 pi by 5, omega naught is 2 pi by 5. So my n naught value will be 5 only. N naught value will be equals to 5. So 1 by 5 summation n goes from 0 to 4 x of n e to the power minus j k omega naught n. This is how I can break it down. Is that clear to you? All good? All fine? So what do you think what this is equals to? So 5 of ak, you know, what will be your 5 of ak? This 5 can go here. N goes from 0 to 4 x of n e to the power minus j k to pi by 5. Let's take it to the next page. So basically my 5 of ak is equals to this particular thing. 5 of ak is equals to this particular thing. Now what do you think what is this? 1 by 2j I can take outside. So my a is equals to 1 by 2j I can take outside. right? 1 by 2j I am taking outside, 1 by 2j I am taking outside. 0 to 4 x of n e to the power j 4 pi by 5n. So value of k I need to put minus 2, right? So value of k I need to put minus 2. Is that clear to you? What did I do here? 1 by 2j, 1 by 2j was outside. X of n e to the power j 4 pi by 5n I needed. So from 0 to 4, x of n e to the power j minus k 2 pi by 5n I already know. So in place of k I need to put minus 2, then I will get this particular thing. If I put in place of k, if I get minus 2, then I will get this particular thing, right? Then here minus 1 by 2j. And here also you can see one thing, that in place of k, if you put plus 2, in place of k, if you put plus 2, then you will get this particular expression. So in case of k, you need to put plus 2. So that is equals to 1 by 2j. 5 of 5 is also can coming, 5 can also come common. So 5 by 2j. A of minus 2 minus a of 2. A of minus 2. A of minus 2. That is minus a of minus 2. A of minus 2. Where is a of minus 2? A of minus 2 is not there. But it is periodic with 5. Right? It is periodic with 5. You know that a of k plus minus 5 would be equals to ak. So if I put a of 3 minus 5, what that would be equals to? A of minus 2, and that would be equals to a of 3 only. So a of 3 minus 5 would be equals to a of minus 2 only. So what will be the value of a of minus 2? I hope you understood this particular thing. This is very simple. If you have the value of a of 3, then can you get the value of a of minus 2? Yes, because it is periodic with 5, no? So a of 3 minus 5. So minus 2j you are getting. Minus 2j you are getting. So a of minus 2 is minus 2j, and a of 2 is 2j only. So minus 2j and minus 2j. A of minus 2 is minus 2j, and then minus sign was there, and a2 is 2j only. So what you are getting? Minus 10. That's it. This is the answer. Okay. More things can we do? Can we do more things? What I can see is that from here I can see that this is coming out to be even, right? AK is coming out to be even. So x of n will also be even, and this particular part is odd. So I just want to see if there is another method or not. There might be some other method as well, because I can see that a naught is 1, a1 is 3j, 2j. So a of minus 1 would be equals to minus 3j. It is coming out to be odd. Sorry. It is coming out to be odd. This particular thing is coming out to be odd. A naught is coming out to, this AK is coming out to be odd. You can see that a of 1 is equals to minus of a of 4. What I want to say is that a of 1 is equals to minus of a of 4. And what would be a of 4 would be equals to? That would be equals to a of minus 1. So a1 is coming out to be minus of a1, and similarly a2 is coming out to be minus of a2, right? Sorry, minus of a of minus 2. So if it is odd, it is not odd, because a naught value is 1. If it was odd, then a naught could not be 1. No, a naught has to be 0. So it is not odd as well. You thought that it was odd. Can you say that a of k is odd? No, because a naught value is 1. Do you remember in case of discrete time, the value at or in case of continuous time as well, the value at n equals to 0, the value at t equals to 0 has to be 0, then only you will call it odd. In the basics of signal, we have seen this particular thing, that it has to be 0, the value has to be 0, because what is the condition? That a of k should be equals to a of minus k, minus sign. So a of 0 should be equals to a of minus 0. What is a of minus 0? That is 0 only. So if you do this, what you are getting? A of 0 should be equals to 0. Basically, a value, positive value should be equals to negative value. That is only possible when a of 0 is 0. So it is not even odd. So you cannot do anything. Is there any other possible method there? Something with even odd I want to do. Something with even odd, but I am neither getting it even nor I am getting it odd. So yeah, if it might be there, like some other method would be surely there. Okay, you can try it on your own. Okay, I think it might be there or it would not be there, but I think this would click. In the examination, it is not that tough, it would click. That I can convert it to sinusoid can be converted into complex exponential, and then I can compare with the basic formula. So comparison with the basic formula, I get the answer as -10. Parseval's theorem. So in case of continuous time, if xt and yt are periodic, they are periodic with t, not t naught, periodic with t. Periodic, both are periodic with time period t. Both periodic with time period t. So here what you would got? Here your C of this is having a Fourier series coefficient of exponential Fourier series coefficient of Cn, and this is having exponential Fourier series coefficient of Dn. So what we will get? Cn d of -n. When we were studying Parseval's theorem in continuous time Fourier series, I did not teach you this particular expression. I directly taught you this particular expression, that here you will get summation n goes from -infinity to infinity mod of Cn square. This is what I taught you. But here I am again teaching you. Did we study Parseval's theorem in case of Fourier series? Yes. Sorry, in case of Fourier transform. Yes, we studied it. What we used to do? -infinity to infinity. First one as it is, Fourier transform of the other one with inverted dot d omega. So here also we are going to do the same thing. C of n as it is, d of n inverted. Is that clear to you? Summation will go from where to where? C of n was periodic? No. So summation will go from -infinity to infinity. There you go. Can you find out the energy? For a periodic signal, what do you find out? Energy or power? Power. So what we will find out here? Power we will find out. Now in case of yt, I am putting x conjugate t. Can this be written as 1 by t minus t by 2 to t mod of x of t whole square dot dt? Yes, surely it can be written, and it is equals to power of xt, and that would be equals to what? Summation n goes from -infinity to infinity. Fourier transform of the first one, what that would be? C of 1. So not Fourier transform, yaar. Exponential Fourier series coefficient of first one, that would be C of n. What is the exponential Fourier series coefficient of this one? That is C conjugate minus n. But here what you need to do? You need to write down the exponential Fourier series coefficient, but mirrored. So what you are getting? There you go. So similar thing we saw in CTFS, right? Sorry, similar thing we saw in continuous time Fourier transform, similar thing we saw in discrete time Fourier transform as well, and now we have seen in case of continuous time Fourier series, and now we are going to see in case of discrete time Fourier series as well. So x of n dot y of n, both are periodic with n naught. Periodic with n. Both are periodic with n. So that's why you are doing from 0 to n minus 1 divided by 1 by n. So what this will represent, you would know what this will represent. This will represent the power. Basically, how will you solve it? 1 by n, summation n goes from 0 to n minus 1, x of n mod whole square. So this is given as power of xn. And what this would be equals to? That we will see. What do you think what this would be equals to? So what you need to do? Summation. If I am saying that this is having ck and this is having dk. So what this would be equals to? Ck d of minus k. But here it was periodic. Sorry, here it was aperiodic, so limit was from -infinity to infinity. But this is periodic, so limit will be from 0 to n minus 1. If they are periodic with n, so they will also be periodic with n only, no? Periodic with n. Right? So that's it. This is the answer. That's it. This is the answer. And in place of y of n, if I put x conjugate n, what I will get? What is the Fourier transform of this one? C of k. What is the Fourier transform of this one? C conjugate minus k. So similar thing will happen here as well. C of k, C conjugate. Here I am supposed to put minus k, but there will be inversion. And limit of k will go from 0 to n minus 1. So what you are getting? Mod of ck square. Okay, so rarely we are going to use it, but just you can remember this is the Parseval's theorem and this is how you can solve it. Very easy, very straightforward, very straightforward. In the statement wise question can be asked. Mostly they can ask this kind of question. In the statement, they can ask this kind of question that 1 by t minus t by 2 to t by 2 xt dot yt dot dt would be equals to what? If x of n is periodic with t and they are having the exponential Fourier series coefficient of Cn and Dn. So it would be equals to this one. Okay, and this is known as Parseval's theorem. This is a, you can say this is an identity. This is an identity. Okay, but this is a theorem. This is also identity, but this is a theorem. Okay, right? Questions we are not going to see, but statement wise you can remember. Let's see this question. This would be the last one, I guess. Yeah. So try doing it on your own with the help of a CK diagram. With the help of diagram of CK, you are going to find out the expression of x of n. Along with that, you need to comment on the nature as well, that x of n will be real, even, odd, neither even nor odd, complex, what it would be. So you need to do the both of the things, that you will find x of n. Along with that, you will comment on the nature as well. So after finding x of n, commenting on the nature would be very easy. So you will not find x of n first. You will comment on the nature first. Are you able to understand this point? Let's just say we start finding x of n, then commenting on the nature would be very easy, because we could see the expression that it is real. Yes. Is it even or odd? That we will be able to see, right? So what you will do? First, you will comment on the nature without even finding out the expression of x of n. So how will you comment on the nature? What did I tell you? First thing, always you need to see mode of CK. If mode of CK is even or not even. If it is even, that means there are two possibilities. It could be real or it could be imaginary. It cannot be complex. Okay. Now between real and imaginary, how will you differentiate? So let's add a page. Between real and imaginary, how will you differentiate? So for real, what is the scenario? Do you remember? For real, I told you the angle at positive frequency plus the angle at negative frequency should be even multiple of pi. And for imaginary, what is the scenario? The angle at positive frequency plus the angle at negative frequency should be odd multiple of pi. Here, what is the scenario you are getting? Here, what is the angle? Plus pi by 2 minus pi by 2. Here, what is the scenario you are getting? Here, what is the scenario you are getting? Ck plus C of minus k. One time you are getting plus pi by 2 minus pi by 2. Other time you are getting plus pi minus pi. Plus pi minus pi. Will you see for these one as well? No. I will see for one time period, right? What is the time period here? Time period is 7. 1 sample, 2 sample, 3 sample, 4 sample, 5 sample, 6 sample, 7 sample, 8 sample is being repeated. Minus 2 is being repeated at plus 5. That means what is the time period? Time period is 7. So n naught value is 7. N naught value is 7. So between minus 2 to plus 4 I am gonna see. So minus 2 plus 2. So minus pi plus pi. Minus pi by 2 plus pi by 2. What you are getting? Both are 0 only. That means even multiple of pi. Even multiple of pi. What does that mean? It is x of n is real. So first thing is done. X of n is real. So x of n is real. It is not imaginary. Now even odd, neither even nor odd. So for even odd as well, if mode of Ck is even, that means x of n could be even as well, x of n could be odd as well. And there is chance that it could be neither even nor odd as well. Like after this as well, there is chance that it could be complex as well. Are you able to understand this point? After this as well, there could be a chance that it could be complex as well. When this chance would come? This chance would come when the angle of Ck and angle of C of minus k is neither the multiple of 2n pi and nor it is the multiple of 2n plus 1 pi. Basically, it is neither even multiple of pi nor it is odd multiple of pi. Let's just say C of k plus C of minus k was coming pi by 2. Then it would be complex. Then it would be complex. What would be complex? X of n would be complex. Right? So surely all three chances are there. Here I should not have cut. Here this cut mark should not have been there. First I need to check real, imaginary, complex, and first condition is that at least this should be even. If this is not even, then directly you can say that it will be complex. Forget about it. Mode of Ck has to be even. If it is not even, directly you can click on complex. But if it is even, then you need to check real, imaginary and complex as well. Real it would be there if multiple, if even multiple is there. Imaginary it would be there if odd multiple is there. Right? So we got to know that it is the even multiple. X of n is real. This is what we got to know. Now for even and odd, what is the condition? That your x of n, we are commenting on x of n. So x of n would be even when, so in case of even and odd, what we do? we actually subtract the angles. We actually subtract the angles. So it should be even multiple of pi, and this should be odd multiple of pi. This is the condition, right? So here what you are getting, so one time you are getting plus pi by 2, then minus pi by 2. So what you are getting, pi by 2 minus of minus pi by 2, because we need to subtract the angle. Other time what you are getting, pi minus of minus pi, pi minus of minus pi. So here what you are getting pi, here what you are getting 2 pi. So what is this? This is odd multiple. This is odd multiple. And what is this? This is even multiple. So one time you are getting odd multiple, one time you are getting even multiple. One time you are getting odd multiple, one time you are getting even multiple. What does that mean? That means x of n is neither even nor odd. What you expected? You expected either it should be even multiple or it should be odd multiple. Either it should be even multiple or it should be odd multiple. But one time you have got odd multiple, one time you have got even multiple. So answer is neither even nor odd. These are also. So this is how you could have solved it. So it is real plus neither even nor odd. Is that clear to you? Okay, well and good. Let's find out the expression of x of n. What we need to find? Expression of x of n. I told you one thing. Do you remember in case of Cn? I told you one thing. If all the amplitude are same, if mode of Ck all the amplitude are same, then answer could be mentioned in two forms, a by b, and linearize as well. Two forms could be there of the answer, a by b and linearize. A by b you will get if you apply the concept of GP. A by b you will get if you apply the concept of GP. So here the concept of GP will be applicable. What I mean to say, let's just find out the value. What will be the value of C of 0? That would be 1, because here the magnitude is 1, angle is 0. What is your C of k? Your C of k is magnitude of C of k e to the power j angle of C of k, right? This is your C of k. So what is the value of C0? Magnitude is 1, angle is 0 degree. What is the angle? 0 degree, because here it is not shown. Angle is not shown, that means it is 0 only. So what is the value of C of 0? That is coming out to be 1. What is the value of C of 1? Magnitude is 1 only, but the angle is pi by 2. Here you can see that angle is pi by 2, then angle is pi. So let's keep it as e to the power j pi by 2 only. Actually this could be equals to j, but we will keep this thing as well, we will keep this thing as well. So have some patience. C of 2 e to the power j pi, what that would be equals to? Minus 1. So we will keep this thing as well, we will keep this thing as well. Basically what is the amplitude? Amplitude here was 1 only. Here amplitude was 1 only, e to the power j pi. So e to the power j pi minus 1 also you are getting. Similarly C of minus 1, what you are getting? Amplitude is 1 only, but minus pi by 2, that is equals to minus j. And C of minus 2 you are getting e to the power minus j pi, that will be equals to minus 1, right? What will be your x of n equals to? X of n will be equals to only non-zero are C2, C of minus 2, C of minus 1, C of 1, C of 0. Only all these are non-zero. So you don't need to care about C of 3, right? You don't need to care about C of minus 3. You don't need to care about C of plus 3. You don't need to care about C of minus 4. You don't need to care about C of 4, right? Yeah. So how your x of n could be written? X of n could be written C of minus 2 e to the power minus j 2 omega naught n. C of minus n, C of minus 1 e to the power minus j omega naught n, plus C of 0 plus C of 1 e to the power j omega naught n, plus C of 2 e to the power j 2 omega naught n, right? Because you know that what is your x of n? X of n could be represented in terms of complex exponentials, where k belongs to the time period n naught. K belongs to the time period n naught, which is equals to n naught is equals to 7. Here we can see that n naught equals to 7. Okay, so yeah, let's find out x of n. So what mostly student would have done is that in case of C of minus 2, they would have put minus 1. This is what mostly students would have done. So let's do it. In case of C of minus 2, I would put minus 1. Then I would put here plus 1. Sorry, this was actually minus G. So I would have put minus G. Then I would have put C naught value, that is equals to 1 only. Then this value is plus J. Right? C1 value is plus J. C1 value is plus J, and then the value C2 value is minus 1. C2 value is minus 1. This is what a lot of students would have done. Now from here what you can see is that if I take minus sign common, so e to the power j 2 omega naught n plus e to the power minus j. This is minus j 2 omega naught n, this is plus j 2 omega naught n. This is what we are getting, right? What I will do, divide by 2 and multiply by 2. Why I am doing so, you would understand, right? Divide by 2 and multiply by 2. Plus, here what I can do is that if I take j common, so e to the power j omega naught n minus e to the power minus j omega naught n. What I need to do, divide by 2j and multiply with 2j as well. So divide by 2j and multiply with 2j. And next one is there. So what is the answer you are getting? X of 1. 1 is already there. Minus 2. What is this? Cos 2 omega naught n. This would be minus 2 sin omega naught n. Okay, this is minus 2 cos omega naught n, j and j minus 1 it would be, so minus 2 sin omega naught n. What is the value of omega naught? That is 2 pi by 7. So you will be getting 1 minus 2 cos 4 pi by 7 minus 2 sin 2 pi by 7n. So this would be the option 2, I guess. 1 minus 2 4. 1 minus 2 cos 4 pi by 7n. Yeah. So this is the option 2, which is very easy to click. But option 1 can also be the answer. And this example, the same example we took in case of continuous time Fourier series as well. The same example we took. There I told you, you can get this particular expression in terms of GP as well. And when you will get GP, you will get GP only when all of mode of CK are constant. All of mode of CK are having the same value. Let's just say if it was having a value of 2, then nothing would work. Let's just say this was also having a value of 2, this is also having a value of 2. Now you will not get the GP. For getting the condition of GP, it is necessary that mode of CK is always constant. Like these two, these could be 2, these could be 2, these could also could be 2. So all are 2 to 2. Basically all should have the same value. This is the condition. The condition is not even that it should be even. No, this is not the condition. You will get the answer in this kind of form, in A by B form. When you will get the answer in A by B form, you will get it only when all these are the same, and they are the same. So now yes, there is chances that you can get a GP. So are we getting a GP? Yes, we are getting a GP. So let's check that. So x of n. What is the value of C of minus 2? So C of minus 2, I am going to put e to the power minus j pi. E to the power minus j pi. E to the power minus j 2 omega naught n. Plus, what is the value of C of minus n? C of minus 1, that is e to the power minus j pi by 2. Then C naught is 0. Then e to the power j pi by 2. What is the value of C of 1? C of 1 is e to the power j pi by 2. So e to the power j omega naught n plus e to the power j pi, e to the power j omega naught n. What you can see here, e to the power minus j pi plus 2 omega naught n, e to the power minus j pi by 2 plus omega naught n, then plus 1, then e to the power j pi by 2 plus omega naught n, then e to the power j pi plus omega naught n. So what is the common factor here? What do you think? What is the common factor? From here to here, it is very easy to see the common factor. Basically, what you need to multiply so that you get 1. common factor is e to the power j pi by 2 plus omega naught n. From here to here it is very easy. Now you can see that in the first term if I multiply this particular thing, what I will be getting, this minus pi will be reduced to minus pi by 2, this minus 2 omega naught n will be reduced to minus omega naught n, and then the same thing, then this thing you will get, and then pi by 2 plus pi by 2 will be pi, omega naught n plus omega naught n will be equals to 2 omega naught n, right? So this is your common factor. What is the number of terms? Number of terms are 5. So can you write down the summation? The summation would be first term a r to the power n minus r to the power a r to the power n. What is the value of n? How many terms are there? 5 minus 1 upon r minus 1. What I need to do? I need to make sinusoid. Look, e to the power j theta minus 1. If this kind of thing is there, always you can make something, or plus 1 could also be there. So always you take out the half of it. What you will get? Look, this is what you are getting. So always try taking out the half of it. So what you will do? I will take out the half of it. Here what is there? E to the power minus j pi plus 2 omega naught n is already there. I will take the half of it. So 5 is already there. So 5 by 2 I will take outward. So e to the power j 5 by 2 pi by 2 plus omega naught n. This is what I will take outward. So e to the power j 5 by 2 pi by 2 plus omega naught n minus e to the power minus j 5 by 2 minus j pi by 2 plus omega naught n divided by, here also I will take the half of it outward. Divided by 2. I will take half of it outward. What you are getting? What you will be left with? Why I am doing so, you would able to understand, right? Why I am doing so? Because what I will be left with? Omega naught n divided by 2 minus e to the power minus j pi by 2 plus omega naught n divided by 2. Okay, so what I'm gonna do here, divide by 2j. If I divide by 2j on the upper side, downward side as well, I will divide by 2j. And one interesting thing you will notice here, that everything will cancel out. How it everything will cancel out? What is this? Let's just call this as theta. Okay, I am calling this as theta. Pi by 2 plus omega naught n as theta. I should have called it theta only. Before only I should have called it theta, but needlessly I wrote down the complex expressions. So what is this? E to the power minus j 2 theta. It is e to the power minus j 2 theta, right? What I am doing? I am calling theta equals to pi by 2 plus omega naught n. So e to the power minus j 2 theta plus 5 pi by 2 theta divided by e to the power j theta by 2. So this is 2.5. If this goes upward, this will become minus 5. Sorry, minus 0.5. So basically what this is, e to the power minus j 2 theta, and this is 5 by 2. So this will be 1 by 2 theta, and this is also 1 by 2 theta. So everything is being cancelled out. And here e to the power j 5 pi by 2 theta minus e to the power minus j 5 pi by 2 theta divided by 2j, then e to the power j theta by 2 minus e to the power minus j theta by 2 divided by 2j. So what you are getting? Sine 5 pi by 2 theta. What you are getting? X of n as sine 5 pi by 2 theta divided by sine theta by 2. Right? And what kind of answer they have given? 5 pi by 4. So basically they are taking it inside. Now I can replace my theta. So 5 pi by 2 will go inside. So it will become 5 pi by 4 plus 5 by 2 omega naught n. 5 pi by 4 plus 5 by 2 is going inside. 5 by 2 omega naught n. 5 by 2 omega naught n divided by sine, this would be pi by 4 plus basically what is happening, theta is pi by 4 plus omega naught n by 2. What is the value of omega naught? Two pi by 7. Omega naught is 2 pi by 7. So x of n is equals to sine 5 pi by 4 plus 5 pi by 7 n, right? 5 pi by 4 plus 5 pi by 7 n divided by sine pi by 4 plus 5 pi by, not 5 pi by, it would be, what is the value of omega naught? It would be pi by 7n. There you go. This is the answer also you are getting. So what I can sense is that, yeah, so this is also true. So both are true. What I can sense is that if they want to frame a question on this particular topic, then they will frame a question like this only, where both of the answers are possible, A by B and a linear answer as well. So if some good question is coming, then it should be coming from this kind of a problem only. Otherwise, other questions also you will be able to solve. This is very simple. These kind of questions we have seen in case of continuous time, ditto same process we need to follow. Ditto same process. So you would be able to solve these kind of questions. So only one question we are practicing. Here we have seen everything. We have seen the nature as well, and we have seen the expression as well. Also you can see from the final expression, it is surely real. Is it even? No, because this part is even, but this part is odd. So it would be neither even nor odd. And here also you can see that in case of n, if I put minus n, then I am not getting anything outward. So it is neither even nor odd. So yes, real and neither even nor odd, which we can verify from here as well. But in the examination, we will directly follow this particular process. We are not going to find x of n to follow this particular answer. Well and good. So yeah, that's it. This is the end of discrete time Fourier series as well. Next, we are going to study about DFT, discrete Fourier transform. So what I would do is that I am thinking that since this video is roughly around 1 hour only, so I can add up in the previous video only. So one whole video will be there of DTFS. Okay. So I will add up this particular video in the previous video only. So it would be roughly around 3 hours 15 minutes. So it works. One video will be there of DTFS, which is of 3 hours and 15 minutes. Thank you very much.